are red, plus sign small caps. Tilde the caret symbol indicates a following superscript character. Lowercase letters are set in square brackets. Additionally, an underscore is prefixed, as for example when specifying a specific Angle D manual of Pharmacognosy by A. Church, 2nd volume. Special Pharmacognosy illustration, Leipzig 1912, published by Kort Doherty. Tauchnitz Church, 1st section, wit. Handbuch Pharmacognosy, Zweiter Band, Spezielle. Pharmacognosy by Church, notes on the transcription. The present text has been reproduced as faithfully as possible, based on the 1912 book edition. Uncommon and no longer used spellings have been left unchanged compared to the original. Foreign expressions were not corrected. Spellings for raw materials, chemical substances, commodities, as well as personal and place names are not uniform. The original was set in black letter. Special typefaces are indicated in this text using the following special characters: italic, underlines bold, equality sign by H237 illustrations in the text, and inserted tables, as well as 3 maps illustration Leipzig 1912 published by Karl Perm. Tauchnitz, the right of translation into foreign languages is reserved by E-Publishing House, 2nd part. Special Pharmacognosy, 1st section, not to me but through common studies. Introduction. In discussing the tasks of pharmacognosy part P6, I have defined the aim of roots, leaves, and seeds in chapters together would mean that we are using the related drugs because they are roots, leaves, or seeds, but belonging to a morphological group is indifferent for pharmaceutical use. For the same reason, anatomical structure or inner finer morphology cannot be used as classification principles. Pharmacognosy is a science as being, in addition to an exhaustive, comprehensive treatment of each individual drug, the grouping together of related substances under common points of view. What are these general points of view? Should we use morphological categories? This would put us in the position of the signature I, P886, summarizing AOA, IZ drugs by plant families. After all, it has been shown that we often find the same or similar components in the parts of a single plant family. And Cesalpini is right when he says, Plantae quae generis societate junguntur, plerumque et similis possessent facultates. It's about the components, the faculties, virtues, and powers. However, we also frequently encounter discrepancies here, failing to reconcile the irreconcilable and separating what should be grouped together. Furthermore, the pharmacognostic similarity of species within a genus and of genera within a family is only rarely so great that botanical kinship coincides with pharmacological and chemical affinity. Thus, in the for medical use, only what the drug contains as an active ingredient comes into consideration. If it were the case that every drug only contained one effective component, or only a group of similar components as effective, and if we knew this component for each individual drug, the matter would be very simple. Then, grouping drugs according to Thea, D. Only the chemical system remains CI, P228 and 28. Due to their components, we use drugs. Whether a drug belongs to the Rubiaceae, Zingiberacea, or Lauraceae is pharmacologically irrelevant, just as it is inconsequential whether it is a root, leaf, or flower, or if it has 1 or 2 rows of palisades, or whether it originates from China or Japan. Our components would be the simplest task imaginable. But as mentioned above, P394, the effect of a drug is often a mixture effect resulting from several different components. Therefore, in some cases, we will need to place the same drug at different points within the system. Additionally, we can only identify or specify the components of a limited number of drugs as effective. The difficulties hindering the grouping of drugs based on chemical criteria are therefore significant, but they must be overcome, for all other systems are not fundamentally sound in this regard. The core only meets the chemical system, none other. I will therefore classify and group drugs from a chemical perspective. Chosen, something imperfect will initially emerge, as indeed the first systems used by chemists in their manuals were imperfect. Knowledge advances, the classification will become all the more accurate, accommodating an ever-increasing N. Tive, thus only including those that have been chemically examined to some extent. Drugs that have not been or have been insufficiently chemically examined do not yet have the right to be included in a scientific pharmacology. They only belong in drug inventories and encyclopedias for now. I am very well aware that with the representation I have ACE, the main location, and only mention it at another. For further information on pharmacochemical systems, see IPP2, and this intellectual cohesion, the text that connects articles and article groups, plays an important role. Number of drugs in a secure place within the system. It seems rather unsubstantial to me that some few drugs can be accommodated at various locations. Well, they are simply mentioned at different places. This is not such a great misfortune, but merely shows us the diversity of relationships of the drug in question. One can describe the drug at one TLF. In the following representation. The approach we take in dealing with plant drugs is predetermined by the path followed by the plant cell. Typically, as a result of the assimilation of carbon dioxide, a sugar is produced first. One can imagine the formation of sugar from carbon dioxide, either through formaldehyde Bayer or Lobin-3-core. Phases, CoHo-CoO, 2HO-CHO, CHO-3-CHO, CHO-CHO. In plants, sugar formation also occurs secondarily through polysaccharides or plant acids, as shown below. From the sugar, on the one hand, polysaccharides such as cellulose are formed, gum and mucus, while on the other hand, fats and other aliphatic substances are produced. For the glycerin contained in fats can be derived from grape sugar by adding 4 hydrogen atoms and splitting the carbon chain, just as it reversely becomes glycerol and sugar. And to derive stearin and oleic acid, which are bound to glycerin in most fats, from sugar, one simply needs to assume that 3 molecules of the latter are coupled together via their aldehyde groups, similar to how formaldehyde couples them during sugar synthesis. Then a molecule of 18 carbon atoms would result, in which only one shift and removal of oxygen is needed to generate that acid Emil Fischer. However, one can also think of fatty acids indirectly as being built fatty acids indirectly as being built Attic series, which provides a widespread class of pharmacognostically important substances in terpenes and resinous acid resins, and also leads to fluoroglucin, CHO-3-HO, inosite fluoroglucin. Then follow the unsaturated, ring-closed aromatic substances and their pairings with members of the sugar group, sugar subunits. On the other hand, one can get to olefinic camphor types, cyclic terpenes, retinoids, and phytosterols from carbohydrates. The bridge to the cyclic compounds is formed by the widely distributed hexacyclic saturated inosite, in which the ring closure of a 6-membered system has occurred, one of the first members of the hydroarum, the glycosides, and concluded by the alkaloids. Thus, we progress from the simpler to the more complex, successively treating the drug sugars, starch drugs, cellulose drugs, drugs with aliphatic acids and acidic salts, fat drugs, drugs with essential oils and other odorants, with aromatic phenols, tannin drugs, glycoside drugs, and alkaloid drugs, and in each case we make a classification according to the chemical structure of the main components, or where appropriate, according to family affiliation or pharmacological aspects. The teaching and reference books used in pharmacognosy are mentioned in the chapter Pharmacognostic Systems, IP216, while Botanical Light and Kangieser. Production, export, and import figures are mainly derived from trade reports and export-import lists from London, Hamburg, Amsterdam, New York, Buenos Aires. Some information is also due to the relevant trade ministries, e.g. Italy, the department. Rature is covered in the chapters Pharmacosystematics, P2098, 305, 326, Pharmacomorphology 1, P340, and Pharmacoanatomy 1, P349, 354 to 356 are listed. Von Lippmann and Winterstein. For etymological questions, I rely particularly on Grimm, Kluge, of Commerce in Washington, USA, the German Trade Archive, and other sources such as Tropenpflanzer and Tableau Général du Commerce de France, etc. For the data provided by Prostet ed. Fisher and Byrne kindly took over the processing of plant pests, and the following works were mainly used. P. Surauer, Handbook of Plant Diseases, 3rd edition, 2nd volume, Edited by G. Lindau, Berlin, 1908. A. B. Frank, Diseases of Plants, 2nd edition, 2nd edition. 2nd volume. Breslau, 1896. Bontebellus, Plant Diseases. Berlin, 1895. M. Hallrung, Annual Report on the Field of Plant Diseases. P. Surauer, Journal of Plant Diseases. The first 3 handbooks also refer to those seeking more detailed information. Further literary references are found in individual sections. Mr. Apothecary Israel kindly took over the processing of animal pests. In every drug, the historical part constantly refers to the Pharmacohistoria in Volume I. There the sources are to be found. The leader. A chewer is either cited under each section or at the end of the article. Monosaccharides of the hexose type, especially dextrose and levulose, very rarely free galactose, occur in abundance in many fruits. A mixture of dextrose and levulose is formed when raw sugar saccharose, see below, is split. W. Heesh is a condensation product of these 2 hexases, for example by the enzyme in bees' saliva, see honey. The role that sugar plays in the plant is a complex in organs that contain such rich quantities of sugar that they can be used to display its sugar beet roots, sugar cane stems, coconut palm trunks. It is stored in highly developed stora, ge parenchyma, thus playing the role of a reserve substance. In small amounts, it is found in almost all organs as it represents the form in which carbohydrates migrate. Its role in fruits is different. It may possibly contribute to the direct protection of seed germination by creating a nutrient-rich seedbed, or perhaps serve to attract birds that eat the fruit, since seeds that have passed through the digestive tract usually germinate more easily. Through cultivation, the sugar content has been significantly increased. The pectin in fruits originates from the intercellular substance of the flesh cells, which is why I have called it protopectin. It is soluble in sugar solution, not in water. Church and Rosenberg. This solution forms a gel in cold temperatures. Perhaps the formation of sugar in fruits is related to pectin formation, which conditions the loosening of the fruit flesh. The conversion of reserve strength to sugar during the flowering stage can be beautifully observed in the sago palm, whose stem strength is solved at that time and transported as sugar to the flower cluster formations. The starch grains therefore show more or less signs of dissolution corrosion. See the article sago. The source of sugar in the fruits is partly starch, and perhaps also the abundant occurrence of plant acids, apple acid, wine acid, lemon acid, or tannins in unripe fruits. On the other hand, these plant acids are probably also stages of oxidative breakdown of the sugar. Fruits with apple acid can ripen in cold climates, but not those rich in wine acid, as apple acid is converted into sugar at much lower temperatures. Litt, Emil Fischer, Synthesen in der Puren- und Zuckergruppe. Vortrag, Braunschweig, 1903. Cereals, fruit sugar, and cane sugar often crystallize out. The microhistochemical detection of hexases in drug cells succeeds easily through the feeling reaction. First transferred to the microchemical field by Sachs in 1862. One immerses a not too thin slice for 10 minutes in a concentrated copper sulfate solution, quickly washes it with distilled die Chemie der Kohlenhydrate und ihre Bedeutung für die Physiologie. Berlin, 1894. Further reports of the German Chemical Society, 1890 and following. Von Littmann, Chemistry of Sugars, 1904. Tollens, Short Handbook of Carbohydrates. Chapek, Biochemistry of Plants. In living plants, sugars are always dissolved in cell sape, in dried ma. I'll add water and transfers it into a boiling solution of potassium hydroxide in water. In cells containing reducing sugars, a red-yellow precipitate of copper oxide forms. The slice can also be directly introduced into the feeling solution, the cover glass placed on top, and heated to just below boiling point Meyer-Schimper. One uses the reaction D, discovered by Emil Fischer in 1890, transferred to the field of microhistochemistry by Senft. With phenylhydrazine, one places the preparation in a mixture of a solution of phenylhydrazine chloride and sodium acetate and heats. After cooling, spherets of phenylglucosazine appear in the glucose-containing cells. The reaction also occurs under sheared D because they occur not only with monosaccharides, but also with substances that under these conditions split off such substances or form furan derivatives. For the quantitative macrochemical determination of sugar, the Allian method or polarimetry is now generally used. Lit. Sex, microchemical reactions. In conditions in cells containing saccharose. The direct method by G. Krauss, which involves immersing the sections in glycerin or alcohol to bring out the sugar in droplet form, is successful only with very sugary tissues. Uncertain are the reactions with thymol and sulfuric acid, as well as with naphthol and sulfuric acid, which Malish reported. 1859. Flora, 1862, and Pring's Journal for 3rd. The copper sulfate method was later modified by Flukiger Pharmacognosy, Schimper Instructions for Microscopic Examination of Vegetable Food and Nutritional Substances, 1900. The Identification of Reducing Sugars, Ray. Report of the Botanical Society, 1885, Chapek Proceedings of the Vienna Academy, 1897, and Hofmeister Prinsch's Journal, 31, 1897. Pulse, Senft, Proceedings of the Vienna Academy, 1904, and on the microchemical detection of sugar by acetic acid phenylhydrazine. Pharmaceutical Post, 1902. H. Two new reactions for identifying sugar, Proceedings of the Vienna Academy, 1886. Fundamentals of Histochemistry of Plant Nutritional Substances, 1891. Also see Journal of Physiological Chemistry, 1888. Zimmermann, Botanical Microtechnology, 1892. Invert sugar drugs. Drugs consisting mainly of invert gar or containing a lot of invert sugar, mel, sin. Honey, meal French, honey English, meal Italian, meal Spanish, Honig Dutch, Hunaja Finnish, Mez Hungarian, Hebrew, Shahad, Math Hindi, Madhu Sweet, Makshika Sanskrit, Asal, Asal Nahal Arabic by Ibn Bathar, Asal, Asalal, Waslu Nahal Arabic by Ibn Bathar, Asal, Shahad, Angabin, Enjebin Persian, New Greek. Etymology. The designations in the Romance languages are derived from Mel. The Goth translates the Greek with Milip. All late Germanic dialects have the current word Honig, for which nothing is found in the closely related languages. Ad, Honig, Honeg, MHD, Honig, Old Norse Hu, Nang, Swedish Honing, Danish Honing, AG Unig, English Honey, Old Frankish Honog, Alt Saxon Honeg, Hanig, Dutch Honing, Honing. Klug observes. The origin is not clear. One has thought of Gr. Dust. Honey granular. Honey is a neuter noun, Till in Luther, also in Lessing. The first masculine use in Kaisersberg. Some writers then waver, so Goethe. Now the neuter form has disappeared. Grimm, regarding mead, Kluge notes. MHD, Emet, Mette, Ad, Metto, Mitto, Mittu. Miodo, English mead, Old Norse MJHQ. The Germanic medur appears as Latin may. Dus, previously a Fries. Meets a common German, and also a common Indo-Germanic word idg, medhu, skur, mathu. Honey, sweet drinker, wine. Old Slavic medu honey, wine, Lithuanian. Medus, mead, medus honey, Irish mid. To this old High German madu, sweet, lovely, from which the shift in meaning of Indo-Germanic. Medhu mead, honey, wine is explained. Actually sweet, perhaps a intoxicating liquid. Origin. The bee, Apis mellifica L. Hymenoptera, trib. Aculeata, which is widespread across Europe, Africa, and a large part of Asia in numerous varieties or races, some of which are now considered good species, specifically the worker bee. Extract. Sucks up with its strongly elongated, three-lobed lower lip tongue, Figr. 1 Sr. nectar from the nectarines of many plants, rarely also from extrafloral nectarines, by means of which the plant forms a sugar-rich liquid nectar, as an attractant for insects to ensure pollination. The bee then inverts this nectar in its stomach. Honey S. Tomac, honey bladder, crop fig, 1 hm using saliva from its salivary glands, whose secretions open into the base of the proboscis A in fig. 1. It mixes with the nectar during suction, and enters the honey stomach, where it is emptied for feeding the young brood into previously wax-formed cells. There, it is further concentrated, when collected. Nectar, pollen from the anthers, adheres to the so-called brushes rows of bristles on the inner surface of the tarsus, and corbicles groove-like depressions, surrounded by bristles on the outer side of the hind shank of the hind legs, and mixes with hind legs, and mixes with the hind legs. The honey, when it is emptied into the cell, for 1 kg of honey, 5,600,000 clover flowers are required. Ired Wilson, otherwise, an average of 100,000 to 2 million flowers. A beehive produces C1013 kg of honey. Honey is thus a plant-formed product, reformed by the petiolin in the bee's saliva, often containing pollen grains from the plants from which the bee collected the nectar, sometimes by microscopic analysis of pollen grains, which are oft absent in honey produced from sealed combs. It can be determined from which flowers the bees collected the honey, and, in favorable cases, even if the honey is spring, summer, or autumn honey, for the flowering period of plants is indeed confined within narrow limits. The pollen grains observed in American honeys are described by Young, who found Pfister, as in the literature in German honeys. Illustration, Fig. 1. Schematic representation of the sucking apparatus of the bee. Senior proboscis. Sucking occurs through rhythmic contractions and expansions of the honey stomach. In a saliva is added church. Villiers et colon alterations and falsifications. P. 842. The pollen grains of the following plants are said to be present in honey: Tilia oreganum, lavandula, Melissa rosmarinus, linum, Vaccinium myrtillus, Verbascum thapsus, Melolotus, Epilabium latum, and composite Sinanthes. Zalia pontica and Rhododendron ponticum have been found. Sometimes bees, especially when they cannot find enough flowers, collect the sweet, dextrin-rich secretion of aphids that they find on leaves. This often lower-quality honey is called mead-dew honey. Description: honey forms a clear, thick yellow or yellowish-brown liquid, or a more, as shown in Fig. AAO, and also in Winton-Moeller, Microscopy, 1906. In honey from Chamonix, Erica vaccinium rhododendron. In so-called toxic honeys from Switzerland, Mingrelia, Pennsylvania, and Carolina pollen grains of Aconitum napellus and Lycoctonum, Andromeda mariana, Calmia angustifolia, latifolia, and hirsida. Less cloudy, white mass of dextrose appearing in the microscope as plates and sheets. The color and smell of honey vary according to its source. For example, the smell depending on the type of flowers primarily visited. Honey is sometimes said to take on other properties of the plants visited. So if these are toxic ranunculaceae, Aconitum, Ericaceae, A. Apocynaceae, Nerium, Daphne, Azalea, Datura, Rhododendron, the honey can also become toxic. Honey collected near Kuso Gardens in Abyssinia has the deadly properties of Kuso and is used like it. Kebler, 1896, found a body similar to Andromeda toxin in toxic honey. Poisonous rhododendron. Honey has also been observed recently in India. When visiting flowers, and thus occasionally a fragrant substance or another body formed by the glandular hairs might mix in. Plinius notes that thyme honey has a very good smell and taste, generally much better than, for example, rosemary honey. The Alpheeta CI P652 also mentions a melphimenon, Corsican honey, smelled like Taxus and Wa. In Sly, Pennsylvania, the Caucasus, and in 1905 New Zealand Cune. According to some, the toxicity of a plant has no or only conditional influence. This seems likely, as nectarines indeed only excrete sugar sap, not toxic substances. However, the secretions from the glandular hairs could easily be stripped off by bees. Considered of poor reputation in ancient times. In Vorderindien gilt der Honig als der beste, der durch die Bienen von Strobilantes Arten und Plectranthus rugosus gesammelt wird, Watt. El-Basri weiß bei Ibn Baythar zu berichten, dass die Honige, die von Saturea und die von Absinth stammen, eine verschiedene arzneiliche Wirkung besät. Sen. Letzterer sei auch bitter, und neuerdings wurde berichtet, dass auch der Eukalyptushonig besondere arzneiliche Wirkung besitzen solle, was sich aber nicht bestätigt hat. Die Blütenhonige sind ebenso wie die Frühjahrshonige heller als die Tannenhonige, die Wald- und Honigtauhonige. Die überseeischen Honige besitzen meist einen wenig angenehm en Geruch und Geschmack und sind auch oft unrein. Aus ungedeckelten Waben ausgeschleuderter Honig ist wasserreicher, daher dünnflüssiger unreifer Honig. Das spezifische Gewicht des Honigs beträgt etwa 142, 1000, 14, nicht direkt bestimmt, sondern in Losen 1, 2. Diese Losung soll wenigstens 120 spes, aving weight. Good honey is durable due to the content of acetic acid. Water-rich honey easily ferments. Honey wine, metha, CFI, p. 1016, or turns sour, lit. Arnold, The Honey, Its Significance, Value and Use, 1886. Von Berlepsch and W. Vogel, Beekeeping at its Current Level. Berlin, 1899. Collecting. Bee either forms a structure in hollow trees or protected places wild bee, or in beehives and bee colonies from hexagonal, upright cells combs, wax cells. This is opened by horizontal cuts and the combs are uncovered. Then the contents can simply run out young honey, runny honey, or the flow can be accelerated by centrifuging Y, or by crushing the combs runoff honey, or through pressure and heat-drained honey, pressed honey. The latter is often clarified sieved. Even the other types are often strained through a sieve. Trade types. Lime, heather, fennel, clover, rapeseed, buckwheat honey are quite arbitrary names for good flower honeys. Honeydew, forest. Spruce honey is less good. The trade distinguishes comb honey, sheet honey with the combs, spreader honey, trickle honey, or sink honey, pressed honey, running honey, seeped honey, country honey, stamped honey, country honey, stamped honey. Furthermore, one distinguishes still spring honey from the flowers of rapeseed, fruit trees, willows, etc. Rome the flowers of clover, heteric, etc. High summer honey from the flowers of lime, cornflower, willow, bean, etc. Autumn honey from the flowers of buckwheat, erica, etc. Collected. Already Dioscoride says, the preference deserves the spring honey. After that, the summer honey, the thicker autumn honey. Heather honey is of lower quality. Thai. Aristotle, on the other hand, considers the autumn honey as the best. Plinius states that the best honey is produced during the time when thyme and grapes are in bloom. Wholesale now supplies a great deal of overseas honey, and such honey is distinguished from that of Chile barrels of 70 kg, Havana, Cuba, Mexico, California, and Hawaii, the latter in cans of 25 kg, packed 2 to a box. From Chile, the most important source, varieties are offered such as white stiff 0 and 0, blonde, yellow, and brown. Production. Europe produces approximately 80,000 tons of honey annually. Germany, where beekeeping is conducted most efficiently, e.g., in Holstein, alone produces 20,000 tons. Ness, Spain 19,000 tons. Austria-Hungary, 18,000 tons. France, particularly Narbonne, 10,000 tons. Smaller quantities are supplied by Italy, Greece. Overseas countries delivered approximately 3.25 million cados in 1907, with particularly large amounts coming from Cuba, Chile, San Domingo, Mexico, Peru, and California. Valparaiso to Oran Fig. 250 is a major honey port. In 1908, Cuba supplied 1,320 tons, Mexico 320 tons. Imports into Germany in 1909 included approximately 112,000 kg from California and North America, approximately 630, 0 kg from Chile and Peru, approximately 1,505,000 kg from Cuba, approximately 370,000 kg from Dominica and Haiti, approximately 220,000 kg from Jamaica, approximately 420,000 kg from Mexico, approximately 331,000 kg from various countries, for a total of approximately 3,573,000 kg honey imports to Hamburg by sea in 1906, 1908. 36,746 double-centered Z. The United States of North America imported 145,691 gallons of honey in 1909, primarily from Cuba, namely Tugain, namely 103,092 gallons. France. Honey is mainly a concentrated aqueous solution of invert sugar, fructose and glucose, containing 6580 of 106573 in floral honeys and less in honeydew honeys, invert sugar after 734.7 dextrose. It also contains small amounts of raw sugar, saccharose, 2,5 up to 10, dextrins underneath and acrodextrin up to 4, particularly in conifer honey. protein substances 0.151.8, some colorant, formic acid A Vogel, apple acid, and mineral substances. Traces of gum-like substances and odors are also present. In total, 1.5 is made up of non-sugar components. The acidic reaction is partly due to formic acid, which constitutes 0.0415 of this acid, according to Farnstein. For honeys with dark color are right-rotating. After the precipitation of dextrin, naturally right-rotating honeys become inactive or left-rotating. The right rotation is therefore due to dextrin. Dextrins found in conifer honeys seem to be different, Hilger, and are not related to starch dextrins. Monheim considers honey dextrin as a disaccharide. The sour reaction of honey is mainly due to a non-volatile acid apple acid. Ash contains particularly phosphates 4,10-ash, usually not over 7. Painter stated 1885 that natural honey contains 0.010.03 phosphoric acid, while artificial honey only has traces. Light floral honeys are always left-rotating, while honey-dew honeys in Connie. It was already discovered by Lowitz in 1792 that honey contains a special sugar, i.e., not raw sugar. In fact, Machen found up to 40 melicitos in lime tree honey. The Fahey reaction for distinguishing between natural and artificial honey red coloring of the residue from ether extraction with a resorcin solution in fuming hydrochloric acid is based on the fact that non-heated natural honey lacks, or nearly lacks, oxy-methylferol, a degradation product of fructose, which is found in both artificial honey, invert sugar, and starch syrup, Kaiser. This reaction is not decisive Lippmann. Honey always contains enzymes. Markman identifies 3, a proteolytic on, an invertase, and an alcohol-forming enzyme. These apparently originate from the bee's salivary glands. Regarding the composition of pollen and nectar, Wilson, von Planta, and Kressling have published findings. Nectar often contains only glucose, or only sucrose, or both glucose and in varying ratios. Against pollen, as far as investigated, mainly only saccharose Kressling. Ameisensäure is absent in pollen and nectar. It is produced by the bee. The honeydew see above contains, in addition to saccharose and glucose, the food mixture food sap, which the feeding worker bees insert into the cells of queen. Drones and workers, contains a high amount of nitrogenous substance, C43, along with fat and glucose, C24. Data on the raw sugar content of nectary fluids by Lippmann, p. 1047. Lit. Pasterlake, 1909. There the literature. V. Lippmann, Chemistry of Sugar Types. Swiss Food Book, 1908, and G. Erman Reich Regulations. Elsner in Real Encyclopedia Examination. Koenig, D. Human Food and Pleasure Foods, and Composition of American Honeys, including a microscopical study of honey pollen by young U.S. Depp. Agric, Burr of Chemistry, 1908. Du. RT Die Honigliteratur, 1892-1907. Pfister, Forschungsbücher, 1895. Pollen. Ferner, Kühlmann und Hilger, Zur Chemie des Honigs, Forschungsbücher, 1896. E. Beckmann, Bader Z. 1878, U. 1879. Bishop, Jern, Farm, Chim, 510-459. Tabelle der Zusammensetz, by Villiers Collin, Alterat, et Falsificat. Bensemann Farm, Central, 1894. Heffelmann, Zeitcher, Andu, Chem, 1888. Farnsteiner, Zeitcher, F. Unters, Kaiser, Peter, Z. Chem. Die Honigs, Arbeit, die Kais, Gesundheitsamtes, 1909. Kuhn, V09. Ests, Israel reports. The mites that occasionally appear as pests on pharmaceutical products and preparations mainly belong to the family of pyroglyphines. Among these, there are no true parasites. They live on substances that slowly decompose, rot, are animal or plant-based, in particular sugary ones, and are therefore often found where sugar. Arm, Zeit, 1905, S642 Giftiger Honig. Röhrig Jahres D. Farm, 1908. S435 Ukreis, Ibenda Asche. Markmann Farm, 1903. P. 1000, 1903. P. 110, Mannheim. Honey dextrin of forest honey. Annual Report of Pharmacy, 1935. Furthermore, the literature on the study of food and consumer goods should be compared. Pathology on P. Wandering larva stage, carried and spread by flies that have these small animals attached to their legs. In fermenting raw honey, Glyciphagus domesticus, as parasites live in beehives according to Israel. 1. Larval stages of Meloe species. Solutions are fermenting. They can also be found frequently on almost all dried fruits, such as figs, dates, raisins, plums, etc. But not only on these, but also on all possible other dry vegetable and animal substances and raw materials. One often finds some mite species in remarkable mass proliferation. Particularly those of the well-known common, Maybug Meloe proscarabeus. This beetle lays its eggs in sand, and the emerging larvae climb up on plants and enter flowers. From here, they are carried by the bees themselves, to which they cling with their hairy legs, into the hives, where they crawl into a cell and initially eat the bee egg, and then undergo their further quite complex hypermetamorphosis. The larva undergoes several significant transformations before finally pupating. 2. The beautiful red larvae of the so-called bee wolves, the beetle genus Trichos, particularly Apiarius. They mainly affect wild bee species, especially the mason bee, less frequently the honeybee. 3. Fall brood. The bee moth is very resilient. Tuberculosis bacteria do not affect them at all. Additions and adulterations. If honey is heavily diluted with water in a sediment cylinder, pollen grains and wax particles will settle to the bottom and can be diagnosed microscopically. See above P9. They are regular additives. The caterpillars of Galleria melanella, the wax moth, which can cause some hives to collapse. Galleria belongs to the family Pyralidae, a subfamily of Microlepidoptera. They eat long tunnels through the combs, and often significantly disrupt the bee's hive due to their numbers. They are also occasionally responsible for the onset of American gans and bee larvae. Starch and mineral substances that may also be found in the sediment are unacceptable. Adulterants include water, corn syrup, raw sugar, artificial honey, dextrin, rarely encountered. Starch, glue, glycerin, molasses, saccharin dyes. For more on honey adulteration, see Farm. Zeit, 1903, 142. Those who engaged in honey adulteration in the Middle Ages were punished by losing a hand or 65 pence. Testing. Apart from microscopic examination, the determination of sugar, water, minerals, acidity, and testing for dextrin, as well as observing the optical behavior before and after inversion, before and after the dextrin's precipitation with alcohol. Required, if necessary. Ride dextrin, nitrogenous substances, and phosphoric acid should be determined, and tests can be conducted on saccharin and coal tar colors. Refer to the above for limit values. Honeys with starch sugar or cane sugar additions remain right R, rotating even after dextrin precipitation with alcohol, while genuine honeys become inactive or left rotating. Artificial honey is usually inverted cane sugar cut with natural honey or perfumed with honey parfum. It typically contains no nitrogen, enzymes, phosphoric acid, or only trace amounts as mentioned above, and no formic acid. N-strength sugar, first represented by Kirchhoff in 1811, is sold as honey, lit. Fia, on the detection of starch syrup in honey and fruit juices. Work of the Imperial Health Office 32/1909, Issue 1. Use 1. Use. Honey was the most commonly used remedy in ancient Egypt, and it is also referred to as a general medicine for humans in the Quran. It formed the constituent of theriac borin, P. 551, and was an ingredient in kaifi barai, P. 473. Today, honey is primarily used as a condiment and food. Large quantities, especially those from overseas, are consumed in the production of gingerbread. In medicine, it is used as a mild L-hexativin flavor corrector, and also for mouth and throat waswa. Oxymel, hydromel, melboroxatum, and particularly melrosatum are still widely used, some dating back to ancient Egyptian mel composites burst of pp. 469 and 539. Topical application, which played a role in antiquity, is no longer popular today. Honey, the use of lavender as a nutrient for diabetics is now recommended. History, H3. Honey was one of the first foods consumed by humans. Milk and honey was the diet of the gods, ambrosia, which Zeus, the child of the honey nymph Melissa, mixed. According to Norse mythology, dew Hunangsfall, honeyfall dripped from the sacred oak and nourished the bees. Honey also held high regard among sea peoples. It was not permitted to be used in food offerings. Greek poets sang its praises. Plato mentions honey-glazed fruits as the oldest sacrifice by the Greeks. In Egypt, honey is called Phet Coptic Ebio and Pheo, while in Babylon it is Depu. In ancient Egypt, honey was likely the original sweetening agent used in medicine, and date syrup. Enlil entered Egyptian pharmacy through Babylonian recipes, c. p. 469. Even the oldest cultural peoples cultivated bee breeding and the production of honey and wax. Long before sugar cane was introduced, honey served as a general sweetener, but it was also used medicinally internally and externally. Even in ancient times, the Materia Medica deal with Melito's honey. Pliny also mentions honey from the island Calydna, Pelignian honey, Crete, Cyprus, and Africa, and finally German honey. The ancient dietary honey drinks were Melicraton honey wine, hydromel watered honey, aqua molsa, oinameli molsum, melicraton galli, oxyglicon, and oxymel. These were distinguished. Dioscorides knows, alongside Attic honey from Hymettus, honey from the Cycladic Islands and Sicily, as well as from Sardinia, and poisonous Pontic honey, which is also mentioned by Xenophon, collected from Azalea pontica and Rhododendron ponticum, or A. Datura fluciger. Chapters 101-103 of Book 2 of Dioscorides mentions pale and amber-colored honey and various sugar types made from honey. Hydromel and oxymel were among Hippocrates' favorite remedies. Fermented honey was used to make met, S. 1016. As mentioned earlier, S. 1013, honey was used in antiquity as a preservative for the bodies of noble persons. As Bastien de Folker des Östlichen mentions Propolio's UL on IE, the aromatic tree wax of bees, propolis, lit. Von Lippmann, Geschichte des Zuckers, 1890, which includes a history of honey as a precursor to sugar. Flowers, marigold, woolly flower, white bouillon, mullein, bonhomme herbe de Saint-Fiacre, Notre Dame's candle French, high taper. Asians II, 27 reports. This practice is still common in Burma today. High officials are preserved for a year following their death, which requires extensive preparations, and to keep them fresh, they are immersed in honey, considered the most secure method, and also the cheapest, as the offered honey can be resold. After North America in 1675, B. Brazil in 1845, and Australia in 1862, the bee was introduced. Von Lippmann, who provides many historical notes on honey, proves that honey consumption developed particularly among vegetarian peoples. During the Merovingian period, German gardens consisted only of a few fruit trees and beehives, IP 619. The Frankfurt Lizzie, from 1451, P 812. Torchweed, mullein, woolblade English, Fiore di Verbasco, Tasso barbasso, barabasco, barbarastio miniatone, Candela regia Italian, Ökerfarkoro Hungarian, New Greek, Walkraut Himmelskerze, Fackelkraut, Fackelblumen, Unser Frauenheil, Himmelbrand, Manuel, Marienkerzen, Osterkerze, Wiln, Zolisch, Adi, Ko-O, Nigskron, Königskart, Vulena, Wulina, MHD, Bullen, Heimelbrand, Königswort, Königskerz, Wisselma, Vulkraut, by Brunfels. Dioscorides Amos 564, Kent Merere Arten, der Weiße ist wohl Vieh, Plicatum oder Tapsus, Plicatum ist Nachfras in Griechisch. Enland häufiger, der schwarze Fissinuatum des Theophrast. Bemerkt, dass die Römer den Phlomos, Verbascum gräzisiert Berbasculum nennen. Daraus ist dann Barbascum und Scherbascum entstanden. Plinius schöpft aus derselben Quelle. Auch der Name Thapsos war in Gebrauch, ob die und des Galen VP. Plomoides ist, wie Dragendorf will, ist mir zweifelhaft. Es wird wohl eine der südlichen Arten sein under parallel drugs. The anion of Galen is said to be Verbascum limnans. What the of Hermes Trismegistos, Mercury's herb, is, and what the Egyptian Phlomos heteros atha, L. Kerikion, Honur Abdon is, remains unknown. In ancient times, verbascum was often confused with the labiate phlomis. Adding perhaps from to shine, flame, as stems and leaves were used for lum, apsis, and barbascum. Then Tassus barbatus, even Taxus barbatus, as in Crescentia fern, P6078 was formed, which I consider a Thordosorids error. Thoris Dor, V. Thapsus pole, V. Cuspidatum shrad, V. Kixianum dumor, and verbascum flomo, P. Wix Plinius 2574, or because the inflorescence, see Fig. 2 resembles a candelabra, a torch, or a candle. This is also suggested by names such as Candela regia, King's candle, Torchiola, Mary or Easter candle, while others like wool flowers, woolwort, Woolina barbascum from barba, referring to the hair, as in the Arabic name Adan Eden, da bare ears, Molain, moling from mollis soft, may also refer to this or to its mucilaginous content. Thapsus is related to the yellow color of the flowers, i.e. with which the Greeks called the island Thapsus Isola degli Magnesi, near Syracuse, fluffy. Umbellifer used for dyeing Thapsia gorganica, from thumb. Ides L systematic position. Scrofulariaceae, Pseudosolania verbaceae, Sectio Thapsus, 1909, and also Engler Prantal plant families, separate V. Phlomoides, the wildflower-like marsh marigold, from V. thapsifera. Army, the large-flowered species. Schumann notes in Bergschmidt, Atlas, p. 74, G.F.W. Meyer, first expressed the opinion that V. thapsiform schrader should not be specifically distinguished from V. phlomoidale. We can readily agree with this view. Fluckiger, as the leaf-based characteristic, is hardly sufficient to grant our plant a status other than perhaps that of a variety. In any case, they are very similar, and both flowers are explicitly permitted, e.g. by Farm, Helvete Thornt. Schinskeller described V. thapsiform, 3180 cm tall, leaves elongated, elliptical toothed, yet are parts of middle leaf extending downward very differently. Crown flat, about twice as large and paler than in V. thapsus, 2 longer stigmas, 1-2 times. V. thapsus, which is also quite common with us, is not under consideration for us. It has much smaller flowers. Conversely, I'm low fuzzy, each leaf extending downward to the next lower one. Flower stalks shorter than the calyx. Crown radially symmetrical, twice as large and brighter yellow than in V. thapsus, otherwise like that species. V. phlomoides, 1-2 m tall, stem erect and rigid, simple or with single upright branches. Leaves elongated oval, toothed, lower and upper. T.S. flowers, common mullein, seem to be used in North America, where the plant reaches enormous heights over 7 feet. Also, V. phlomoides is found presumably introduced in the United States, for example, in Massachusetts. Illustration, Fig. 2. Verbascum phlomoideae, L. As necessary as it is to use authors when naming plant drugs, Holmes Ph. Journ. 1900, 1418. Demonstrated with verbascum. There are 5 V. phlomoides, V, and 2 V. thapsiform V. Thapsiform schrader, and V. thapsiform gus. The marshmallow is a magnificent plant of great beauty. Its straight handle-like stem with large gray leaves, and the long flower-covered inflorescences make it one of the most characteristic plants in our flora. Fig. 2. Verbascum thapsiform shrad. In the first year, only a large rosette of leaves develops, and in the second year, the inflorescence appears. The spirally ranged leaves are oblong or narrow, inversely egg-shaped, usually seeded, with their base gradually descending to the next leaf, lobed, pointed, and thickly velvety due to numerous tufts of hair. The detached wool hairs are used as tinder. The flowers of V. thapsiform are united into dichasias, which in turn form a so-called floral tail on a long inflorescence axis. They first appear individually in the axils of the spiral, pointed, and descending outer bracts, the bracteoles of the inflorescence. Fig. 3. The first flower. Fig. 3. One has 2 lanceolate bracteoles. Soon after, 2 or 4 flowers, 3, 5, also with bracteoles, emerge from the axils of these latter of these has 2 bracts. Sometimes additional flowers without petals 6 can also be found in the axils of the upper, older petals. These are the last to bloom. Due to the very different ages of the flowers, usually only one or two of these partial inflorescences bloom at the same time, but as they all come into bloom one after the other in Aeoles, however, before these 2 or 4 form a 3 or 5-petaled dichasia, as the flowers unfold from this dichasia and from petal D, under flower 1, a lateral bud develops as a richness shoot. In simplest case, this richness shoot is single-flowered. However, usually, between the first flower that opens 2 and petal D, a second flower 4 forms. The order of the numbers, a flower stalk of Verbascum thapsiform, remains in bloom from top to bottom for weeks. Here, a flower opens. The gomosepalous, cup-shaped, 5-petaled calyx is densely hairy on the outside, with a length of 6-8 mm. The 5 lobes are lanceolate, elongated triangular, and show an ascending Dachshaus-Nospin arrangement. It is zygomorphic. The hairs are either glandular hairs with often very numerous secreting cells, or stellate hairs with 1-4 tiers bushy hairs. Such hairs also occur on the leaf blades. The ovary is egg-shaped. Illustration, Figure, above, diagram of a partial inflorescence in the axil of the cover leaf D. The circles represent the flowers. The numbers 1-6 indicate the flowering order. In the middle, a sliced corolle. Below, complete bloom in longitudinal section. After Church-Westerly, Atlas. The also median zygomorphic corolle, which detaches very easily, is radially symmeter. IC. 5-petaled, sympedalous, with a width of C3 to 4 cm, sometimes even 5 cm in the median. At the base, the 5 leaves are fused into a short tube. The tips are almost circular. They overlap like roof tiles in descending order of preference. The lower petal lobe is often significantly larger than the 2 lateral ones. The 2 upper ones are of 10-13 smaller than the lower. In the tubular part, the corolle is thick fleshy. The 5 stamens are inserted slightly above the tube of the corolle. They alternate with the lobes. They continue the zygomorphic character of the corolle to a greater extent. The 3 upper ones are differently shaped from the 2 lower ones. The 3 upper ones are approximately 6 mm long. They have a kidney-shaped transverse anther with summit slits and are densely covered with long hairs from the middle to the tip of the filament, so that when observing the fresh flower from above, one sees the entire tube filled with a hair fuzz. They thus serve as a kind of signal to the insect visiting the flower that nothing is to be gained further down in the flower, and they point it to the vivid red anthers. The hairs are supposed, according to Herm Müller, to serve besides the red pollen as a lure for insects. Perhaps, remarks A. Meyer, they exude some palatable substance, or are themselves good food. Observations by Thunmann disprove this. Were any hair fragments found chewed away? So, for the bees, who are the main visitors to the queen of the meadow, since they lack nectaries, only the red pollen grains remain, and these are what they collect and use as food for their brood. The verbascum flower belongs to the pollen flowers. The 2 lower stamens are about 10 mm long, usually cute, hairless, and bear the 3-4 mm long anther on the inner side of the tip of the filament. It is grown with it a piece further. So varied is their structure compared to the hairy stamina. The cross-section through the anther of the long variety looks almost identical to the longitudinal section through the anther of the short variety. See Anatomy, Cal Atlas. The ovary is egg-shaped, approximately 2 mm long, and 2-chambered. The style is only hairy at its base, about 12 mm in length. The unequally sized stigmas are only indistinctly separated from each other. The stigma papilla layer extends a short way down the style. The capsule, which opens radially, can be up to 1 cm long and 8 m wide. The seeds are cylindrical. The embryo, embedded in endosperm, is straight. The fruit consists only of the floral crown with its attached staminate threads. V. phlomoides is widespread across Central and Southern Europe. It grows from France to Denmark and Russia, from Spain and Italy to Crimea, in the Himalayas from Kashmir to Western and Tibet. V. thapsiform does not extend as far south, and is particularly found in Central Europe. V. phlomoides is much rarer than V. thapsiform. Both are often found in the same areas. Both produce numerous bastards, see Pabst Kohler, medicinal plants. They prefer road verges, dry hills, and heaths, as well as stony, uncultivated places and light woodland. They flower from early July to mid-October. Lit. Schrader, Monoger, Generis Verbaceae, Göttingen 181,323, Branché et tout sur le verbascum de la France et de l'Europe centrale. Vendôme, 1875. Illustration of V. Thapsiform and Berg-Schmidt Atlas. 2nd ed. Plate 26 also includes floral literature of V. Phlomoides and Pabst K. Euler medicinal plants. Plate 45. Eichler, flower diagrams. Widler, Flora, 1851. 411. A. Meyer, drug knowledge. Miller, fertilization of flowers, 1877. 277. 272. Kerner, plant life. Tout see below. Lavadu see below. Pathology. Various parasites occur on verbascum, such as Peronospora sordida Burke, Erisif, Sicorisarum D.C., Uromyces scrofulariae D.C., and others, yet these are likely to have no significance for the flowers. Ed. Fisher, on animal pests, larvae and flower buds of verbascum species, Sionis scrofulariae L. E. longitarsis verbaceae pons. Larvae mostly in long, curved leaf mines and leaves of verbascum thapsus and phlomoides. 2. Butterflies. Gortina flavigo H.B. The caterpillar lives in the robust stems of many plants, including Rofularia and verbascum species. Gymnotron teeter, F.B. Larvae on flowers and leaves of Antirrhinum and verbascum species. Gymnotron thapsicola germ, in southern and central Germany, on verbascum species. Cladus verbaceae, Faberem. Beetles, frequently on verbascum flowers. Whether the larva lives in verbascum stems is questionable. Non-verbascum species. Cuculia verbaceae L. Cuculia scrofularia, W.V. The beautiful caterpillars of these butterflies feed on the leaves, flowers, buds, and seed capsules of verbascum and scrofularia species. Cuculia thapsiphaga tart. The caterpillar of this rare butterfly also feeds on verbascum species. Polyaxanthemista Hugh. B.N. Caterpillar on verbascum and selene species. Acronecta euphorbia, W.V. Caterpillar on plantago, euphorbia, and verbascum species. In addition to these, a large number of polyphagous owl caterpillars. Cultivation and collection. Verbascum species are cultivated in rural gardens in Germany, Styria, and Switzerland, and even occasionally supplied to pharmacies, and are often a component of apothecary gardens IS50. As special cultural sites in Germany, the following are to be mentioned. Hord-Württemberg, Neudorf-Bruchsal, Schweinfurt-Schwebheim, Reflein, Aachen ad Elbe, Ballenstedt Ehards, Blaubeuren, Schwarzenfeld-Nah, Berg, Sonderberg-Olsen. Cf. I. P63. In Hungary, the flowers of V. phlomoides are collected on a larger scale from wild-growing plants, B. Peter, but they also come from cultivated sources. Austria also exports Flos verbaceae. Upper Austria cultivates these plants in larger quantities. In Russia, the Poltava Governorate produces Flos V. R.B. Russick. The Moscow Governorate collects the flowers from wild-growing plants. Only the flower crown with its attached pollen threads is harvested in July and August, on sunny days with dry weather, and dried rapidly in the sun, or spread out in a thin layer under artificial heat, which should not exceed 30-35, with removal of water vapor, but ways with good ventilation. Otherwise they, by oxidase, turn brown. Flowers whose enzymes have been killed retain their color, perot and gorus. Since flowers absorb water easily, they are preserved over lime. They also need protection from light. The petals are sieved. 7-8 parts fresh flowers give 1 part dried. Anatomy of the flower. In T. Tubular parts. The corolla is hairless and shiny on both sides, almost colorless below, and yellow above. The epidermal cells on both surfaces are slightly elongated. Fig. The cuticle on the upper inner side is folded in wave-like patterns. The epidermis of both leaf sides, and only these contains, in addition to small yellowish chromatop, pores, yellow cell sap. The pigment, anthoxanthin, is soluble in water and alcohol. Both sides' epidermal cells, approximating the outer surface, have a small, bright, highly light-refracting droplet. Fig. 4 drops, which does not dissolve in chloral, acetic acid, potassium, or alcohol, but does dissolve in hydrochloric acid and sulfuric acid. D is not colored by osmium acid. These drops account for the peculiar luster of the leaves, which the colonel mistakenly attributed to nectar emerging from stomata. He confused the shiny epidermal cells with honey droplets. Nectaries are absent. The outer side of the leaf is densely covered with multi-tiered star hairs, bushy hairs, which have 2-3 tiers. The terminal star has 3-6 rays, and the tier stars have 3-5 rays. The mesophyll is relatively thick in the tube parts of the flower, but becomes thin-layered in the crown lobes. It consists of a thin-walled, sometimes quite well-ventilated parenchyma that appears white in the dried state, whose cells often still contain starch. Enter the filaments of the stamina, each into one of the crown tips, branching off here richly. In the epidermis of the filaments, 5 chiro are found, which turn yellow with sulfuric acid, while the cell sap turns blue. The hairs of the 3 upper stamina are quite long but remain synced, grains connected to the chromatophore. Embedded in the fabric are here and there round or elongated secretion cells with a corked wall, which, embedded in a homogeneous or delicately fibrous mass, contain very small droplets that turn black with osmium acid and are probably essential acid. Oils. The crown tube is traversed by 30 bundles, 5 of which they are culin-firming at the tip and show numerous rough, often arranged in rows, cuticular scales fig. 5, 2 on the surface, sometimes already in the dry state, better in flowers that have been fresh in alcohol. One finds in these hairs peculiar spherocrystals. E1s were by earlier observers quite consistently taken for sugar. According to Thunmann's opinion, they are hesperdine C below, or a body belonging to the hesperdine group. Illustration, fig. 4. Verbascum, thapsiform. 1. Transverse section through the crown tube at the base of the corolla. 2. Transverse section through a crown lobe in the upper part of the corolla. 3. Plan view of the epidermis of the upper surface of the corolla. 4. Plan view of the underside of the corolla, after church esterlet. The pollen grains are round, possess a starch-containing exine that gives them a finely dotted appearance, and has 3 openings for the pollen tube. They are usually so strewn, covered with drops of red oil, that the burst anther appears orange-red. Similar to what some authors also mistake for hesperidin, the spherocrystals mentioned above in the dust-like hairs are found not only in other verbascum species with white filamentous hairs Lavadu, but also in all green parts of Scrofularia. Nodosa Vogel, 1896. In all citrus species when fresh organs are immersed in alcohol for some time, Saxt, Pfeffer, Church, as well as in the epidermis of leaves of Lythrum salicaria, Pilocarpus trichilibus, Lyconium Modorkowski, Adolf Meyer, Thunmann, Church, 8. Husa ad. Meyer, Lamiaceae mentha, Church, Hyssopus, Thunmann, Teucrium, Saturasia Mittlacher, Folium bucco flukiger, Shimoyama, Vicia faba leaves, and Calamintha acinosa, in the flower blade hairs of Viola tricolor L, and in the leaves of Elaeagnus angustifolia L, Hartwich, Bicapsella, Bursa pastoris mica, Baecoculus florifolius Kraus, Solanaceae nicotiana, Church, Tilia Thunmann, Ua Thunmann, considers all these crystalline formations as bodies of the Hesperidine group. They are not sugars. They do not dissolve in water, alcohol, glycerin, ether, chloroform, chloral, concentrated sulfuric acid. D. Concentrated and crystal salt and nitric acid, very hard, and only after several days' action in hot aniline, ammonia, hot acetic acid. They are slightly soluble in lime and barite water, slightly and with a yellow color soluble in concentrated and crystal potassium and sodium lye. For citrus, the macrochemical proof that it is hesperidinical proof that it is hesperidin. Church Österle, Atlas, Lit. Arthur Meyer, Drug Studies, Church Österle. Literature on Hesperidon Crystals. Sachs Textbook, Pfeffer, Botanical Journal, 1874. Has been provided by Tiemann and Will, for conium by Modorkowski. Illustration. Fig. 5, Verbascum thapsiform. 1. Radial longitudinal section through the edge of a hairy filament with pollen thread hairs. 2. Tip of a dust fiber hair. 3. Tip of a dust fiber hair. 3. Pollen grains with pollen tube protruding at the top. 4. Hairs and smooth dust fibers. After 1878-20. Church, Anatomy, Church Esterly, Anatomical Atlas, Krauss, Botanical Annual 1872. Tiemann and Will, Berichts des Chemischen Vereins 1881, 946 Oron. Including Church on the Distribution of Hesperidin in Citrus Species. A.D. Meyer, Natural Science Society in Halle 1882. Hartwich Archives of Pharmacy 1883. Mittlacher Zeitschrift Die Austrian Pharmaceutical Association version 1908. Brammer, Assos. 8 of the French Advanced Science Society 1893. Thunmann, Pharmaceutical Journal 1905. Journal of the Austrian Pharmaceutical Association 1906. Swiss Weekly Journal 1909. Dust particles in various verbascum species. Wessling, on dust particles in Swedish verbascum species. Swedish Pharmaceutical Journal 1908. Chemist. Arbashi contains C10,5 invert sugar rebling. 11. Schneegens, 9.2-11.7. Also some saccharose schneegens, then fat, apple acid mucilaginous substance, and in traces of volatile oil morin, in the C46425.9 Huck. Potassium salts of phosphoric and sulfuric acid, iron and silicon. LSO potassium acetate. In fresh flowers, A. Meyer found only small amounts of reducing sugar. Janssen found in the flowers of V. thapsus, 2.49 mucilaginous substance, 11.76 carbohydrates calculated on dextrin, 5.8 glucose, 1.9 saccharose. There, from bottom to top, a bright yellow layer, followed by grayish-blue, ochre yellow, bright yellow, yellow, light brown, and light gray. The spectrum of the main yellow pigment separated by capillary analysis of the bright yellow zone photographed with a quartz spectrograph exhibits 2 bands at 0.47, 0.45, and 0.45. The NABE 44.25. Sorption in ultraviolet begins at 0.3888 Church, Buss, and Ottenberg. The verbascum pigment belongs to the group of water-soluble anthoxanthines, anthoxanthin Church, anthochlorprantal, xanthion frami, and chlorhids. When a flower leaf of the drug is dispersed in water, with a lot of potassium added, beautiful yellow, often A. G-gregated into rosettes, water-soluble needles, crystallized Church. After washing the preparation with water and adding sulfuric acid, the tissue first turns violet and then permanently red. Solely sulfuric acid colors the yellow cell sap blue, then violet, and finally red. Hesperidin has only been microchemically detected so far, the above. It is a glycoside, specifically the ether of grape sugar rhamnose of hesperitine, the fluoroglucinate ester of isoferulic acid. Illustration. Hesperitine, the coloration of flowers, is caused by enzymes, particularly oxidases. In the roots of verbascum thapsus, Harley found reducing sugars, 0.21, 0.85, and saccharose 0.2, toin on 0.73, lit, rebling. Sugar content of several medicinal bodies. Arch, Farm, 1855, 11. Morin Jern, Chim, Med, 1827, 231. Arch Farm, 1827, 91. Chem, Unters, D. Blumen v. Thapsus, Janssen. The flowers of verbascum, Thapsus, Am, Jern. Schneegens, sugar content of floor. Verbashi, Jern, Farm, FLs, N. Drog. Simple. I-554. Church, comparative spectral analysis of natural and artificial yellow dyes using the quartz spectrography, Verdi D. Butt, just 1904, 414. Buss, Ottenberg. Spectral analysis with the quartz spectrograph on purified and capillarily analyzed DiGu. E. Extracts. Dissertation, Byrne, 1904. Harley, J. Farm, 1905, 49. Odor and taste. The fresh flowers smell repulsive and numbing, and taste bitter and mucilaginous. Confusions. The flowers of V. thapsus are considerably smaller, more bell-shaped than flat. Also, B. Leishnitis has small flowers. V. nigrum has purple dust thread hairs. History. Since time immemorial, the Irish have regarded Phlos verbaceae, and in particular the fresh leaves of the plant, as an infallible remedy against phytosis. The leaves are also smoked in cases of asthma. In the Middle Ages, leaves and seeds were particularly used. According to Schroeder Farm, Med. Chim. IP 890, leaves and roots, as well as flowers, are mentioned. Murray the fern, P 952, specifically used the leaves of the plant. It does not seem to have been cultivated at that time. It is absent in the St. Gallen Abbey Garden, I, P 622, and in Macer's work, I, P 626. Hildegard I, P 669, refers to Watroy. Lowercase letters are set in square brackets. Additionally, an underscore is prefixed, as for example when specifying a specific angle D manual of Pharmacognosy. T as Woolena blendonia. Middle English Medical Books 1, P 683, name it Molin. In the Alfida of Firth, P 642, it is described as Barbastus plasmos. Similarly, in Bartholomeus's work, circa Instans, and the Tabulae Aoi, P 6660, it appears as Tapsus barbatus. Uncommon and no longer used spellings have been left unchanged compared to the original. Foreign expressions were not corrected. Spellings for raw materials, chemical substances, commodities. Handbuch Pharmacognosy Zweiterband, Spezielle Pharmacognosy by Church. Notes on the transcription. The present text has been reproduced as faithfully as possible, based on the 1912 book edition. Typographical errors have been discreetly corrected. Church second volume Special Pharmacognosy Illustration, Leipzig, 1912, published by Victoria. The original was set in blackletter. Special typefaces are indicated in this text using the following special characters: italic, underlines bold, equality sign barred, plus sign small caps, tilde the. Caret symbol indicates a following superscript character. Tauchnitz Church first section, with 237 illustrations in the text, and inserted tables. Leipzig, 1912, published by Chi H. or Herm. U. Tauchnitz. The right of translation into foreign languages is reserved the publishing house second part, Special Pharmacognosy, first section. Not to me, but through common studies, have I prepared these things, thus do not the bees make honey for themselves. See, what are these general points of view? Should we use morphological categories? This would put us in the position of the signature IP 886. Summarizing all roots, leaves, and seeds in chapters together would mean that we are using the related drugs because they are roots, leaves, or seeds. Gessner, Bibliotheca Universalis. Introduction. In discussing the tasks of pharmacognosy, Part P6, I have defined the aim of pharmacognosy as a science as being, in addition to an exhaustive comprehensive treatment of each individual drug, the grouping together of related substances under common points of view. But belonging to a morphological group is indifferent for pharmaceutical use. For the same reason, anatomical structure or inner finer morphology cannot be used as classification principles. We could rather categorize drugs by plant families. Thus, in the end, only the chemical system remains CI, P228. Due to their components, we use drugs. After all, it has been shown that we often find the same or similar components in the parts of a single plant family, and Cisalpini is right when he says, Plantaeque generis societate jungur, plerumque et similis possessent facultates. It's about the components, the faculties, virtues, and powers. However, we also frequently encounter discrepancies here, failing to reconcile the irreconcilable and separating what should be grouped together. Furthermore, the pharmacognostic similarity of species within a genus and of genera within a family is only rarely so great that botanical kinship coincides with pharmacological and chemical affinity. Whether a drug belongs to the Rubiaceae, Zingiberaceae, or Lauraceae is pharmacologically irrelevant, just as it is inconsequential whether it is a root, leaf, or flower, or if it has one or two rows of palisades, or whether it originates from China or Japan. For medical use, only what the drug contains as an active ingredient comes into consideration. If it were the case that every drug only contained one effective component, or only a group of similar components as effective, and if we knew this component for each individual drug, the matter would be very simple. Then grouping drugs according to their components would be the simplest task imaginable. But, as mentioned above, P394, the effect of a drug is often a mixture effect resulting from several different components. Therefore, in some cases, we will need to place the same drug at different points within the system. Additionally, we can only identify or specify the components of a limited number of drugs as effective. The difficulties hindering the grouping of drugs based on chemical criteria are therefore significant, but they must be overcome. For all other systems are not fundamentally sound in this regard. The core only meets the chemical system, none other. I will therefore classify and group drugs from a chemical perspective, thus only including those that have been chemically examined to some extent. Drugs that have not been or have been insufficiently chemically examined do not yet have the right to be included in a scientific pharmacology. They only belong in drug inventories and encyclopedias for now. It seems rather unsubstantial to me that some few drugs can be accommodated at various locations. Well, they are simply mentioned at different places. This is not such a great misfortune, but merely shows us the diversity of relationships of the drug in question. I am very well aware that with the representation I have chosen, something imperfect will initially emerge, as indeed the first systems used by chemists in their manuals were imperfect, but the first attempt will be followed by a second that is better than a third, and as our pharmacochemical knowledge advances, the classification will become all the more accurate, accommodating an ever-increasing number of drugs in a secure place within the system. One can describe the drug at one place, the main location, and only mention it at another. For further information on pharmacochemical systems, see IPP 216F. In any case, Pharmacognosy must no longer remain a collection of drug monographs without intellectual cohesion. And this intellectual cohesion, the text that connects articles and article groups, plays an important role in the following representation. The approach we take in dealing with plant drugs is predetermined by the path followed by the plant cell. Typically, as a result of the assimilation of carbon dioxide, a sugar is produced first. One can imagine the formation of sugar from carbon dioxide either through formaldehyde Bayer or lobe in three phases. In plants, sugar formation also occurs secondarily through polysaccharides or plant acids, as shown below. From the sugar, on the one hand, polysaccharides such as cellulose are formed, gum and mucus, while on the other hand, fats, for the glycerin contained in fats can be derived from grape sugar by adding 4 hydrogen atoms and splitting the carbon chain, just as it reversely becomes glycerol and sugar. And to derive stearin and oleic acid, which are bound to glycerin and most fats, from sugar, one simply needs to assume that 3 molecules of the latter are coupled together via their aldehyde groups, similar to how formaldehyde couples them during sugar synthesis. On the other hand, one can get to olefinic camphor types, cyclic terpenes, retinoids, and phytosterols from carbohydrates. Then a molecule of 18 carbon atoms would result, in which only one shift and removal of oxygen is needed to generate that acid Emil Fischer. However, one can also think of fatty acids indirectly as being built from sugar subunits, inosite fluoroglucin, then follow the unsaturated, ring-closed aromatic substances and their pairings with members of the sugar group, the glycosides, and concluded by the alkaloids. The bridge to the cyclic compounds is formed by the widely distributed hexacyclic saturated inosite, in which the ring closure of a 6-membered system has occurred, one of the first members of the hydroaromatic series, which provides a widespread Vestopterpian class of pharmacognostically important substances in terpenes and resinous acid resins, and also leads to fluoroglucin, CHO3. The teaching and reference books used in pharmacognosy are mentioned in the chapter Pharmacognostic Systems, I, P216, while botanical literature is covered in the chapters Pharmacos and Pharmacoanatomy I, P349, 354-356 are listed. Thus, we progress from the simpler to the more complex, successively treating the drug sugars, starch drugs, cellulose drugs, drugs with aliphatic acids and acidic salts, fat drugs, drugs with essential oils and other odorants, with aromatic phenols, tannin drugs, glycoside drugs, and alkaloid drugs, and in each case, we make a classification according to the chemical structure of the main components. Aspects. Production, export, and import figures are mainly derived from trade reports and export-import lists from London, Hamburg, Amsterdam, New York, Buenos Aires. The chemical literature is cited in each chapter. Some chapters were advised on by profs. von Lippmann and Winterstein for etymological questions. I rely particularly on Grimm, Kluge, and Cangether. Some information is also due to the relevant trade ministries, e.g. Italy, the Department of Commerce in Washington, USA, the German Trade Archive, and other sources such as Tropenpflanzer and Tableau Général du Commerce de France for the data provided by Professor Ed. Sicardo, Syllogia of all known fungi. Volge 13, 1898. M. Holrum, Annual Report on the Field of Plant Diseases. P. Serauer, Journal of Plant Diseases. Further literary references are found in individual sections. Mr. Apothecary Israel kindly took over the processing of animal pests. In every drug, the historical part constantly refers to the Pharmacohistoria in Volume I. There, the sources are to be found. The literature is either cited under each section or at the end of the article. Fisher and Byrne kindly took over the processing of plant pests, and the following works were mainly used. P. Serauer, Handbook of Plant Diseases, 3rd edition, 2nd volume, edited by G. Lindau, Berlin 1908. A. B. Frank, Diseases of Plants, 2nd edition, 2nd volume, Breslau 1896. Von Tubeller, Plant Diseases, Berlin 1895. PA8. Monosaccharides of the hexose type, especially dextrose and levulose, very rarely free-galactose, occur in abundance in many fruits and should hardly be absent from any growing cell. In small amounts it is found in almost all organs as it represents the form in which carbohydrates migrate. Its role in fruits is different. A mixture of dextrose and levulose is formed when raw sugar, saccharose, see below, is split, which is a condensation product of these two hexases, for example, by the enzyme in bee saliva, see honey. The role that sugar plays in the plant is a complex one. In organs that contain such rich quantities of sugar that they can be used to display it, sugar beetroots, sugarcane stems, coconut palm trunks, it is stored in highly developed storage parenchyma, thus playing the role of a reserve substance. It may possibly contribute to the direct protection of seed germination by creating a nutrient-rich seedbed, or perhaps serve to attract birds that eat the fruit, since seeds that have passed through the digestive tract usually germinate more easily. Through cultivation, the sugar content has been significantly increased. The pectin in fruits originates from the intercellular substance of the flesh cells, which is why I have called it protopectin. It is soluble in sugar solution, not in water. Church and Rosenberg. This solution forms a gel in cold temperatures. The starch grains therefore show more or less signs of dissolution corrosion. See the article Sago. The source of sugar in the fruits is partly starch, and perhaps also the abundant occurrence of plant acids, apple acid, wine acid, lemon acid, or tannins in unripe fruits. Perhaps the formation of sugar in fruits is related to pectin formation, which conditions the loosening of the fruit flesh. The conversion of reserve strength to sugar during the flowering stage can be beautifully observed in the sago palm, whose stem strength is dissolved at that time and transported as sugar to the flower cluster formations. On the other hand, these plant acids are probably also stages of oxidative breakdown of the sugar. Fruits with apple acid can ripen in cold climates, but not those rich in wine acid, as apple acid is converted into sugar at much lower temperatures. Lit. Emil Fischer, Synthesen in der Puren- und Zuckergruppe. Vortrag, Braunschweig, 1903 UN. In dried materials, fruit sugar and cane sugar often crystallize out. The microhistochemical detection of hexases in drug cells succeeds easily through the Feeling reaction, first transferred to the microchemical field by Sachs in 1862. Die Chemie der Kohlenhydrate und ihre Bedeutung für die Physiologie. Berlin, 1894. Further reports of the German Chemical Society, 1890 and following. Von Lippmann, Chemistry of Sugars, 1904. Tollens, Short Handbook of Carbohydrates. Chapek, Biochemistry of Plants. In living plants, sugars are always dissolved in cell CP. One immerses a not too thin slice for 10 minutes in a concentrated copper sulfate solution, quickly washes it with distilled water, and transfers it into a boiling solution of potassium hydroxide in water. In cells containing reducing sugars, a red-yellow precipitate of copper oxide forms. The slice can also be directly introduced into the Feeling solution, the cover glass placed on top, and heated to just below boiling point Meyer-Schimper. One uses the reaction discovered by Emil Fischer in 1890, transferred to the field of microhistochemistry by Senft with phenylhydrazine. Krauss, which involves immersing the sections in glycerin or alcohol to bring out the sugar in droplet form, is successful only with very sugary tissues. One places the preparation in a mixture of a solution of phenylhydrazine chloride and sodium acetate and heats it. After cooling, spherets of phenylglucosazone appear in the glucose-containing cells. The reaction also occurs under certain conditions in cells containing saccharose. The direct method by G. Uncertain are the reactions with thymol and sulfuric acid, as well as with naphthol and sulfuric acid, which Molish reported because they occur not only with monosaccharides, but also with substances that under these conditions split off such substances or form furan derivatives. For the quantitative macrochemical determination of sugar, the Allen method or polarimetry is now generally used. Lit. Sachs, Microchemical Reactions. Proceedings of the Munich Academy, 1859, Flora, 1862, and Pring's Journal III. The copper sulfate method was later modified by Flückiger Pharmacognosy, Schimper Instructions for Microscopic Examination of Vegetable Food and Nutritional Substances, 1900 A.R. Senft Proceedings of the Vienna Academy, 1904, and on the microchemical detection of sugar by acetic acid phenylhydrazine. Pharmaceutical Post, 1902. Molish, 2 new reactions for identifying sugar. Proceedings of the Vienna Academy, 1886. Fischer-Princh's Journal, 22. Arthur Meyer, Microchemical Reactions on the Identification of Reducing Sugars. Report of the Botanical Society, 1885. Chapek Proceedings of the Vienna Academy, 1897. And Hofmeister-Princh's Journal, 31, 1897. Poulsen, Botanical Microchemistry, 1881. Dodiwanma. Fundamentals of Histochemistry of Plant Nutritional Substances, 1891. Also see Journal of Physiological Chemistry, 1888. Drugs consisting mainly of invert sugar, or containing a lot of invert sugar. Mel, Sin. Honey. Meal French. Honey English. Meal Italian. Meal Spanish. Honig Dutch. Hunaja Finnish. Mez Hungarian. Hebrew. Shahad. Mad Hindi. Madhu Sweet. Makshika Sanskrit. Asl Aslun Nahal Arabic by Ibn Bathar. Asal Aslun Nahal Arabic by Ibn Bathar. Shahad, Angabin, and Jebin Persian, New Greek. Etymology, the designations in the Romance. Languages are derived from Mel, the Goth, translates the Greek with Milip. Honag, Honang, MHD. Honik, Old Norse Hunang, Swedish Honing, Danish Honing, AG's Hunig, English Honey, Old Frankish Honag, Old Saxon Honig, Hanig, Dutch Honing, Honing. Also altered forms. Klug observes. The origin is not clear. One has thought of Dr. Dust. Honey granular? Honey is a neuter noun still in Luther, also in Lessing. The first masculine use in Kaisersberg. Some writers then waver, so Goethe. Now the neuter form has disappeared. Grimm. Regarding mead, Kluge notes, emch, d, imt, mit, acht, meto, mitu, mead Anglo-Saxon. To this old High German madu sweet, lovely, from which the shift in meaning of Indo-Germanic medhu mead, honey, wine is explained, actually sweet, perhaps a intoxicating liquid. Origin, the bee, Apis mellifica L. Hymenoptera trib. Meo, English mead, Old Norse mjq. The Germanic medur appears as Latin medus, previously a frizz, meets a common German, and also a common Indo-Germanic word id, medhu, skier, madu. Wine Old Slavic medu, honey. Wine, Lithuanian medus mead, medus honey. Irish mid. Aculeata, which is widespread across Europe, Africa, and a large part of Asia in numerous varieties or races, some of which are now considered good species. Specifically the worker bee. Extracts, sucks, 3-lobed lower lip tongue, Fiji, 1s, R nectar from the nectarines of many plants, rarely also from extrafloral nectarines, by means of which the plant forms a sugar-rich liquid nectar as an attractant for insects to ensure pollination. The bee then inverts this nectar in its stomach, honey bladder, crop, fig, 1 using saliva from its salivary glands, whose secretions open into the base of the proboscis A in fig. 1. It mixes with the nectar during suction and enters the honey stomach, where it is emptied for feeding the young brood into previously wax-formed cells. When collecting nectar, pollen from the anthers adheres to the so-called brushes rows of bristles on the inner surface of the tarsus and corbicles, groove-like depressions, surrounded by bristles on the outer side of the hind, shank of the hind legs, and mixes with the honey when it is emptied into the cell. For 1 kg of honey, 5,600,000 clover flowers are required whilst otherwise, an average of 100,000 to 2 million flowers. A beehive produces 10-13 kg of honey. Honey is thus a plant-formed product, reformed by the penicillin in the bee's saliva, often containing pollen grains from the plants from which the bee collected the nectar. Sometimes by microscopic analysis of pollen grains, which are often absent in honey produced from sealed combs, it can be determined from which flowers the bees collected the honey, and, in favorable cases, even if the honey is spring, summer, or autumn honey. For the flowering period of plants is indeed confined within narrow limits. Sucking occurs through rhythmic contractions and expansions of the honey stomach. The pollen grains observed in American honeys are described by Young, who also found Pfister, as in the literature in German honeys. Illustration, Fig. 1. Schematic representation of the sucking apparatus of the bee. SPD salivary glands. Honey stomach esophagus, VK valve, AAON, and also in Winton Molar, microscopy 1906, in honey from Chamonix, Erica, Vaccinium, rhododendron. In a saliva is added church. Villiers et colon alterations and falsifications, p. 842. The pollen grains of the following plants are said to be present in honey: Tilia organum, Lavandula, Melissa, Rosmarinus, Linum, Vaccinium myrtillus, and Ericaceae, Salvia officinalis, Verbascum thapsus, Melalotus, Epilabium, Ledum, and composite Sinanthes as shown in Fig. In so-called toxic honeys from Switzerland, Mingrelia, Pennsylvania, and Carolina pollen grains of Aconitum napellus and Lycoctonum, Andromeda mariana, Calmea, Angustifolia, Latifolia, and Hirsuta, Azalea pontica, and Rhododendron ponticum have been found. Sometimes bees, especially when they cannot find enough flowers, collect the sweet dextrin-rich secretion of aphids that they find on leaves. This often lower-quality honey is called mead-dew honey. Description: honey forms a clear, thick yellow or yellowish-brown liquid, or a more or less cloudy, white mass of dextrose appearing in the microscope as plates and sheets. The color and smell of honey vary according to its source, for example, the smell depending on the type of flowers primarily visited. Honey is sometimes said to take on other properties of the plants visited, so if these are toxic ranunculaceae, aconitum, Ericaceae, Apocinaceae, Nerium, Daphne, Azalea, Datura, Rhododendron, the honey can also become toxic. Honey collected near Cuso gardens in Abyssinia has the deadly properties of Cuso and is used like it. Kebler, 1896, found a body similar to andromedatoxin in toxic honey. Poisonous rhododendron. Honey has also been observed recently in India, Ainsley, Pennsylvania, the Caucasus, and in 1905 New Zealand coon. According to some, the toxicity of a plant has no or only conditional influence on the effect of honey. This seems likely, as nectarines indeed only excrete sugar sap, not toxic substances. However, the secretions from the glandular hairs could easily be stripped off by bees when visiting flowers, and thus, occasionally a fragrant substance or another body formed by the glandular hairs might mix in. Plinius notes that thyme honey has a very good smell and taste, generally much better than, for example, rosemary honey. The Alphita CIP 652 also mentions a mill. Corsican honey smelled like taxus, and was considered of poor reputation in ancient times. Und neuerdings wurde berichtet, dass auch der Eukalyptushonig besondere arzneiliche Wirkung besitzen solle, was sich aber nicht bestätigt hat. Die Blütenhonige sind ebenso wie die Frühjahrshonige heller als die Tannenhonige, die Wald- und Honigtauhonige. In Vorderindien gilt der Honig als der beste, der durch die Bienen von Strobilantes-Arten und Plectranthus rugosus gesammelt wird. Watt. El-Basri weiß bei Ibn Baithar zu berichten, dass die Honige, die von Satureia und die von Absinth stammen, eine verschiedene arzneiliche Wirkung besitzen. Letztere sei auch bitter. Die überseeischen Honige besitzen meist einen wenig angenehmen Geruch und Geschmack und sind auch oft unrein. Aus ungedeckelten Waben ausgeschleuderter Honig ist wasserreicher, daher dünnflüssiger, unreifer Honig. Das spezifische Gewicht des Honigs beträgt etwa 142,1478. Matter, es wird nach Farm, Helv, nicht direkt bestimmt, sondern in Losung 1-2. Diese Losung soll wenigstens 1.12 spes. Having weight. Good honey is durable due to the content of acetic acid. Water-rich honey easily ferments honey wine. Method, CFFIPA 10. Lit. Arnold, The Honey, Its Significance, Value and Use. 1886. Polly, Honey. 1890. Von Verlupschen W. Vogel, Beekeeping at its Current Level. Berlin, 1899. Collecting. The bee either forms a structure in hollow trees or protected places wild bee, or in beehives, and bee colonies from hexagonal, upright cells, combs, wax cells. This is opened by horizontal cuts, and the combs are uncovered. Then the contents can simply run out young honey, runny honey, or the flow can be accelerated by centrifuging centrifugal honey, or by crushing the combs runoff honey, or through pressure and heat-drained honey, pressed honey. The latter is often clarified sieved. Even the other types are often strained through a sieve. Trade types. Lime, heather, fennel, clover, rapeseed, buckwheat honey are quite arbitrary names for good flower honeys. Honeydew forest, spruce honey is less good. The trade distinguishes. Comb honey sheet. Honey with the combs, spreader honey, trickle honey or sink honey, pressed honey, running honey, seeped honey, country honey, stamped honey, country honey. Furthermore, one distinguishes still. Spring honey from the flowers of rapeseed, fruit trees, willows, etc. Early summer honey from the flowers of clover, heteric, etc. Summer honey from the flowers of lime, cornflower, willow, bean, etc. Autumn honey from the flowers of buckwheat, erica, etc. Collected. Already Dioscoride says, the preference deserves the spring honey. After that the summer honey, the thicker autumn honey. Heather honey is of lower quality. Aristotle, on the other hand, considers the autumn honey as the best. Plinius states that the best honey is produced during the time when thyme and grapes are in bloom. Wholesale now supplies a great deal of overseas honey, and such honey is distinguished from that of Chile barrels of 70 kg, Havana, Cuba, Mexico, California, and Hawaii, the latter in cans of 25 kg, packed 2 to a box. From Chile, the most important source, varieties are offered such as white stiff 0 and 0, blonde, yellow, and brown. Production. Europe produces approximately 80,000 tons of honey annually. Germany, where beekeeping is conducted most efficiently, e.g., in Holstein, alone produces 20,000 tons. Spain, 19,000 tons. Austria-Hungary, 18,000 tons. France, particularly Narbonne, 10,000 tons. Smaller quantities are supplied by Italy, Greece, Belgium, Holland, England, and Russia-Poland. Overseas countries delivered approximately 3.25 million kdo in 1907, with particularly large amounts coming from Cuba, Chile, San Domingo, Mexico, Peru, and California. Valparaiso, France. In 1908, Cuba supplied 1,320 tons, Mexico 370 tons, Chile and Peru 700 tons, California and North America 56 tons, and other countries 433 tons approximately. The United States of North America imported 145,691 gallons of honey in 1909, primarily from Cuba, namely 103,092 gallons. France, 1980, 832 quintals, especially from Germany and Chile. Honey is mainly a concentrated aqueous solution of invert sugar, fructose and glucose, containing 6580, often 6573, in floral honeys, and less in honeydew. Honeys invert sugar after 7. Swiss food regulations, water. Imports into Germany in 1909 included approximately 112,000 kg from California and North America, approximately 630,000 kg from Chile and Peru, approximately 1,505,000 kg from Cuba, approximately 370,000 kg from Dominica and Haiti, approximately 220,000 kg from Jamaica, approximately 405,000 kg from Mexico, approximately 331,000 kg from various countries, for a total of approximately 3,573,000 kg in honey. Imports to Hamburg by sea in 1906. Double Centner G. It also contains small amounts of raw sugar saccharose, 2,5, up to 10, dextrins underneath and acrodextrin, up to 4, particularly in conifer honey. Protein substances 0.15-1.8, some colorant, formic acid A. Vogel, apple acid, and mineral substances. Traces of gum-like substances and odors are also present. In total, 1.5 is made up of non-sugar components. The acidic reaction is partly due to formic acid, which constitutes 0.015 of this acid. Ash contains particularly phosphates, 4,10-ash, usually not over 7. In fact, McKen found up to 40 malacetos in lime tree honey. Hayner stated 1885 that natural honey contains 0.01-03 phosphoric acid, while artificial honey only has traces. Light floral honeys are always left rotating, while honeydew honeys and conifer honeys with dark color are right rotating. After the precipitation of dextrin, naturally right rotating honeys become inactive or left rotating. The right rotation is therefore due to dextrin. Dextrins found in conifer honeys seem to be different Hilger and are not related to starch dextrins. Onheim considers honey dextrin as a disaccharide. It was already discovered by Lowitz in 1792 that honey contains a special sugar, i.e., not raw sugar. The Fihey reaction for distinguishing between natural and artificial honey red coloring of the residue from ether extraction with a resorcin solution in fuming hydrochloric acid is based on the fact that non-heated natural honey lacks oxymethylferrol, a degradation product of fructose, which is found in both artificial honey, invert sugar, and starch syrup Kaiser. This reaction is not decisive, Lippmann. Honey always contains enzymes. Markman identifies 3, a proteolytic one, an invertase, 1 SPD. They are absent in artificial honey. Regarding the composition of pollen and nectar, Wilson, von Planta, and Kressling have published findings. Nectar often contains only glucose, or only sucrose, or both glucose and sucrose in varying ratios. Against pollen, as far as investigated, mainly only saccharose Kressling. Amizonzora is absent in pollen and nectar. It is produced by the bee. The honeydew see above contains, in addition to saccharose and glucose, 839 dextrin. The food mixture food sap, which the feeding worker bees insert into the cells of queens, drones, and workers, contains a high amount of nitrogenous substance. Koenig D. Human Food and Pleasure Foods, 4th ed., 1904. They're the most important chemical literature. Brown, Chemical Analysis of Chemistry, 1908. Dort die Honigliteratur, 1892-1907. Pfister, Forschungsbericht, 43, along with fat and glucose C24. Data on the raw sugar content of nectarary fluids by Lippmann, p. 1047, lit. Asterlake, the bee honey, and its substitutes. 1909, they're the literature. V. Lippmann, Chemistry of Sugar Types. Swiss Food, Book 1908, and German Reich Regulations. Elsner, in Real Encyclopedia Examination. 1895 pollen. Ferner. Kuhnmann und Hilger, zur Chemie des Honigs. Forschungsbericht, 1896. A. Beckmann, Beiter Z. Prüfe die Honigs, Zecher, Annal, Chemie 35, Beetplante, Bienenzeit, 1878. U. 1878. U. 1878. 1879. Bishop Jern. Tabelle der Zusammensetz. Bei Villiers Colon, alterat, et falsificat. Benjamin, Farm, Central, 1894. Heffelmann, Zeitcher, Engu, Chem, 1888. Farns, D. Kais, Gesundheitsamtes, 1909. Kuhn, Farm, Zeit, 1000, 1905, S. 642, Giftiger Honig. On pests, Israel reports. The mites that occasionally appear as pests on pharmaceutical products and preparations mainly belong to the family of pyroglyphines. Rohrig Yaris B. D. Farm, 1908. S. 435 U. Kreis, Ibenda Asche, Markmann, Farm, Time, 1903. p. 1010. Monhamun, 1903, p. Furthermore, the literature on the study of food and consumer goods should be compared. Pathology. They live on substances that slowly decompose, rot, are animal or plant-based, in particular sugary ones, and are therefore often found where sugar solutions are fermenting. They can also be found frequently on almost all dried fruits, such as figs, dates, raisins, plums, etc. But not only on these, but also on all possible other dry vegetable and animal substances and raw materials. One often finds some mite species in remarkable mass. Mites usually reach these substances in the wandering larva stage, carried and spread by flies that have these small animals attached to their legs. This beetle lays its eggs in sand, and the emerging larvae climb up on plants and enter flowers. From here, they are carried by the bees themselves, to which they cling with their hairy legs, into the hives, where they crawl into a cell and initially eat the bee egg, and then undergo their further, quite complex hypermetamorphosis. In fermenting raw honey, Glyciphagus domesticus, Tyroglyphus longer, and Cero see the chapter Pharmacopathology. p. 380 are not rarely found, as parasites live in beehives according to Israel. 1. Torrent. Larval stages of Meloe species, particularly those of the well-known common May-bug Meloe proscarabeus, the caterpillars of Galleria melonella, the wax moth, which can cause some hives to collapse. Galleria belongs to the family Pyralidae, a subfamily of Microlepidoptera. The larva undergoes several significant transformations before finally pupating. 2. The beautiful red larvae of the so-called bee wolves, the beetle genus Trichodes, particularly Apiarius. They mainly affect wild bee species, especially the mason bee, less frequently the honeybee. They eat long tunnels through the combs, and often significantly disrupt the bee's hive due to their numbers. They are also occasionally responsible for the onset of American fall brood. The bee moth is very resilient. Tuberculosis bacteria do not affect them at all. Additions and adulterations. If honey is heavily diluted with water in a sediment cylinder, pollen grains and wax particles will settle to the bottom and can be diagnosed microscopically, see above P9. They are regular additives. However, pieces of bee organs and bee larvae, starch and mineral substances that may also be found in the sediment are unacceptable. Adulterants include water, corn syrup, raw sugar, artificial honey, dextrin. Those who engaged in honey adulteration in the Middle Ages were punished by losing a hand or 65 pence. Testing. Apart from microscopic examination, the determination of sugar, water, minerals, acidity, and testing for dextrin, as well as observing the optical behavior before and after inversion, before and after the dextrin's precipitation with alcohol. Required. If necessary, dextrin, nitrogenous substances, and phosphoric acid should be determined, and tests can be conducted on saccharin and coal tar colors. Good testing in Farm, Elvet, IV, Swiss Food Book, and in Schmidt, Textbook of Pharmaceutical Chemistry. Refer to the above for limit values. Honeys with starch sugar or cane sugar additions remain right rotating even after dextrin precipitation with alcohol, while genuine honeys become inactive or left rotating. Artificial honey is usually inverted cane sugar cut with natural honey or perfumed with honey parfum. It typically contains no nitrogen, enzymes, phosphoric acid, or only trace amounts as mentioned above, and no formic acid. However, even strength sugar, first represented by Kirchhoff in 1811, is sold as honey. Lit. Fia, on the detection of starch syrup in honey and fruit juices. Work of the Imperial Health Office 32-1909, Issue 1. Honey was the most commonly used remedy in ancient Egypt, and it is also referred to as a general medicine for humans in the Quran. It formed the constituent of theriacfavern, P551, and was an ingredient in kyphivafern, P473. Today, honey is primarily used as a condiment and food. Large quantities, especially those from overseas, are consumed in the production of gingerbread. In medicine, it is used as a mild laxative and flavor corrector, and also for mouth and throat washes. Oxymel, hydromel, melboraxatum, and particularly melrosatum, are still widely used, some dating back to ancient Egyptian mel composites first, pp. 469 and 539. Topical application, which played a role in antiquity, is no longer popular today. Honey, the use of lavender as a nutrient for diabetics, is now recommended. History. Honey was one of the first foods consumed by humans. Milk and honey was the diet of the gods, ambrosia, which Zeus, the child of the honey nymph Melissa, mixed. With honey, Zeus put Kronos to sleep. According to Norse mythology, dew Hunang's fall honeyfall dripped from the sacred oak and nourished the bees. Honey also held high regard among Semitic peoples. It was not permitted to be used in food offerings. Greek poets sang its praises. Plato mentions honey-glazed fruits as the oldest sacrifice by the Greeks. In Egypt, honey is called ft Coptic ebio and pheo, while in Babylon it is dipu. In ancient Egypt, honey was likely the original sweetening agent used in medicine, and date syrup only entered Egyptian pharmacy through Babylonian recipes, see p. 469. Even the oldest cultural peoples cultivated bee breeding and the production of honey and wax. Long before sugar cane was introduced, honey served as a general sweetener, but it was also used medicinally internally and externally. Even in ancient times, several commercial varieties were distinguished. Dioscorides knows, alongside Attic honey from Hymettus, honey from the Cycladic Islands in Sicily, as well as from Sardinia, and poisonous Pontic honey, which is also mentioned by Xenophon, collected from Azalea pontica and Rhododendron ponticum, or Aedendron ponticum, or A. Datura fluciger dor. Chapters 101-103 of Book 2 of Dioscorides de Materia Medica deal with Melitos honey. Pliny also mentions honey from the island Calydna, Pelignian honey, Crete, Cyprus, and Africa, and finally German honey, Crete, Cyprus, and Africa. The ancient dietary honey drinks were Melicraton honey wine, hydromel-watered honey, aqua mulsa, oinameli mulsum, Melicraton galli, oxyglycon, and oxymel. Hydromel and oxymel were among Hippocrates' favorite remedies. Fermented honey was used to make Met IS 1016. As mentioned earlier, IS 1013, honey was used in antiquity as a preservative for the bodies of noble persons. As Bastian die Völker, des Östlichen Asiens II, 27 reports, this practice is still common in Burma today. Von Lippmann, who provides many historical notes on honey, proves that honey consumption developed particularly among vegetarian peoples. During the Merovingian period, German gardens consisted only of a few fruit trees and beehives, p. 619. The Frankfurt Lizzie from 1450 p.l. High officials are preserved for a year following their death, which requires extensive preparations, and to keep them fresh, they are immersed in honey, considered the most secure method, and also the cheapest. After North America in 1675, Brazil in 1845, and Australia in 1862, 812 mentions Propolio's UL on IE, the aromatic pre-wax of bees, propolis, lit. Von Lippmann, Geschichte des Zuckers, 1890, which includes a history of honey as a precursor to sugar, flowers, Berbashi floss, sin, Gardor, marigold woolly flower, white bouillon, Molaine, Bonhomme, Herbe de Saint-Fiacre, Notre-Dame's candle French, eye taper, torchweed, Molaine, Moline, Moline, Woolline, Woolline, Woolline English, Fiore di Verbasco, Tasso Barbasso, Barbasco, Barbarasco, Barbarastio, Mignatone, Candela Regia Italian, Ocorfarcoro Hungarian, New Greek, Wallkraut, Himmelskerze, Fackelkraut, Fackelblumen, Unser Frauenheil, Himmelbrand, Manwall, Marienkerzen, Osterkerze, Wiln, Zölich, Bullen, Heimelbrand, Königswurz, Königskerz, Wisselma Wohlkraut. Bei Brunfels, Plicatum ist nach Fraß, in Griechenland häufiger, der schwarze Pfund, Sinuatum des Theophrast. Bemerkt, dass die Römer den Phlomos, Verbascum gräzisiert, Berbasculum nennen. Daraus ist dann Barbascum und Verbascum entstanden. Plinius schöpft aus derselben Quelle. Auch der Name Thapsus war in Gebrauch. Ob die und des Gallenwörter Phlomoids ist, wie Dragendorf will, ist mir zweifelhaft. Es wird wohl eine der südlichen Arten sein unter Parallel Drugs. What the of Hermes Trismegistus, Mercury's herb, is, and what the Egyptian Phlomos heteros athal, Kerikion, Onu Rabdon is, remains unknown. In ancient times, verbascum was often confused with the labiate phlomis. This is also suggested by names such as Candela regia, king's candle, torchiola, Mary or Easter candle, while others like woolflowers, woolwort, woolina, barbascum from Barba. In Ibn Bathar, for verbascum species, bizir, sikran el haw, fish-numbing poison, flumis, miknasat el andar, berbashka. Edom, perhaps from to shine, flame, as stems and leaves were used for lampwicks. Plinius, 2574, or because the inflorescence, see Fig. 2 resembles a candelabra, a torch, or a candle. Molin, molin from mollis soft, may also refer to this, or to its mucilaginous content. Thapsus, umbellifer used for dyeing Thapsia garganica, Cixianum du mort, and verbascum phlomoides L. Systematic position, Scrofulariaceae, Pseudozolania verbaceae, sect Geothapsus, 1909, and also Engler Prantl plant families, separate V. From Thapsus and Barbascum, then Tassus barbatus, even Taxus barbatus, as in Crescentia first, p. 678 was formed, which I consider a scribe's error. Staminal plant, Verbascum thapsiform Schrader, V. Thapsus L. var, Thapsiform hook, Bill, V. Phlomoidme, V. Thapsus pole, V. Cuspidatum Schride, V. Phlomoides, the wild-flower-like marsh marigold, from V. thapsiform, the large-flowered species. Schumann notes in Bergschmidt, Atlas, p. 74, G.F.W. Meyer, first expressed the opinion that V. thapsiform Schrader should not be specifically distinguished from V. Phlomoides L. We can readily agree with this view, held also by Franchet and Flückiger, as the leaf-based characteristic is hardly sufficient to grant our plant a status, other than perhaps that of a variety. In any case, they are very similar, and both flowers are explicitly permitted, e.g. by Farm, Helvet IV. Thapsus, 2 longer stigmas 1-2 times as long as their drooping stigma sacs. Stigma-based drooping, spatulate. V. thapsus. Thapsus, otherwise like that species. V. phlomoides, 1-2 m tall, stem erect and rigid, simple or with single upright branches. Leaves elongated oval, toothed, lower and upper parts of middle leaf extending downward very differently. Crown flat, about twice as large and paler than in V. I am separating them here without taking a position on the issue. Schins-Keller described V. thapsiform, 3180 cm tall, leaves elongated, elliptical, toothed, yellow fuzzy, each leaf extending downward to the next lower one. Flower stalks shorter than the calyx, crown radially symmetrical, twice as large and brighter yellow than in V. Conversely, its flowers, common mullein, seem to be used in North America, where the plant reaches enormous heights, over 7 feet. Also V. phlomoide is found presumably introduced in the United States, for example, in Massachusetts. Illustration, Fig. 2. Verbascum phlomoides L. Lee. In the first year, only a large rosette of leaves develops, and in the second year, the inflorescence appears. As necessary as it is to use authors when naming plant drugs, Holmes, P.H. Jern, 1900, 1418, demonstrated with verbascum. There are 5 von Boisdale, Bith phlomoides, L. V. blomeratum, Blaise V. Borhaviel V. montanum Schrad, V. bosientum Bois, and 2 V. thapsiform V. thapsiform Schrader, and V. thapsiform Gus. The marshmallow is a magnificent plant of great beauty. Its straight, candle-like stem with large gray leaves and the long, flower-covered inflorescences make it one of the most characteristic plants in our florafig. 2. Verbascum thapsiform Schrad, as well as V. phlomoides L. are biennial. The spirally arranged leaves are oblong, or narrow inversely egg-shaped, usually seeded, with their base gradually descending to the next leaf, lobed, pointed, and thickly velvety due to numerous tufts of hair. The detached wool hairs are used as tinder. The flowers of V. thapsiform are united into dichasias, which in turn form a so-called floral tail, sitting on a long inflorescence axis. They first appear individually in the axils of the spiral, pointed, and descending outer bracts, the bracteoles of the inflorescence. Fig. 3d. The first flower fig, 3. Soon after, 2 or 4 flowers, 3-3, 5-5, also with bracteoles, emerge from the axils of these latter bracteoles. However, before these 2 or 4 form a 3 or 5 petaled dichasia, As the flowers unfold from this dichasia and from petal D under flower 1, a lateral bud develops as a richness shoot. In the simplest case, this richness shoot is single-flowered. However, usually, between the first flower that opens 2 and petal D, a second flower 4 forms. Sometimes additional flowers without petals 6 can also be found in the axils of the upper, older petals. These are the last to bloom. Due to the very different ages of the flowers, usually only 1 or 2 of these partial inflorescences bloom at the same time. But as they all come into bloom one after the other, in the order of the numbers, a flower stalk of Verbascum thapsiform remains in bloom from top to bottom for weeks. Here, a flower opens. There another Schumann and Church Esterle, anatomical atlas. The Damascepalus cup-shaped, 5-petaled calyx is densely hairy on the outside, with a length of 6-8 mm. The 5 lobes are lanceolate, elongated triangular, and show an ascending Dachshaus-Nospin arrangement. It is zygomorphic. The hairs are either glandular hairs with often very numerous secreting cells, or stellate hairs with 1/4 tiers bushy hairs. The summit star has 3-6 rays. Such hairs also occur on the leaf blades. The ovary is egg-shaped. Illustration, Fig. 3. Above, diagram of a partial inflorescence in the axil of the cover leaf D. The circles represent the flowers. The numbers 1-6 indicate the flowering order. In the middle, a sliced corolle. Below, complete bloom in longitudinal section. After Church Esterle atlas, the also median zygomorphic corolle, which detaches very easily, is radially symmetric, 5-petaled, sympedalous, with a width of c. 3.5 to 4 cm, sometimes even 5 cm in the median. At the base, the 5 leaves are fused into a short tube. The tips are almost circular. They overlap like roof tiles in descending order of preference. The lower petal lobe is often significantly larger than the 2 lateral ones. The 2 upper ones are often 13 smaller than the lower. In the tubular part, the corolle is thick fleshy. The 5 stamens are inserted slightly above the tube of the corolle. They alternate with the lobes. They continue the zygomorphic character of the corolle to a greater extent. The 3 upper ones are differently shaped from the 2 lower ones. The 3 upper ones are approximately 6 mm long. They have a kidney-shaped transverse anther with summit slits and are densely covered with long hairs from the middle to the tip of the filament, so that when observing the fresh flower from above, one sees the entire tube filled with a hair fuzz. They thus serve as a kind of signal to the insect visiting the flower that nothing is to be gained further down in the flower, and they point it to the vivid red anthers. The hairs are supposed, according to Herm Müller, to serve besides the red pollen as a lure for insects. Perhaps, remarks A. Meyer, they exude some palatable substance or are themselves good food. Observations by Thunmann disprove this. Never were any hair fragments found chewed away. So, for the bees, who are the main visitors to the queen of the meadow since they lack nectaries, only the red pollen grains remain, and these are what they collect and use as food for their brood. The Verbascum flower belongs to the pollen flowers. The 2 lower stamens are about 10 mm long, usually quite hairless, and bear the 3-4 mm long anther on the inner side of the tip of the filament. So varied is their structure compared to the hairy stamina, the cross-section through the anther of the long variety looks almost identical to the longitudinal section through the anther of the short variety C, anatomical atlas. The ovary is egg-shaped, approximately 2 mm long, and 2-chambered. The style is only hairy at its base, about 12 mm in length. The unequally sized stigmas are only indistinctly separated from each other. The stigma papilla layer extends a short way down the style. The capsule, which opens radially, can be up to 1 cm long and 8 mm wide. The seeds are cylindrical. The fruit consists only of the floral crown with its attached staminate threads. V. plomoides is widespread across Central and Southern Europe. It grows from France to Denmark and Russia, from Spain and Italy to Crimea, in the Himalayas from Kashmir to western Tibet. Thapsiform does not extend as far south, and is particularly found in Central Europe. V. plomoides is much rarer than V. thapsiform. Both are often found in the same areas. Both produce numerous bastards, see Pabst cooler, medicinal plants. They prefer road verges, dry hills, and heaths, as well as stony, uncultivated places and light woodland. They flower from early July to mid-October. Lit. Schrader, Monager, Generis Verbaceae, Göttingen, 181-23. Franchet, Études sur les verbascum de la France et de l'Europe centrale. Vendôme, 1875. Illustration of V. Lavadu, see below. Pathology. Various parasites occur on verbascum, such as Peronospora sordida Burke, Erisif, Sicorisarum DC, Uromyces scrofulariae DC, and others, yet these are likely to have no significance for the flower's ed. Fisher. On animal pests, Israel reports 1. Beetles, Fapsiform in Berg-Schmidt Atlas. 2nd ed. Plate 26 also includes floral literature. Of V. Phlomoides in Pabst Kohler, medicinal plants. Plate 45. Eichler, flower diagrams. Eichler, flower 1851. 400 and L. Meyer. A. Meyer, drug knowledge. Herm, 11. A. Meyer, drug knowledge. Miller. Fertilization of flowers, 1877. 272. Bruchus marginellus fabra. Larvae in flower buds of verbascum species. Sionis scrofulariae L. Sionis verbaceae FB. Larvae skeletoniza. Larvae on flowers and leaves of Antirrhinum and verbascum species. Gymnotron fapsicola germ. In southern and central Germany on verbascum species. Clitus verbaceae fabra. Beetles, frequently on verbascum flowers. Whether the larva lives in verbascum stems is questionable. Longitarsis verbaceae pans. Larvae mostly in long curved leaf mines in leaves of verbascum thapsus and phlomoides. 2. Melitea trivia WVV, caterpillar, in southern Germany on verbascum thapsus and other verbascum species. Gortina flavago HB. The caterpillar lives in the robust stems of many plants, including verbascum species. Cuculia verbaceae L. Cuculia scrofulariae WV. The beautiful caterpillars of these butterflies feed on the leaves, flowers, buds, and seed capsules of verbascum and scrofularia species. Cuculia thapsiphaga Tier. The caterpillar of this rare butterfly also feeds on verbascum species. Polia xanthomista huben, caterpillar on verbascum and Selene species. Acronecta euphorbiae, WV caterpillar, on Plantago, euphorbia, and verbascum species. In addition to these, a large number of polyphagous owl caterpillars also feed on verbascum species. Cultivation and collection. Verbascum species are cultivated in rural gardens in Germany, Austria, and Switzerland, and even occasionally supplied to pharmacies, and are often a component of Apothecary Gardens IS 550. The Moscow Governorate collects the flowers from wild-growing plants. As special cultural sites in Germany, the following are to be mentioned. Horb-Württemberg, Neudorf-Bruchsal, Schweinfurt-Schwebheim, Rethlein, Aachen ad Elbe, Ballenstedt a Harz, Loberen, Schwarzenfeld-Naburg, Sonderburg-Alsen. CFI P63. In Hungary, the flowers of V. Phlomoides are collected on a larger scale from wild-growing plants, B. Peter, but they also come from cultivated sources. Austria also exports Flos verbaceae. Upper Austria cultivates these plants in larger quantities. In Russia, the Poltava Governorate produces Flossverb, rust. Flowers, whose enzymes have been killed, retain their color Perot and Goris. Since flowers absorb water easily, they are preserved over lime. They also need protection from light. The petals are sieved. Anatomy of the flower. Only the flower crown with its attached pollen threads is harvested in July and August, on sunny days with dry weather and dried rapidly in the sun, or spread out in a thin layer under artificial heat, which should not exceed 30-35, with removal of artificial heat, which should not exceed 30-35. Water vapor, but always with good ventilation, otherwise they by oxidase turn brown. In the tubular parts, the corolla is hairless and shiny on both sides, almost colorless below and yellow above. The epidermal cells on both surfaces are slightly elongated. Fig. 4. The cuticle on the upper inner side is folded in wave-like patterns. The epidermis of both leaf sides, and only these contains, in addition to small yellowish chromatophores, both sides' epidermal cells, approximating the outer surface, have a small, bright, highly light-refracting droplet. Fig. 4 drops, which does not dissolve in chloral, acetic acid, potassium, or alcohol, but does dissolve in hydrochloric acid and sulfuric acid, and is not colored by osmium acid. These drops account for the peculiar luster of the leaves, which the colonel mistakenly attributed to nectar emerging from stomata. He confused the shiny epidermal cells with honey droplets. Nectaries are absent. The outer side of the leaf is densely covered with multi-tiered star hairs, bushy hairs, which have 2-3 tiers. The terminal star has 3-6 rays, and the tier stars have 3-5 rays. Embedded in the fabric are here and there round or elongated secretion cells with a corked wall, which, embedded in a homogeneous or delicately fibrous mass, contain very small droplets that turn black with osmium acid and are probably essential oils. The mesophyll is relatively thick in the tube parts of the flower, but becomes thin-layered in the crown lobes. It consists of a thin-walled, sometimes quite well-ventilated parenchyma that appears white in the dried state, whose cells often still contain starch grains connected to the chromatophore. The hairs of the 3 upper stamina are quite long but remain single. They are culinforming at the tip and show numerous rough, often arranged in rows, cuticular scales, Fig. 5.2 on the surface. In the dried state, they are often curled or twisted together into bands. The crown tube is traversed by 30 bundles, 5 of which enter the filaments of the stamina, each into one of the crown tips, branching off here richly. In the epidermis of the filaments, in addition to yellow cell sap, warty red chromatophores Fig. 5 triero are found, which turn yellow with sulfuric acid, while the cell sap turns blue, sometimes already in the dry state, better in flowers that have been fresh in alcohol. One finds in these hairs peculiar spherocrystals. The same ones were by earlier observers quite consistently taken for sugar. According to Thunmann's opinion, they are Hesperidin, see below, or a body belonging to the Hesperidine group. Illustration. Fig. 4. Verbascum thapsiform. 1. Transverse section through the crown tube at the base of the corolla. 2. Transverse section through a crown lobe in the upper part of the corolla. 3. Plan view of the epidermis of the upper surface of the corolla. 4. Plan view of the underside of the corolla. After Church Esterla, the pollen grains are round, possess a starch-containing exon that gives them a finely dotted appearance, and has 3 openings for the pollen tube. They are usually so strongly covered with drops of red oil that the burst anther appears orange-red. Jabarandi Holmes, Petalea trifoliata, umbellifers like Conium Modorkowski, Adolf Meyer, Thunmann, Church, Aethusa Adi, Meyer, Lamiacie Menta, Church, Hisopus, Thunmann, Teucrium Saturasia Mittlacker, Folium bucco flukiger, Shimoyama, Vicia faba leaves, and Calamintha acinosa in the flower blade hairs of Viola tricolor L, and in the leaves of Elaeagnus angustifolia L. Similar to what some authors also mistake for Hesperidon, the spherocrystals mentioned above in the dust-like hairs are found not only in other verbascum species with white filamentous hairs Lavadu, but also in all green parts of Scrophularia. Nodosa Vogel, 1896. In all citrus species when fresh organs are immersed in alcohol for some time, Sachs, Pfeffer, Church, as well as in the epidermis of leaves of Lythrum salicaria, Pilocarpus trachylobus, in Aleppogallan Hartwich, by Capsella bursa, Pastoris mica, by Coculus lorifolius kraus, Solanacea nicotiana, Church, Tilia Thunmann, Ue Thunmann, considers all these crystalline formations as bodies of the Hesperidin group. They are not sugars. They do not dissolve in water, alcohol, glycerin, ether, chloroform, chloral concentrated sulfuric acid, concentrated in crystal salt, and nitric acid, very hard, and only after several days' action in hot aniline, ammonia, hot acetic acid. They are slightly soluble in lime and barite water, slightly, and with a yellow color soluble in concentrated and crystal potassium and sodium lye. For citrus, the macrochemical proof that it is Hesperidine has been provided by Thiemann and Will. For conium by Modorkowski. Illustration, Fig. 5, Verbascum thapsiform. 1. Radial longitudinal section, through the edge of a hairy filament with pollen thread hairs. 2. Tip of a dust fiber hair. 3. Pollen grains with pollen tube protruding at the top. 4. Hairs and smooth dust fibers. After Church Esterle Atlas. Arthur Meyer, Drug Studies. Church Esterle, Anatomical Atlas. Church, Anatomy, Lavadu. Research on the Anatomy of Verbascaceae. Thesis. Paris 1902. Published there. Literature on Hesperidian crystals. Church. Anatomy. Church Uesterle. Anatomical Atlas. Borden. Proceedings of the Natural Sciences Society in St. Petersburg, 1883. Modrakowski, Polish Archive of Biology and Medical Science, 1905 by Thunmann. Krauss, Botanical Annual, 1872. 2. Timon and Will, Barrett's des Chemischen Vereins, 1881, 946, including Church, on the distribution of Hesperidian in citrus species. Thunmann, Pharmaceutical Journal, 1905, Journal of the Austrian Pharmaceutical Association, 1906. Swiss Weekly Journal, 1909. Dust particles in various verbascum species. West Swedish Pharmaceutical Journal, 1908. Chemistry. The Flores Verbaceae contains C. Admire, Natural Science Society in Halle, 1882. Hartwich, Archives of Pharmacy, 1883. 1883. 1888. 1888. 1888. Vogel, Pharmaceutical Journal, 1896, 109. Mittlascher, Zeitschrift die Austrian. Breimer, Associate of the French Advanced Science Society, 1893. 1050 invert sugar rebling. 11 Schneegens, 9.2 11.7. Also some saccharose Schneegens, then fat, apple acid, mucilaginous, phosphoric, and sulfuric acid, iron, and silicon. Also potassium acetate. In fresh flowers, A. Meyer found only small amounts of reducing sugar. Janssen found in the flowers of V. thapsus 2.49 mucilaginous substance, 11.76 carbohydrates calculated on dextrin, 548 glucose. The capillary analysis of the extract shows, in order from bottom to top, a bright yellow layer, followed by grayish-blue ochre yellow, bright yellow, yellow, light brown, and light gray. The spectrum of the main yellow pigment, separated by capillary analysis of the bright yellow zone photographed with a quartz spectrograph, exhibits two bands at 0.45 and 0.45 Vin. The end absorption in ultraviolet begins at 0.388 Church, Buss, and Ottenberg. The verbascum pigment belongs to the group of water-soluble anthoxanthines, anthoxanthin Church, anthochlorprentyl, xanthan frami, and chloes. When a flower leaf of the drug is dispersed in water, with a lot of potassium added, beautiful yellow, often aggregated into rosettes, water-soluble needles crystallize Church. After washing the preparation with water and adding sulfuric acid, the tissue first turns violet and then permanently red. Solely sulfuric acid colors the yellow cell, that blue, then violet, and finally red. Hesperidian has only been microchemically detected so far, see above. It is a glycoside, specifically the ether of grape sugar rhamnose of hesperetin, the fluoroglucinate ester of isoferolic acid. Illustration: hesperetin, the coloration of flowers, is caused by enzymes, particularly oxidases. In the roots of Verbascum thapsus, Harley found reducing sugars 0.2, 1 0.85, and saccharose 0.2, 1 0.73. Planchon Collin Drogue, simple. I-554. Church, Comparative Spectral Analysis of Natural and Artificial Yellow Dyes Using the Quartz Spectrography, Berdidi Bot, Jess 1904, 414. Plus, Dyes, Research Report 1896. Rebling, Sugar Content of Several Medicinal Bodies. Arch, Farm, 1855, 11. Morin, Jern, Chim, Med, 1827, 231. Arch, Farm, 1827, 91. Chem, 1827, 91. Chem, 1890, 600. Schneegens, Sugar Content of Flor. Verbaceae Jern, Farm, F. Else, Lauter, 1898, 17. Ottenberg, Spectral Analysis with the Quartz Spectrograph on Purified and Capillarily Analyzed Dye Extracts. The fresh flowers smell repulsive and numbing, and taste bitter and mucilaginous. The dry flowers smell pleasantly of honey and violets, and taste sweetly. Confusions. The flowers of V. thapsus are considerably smaller, more bell-shaped than flat. Also V. lichnitis. Since time immemorial, the Irish have regarded Flos verbaceae, and in particular the fresh leaves of the plant, as an infallible remedy against phytosis. The leaves are also smoked in cases of asthma. In the Middle Ages, leaves and seeds were particularly used. According to Schroeder Farm, Med. Chim. IP 890, leaves and roots, as well as flowers are mentioned. Murray I, p. 952, specifically used the leaves of the plant. It does not seem to have been cultivated at that time. Similarly, in Bartholomeus's work, Circa Instans, and the Tabulae p. 660, it appears as Thapsus barbatus. It is absent in the St. Gallen Abbey Gardenoi, p. 622, and in Macer's work I, p. 626. Hildegard I, p. 69, refers to it as Wollina blandonia, Middle English Medical Books Verd, p. 683, name it Moling. In the Alphetoi, p. 642, it is described as Barbastus flosmos. 664 refers to it as Flomos vel flosmos, Thapsus barbatus. The Nördlinger Register 1480 lists it as Tassibarbesi, and the Braunschweiger Inventar 1522, Ib. p. 815, as Thapsus verbatus. Verbaci, Thapsi verbati, Wohlkrautlum, Konikertsblumentot. Before the 15th century, blooms in Germany do not seem to have been used medicinally. Parallel drugs. In southern Europe, similar verbascum species are used. In Portugal, Verbascum crassifolium H. et al. In Italy, V. densiflorum B. In Spain, V. micranthum H. et al. Flukiger. In America, V. thapsus. Also in North India, this species, which occurs in the Himalayas from Kashmir to Bhutan, and is known as Fula or Gidar tamaku, nicotine tobacco, is used, but mainly the leaves and seeds pharmacognosy. And even in France, V. thapsus seems to be preferred planchon colon. For the use of verbascum species as fish poisons, see under saponin drugs. The flower crown does not come into consideration here. Bathia blooms. Mahua mahula, janglimova, sansk, maduka, i.e., sweet. CPL 8 produces in India the forests of Mongir in central India and the Satpura range in the west, several hundred 150-200 kg, 100 kg, 200 kg of fleshy petals per tree, which yield up to 60 liters of alcohol. They then fall off naturally and are easy to collect. They appear from time to time in commerce, and are especially exported to France, England, and America. They taste very sweet, like raisins. They contain only invert sugar lipman, up to 50 castle and rice, or 63 poisson, and produce especially in Gujarat and Rajasthan fermented alcohol. By Lipman, Bear D. Shem, Jess 1902. Bear the Lit. Watts Dictionary. Lockwood. Notes on the Mahua Tree Journal. Lynn. Sock. Visti Septent, 1879. Castle and Rice, 1881. Poisson Bull. Soc Gilbert, de France, 1881. Tropenpflanzer, 1909. Although religion forbids Hindus and Muslims from drinking alcohol, alone in British India, during the years 190,708, 9 million gallons of spirits were produced for the indigenous population, mainly from Basia petals Mahawa. For example, in Dadar and on the Uran Peninsula near Bombay, where alone there lie 19 distilleries. Fruits and fruit clusters. Carakai, Sin, figs, fig old, Vige vague medieval, figs French, figs English, Fici Italian, Vijig Dutch, Ficija Hungarian. Victuna Finnish, the fruit, the tree, ancient Greek. The hieroglyphic signs for fig are reproduced on P468. Ficus, e.g., at Plinius, Celsus, and Caperficus, Tina, Tena Aram, Ten Arab, Tien Heber, Anger Hindi, Bengal. Stampflanza ficus, Carica L. Cultivated fig forms, countless cultivated varieties near Naples. Leucocarpa, dotata, columbra, polymorpha, pachycarpa, deliciosa, Ipoluca, Gasparini. The fruit was called tab, the tree often nauhi nel tab, i.e. sycamore with figs. The fig tree is also written db, deb, deba, deb, thereby the fig, nan bet, the small fig. At Theophrast taerina sica wild fig, the unripe fig, Olinthos at Galen, lat. Semler lists the following cultivars. San Pedro in Sicily, Fico di San Pietro in Italy and Dalmatia. Brown Turkish, climate hardy, brown or black Ischia, white Ischia, Igo Breba in Spain, Angelica, Meri, Otalo in Sicily, white Genoa, white Smyrna, white Adriatic in Dalmatia, Italy, and California. Gentile in California. Also see Muller. Article Ficus in the Real Encyclopedia of General Pharmacy. Description of the parent plant. The cultivated fig is a large shrub, or a much-branched tree figs. Not all these varieties are suitable for drying. Some only provide table figs. Edem carica e.g. in the Alpha, Caricae by Plinius, a variety of figs originating from the region of Carian, opposite Rhodes. Fig is indirectly derived from ficus, perhaps from Cohen. However, both may have a Semitic origin, from Shikuma, and ficus from Pagi. Figi, like other southern European tree and fruit types, comes from Roman Latin, specifically North Italian Provençal figa, which also gives rise to French figue. Systematic position, Moraceae, Artocarpoideae Physae sect, uses. The genus Ficus linnae, general plant, includes approximately 600 species. Dragendorf lists 61 used species. It has a very peculiar appearance, especially when unleafed, with branches bending outward then inward, giving it a unique, round, bizarre, eerie look. The rather large, rough, blue-green leaves are peculiarly lobed, 3 to 5 lobed fig leaf, and alternate. In their axils arise peculiar cup-shaped receptacles, whose inner wall is lined with the flowers, and which have an ostial eye at the top. These flower clusters develop into the fig, which is therefore not a fruit, but a fruiting body. Often, numerous fruit clusters are seen protruding closely together from the bark, on the trunk, and thicker branches. All parts are penetrated by unsegmented milk tubes. Since one cannot see the flowers from the outside, the Chinese called the fig fruit, without bloom, see above, and even Albertus Magnus says, it bears fruit without flowering. The cauliflory of the fig, which Pliny already mentioned, is also found here, as in many tropical ficus species fig. 7. Caproficus is virtually pure male, due to complete sterility over 2 generations of flowering, and very poor seed yield in the 3rd generation resulting from the formation of so-called gall flowers. The cultivated fig is purely female due to the absence of male flowers. Fertilization is mediated by fig insects, particularly Blastophaga grossorum gravenhorst, Cynips Seamslelt. A chalcedid wasp acts as an inquiline and transmits pollen. The gall flowers, Gasparini in the ovary through the short style. After Solm's view that the wild fig caproficus, Caprofico, Profico, and the cultivated fig ficus, which were already well distinguished from each other in antiquity, should be considered as 2 different races, of which the cultivated fig is derived from the wild fig, was proven erroneous. It is now generally assumed based on Fritz Miller's observations on figs in South America, and Solms also agrees with this that, as Linnaeus intended, Caprificus represents the male fig, and the cultivated fig represents the female fidge. The inquilines develop only in the short-styled gall flowers on male plants. They find ripe pollen upon leaving the fig, and carry it to the female figs of female plants where, since the flowers here have long styles, without being able to lay eggs themselves. Illustration, fig, 6, fig tree with leaves. After Hamilton, Dutch. The overwintering mam of the Caproficus contain only female galls, and thus the overwintering generation of Blastophaga, which later develops into Profici, does so in the lower 2/3 of galls for the tenant generations, in the upper third, near the mouth with numerous male pollen-producing stamen flowers that last for months. A small Asian fig tree just before harvest. W. Tiedemann thought, but for the fig, less importance is placed on the fertilization of the flowers than on the development of the fleshy receptacles. Within the inflation of the Caproficus, Protandrous dichogamy Gasparini prevails. Given that the pollen ripening of the Caproficus's stamen flowers and the conception ability of the stigmas of the female flowers of the cultivated fig coincide, fertilization of the latter through insect mediation is ensured. Illustration, Fig 7. Both seem not to be in direct relation to each other in the culture of the fig cavallini, as is also the case with many fruit varieties where seed formation and fruit development are independent. We know about seedless fruits. Nonetheless, in commercially grown figs, seeds are almost always present. However, traces of animals are very rare. It is stated that the females of Blastophaga, after arduously making their way through the ostiole, often leaving their wings behind, do not leave the calyx of the inflorescence again, as they cannot take the return trip due to the inward-facing scales of the ostiole rim. But this cannot be correct. They must repopulate in most cases, as commercially grown figs typically do not contain them. I have examined many figs and never found an insect or its remains inside. Illustration: fig culture in the Mediterranean region. From Ravicini, The Fig Trees of Italy, Bern, 1911. From Ravicini, The Fig Trees of Italy, Bern, 1911. Illustration: relationships between the three fig types according to Church and Ravicini. Explanation of symbols: insect paths, pollen transfer, edible fruit clusters, male flowers, doll flowers, scattered female flowers, scattered male flowers. Caprification is very ancient and may be considered an invention of the Semites of Syria and Arabia. The two usual forms are described by Plinius. For the countries that do not practice it, or have ceased to practice it: Egypt, central and northern Italy, Sardinia, Corsica, northern Spain, southern France. Yet, it seems necessary for certain cultural races, as experiments in California have shown. For successful fertilization, it seems that caprification, i.e., hanging blooming caprifig branches or garlands in the crown of the cultivated fig or intermediate plants of Capreprofis, Algeria, Tripoli, Syria, Caucasia, Greece and Greek islands, Malta, Sicily, parts of southern Italy, particularly Naples, Calabria, Catanzaro, in Spain, Andalusia, Valencia, Extremadura, Murcia, and southern Portugal. Therefore, the caprificus, or wild fig tree, is planted where the wind blows through the fig gardens, so that it may bring flying insects to the fig trees. Another method has been discovered, namely, to tie the figs together when brought from elsewhere and place them on the tame tree. Theophrast, a primary source for Plinius, also discusses caprification. Both recognize a connection with insects, as does Aristotle. However, it was only Linné in 1744 who recognized the significance of insects for reproduction and the formation of mature seeds in ficus long before Sprengel. Solms suggests that the caprification is a gardening operation necessary in long past times, now hardly useful, preserved in its same form through living tradition from generation to generation until today. Whether parthenogenesis also occurs in Ficus carica remains to be investigated. Another operation is oiling, the Italian obliazione, which involves smearing oil onto the ostiole. One drops a bit of olive oil onto the ostiole using a straw. It was already known to the ancient Jews and also to Theophrast. It appears possible, as for example in Ficus roxburghi, neither an ovary nor antipodes develop normally, and the embryo arises from the nuclear tissue Cunningham. The matter is not difficult to decide. One simply needs to enclose unripe figs in a well-closing mesh bag, leave them to ripen, and examine whether mature fruits are also formed. This practice is still followed today in Italy, Syria, Spain, and Provence, bringing fruit clusters to maturity earlier. Lit. Mico, Prod, Monager, Bitumen, Hookers, London, Journ, of Bot, Vano, Vasperini, publications mostly in the Acad. Di Napoli and Cavallini Opuscoli, both cited by Solms. Tournefort Rye, p. 905. Count Solms Lobach, The Origin, Domestication, and Spread of the Common Fig Tree, Abhandel, D. Göttinger, des die Wissenschaft, 28, 1881. Also separate edition, 1882. There is further literature on this topic, also. Gender differentiation in fig trees. Bot Zeit, 1885, cited in Bot, Jarisber, Troib D. The Female Organ and Embryogenesis in Fick, Herta. Anjard, Bot Beatens, 1902. Fritz Miller, Caprificus and Feigenbaum. Cosmos Jude 82, Ref. Bot, Jarisber. King, Observations on the Genus Ficus, Journal of the Linné Society 24, and Annals of the Royal Botanical Gardens, Calcutta, 1887. Schweinfurth, Bulletin de l'Herbier Boissier, 1896. Westwood, Description of the Insects Infesting the Seeds of Ficus carica, Transactions of the Entomological Society, 1882. Yares B. P. Mayer, On the Natural History of the Fig Insect mit Zool, Stat Dort. Neapel III, 1882. Mayer and Fritz Miller, On the Natural History of the Fig Insect, Cosmos 12, Ref. Bot, Jarisber. Church and Esterly, Anatomical Atlas. Illustrations in Berg-Schmidt, Atlas, 1st edition, Bentley Tryman, medicinal plants, and Zippel-Bowman, wall charts. Cercospora boleana thum occurs on leaves and fruit bodies, leading to premature falling. Also observed is a botrytis that penetrates the fruit bodies, forms its canidia there, and then spreads to the branches. Fisher. Among the fungi that infect and destroy the fruit bodies of the fig tree, the following species are particularly notable. Coletotrichum carica Stevens et al. Zeitschrift für Pflanzenkrankheiten Dictionary 1909, p. 65. Causes the fruit bodies to rot and fall off prematurely. The flesh of ripe figs in trade is sometimes dotted with a black, slightly slick spore mass belonging to a fungus that Reichardt verhandelt. Zoolog, Botan, Giselsch, Wingset in 1867, considered a eustillagene, and named Uschulagoficum. It has spread from east to west even before historical times, when it was not yet an cultivated plant hain. In early history, fig cultivation was probably limited to Syria, Egypt, Arabia, and Babylon. Hennings Hedwigia Darktinortort, 1895. However, demonstrated that it is an aspergillus species, which must be named Sterigmatocystis ficum Reich, P. Hen. Occurrence and cultivation. Schweinfurth considers the still-occurring Ficus palmata Forst, F. pseudocarica, Hochst, as the ancestral form from which cultivated figs originated. The original home of the fig is sought by Solms in South Arabia. From there, it was brought to Idumea, Coel, Syria, as well as Babylonia and Egypt, where it was domesticated. Ficus carica, however, already existed during the Quaternary and Flood period in the western Mediterranean region. Even a ficus is found in Cretaceous Greenland. The fig culture then spread later from northwestern India, and the East Arabian steps over the countries around the Caspian Sea, Upper and Middle Mesopotamia, Syria, Palestine, and Asia Minor. It is also cultivated today in China, northwestern India, the Deccan, Beluchistan, California, Canada, Mexico, and Chile. In California since 1901, increasing in quantity. The most extensive fig cultures are found in Asia Minor, in the district of Aden, around the Menderes-Tehe meander, with large fig gardens also located near Ayazluk, Ephesus. By culture, the fig is likely to have been spread by the Semites of Syria over the whole Mediterranean area, then later crossed the Alps and reached England. It survives in sheltered places over winter, at the southern tip of the Swiss lakes, in South Tyrol and Provence, as well as in southern England and the Channel Islands. Very good growth occurs at Yenishehir, southeasterly of Iznik-Goli, by the Sabanja Lake and the Gulf of Izmid, as well as at Anadoli Kavak on the Bosphorus. Malatia similar. Brazil cultivates the fig, especially fig blanc, albicone, napolitai, and negretto. Similar, tropical agriculture. Collection. In the axil of the leaves, early development occurs in late winter on last year's shoots, usually singly, of the June maturing early figs grossi, profici, orni. Later, in the lower branches, come the summer figs provided mamas. They develop in August and ripen in November. And finally, the late figs crotiri, mam that last through winter, and ripen in April-May of the next year come to maturity. Figs are usually dried in the air and sun on heaps. The fig remains on the tree until full ripeness. The drying process must be very careful, either in the sun or using special drying equipment at 40-50. See also commercial varieties. The fig belongs to the Mediterranean drug realm, IS 441. It is a highly subtropical plant. Trees cultivated in the tropics bear less good fruit. Litt. Ritter, Geography of Asia, the 7th, Berlin 1844. For further literature. Solms Locke, Sit, Bouchan, Prehistorical Botany, 1895. Semler recommends soaking the figs for a short time in a potash solution. 114, before drying to make their skin softer. Figs are pressed in simple, specialized presses. Rossi, sulla Prad, di Fici Secchi in Italia, Ansco sub d'Agricolt, Portici Napoli, 1881. Illustration. Figi 8. Arrival of a small Asian fig transport from the interior of the country at the station. W.A. Semler AAO commercial varieties and packaging. Even in ancient times many varieties were known. Superior figs were supplied by Kaunas, northeast of Rhodes, and Karya in southwest Asia Minor, from which figs still come to us today, just as they did then in wooden boxes. The Athenian figs were also renowned. Pliny mentions Lydian, African Ruspina, Alexandrian, Rhodian, Tiburtine, Herculanean, Chalcidian figs, and also those named after Livy and Pompey, as well as figs from the island of Eleusis and the Marrucini, a total of 29 varieties. In Passi's Tariff, 1540, p. 703, fighi di Schiavonia di Levante, di Italia, and del Ponente are mentioned. Tiedemann thought, the best but not very durable figs of today's trade are the Smyrna figs, Turkish figs, which originate from Asia Minor, particularly from the plain of Aydin, Innovasi, Nasli, and Sultan Hesar, and are exported from Smyrna. They are large, flattened, round, very sweet, with a taste of honey, and have a thin, yellowish skin. In 1901, exports reached 20 million kg. 8 and from there to Smyrna, the main hub and export port for small Asian figs. There are 3 subtypes, Eleme Turkish, hand-picked, and Erbegli, both packed in round wooden drums, boxes box figs, or small crates covered with laurel leaves, and Rabba mercantile in barrels, loose, unpressed. Figs are the most prestigious source of wealth for Smyrna, which dominates the fig trade. Here they are weighed, cleaned, and sorted, certain varieties also sprinkled with powdered fruit sugar. The smaller Greek figs Fracasani, Corfu are less sweet, tougher, and more durable. They are particularly exported from Kalamata, at the seaboard of Messenia, from Andros and Syros, either as crown or morel figs, Caricae and Corinus pressed and tied to sapirus reeds, or baskets. Italian figs are mostly shipped loose in baskets, basket figs. One distinguishes Neapolitan Calabrian from Cosenza and Calabria Superiore, Sicilian, Puglian, and Genoese figs. They are smaller and softer than Greek figs, but less durable. The Tyroler figs come from South Tyrol, Trento, Rovereto. Named after their packing material, laurel or rosemary leaves, they are known as laurel, leaf, or rosemary figs. The Dalmatian, Istrian, or Triester, the southern French, Spanish, and Portuguese figs are similar to the Calabrian ones and usually come via Hamburg. Marseille supplies a lot of figs, about the size of Cosenza figs. Turkey and Greece exported 30 million kg of figs in 1907, worth 90 million piastres Greece alone. 14 million, Italy, in the same period, paying 4 million kg in 1906. Turkish figs are traded in Smyrna and Istanbul, Italian ones in Catania, Bari, and Genoa, Greek ones in Patras. Major ports for imports are Marseille, London, and Trieste. A key point in fig trading. Figs grown in India are not exported. They are less good than the Mediterranean figs. The Egyptian figs, donkey figs, Pharaoh's figs, Adams's figs are the walnut-sized fruit clusters of the sycamore ficus, Icamoris. The Indian fig is not a fig, but the fruit of Opuntia vulgaris Miller Opuntia ficus indica. Smaller amounts came from Trieste, Algeria, Italy, insignificant quantities from France, Arabia, the United States, European Turkey, and the Russian Baltic ports. Turkey, then from Italy, Algeria, and Spain. Muller, in Real Encyclopedia of General Physics III, Flukiger, Pharmacognosy and Related Subjects. The import of figs into Hamburg in 1906 was 32,226 double centners Z's 1907, 21,1772, 1907. Most of the figures for 1908 originated from Asia Minor, 15,886 DZ, followed by Greece and the Ionian Islands, 5,600 in Spain, 4,689. The United States of North America imported 15,235,513 pounds of figs in 1909, mainly C13 mil from Asia Minor and C1 mil from Greece. Ficus carica, transverse section through a fruit cluster and female flower. After Church Oesterle, Anatomical Atlas, Morphology and Development of the Drug. The fig fruits typically form in pairs in the axil of a leaf as lateral formations on the axillary bud. Anatomical Atlas Taev. 28. They are initially enclosed by the deciduous stipules of the bearing leaf. However, usually only one fruit cluster develops, while the second remains in the stage of a short bud. Every fruit cluster is enclosed by an involucre, which is still well preserved at the base of a ripe fig, and consists of 3 scaly leaves, the bract of the axil bud, and the bracts of the inflorescence. The inflorescence is arranged as a flat cup with scaly leaflets around its edge, from which the scales that eventually close the ostiole develop, and on its bottom, the flower clusters are found. As development progresses, the cup becomes deeper and finally forms a chalice receptacle, hypanthium, fruit, or floral base. This has an ostiole at its tip, not quite centered, which is sealed by scales pointing upwards when the fig is unripe to initially deter insects. At this stage, the young fig is still quite round and green. It produces a strong milk when damaged, tastes unpleasant, and has an offensive smell. The rough white tissue of the receptacle contains starch. The flowers that line the entire inner wall of the vase in cultivated fig trees are usually entirely female, long-petaled, short-stemmed with a one-sided protruding ovary, bearing a style with 2 long scars, and typically have 3 perianth leaves. Fig 9. Between them, on the bottom of the vase, there are hairs in that. Atlas Taff, 28, 6, 8, 18. The ripe fig has a more or less slender, pear-shaped form, with a green-violet color that can also range from brown to red, violet, or blue-black. Colored striped or speckled varieties are also known. Sometimes the fig bursts and releases thick syrup flockiger. Even more pronounced are the changes inside the jar. The ostiole of the ripe fig is closed by downward-pointing scales that guide insects inside. The tissue of the receptacle has become hyaline soft, rich in sugar and starch-free. The taste is now mucilaginous sweet. Upon injury, no milk sap flows out anymore. The content of the milk tubes has solidified. It is no longer liquid. From the flowers have developed small yellow, almost spherical fruits that are entirely embedded in a yellowish hyaline fruit pulp, formed by a profound pectin mucilaginous metamorphosis of the jar wall. Flower stalks, perianth leaves, stigmas, and ovaries, as well as the outermost layers of the fruits, which contain plenty of sugar. Nevertheless, one can still find traces in the ripe fig, especially of the scars, the aforementioned now thicker hairs, possibly individual perianth leaves with their marginal hairs, and naturally the approximately 2 mm-sized fruits. The fruit is a drupe. Figs are either sold simply dried or pressed. The pressed ones are compressed from above into sheets, so that on one side, a little laterally from the center, the ostiole is visible, on the other, the stalk attachment. Lit. Payer. Organography. P275, tab 60. Eichler. Flower diagrams. Church and Esterly. Anatomical Atlas. PL 28. Anatomy of the drug. The wall of the hypanthium is covered by an epidermis, consisting of polyhedral cells in which there are slits, here and there, and quite a few, mostly only short, tough, conical hairs fig. 10. Then follows a zone of parenchyma, whose cells contain oxalate druses, and above them the layer carrying the milk tubes. After Churcho-Esterly, Anatomical Atlas. From the ovary wall, the outermost parenchymatous layers undergo degradation during pectin slime metamorphosis, affecting the entire interior of the cup. Further inward lie the vascular bundles. The innermost zone is usually obliterated. The milk tubes are relatively thin-walled, 1545, usually 20-30 m wide and very highly branched. They belong to the type of simple ungrained and contain quite large 4-7 m, the seed kernels, whether isolated or fused into bundles, are soluble only in chloroform. The vessels are usually spiral, rarely net-veined. They have a diameter of 15-22 microns, thus generally narrower than milk tubes difference compared to cicorium root as described. Illustration, Fig. 10, Ficus carica. Transverse sections through the various layers of the hypanthium from the epidermis, one to the inner parts. Usually only the third layer remains in the form of small, thickened isodiometric cells, and the innermost layer, consisting of short, heavily thickened brachyscleran fig. 11. The seed coat consists of obliterated cells and is collapsed. The embryo is strongly curved, with radicals and 2 cotyledons clearly visible. It is embedded in endosperm. Within it and the embryo are numerous Allura-1 grains containing crystalline and globoid substances, embedded in oil plasma. Transverse section through the margin of a prepared fruit. The outer layers 1-2 have deteriorated. After Church-Esterle, Atlas, Lit, Church, Angewanta Anatomy, Fig Joy. Pathology of the drug. Frequently, dry figs contain mites, particularly Carpoglyphus pastellarum, Glyciphagus prunorum, and others. Israel, SIP 380, Chemistry. 611. Church, Esterly, Anatomical Atlas, J. Moeller, Microscopy of Food and Pleasure Products. 2nd ed. 1905. Further literature there. In Malpichi Opera 1687, a good longitudinal section through the receptacle can be found. He already observed milk tubes. Dried figs contain, in addition to about 5.5 pectin, 276270, mainly about 51 sugar, which seems to be only invert sugar, dextrose levulose, and no raw sugar, saccharose. Even after inversion, the sugar content remains approximately the same dieterics. The grape sugar often crystallizes and covers the surface as a crust. A liter of freshly pressed fig juice contains 128 g sugar balance. Unripe figs contain very little sugar, but a lot of starch, while ripe figs are starch-free. Fresh figs often contain 86 water, dried ones around 30. Since the fig contains over 6 protein, it is very nutritious. The content of the milk ducts, which exude and give an unpleasant taste when cutting into unripe figs, hardens during ripening, and then contains numerous rather large rubber seeds consisting of gutta see above. The seeds contain fatty oil and aileron. The ash content is 130. The ash contains 0.06 boric acid Hodder 1895. Even Pliny and Dioscorides knew that the milk sap of unripe figs, which was much used in medicine in ancient times, causes milk to clot. Lit. Older analysis by Blay and Pereira, Doctrine of Medicinal Substances. Flukiger, Pharmacognosy Dieterics. Koenig, Chemistry of Foods and Beverages, 4th ed., 190,304. Composition of fig coffee by Koenig. Odor and taste. The odor is weak and not unpleasant. The taste is strongly sweet and viscous. Figs cannot be stored for longer than a year. Albini, Report of the German Chemical Society, 1871. Balland, Journal of Pharmacy, 1876. Carlucci and Rossi, Botanical Annual, 1881. For more on milk sap, see Bouchut, Journal of Pharmacy, 1880. Hansen, Botanical Annual, 1881 and 1885. After this time they dry out and become unappealing, and are covered with a layer of weathered grape sugar crystals depicted in the Anatomical Atlas. It is known that figs are sometimes sprinkled with flour, especially chestnut flour, to increase their shelf life. E. Hanausek, in Erdmann Koenig Scientific Horticulture. Use. Today, figs are almost exclusively used in folk medicine as a soothing agent. Fig plasters were known by the Jews from the time of Isaiah, and the Schola Salernitana teaches. Crushed figs should be applied to cramps, corns, boils. They help and heal broken legs. Recently, a lot of alcohol has been distilled from fermented figs, for example, in Asia Minor. Fig wine is also prepared in the Orient. Roasted, the fig becomes fig coffee, which is a coffee surrogate and is sometimes added to coffee to improve taste. Carlsbad coffee. However, today the fig is only a component of a special pectoral with fruits. Among Arabs, it is considered an aphrodisiac signature. The purgative effect, which it possesses like all sugar-based drugs, is dramatically depicted in Bach's herb book. CY, P323, page G, 313. Fresh figs are a popular food and fruit in the South. It is quite expensive, so counterfeits are found on the market, especially chicory with embedded clover or cruciferous seeds, which can be easily recognized under a microscope. Corn coffee, roasted pears, and carob beans also appear as fakes of fig coffee. Fig cheese, used in Spain and Portugal, is a pressed mixture of figs, almonds, hazelnuts, pistachios, and spices. History. The fig is one of the oldest cultivated plants, present in the western half of the Mediterranean region as early as the end of the Pliocene. It then became extinct, and was likely reintroduced from the east by the Phoenicians in prehistorical times. Lloyd, initially from Syria to Greece and Italy, and then to Spain and Gaul. A Babylonian hymn from the library of Nippur dating back to 2000 BCE mentions the fig, sweeter than grapes and figs, cuneiform texts of the Brit. Ben Sira's alphabet 11th century includes a list of plants in Nebuchadnezzar's garden, which also features figs TNM. They also have an Assyrian name, Titu. Assyrian monuments often depict the fig tree alongside date palms and grapevines, at least those depicted in I-Fig 371 with Selix, referred to as a fig tree for a fig, so that the statement Herodotus 5th century BCE that Babylon did not produce figs cannot be correct. Herodot also claimed that Egypt did not produce wine, yet we have countless depictions of viticulture and winemaking on Egyptian monuments from the earliest times. Similarly common is it to find them on Egyptian monuments king. Figs are already present as part of the funeral feast in a tomb from the 12th dynasty, 2400-2600 BCE. There can be no doubt that fig cultivation was at its peak in ancient Egypt, 2400-2200 BCE fig. In ancient Jewish times, figs and wine were grown together. The ancient Indians also knew the fig S507. The cultivation of the fig in Italy seems to date back to the time of Greek colonization according to Solms. It is even older and belongs to the oldest Roman legend cycle. The first cultivation in Greece dates from the late Homeric period, Hain, around the 9th or 8th century BC. After Greece, fig cultivation was brought with the capra fig. The Romans did not adopt this, but initially propagated the fig tree through cuttings. Dioscorides, who, like Plinius and Ibn Bathar, mentions a number of diseases that figs can cure. Even Hippocrates used figs as a remedy, also mentions the wild fig tree and the lie of the fig tree. Several sacred fig trees stood on the Roman Forum. By the time of Plinius, 29 varieties of figs had already been bred. Illustration, Fig 12, ancient Egyptian depiction of fig harvesting, from a painting on the west wall of tomb, Naboregnau. 2 in Beni Hassan, Tuto. Dynasty 2400 to 2200 BCE after King. In Egypt, the fig tree was sacred to Osiris. Figs played a significant role during the Dionysian festivals. In Rome, the fig symbolized the vulva, while among the Greeks, it represented the penis. In the Orient, the fig is a symbol of reproduction and fertility due to its numerous fruitlets. During the Thargelian festival, 2 Pharmaca, draped in white or black figs as a sacrifice for death, were offered Hain. Scribonius Largus I, S577, mentions Caprifificus and Ficus arida dried figs. The Edict of Diocletian I, S570 here, are found fresh and dried figs, as well as pressed and duplicate split ones. The Scriptores Rei Rusticae, S573, often dedicated lengthy chapters to the fig, which can also be found on Pompeian wall paintings, and among the plant remains of Pompeii Wurst, S575. Figs were highly valued as a medicinal remedy by the Romans, just as they were by the Arabs. Ibn Bathar Prince, S688, dedicates a large chapter to it. Charles the Great desired its cultivation. S620. However, fig trees are absent from the St. Gall Monastery garden Warn, SS622. Perhaps Hildegard knew of the fig tree or ficus tree. In the middle, Low German Gotha Medical Book 1, SV 681, it is referred to as Vige. The Alfita Ord, S644 lists Caracae Sicae. It seems to have arrived relatively early over the Alps. It was introduced to England during the reign of Henry VIII, brought by Cardinal Pole, yet it seems to have been cultivated there already in the 13th century. The medieval drug trade included figs. Finally, note that fig is also mentioned in the Pensao Kang Mu, P519, so it was used in Chinese medicine as well. 1884, and Egypt's relations. Schwendener, Kulturpflanzen, Vortrag, Unger, Botan, Streifzüge 1857, Moldenke Bäume Ägyptens, 1902. Buchschauen vor Geschichte, Botanic, 1895, Dactyli, dates, data French. Diseases of the fig tree were described by Rhizotome Clidemus Theophrast. Cause. Plant, 312. Lit. Hamilton, Botanique de la Bible, 1871. Flukiger Hanbury, Pharmacographia. There is further historical literature there. Schweinfurth, Bear, D.D.B. Bott, Jess, Date English, Datal Spanish, Datero Italian, Dadel Dutch, Datolia Hungarian, Tateli Finnish, Greek, Synonyms and etymologies among the Assyrians, Muzuan, Sumerian, Akkadian, Heavenly Chief. Hieroglyphic signs, IS 468 and 4070. Palma Plinius, P. Carioti scrib, Larg Prime. Dactyli Latin, Greek Dioscurus, Aryan Galen Hippocrates, Nahul, Tamar, Ruthab, Busir Arabic, El-Or, Teamer Hebrew, from which perhaps Tamarinda. In Chinese, the palm is called Wu Tao Tizi, i.e. 5 loads, or Fotiu, i.e. foreign plant. The fruit, Sao. Date, at Harrisbach 1570. Dactyl Middle High German datel, tatel, from Italian datilo, which itself comes from. The feathery leaves of the date are finger-shaped kludge, or more likely after the shape of the fruits, or from Aramaic dakwal, dipla palm. Palma originally referred to Chamaerops humili, but later became the general name for the date palm throughout the Middle Ages, and then was extended to all palms, the ancestral plant and systematic position. Phoenix dactylifera L, with 50 to 80, or even 150 cultivated varieties. Palmae coryphena, Phoenicae. Description. The dioecious date palm forms tall, slender trees. Its Hebrew name Tamar means slender and tall, reaching up to 20 meters fig, 212, 217, tab. 19, giving the landscape its distinctive character in Africa. The wild ancestral form is unknown. The ancestral form from which the cultivated date palm originated may be Phoenix spinosa Fischer. According to this, tropical Africa would be the original homeland of the date palm. Dates have been cultivated for millennia, and it was only through cultivation that sweet fruits were produced. The Babylonians Nabateans are considered the inventors of date cultivation, p. 479. Since the date palm is dioecious, pollination is promoted by hanging the male inflorescences, even when closed, into the canopy of female plants as soon as they give out a sound resembling that produced by rubbing damp flour. The pollen then falls and causes fertilization. The flowers are often grouped in large inflorescences containing up to 200 blooms between the terminal leaf clusters. The number of fruits ripening on each inflorescence varies between 80 and 200. The fruits mature after 5 months, usually in July, August, September, and October. For commerce, they are harvested slightly before complete ripeness and allowed to ripen further in the sun. The fully ripe date becomes soft. The date palm bears fruit from the 5th year, but many not until the 15th, reaching its maximum in the 30th and ending in the 95th. A tree can provide 50-70 kg of dates. The fruits are yellow, yellowish-brown, or yellow-browning in color. Occurrence: the date palm, one of the most valuable fruit trees in the world, the king of oases, is found in Arabia, Egypt, Nubia, the Sahara oases, Algeria, Tunisia, and Morocco Atlas Mountains. It extends westward to the Canary Islands and Cape Verde Islands, and eastward to Iran, the Persian Gulf, and as far as the Indus River. The center and home of the cult date is probably Arabia. In Nice and San Remo, the date ripens in sheltered places. It can withstand temperatures down to 5 knots beyond the Alps. It dips its roots into water and its crown into fire, meaning it requires groundwater and a hot climate. Its Assyrian name, Mosuan, means heaven-headed. Beled el-Jasherid, meaning dateland, formerly referred to the southern slopes of the Atlas system. The Nile Valley is a vast date palm oasis. The number of date palms in Algiers exceeds 4 million. In Egypt, Algiers, and Tunis, the date palm is an important tax object. In Arabia, which has many date palm oases, Jeddah is a major date market, as are the Bahrain Islands, where a popular Arabic proverb goes, "Bringing dates to Bahrain means just as much as carrying owls to Athens." Persia has extensive palm groves, particularly in Laristan. They form small village forests everywhere. They require an average annual temperature of 24-25 C. Pathology regarding plant pests, Professor Ed. Fisher reports. The flesh of ripe dates is often destroyed by a parasite that Corda considered to be a Eustylagene, but according to Patouillard and Delacroix Bull, p. 118. It is an aspergillousy, and must be called Sterigmatocystis phoenicis corda patouille. At Delacroix, in the Nile Valley, the disease is known as macattle. It is occasionally observed on dates that are shipped to Europe in boxes, commercial varieties. The date is a characteristic drug of the southern province of the Mediterranean drug kingdom RS, S441. Most dates now come from Arabia, Persia, and Egypt. Algeria and Tunis supply very good dates. The best dates are African ones. They are nearly spherical, finger-shaped, about 2-3 centimeters long, soft, and very sweet. The income from the taxed date palm in Africa is estimated at M10 per tree. The main trading place for Turkish dates is Basra. Import ports include Marseille, then Genoa, Hamburg, and London. They are found in trade either loosely packed in boxes or pressed into balls blocks. The countries under Turkish sovereignty produced 51 mil. The United States imported 2,186.921, 8 pounds of dates in 1909, with almost 19 million coming from the Asian part of Turkey. Anatomy. The pericarp is covered by an epidermis. kg in 1907, worth 34 mil, piaster. Date imports to Hamburg from the sea amounted to Z, 1906, 21,813, 1907, 14,000, 14,156, 1908, 24,117, most 15,177. Imported in 1908 came from Arabia. Persia also contributed significantly 3,921, as did Great Britain 2,943 from its colonies and Egypt. Imports were smaller from France, Morocco, Syria, and Asia Minor. This is followed by a clearly demarcated zone of strongly tangentially stretched, thin-walled parenchyma, cells. The sclerenchyma layer, composed of round, or strongly radially stretched cells, that often project inward, like spikes. Then comes a zone of larger parenchyma cells, followed by the region of inclusions. Larger round parenchyma cells here each produce a bright, highly refracting, soft round body, which behaves similarly to reagents as the inclusions of Serotonia and Diospyros ticomero. The date fruit inclusions color with iron chloride, blue-black, with vanillin acetic acid red. They contain an insoluble in water fluoroglucotannin. The endocarp easily peels off as a silver skin. At the position corresponding to the seed groove, see below, it is protruded as a belt. Between it and the flesh, sugar crystals are occasionally found. Vogel, food fig, 136. The seed is elongated, pointed on both sides, with a groove on one side. The thin seed coat consists of an outer bright multicellular layer and a single row of brown cells, which also penetrate into the groove. The cells are slightly thickened and dotted. The endosperm is hard, horny, but can be cut with a knife. 47 invert sugars, 20.7 to 39.3 dextrose, and 22.1, 22.4. It consists of radially arranged, stretched, thick-walled, and densely spotted cells that contain a large amount of allurone grains. The small germ lies in the middle of the convex longitudinal side. Chemistry. The date contains in the dehulled flesh 2866. Average C. The crystalline mass that forms from date honey, see below, consists of 83.4 dextrose and 11 levulose grimber. Date also contains, in percentages, 20.8 water, 6.6 protein substances, 1130 pectin and gum, 0.2 fatty oil, 5.5 raw fiber, and 1.6 ash. Ash of the seeds, 1.1. 816, so they were at least then used as medicine. Poorer quality dates are used for alcohol production. The seeds contain a lot of reserve cellulose, a hemicellulose that is dissolved during germination, and cytase nucleum. They supply hydrolyzed galactose and mannose, thus containing galactans and mannans. Dates are the principal food of tribes in all North Africa. Every caravan has a stock of dates. The elements of the contented farmer are the sun, the Nile, dates, and whips. The roasted kernel is used as a coffee substitute in Algeria and elsewhere. In Europe, date kernels are used to falsify spices. Date kernels Dactylorum ossaceonuclea are found in the Braunschweiger tax of 1574, IPA. Date use in medicine is rare in Europe, but it is a component of the quatre fruits pectoraux. Date syrup is used in Africa as a pectoral. For more information, see Dragendorf, medicinal plants. In the interior of Algeria, a very sugary date variety gars is prepared with date honey dibus and date syrup by layering the fruits on orders of palm branches and exposing them to the sun. A syrup-thickened juice then flows out, from which sugar often crystallizes abundantly. Date honey malfinicinum is already mentioned in the Edict of Diocletian I, p. 5070. To obtain sugar from the date palm, deep cuts are made at the top of the stem. In Jessore, near Calcutta, a lot of sugar is still produced from palm sap today. Date wine douchab, mentioned in the Bible, Herodotus and Plinus, is still being made, see IP 1017. Likewise, date brandy in Egypt and India. Dates were and are sometimes used as money in the Orient I, p. 186. The date was already known in the land between two rivers Mesopotamia during the Old Sumerian period I, p. 476. She is a component of numerous cuneiform recipes, just like palm wine, date wine I, p. 485. The date palm is found in the oldest plant depictions that have reached us, such as on Assyrian monuments. Famous was the royal date garden of Babylon. Bagu, T.P. 532 reports that dates were used by the Babylonians for bread, cakes, wine, vinegar, honey, and flour, that they utilized the leaves for basket weaving, the seeds as animal feed, and charred ones as coal for blacksmiths. On Egyptian monuments, the date palm is already present in the 3rd millennium BCE I, Fig. 467. It seems to have been cultivated there during the 10th-11th dynasty 2562,380 BCE king. It is also found among very ancient grave goods, list in Bushan. In the papyrus Ebers, dates, even unripe ones, are mentioned as a remedy along with date honey, wine, and cakes. Date wine and date honey were already considered remedies during the Old Kingdom. An ancient, still valid, unwritten law forbids the destruction of the date palm tree. Dates tamar and its honey dibs were also used by the Jews. Genesis 43. It reached the Greek islands around the year 1000 CE. Around 700 CE, it spread to Attica and Corinth. Schwendener. Theorist Theophras, Own, p. 547, provides an in-depth discussion of its cultivation, artificial fertilization, and yield capacity. He praises the dates of Syria, and those from Jericho, known as Palmyra Hebrew for Date City. Plinius distinguishes various types: the royal, Cydrus, Margarites, Sandalium, Caryota, Nicolea, Adelphium, Palmin, Dactylos. In the Periplus, Phoenix from Persia and Gedrosia is mentioned, IP 535, with Barigaza as its port of export. In the Pen Sao Kang Muburum, p. 519, Persian dactylos are found. For the Chinese, the date palm was a foreign plant, CP 35. In Serapian's List I, p. 606, Dactyli rorib appear. Dachuli are also found in Cordis Warren, p. 798, Lit. Bayon, Monographie d'Espagne, Paris, 1895. Drude, Palmen in Ingler Prandtl, Martius, Verbreit, D. Palm, in D. Alt. Welt, Munch, Gel, Anzeig, 1839. Schwendener, Kulturpflanzen Vortrag, Schweinfurt, Pflanzengeoger, Itzidiges, Nilsons, Peterm, Geoger, Mit, 1868, and On the Culture of Date Palms Garden, Flora, 1901. Curtis, Nil Sketches by Howard G. German by Spielhagen, 1857. Fischer, The Date Palm. Also see Fischer's Maps in Peterm. Geoger, Mit. Supplement 64, Geoger, Mit. 1881. Semler, Tropical Agriculture. Second ed. I. Hasek, Beauty and Utility of Palms. Lecture, Vienna, 1898. Morphological Illustration in Herile, Traité de Pharmac, 1901, p. 64. Termination of Date Palms in Saxelherbe, D. Bot S. Planchon Collin, Simple Drugs. Hanausek, Journal of the Austrian Pharmaceutical Society, 1892. Vogel, Food and Consumer Goods Anatomical Illustration. Ticomiro, Intracellular Inclusions in the Fruit Parenchyma of some Sweet Fruits, etc. Bull, Sorte, des Naturalistes, de Moscow, extant 1905. Koenig, Food and Consumer Goods. Grimbert, Jern, Farm, Chim, 1889, p. 485. Vinson, The Endo and Ectoinvertes of the Date. Jern, Am Chem, Sok, 1908. Pasula, 1. Passulae majoris, uve passae, grossa rosinen, zibeben, raison sex arpaceae, ude Malaga, France, raison Engel, rosine whole, rusina fin, mazalaselu, The grape berry is called Arab. Aneb, the grape Egyptian ll, arar t, and the raisins zemtien. Vitis vinifera L. Vitatae, vitoideae, in very numerous cultivated forms, as well as the American vine, Vitis labrusca, Lu, and possible original home in the South Caucasus, the largest raisin market in the world, Savannah in Georgia, from Les Grandes Cultures, Etim. Vitis has been interpreted very differently. Vitis avino, idque avino, iddic, aviavaro, vitis dicta quod vimum habeat sitius radicandi, Isidore, also from vincere to bind, vinum, vin, wine, etc., in all cultivated languages, see also under history. The dried ripe berries, which have a very great variety in shape, size, and color, come from Spain, France, Greece, and Asia Minor into trade. The best are the Smyrnae Elameas Caricae, Chesna, as well as the Valencia raisins, Spain. The sultanas are the largest. The Malaga grape raisins Muscatel are very fleshly, often still on the stems. The zibets are hard-fleshed, dark, and often stuck together. Raisins are shipped in boxes or barrels. Especially Malaga and Valencia are shipping ports for raisins. The methods of drying differ. Either the grape is dried directly in the sun, or previously dipped in hot water, or artificial heat is used. Valencia raisins are, before drying to make their skins softer, dipped in a lye bath made from grape ash. The swollen round fruits are covered by an epidermis consisting of polygonal cells. Both ports ship a total of 3 million boxes, each weighing 25 English pounds together. 3/4 of the raisin export falls to Malaga. The Malaga raisins are large, fleshly, and carefully sorted. California is also producing increasing amounts of raisins now. Savannah in Georgia is one of the world's largest raisin ports. Fig. 13. The mesocarp consists of large, thin-walled cells that contain tabular sugar crystals and harsh, often pointed whinstone crystals in the dry substance. If you cut through a raisin in oil, you will see the cut surface covered with numerous large crystals of sugar and whinstone, embedded in a soft hyaline sugar mass. In addition, small rosettes of fine needles can be found. If you cut it in water, the sugar crystals dissolve, revealing that the whinstone is particularly located at the periphery. Heating the water preparation also dissolves the whinstone crystals. The delicate vessel bundles are sometimes accompanied by crystal chamber fibers. The fruit cavity appears as a split. The pear-shaped, usually occurring in pairs, seeds possess an epidermis with a thick outer wall. Following this is a thin-walled parenchyma, from which some cells bear oxalate needles, and onto which a broad zone of heavily thickened, radially stretched sclerids lies. Deep within again lies a delicate tissue grid cells and an inner epidermis. Illustration, molar. The endosperm contains alerone grains that either contain an oxalate pit or globoid. Illustration, Fig. 14. The common method in Greece to dry raisins, from Les Grandes Cultures. They contain 60.573.5 on average. 61-64 invert sugars king, and about 27 dextrose, and about 34 levulose. Furthermore, apple acid and pectin, with seeds containing 5-6 tannins. The occasionally extracted fatty oil comprising 15-18 of the seeds mainly consists of glycerides of ursic acid CHO. Also present are those of stearic and palmitic acid FIT. Sugar and wine gum sometimes crystallize on and in dried grape berries. Grapes also contain percazuo.3, 2-mgr salicylic acid, likely as a methyl ester traphogen, and some boric acid Norton. The import of raisins in Hamburg from the C and Desi for 1906. Most 67,055 ZZ of the 1908 import came from Asia Minor and Spain 24,382. Significant was also the supply from European Turkey, 3,031 in Persia. Smaller amounts came from Russian ports on the Black and Azov Seas, Greece, and the Ionian Islands, Syria, Italy, France, Chile, Australia. Germany imported 1909, 184,665 ZZ raisins. 2. Passulae minores, Uve Corinthiaci, Small raisins, currants, raisins de Corinta, currants, from Vitis vinifera var. Aperina L. The grape-sized, seedless currants originate from Greece, particularly from the Ionian Islands e.g., Zante, and also from Morea. Patras in Peloponnese is the largest currant port. They constitute a major export article for Greece and are mostly traded in boxes. Fig. 15. The currants contain abundant grapestone crystals in their flesh. The red dye is confined to the peripheral cell layers. Illustration. Fig. 15. Loading of currant crates, August 10-15, from Grand Cultures. They contain on average C. 62 invert sugar, and indeed 31-36 lactose, and 25-30 dextrose. On average 152, free acid reference to wine acid, and 0.4 apple acid. Greece, the main production land of raisins, where the currant grape arrived around the year 1600, produced in 1907, 288,300,000 1908, 328,500,000 Venetian liters of raisins, and exported in 1907, 209,238,000. Much lower was the export of currants sultanas. See above. Germany imported in 1909, 158,640 raisins. Pathology, Professor Ed Fisher reports on the pests. Given the great importance of the vine as a cultivated plant, naturally its pests have also received special attention. The number of parasites recorded on Vitis vinifera is therefore particularly high. It was 1907, 733,433, 1900, 15,207,440 Venetian liters a manual. A Venetian liter is 480 g. The import of raisins in Hamburg was Zs from the sea in 1906, 8,700. Windhausen, 900. Most 64,291 z of the 1908 import came from Greece and the Ionian Islands. We will here, especially following Serauer's Handbook of Plant Diseases, 3rd edition, only highlight some of the most important ones and focus on those that also affect the berries. For further information, we refer to the phytopathological literature, in particular Viala, Les maladies de la vigne, and Semler, Tropische Agriculture, Plasmopara viticola Burke, et Kurt Beryl, et de Tony, calls for the vine under the name false mildew or mildew, which causes discoloration and leaf death, potentially leading to smaller berries due to nutrient deficiency. The fungus can also infect flowers and younger fruits, causing them to shrivel and fall off. It thus appears as a cobweb-like coating that becomes mealy due to conidial formation. This condition of the fungus is already well known under the name Oidium tacheri, and the disease is therefore also called simply oidium or true grape powdery mildew. This disease is particularly fought with Bordeaux mixture C. Church, copper from the viewpoint of hygiene. Stuttgart 1893, Uncinula necator swine, Burr, Euspiralis Burke, et Kurt. A member of the Ericifaceae family, develops its mycelium on leaves epiphytically, sending out haustoria only into the upper cuticle. It becomes particularly damaging because the fungus also affects young berries, causing them to remain small, develop cracks, and eventually rot. This disease can be successfully controlled by dusting with sulfur flowers. Viala et ras, especially in its pycnidium form, Phoma uvicola Burke. Et Kurt, causes what is known as black rot, where the berries develop discolored, later brown spots, then shrink and dry out. Charinia diplodiella speg, Biala et rawaz, with its pycnidium form Coniotherium diplodiella speg. Tac. Like the previous one, a pyronomicete, is the cause of white rot. The berries first take on a gray-white color, and eventually dry out as well. Botrytis cinerea pers. A gray mold is considered the conidial form of the discomycete Sclerotinia focaliana. Appearing on ripe berries, it causes what is known as noble rot, while on unripe berries, it induces sour rot. Berry rot can also be caused by penicillium, Glowosporium ampulophagum Pass. Saki, Sphaecoloma ampulinum Dubai. A perfect fungus is the cause of blackburn or anthracnose, which occurs on all parts of the vine and also affects the berries, causing them to develop brown spots, shrivel, and dry out. Melanconium fuliginium scrib. Et viala cavi, another imperfect fungus, induces a shrinking of the berries known as bitter rot, pest. Application. Pastules belong to the fruits of the pectoral species cum fructibus. He is also found in Pegolotti, Olivier de Serres, 1600, Glauber and Juncker Conspectus Chemiae, 1730. Dried laxative currants, pastulae, laxative, are prepared by soaking currants in wine and drying them. In former times, the grapevines Pampini vitis and the juice Omphecium of unripe grapes agresta were also used. Pharmacy usually employs Valencia raisins Hanbury. Ground grape seeds have been observed as coffee substitutes. The concentrated grape juice is called thila by Ibn Bathar, also mentioned by Galen. Fresh grape must was already used by the ancients as a sweetener, and grape sugar was already produced by the Arabs from concentrated grape juice Ibn al-Awamam, Ibn Battuta. During the Continental Blockade, there were grape sugar factories in France, but they ceased operation when Kirchhoff discovered the preparation of starch syrup, imponderable, capillary syrup, in 1811 von Lippmann. The homeland of vine culture is likely near the Caspian Sea, along the Oxus and Jaxart rivers, and south of the Caucasus Mountains. From there they may have spread to the west, initially to Palestine, Syria, Phoenicia, Babylon, and Egypt. Schrader does not consider Semites as inventors of wine culture, but rather Indo-European tribes of western Anatolia. He directs wine from the Indo-Germanic vino ranke. The word wine is also Indo-Germanic and derives, like vitis, from the Proto-Indo-Germanic UAE to twist, thus originally referring to the vine hoops. The Phoenicians then brought winemaking to Massilia Marseille. From there it spread to Spain. The Romans brought it to the north. In Africa, Tunisia, and Algeria, as well as Cape Colony, now grow grapes. Similarly, Australia and China have become wine countries. In America, Chile, Argentina, Peru, Bolivia, Brazil, Uruguay, Mexico, as well as Florida, Virginia, and California, produce wine. Prehistorical tuffstone deposits in Montpellier contain grape leaves planchon, while remains of pile dwellings hold grape seed here. In pile dwellings of the Neolithic and Bronze periods, grape seeds have often been found catalogued by Bouchon. Even on Egyptian monuments from the 5th dynasty around 3500 BCE, we find depictions of the cultivation and care of the vine and the preparation of wine. It was called arpi there. The ancient Egyptians knew 8 varieties of wine. The vine must have been brought to Egypt in prehistoric times. Similarly, it appears on many Babylonian monuments, IP 481, 483. Even in ancient Greek graves, depictions of grape harvesting can be found. On Achilles' shield, the harvesting of grapes is depicted. Hoops. Even the ancient Egyptians dried grapes and made raisins. Such varieties specifically, Vitis vinifera var, Monopyra noer, found among Egyptian burial artifacts, Braun, Schweinfurth. Raisins. Crete, the El Dorado of ancient medicinal plant culture, was also an important wine region in early times, as the then climate of Italy was not particularly favorable to viticulture. Bouchon. The vineyards of Burgundy and Bordeaux already existed during Strabon's time, on the Mosel and the right bank of the Rhine in the 2nd and 3rd centuries. Raisins are also mentioned in the Bible in Isaiah and Jeremiah, even kernless grapes, Soric. In Diocletian's Edict of Verne, S. 570, Ube passae fabriles and maximae is listed during the Middle Ages. In medieval medicinal lists, such as the Alfeda Y, S.L. 655 by Platarius, Serapion, and in Synonyma Bartholomew, you'll find Pasuli, Uva Passa, Haineb, and Uva Chibib. Raisins panza are also mentioned in the Barcelona Customs Book, C. 1430I, S. 705, and the Danzig list of 1410I, S. 811, includes them as an import from Lisbon. Pastulae nucleate appear in the Nördlingen Register Fest. Rosenmüller, Biblical Natural History. Hoops, Forest Trees, and Cultivated Plants, 1905. Vogel, Food and Deliciousness. T. F. Hanausek, Food and Deliciousness, 1884. Villiers et Colin, Treatise on Alteration and Forgery, 1900. 813. At Cordis the Furin, S. 801, one finds extracted leaves in Mucilago, as well as laxative P. See above. Grapes are also found in the Pensau Kanmu as a medicinal plant. Lit. Delich, The Bible and Wine, 1885. Vernig, Plants of Ancient Egypt. Vernig, Plants of Ancient Egypt. Pen, Cultivated Plants. Bushan, Prehistoric Botany. Howard, Microscopic Examination of Fruits. U.S. Agriculture Department, Bulletin 66. Lampe, Construction and Design of Juicy Fruits. Weinlaube, 1880. Koenig, Food Chemical Literature therein. Fitz, Reports of the Chemical Society. 1871. Also compare the literature of the investigation of food and pleasure on the preparation of raisins. See also Semler, Tropical Agriculture. Fruits processed into rubes or pulps. De rebus de berberis nucum diamorum cerasorum diamarinatum. In the Prague texts of 1659, rube mirobalanorum, and cordis among the lenitiva its. This includes juniper berries, linden berries, plums, jujubes, apricots, and blueberries, which have been prepared as rubs, rubs, alion, p. 1062, by the Arabs since ancient times, but not always for medicinal use. 1, p. 796, also mentions the following rubes, R.I. Sin, Bacchae juniperi, Dalbuli juniperi, juniper berries, Jagers, Jahandos, Kudig, Katic, cranberry, Eneber, Reckholder, Nertberries, Bays de Ginevra, Efer juniper berries eng, Bacca di Gineproital, Geneva bestut, Katajan marja fin, Boroka bogio hung, Gierka, in the Alfita and the Sinonima wine, S650, Genur, Ghost, Quicantre, Grana juniperi, Juve et Semen, with Hildegard, Cedrus and Juniper, with Albertus Magnus Perfurus S. 674. Junipers in Middle English medical books were S. 6683. Tribulus. Further see below under Edom, and with Kangieser, Etum. Juniper Klug writes Watchholder. Both spellings are acceptable from Wack, alive here evergreen and AID. Tra English treater, tartry. All is a derivational suffix. Weckholter or Wachholtern, underlying word Wehalturia or Wehalter, MHD. In the German Pharmacopoeia wine, P681, Wakandelembere. Also, Queckholter, Northern Germany, from Queck alive here evergreen angels, Quickbeam. Juniper also often deformed to Weckholter Brunswick, Bach, Wechelter, Weckelder, Wackhilter. With Hildegard also, Wachelter Bohm with Megenberg, Wechalter and Ortis Sanitatis, and with Cordis. 592 believes that in Juniperus, the term fire is contained due to the shape of the bush, or because the wood sustains fire for a long time. Crana berry, less likely from cran crane or grony green and Witu wood. Nirk from knit hedge, low shrub, Kangieser. In the Würzburg recipe for one P624 it states Aeschylitis cranuido. Pritzel and Jessen, folk names. Kangieser, etymology. Perger, studies on the German names of plants native to Germany. Memorial of the Vienna Academy, 1860. Parent plant. Juniperus communis L. Linnae, spec plant. Ed. I. 1040. Ettim. The derivation of Juniperus is doubtful. Ischim, Eschwil, Ispal, I. S. In Low German. Waschandel East Frisia. Jaschandel Upper Silesia from Jacques Lively, here evergreen. Reicholder Cordis. Reckholder in Switzerland, from Reck vigorous, quick and lively. See above. Katic, Kati, Kitachu, from Old Slavic Kadidi too. Smoke, Kranwit near Megenberg, Kranowit, Kranetwit, Krajavet, Kranowet, Austria, even Kranat from AJD. Others derive it from Unix cow and Perere, to give birth, or even connect it with Juvenes and Perere, to suggest the use of Juniperus species as abortifacients, while others link it to the Celtic word Juniperus rough. Coniferae, Pinoidae, Cupressinae, Cupressinae sexio-oxycedrus. For the other species of the genus Juniperus used, see Church, Art, Juniperus in Realenzaco. D. Gis Farm, 178. Kangieser considers the derivation by Boerhaave from Junior and Pario, as the younger green fruits ripen, while the older black ones still hang on the bush as the most probable. From Juniperus, then came Genevria French, Anabro Spanish, Genepro Italian, Zimbro Portuguese, as well as Geneva. Systematic position. The species of the genus Juniperus form trees or shrubs with alternating 2- or 3-parted leaves arranged in wreaths, and dioecious or monoecious flowers. Fig. The male flowers are formed by pollen sacs inserted at the base of the stamens, while the female ones produce a small arm-branched cone. Juniperus communis L. The scales of the female cone are produced by complete fusion of the inner and outer wreaths, thus forming a berry-like cone, berrycone. Galbulus, falseberry, which contains 1-3, rarely 4-8 seeds. Pollen without exine blisters. Ovula free, not enclosed in an ovary gymnosperm. Naked seed, erect, integument cup-shaped, opening at the tip. 2 cotyledons. In Sexio-oxycedrus, the needle wreaths are 3-parted. The cone container of the needle, which does not disappear as systematists often claim, does not curve outward as in Sabina. Cones in 1-3 jointed clusters, of which only the upper one is fertile. Occurrence and distribution is a species distributed throughout Europe to the far north Nordkap, countries around Hudson Bay, as well as through Central and North Asia on open heaths, and in forests as undergrowth, forming stands along seacoasts. Region of mountains in the western Himalaya up to over 4,000 m, absent in the tropics and subtropics, but for example commoner in northern Italy, rarely occurring in societies Lüneburger Heide, East Prussia, Hungary, and then assuming a specific vegetative character see below. It is a low-growing shrub, but can also grow higher up to 3 m and then show pyramidal outlines, or even become tree-like up to 12 m and then take on a cypress-like appearance, ZBD, beyond the Alps, in Norway. In Hungary, juniper bushes often form impenetrable thickets. Alpina Gaude, J. prostrata Hort, or Juniperus sibirica Bergsdorf, but also considered good species. From a distance, in mountainous regions, particularly on peat soils, it can be humifous, and the needles broader and less sharp. Sierra Nevada at 2,600, Nevada at 2,600 m, on the Balkan Peninsula, in South Siberia. Such low-growing forms found in the High Alps, Scotland, Scandinavia, Novaya Zemlya, and Greenland are probably distinguished as Juniperus nanowild. Juniper, now the most widespread conifer in Europe next to the spruce, must have grown throughout Germany already in ancient Germanic times. Hoops. Description of the parent plant. The initially smooth bark turns brown even on a 2-year-old shoot, and often scales and bands peel off from it. Lime seems to inhibit growth, particularly see Kernicka and Roth in Karst and Schenk. Vegetation pictures, 5th series, Volume 1 and 2. Illustration, Fig. 16. Juniperus communis. LABC male, EF, female inflorescence, D pollen, G cross-section, through F, I, case. The younger internodes are more or less clearly triangular. The linear prismatic, erect, linear, rigid needles with a sharp stinging tip are arranged in alternating 3-parted, close clusters. The flowers occur in the axils of last year's leaves on short lateral shoots. The male ones are nearly sessile, small 3-4 mulumba, egg-shaped to oblong egg-shaped. Among the female, the 3 upright ovules protrude freely from the roof-like husk, enclosed by 3 fruit leaves that seem to alternate with them. Fig. Illustration, Fig. 17, Juniperus communis. The opening is closed. The congenital fusion of the integument with the fruit leaf is evident left. 5. Mature fresh berry cones cut longitudinally. 6. Same, cut transversely, after Church-Esterle, Atlas. The developmental history of the galbulus is as follows. More detailed information in AA. Longitudinal section through a twiglet and the ovules seated at its tip before fertilization. 2. The same after fertilization. The fruit leaves HBL have thickened and begin to grow around the seed structures. 3. The fruit leaves are almost fully grown around the seed structures, but the terminal opening has not yet closed. 4. The embryo sac megasporangium develops only after fertilization has taken place May, June. In the first year, only the embryonic structures form. Only in the spring of the following year does the embryo develop. Meyer and in Church-Esterle, Anatomical Atlas. Fruit-bearing branches are found soon in the axils of all 3 needles, sometimes only in the 2 or 1 needle of the terminal shoot. They are equipped with up to 9 3-toothed scale leaves. At the tip of the branch, there sit the 3 ovules, each of which has only 1 integument. This results in a structure that possesses all the characteristics of a berry. The only difference is that, while in the true berry, the ovules are already enclosed within a fruit knot formed by the calyx lobes from the outset. Here the fruit knot wall is formed later. The berry cone is formed when the 3 leaves of the uppermost high leaf, which can be called fruit leaves, surround the ovules that are developing into seeds, and eventually the cup formed closes almost completely from top to bottom, leaving only laying a 3-toothed gap behind. The designation Bacchae juniperi can therefore be retained, even if one needs to use the term berry in a broader sense. A gallibulus, it is certainly not, at most. The tips of the fruit leaves, which are completely fused together on both sides, are still visible as small bumps on the ripe fruit. The leaves of the second upper leaf pair, which can be considered overlying or covering leaves, sometimes fuse with the base of the calyx lobes. The seed formations do not fully fuse with the calyx lobes. The tip of the seed remains free and protrudes into the terminal cavity of the 3-lobed split. Church and Esterle. Anatomical atlas there, and in Meyer's work the developmental history is presented. Flukiger, Pharmacognosy. Illustration, Bergschmidt, Atlas. Schubeler, Norwegian Flora, 1875, and Viridarium Norvegicum, 1888. Church, in Real Encyclopedia of Pharmacy the 7th. Pfitzer, Development of the Embryos of Conifers, Botanical Journal, 1871. Strasburger, Conifers and Natation, 1872. 1872. A. Meyer, Scientific Drug Manual. At the base, however, the expectation is so complete that the tissue of the seed coat gradually merges with that of the ovules fig. 17. Lit. Eichler, in Engler Prantal, Plant Families. Plant Families. Brandis, Forest Flora of Northwestern and Central India, 1874. Kerner, Plant Life of the Danube Countries, 1863. Pabst Kuhler's Medicinal Plants, Plate 53, and in almost all other illustration works on medicinal plants. The oldest illustrations by the Patras, Pathology, parasitic fungi, seem to have no significant direct destructive effect on the berry cones of Juniperus communis, while numerous parasites are known on leaves and branches. We mention only the Gymnosporangium species, whose teleotosporic mycelium perinates in the branches, Perpetrichia nigra, which entwines its mycelium around the leafy branches, Exosporium juniperinum, which, according to Jetchevsky-Zetcher, für Pflanzenkrankheiten G. 1901, causes the needles and often the entire bush to die back, and others ed. Fisher. Regarding animal pests, Israel reports, moth, Caesia cephiformis ops, the larva of this rare glassy skipper, lives in stem swellings of Juniperus communis. Bupalus pignarius L. The larva of this common and often harmful spanworm species occurs on Juniperus communis. Cidaria juniperata L. The larva attacks young shoots. Ipsolophus juniperellus L. The small caterpillar twists the needles into small bags and hollows out needles and young shoots. Apart from these, a large number of microlepidopterans live on Juniperus, but they are less relevant. Collection. Only fully ripe berries of the second year are collected and dried without artificial heat. Juniper berries easily absorb moisture, so they are best stored over lime. The powder is made from dried berries over lime. Fruits exposed to insect damage can be protected by spraying them with ether and storing them in well-closing containers washed out with ether Idelson. Commercial varieties. Watchholder beeren come particularly from North Italy, Parma, Hungary, especially the Carpathians, France, particularly southern France and the departments of Jura, Doubs, Savoie, and Germany, East Prussia, Lüneburger Heide, less so from Russia and Dane. Moravia. Trade speaks of Italian, Hungarian, and German Wacholderbeeren. The Italian ones are traded in sacks of 50 or 60 kg. Morphology of the drug. The Bacchae juniperi are almost spherical, barely weakly triangular, and have a diameter of 5-9, usually around 6-8 mm. The Indian and Newfoundland ones are larger. They are dark brown on the outside, and often still covered with a bluish ripening waxy coating. After wiping off this easily shedding ripening, they appear glossy. Often, a small tip of the sprout remnant with the little high leaf blades is still attached at the base. Slightly to the side of the tip, one can see the broad tips of the 3 fruit leaves, see above. Between these, with the magnifying glass, the 3-rayed fissure. In the fruits of Juniperus nana, less frequently in June, It occurs that the galbulus arises from the fusion of two three-part leaf quarters, so that 6 seams show at the tip. This form has Geppert described as Juniperus commune, var. duplicata. In Juniperus oxycedrus, this appearance is frequent flukiger. The interior is woody fleshy, green-brown, often glistening with numerous oil containers. The 3 very hard seeds can be easily extracted. They are oval-oblong, bluntly triangular, usually provided with a strong, sometimes almost wing-like keel, pointed on the micropyle side with the tip directed upwards. They are fused to the fruit calyx scale up to half their height, free at the top. Succedanean cross-sections show that the seeds at the base of the fruit are completely ringed with tissue around them, only partially in the middle, and not at all at the top, growing together with the ovary tissue. The calyx is completely formed below, only partially fused at the edges in the middle, and not at all at the top. They carry, embedded in the testa, 1-2 on the belly side at the base, 2-8 on the back side, usually of unequal size, bladdery, round to elliptical in shape, and often stick to the seed when removed. The straight embryo is embedded in endosperm. Illustration: Fig. 18, Juniperus communis, cross-section through mature seed and adjacent tissue of ovary. The nutrition layer 4 and 5 is obliterated, except for the inner epidermis 5, as well as the nuclear remnant 6, 7. It contains, in addition to a large cell nucleus, a brown granular mass that turns yellow-brown through iodine green-black through iron chloride, and gold-yellow through potassium, giving rise to the deep brown-black color of the outer surface. The nutrition layer penetrates into the scleroid layer of the seed coat, 3 at corners, X endosperm, radical, secretion containers. After Church Esterly, Atlas, Anatomy of the Drug. The epidermis of the fruity rind is heavily thickened on the outside, with a textured pattern on the sides. The assumption by Nestler that the filamentous fungi aspergillus, at least 3 different types were found by Lendner, present in and on the fruit, caused the berries to turn from green to brown-black is incorrect. Rather, the rapid color change associated with ripening, known even to Theophras, is due to oxygen in the air and the effect of peroxygen and peroxidases on the tannins and resinous substances in the epidermis Lendner. The outer wall of the epidermal cells is coated with a fine, waxy layer that is particularly present on fresh fruits, regularly. The large round cells contain a large cell nucleus, and often still chlorophyll grains in unripe fruit, also starch. In glycerin preparations, sugar often crystallizes in these cells into beautiful tables. Slit openings are usually only found at the tip of the fruit. Towards the slit, the epidermal cells of the inner fruit wall become papillate, and the slits are pushed apart by tooth-like pulps. Following the epidermis is a weakly collagenous hypoderm of several cell layers. Then, the tissue quickly becomes very porous and well aerated. Within this soft tissue, numerous large schizogenic oil containers are embedded, which have an elliptical shape in the outer fruit wall, reaching 100-150 micrometers. Naked eye. They all belong to the fruit wall, but are partly so firmly embedded in the seed coat that they adhere to the seeds when they are removed fig. They usually contain a bright viscous balsam in the dried state, colorless oil in unripe fruits, and sometimes a crystalline resinous mass in overripe fruits. The oil quickly becomes hardened. 3 larger ones, corresponding to the midribs of the leaf blades, are attached to the outer wall. Within these, there are smaller ones arranged in a bow opening outward, 6 in each. In younger fruits, the excreting epithelium and resin-producing layer are clearly visible. Additionally, one can find numerous empty idioblasts, sometimes bent or curved individually or in groups, with a woody, somewhat thicker wall, dot-like or rarely net-like thickenings. One can regard them as scattered, metamorphosed tracheids of an improperly formed trachide bundle or transfusion tissue. They are also easily visible in the powder by applying fluoroglucinic acid salt, and can be found in the vessel bundles as well. The delicate vessel bundles are numerous. They exhibit a radiate arrangement of their elements, and conduct along with a group of coarse bast fibers, usually left-sloping spots, delicate spiral tracheids, mostly only 7-8 microns wide. The seed coat shows the following construction fig. 18. Below the epidermis follows a series of parenchymatous cells, where the seed is fused with the ovary, its tissue gradually merges into that of the ovary. The third layer of the seed coat is the sclerenchyma layer. On the inner sides where the seeds are exposed, the semenschal epidermis emerging from the epidermis of the integument can be seen. It possesses thickened outer walls facing the cavity. This epidermis detaches early from the layer beneath it and is often completely separated as a thin skin on mature seeds over large areas. It consists of sclerenchyma cells of varying strength, especially in the inner parts of the coat, significantly thickened and radial in orientation, with diverse shapes, whose walls are lignified and layered, and that possess numerous tubercles. Within the lumen, they often contain one or several oxalate crystals. The perisperm is almost entirely resorbed into a delicate brown skin that covers the endosperm, composed of nearly completely obliterated cells. The sclerenchyma layer is followed by the nutrient layer, which is usually highly obliterated in mature seeds. Where the seed is sharply triangular, the nutrient layer penetrates in the form of wing-like spikes along the edges. The inner epidermis of the nutrient layer, inner epidermis of the integument, does not obliterate. The outer wall of the epidermis consists of 3 layers: a layer of cylindrical cells, a tough yellowish middle layer that penetrates into the intercellular walls. The thin-walled endosperm contains oil and alerone grains with crystalline and globoid structures. The inner edge of the endosperm consists of parenchymatous tissue. The straight radicals and the 2 convex cotyledons, directed towards the apex of the seed, also contain oil and aleron. Lit. A. Meyer, Scientific Drug Knowledge with Illustrations. Churchill Westerle, Anatomical Atlas. In the powder, the parenchymal remains and sclerenchyma groups are present, as well as remnants of the outer epidermis. Individual sclerenchyma cells can also be found, along with cells from the transferred tissue see above and broken off papillae from the inner epidermis of the fruit peel. And food and luxury goods. Nestler, on the occurrence of mushrooms in juniper berries. Report of the Botanical Society, 1899. Lendner, Bulletin of Scientific Pharmacology, 1903. See also H. Mongen, Anatomical Study of the Leaf of Juniper Species. Thesis. Koch, Mikrosk, Annelies, D. Drogenpolf IV, Tate FF 13, Chemie. Fresh juniper berries contain 707. Invert sugars, 32.8888 in the dry substance. No saccharose, 6.67 other nitrogen-free substances, 2.79 free acids, 0.9 nitrogenous substances, and 78.5 water conic. It is supposed after Vogue tea to be or contain a glucotanide. Chlorophyllin church and other substances are probably also present. Nicolay found a crystalline resin, which Henry the Younger analyzed C75, H5F. Donath and Franz found in Moravian juniper berries. Sugars 29.65, 12-162. Wax-like, fat 0.6, 40.6, 1.29. 1.33. Essential oil 0.9. Bitter substance juniper 9.43. Bitter substance juniper 837 9.84. Acid 1.86, 115. Acetic acid 0.9, 40 0.57. Apple acid 0.2, 1 0.43. Older fruits also contain butter acid. Barren found in Italian juniper berries, 25.8 sugar. In fully ripe ones, Franz found 26.9, but only 846 in half-ripe ones. The amorphous bitter substance, the juniperin of Stier, which precipitates out of a solution of the rind and from the decoction, is black, soluble in much water and ether. On average, Italian berries yield 1,150, Bavarian 1,112, Hungarian 0.81 essential oil. The higher the climate temperature, the higher the oil content Mayer. The oil poorest are those from Trondheim and Gjelvestad, or Bruce, Sweden. The saponification number is usually between 333.7 and rarely exceeds 7.4 and 16.4 Kreml. The most left-rotating oil contains, in the fraction boiling between 155-162, pinane Ch tilden, Wallach, and, in the fraction boiling at 262.75, cadene Schimmel. Esters Kreml are not present here. Schimmel. In the afterrun, Schimmel, 1895, discovered a crystalline body that melts at 165-166, which is likely the watchholder camphor, watchholder stirrupton, already observed earlier by Buchner, Blanchet, Wandesleben, and Zaubser, for which Wandesleben provided the formula CHO. The pentosan content is 5.9, 6 to 6.07. Inosite has also been detected. The wax that forms the fruit ripening consists of serotinzor and palmitoylmyrisyl alcohol, in addition to small amounts of a monovalent alcohol with low molecular weight and glycerol esters, VOGDART. The watery extract should not be less than 20 pH. When the crushed berries, for the purpose of extracting the essential oil, are distilled with steam, this is the succus, or rue juniperi, juniper berry must, juniper berry salt, cadigmus, johandelberry juice, robe de Genièvre. The commercial product sometimes delivers 30-32. The juniper brandy Steinhager, Gin, Genièvre, contains 42.555 aldyl alcohol Mansfeld and Franz at King. On the production of juniper brandy, see Baron des Spur, 1890. The ash content of the berries is usually 3-4.5 and should not exceed 5 pH. Helve a fourth. The ash is greenish. It has little smell of juniper berry oil, but sometimes contains so much sugar that it crystallizes well. The pharmacopoeia is e.g., the helvet. IV, however, under Succus juniperi inspicatus, they understand an extract made from undistilled berries with subsequent addition of sugar. If one wants a pectin-rich extract, extraction must take place simultaneously with sugar addition. Church. Unripe juniper berries are not sweet, and contain starch that later disappears ash off, as well as numerous peroxidases Lender. The essential oil of unripe fruits also has a different composition than that of ripe ones Blanchet and Sell. A farm, Brit, distills old junip from unripe berries, lit, steer, analyst, Rupert. Vi 1857, Konig Nahrungs Eugenusum, Borf, Ofbalt. Donath Jaresber. DPH, 1873. Polytechnum, Jern, 1877. Vierteljahrschur, F. Nahor, Eugenusum, 1892. Franz, 1892. Franz, Ebenda, Ritthausen, Land, Versuchstadt, 1877. Berenkem, Bethhausen, 1890. Vogt Dissert, Erlangen, 1990. Doct Dissert. Nicolet, Journal of Pharmacy, 1831. Asch and Hauke, Austrian Pharmaceutical Review, 1902. Gildemeister and Hoffmann, Ether, Oils. Wandesleben, Annual Report of Chemistry, 1861. Zaubser, Reports of Pharmacy, 22. Tilden, Annual Report of Pharmacy, 1877. Schimmel, Reports, 1887, 1890, 1895. Mayer, Prague Review, 1884. The juniper berry has a distinctive spicy sweet taste with a hint of bitterness. Confusions. Even in the Mediterranean regions, it still has larger fruits, 12-15 mm. J. Older literature in Schwartz's Tables and Gemellen's Handbook of Organic Chemistry Feuille, 1858. The oil yield was determined by Carthuser Ferrand, P962, and Spielmann on the Q, but Spielmann 62 by Buchner Rupert. 1825. Blanchet Liebig's Annal, 1833. Dumas Ibid. 1835. Souberan et Capitaine Ibid. 1840. Taste. The fruits of Juniperus macrocarpa Sibthorpe, reaching the size of a cherry, are very sweet. Even better tasting are the fruits of junip. Californica, consumed in large quantities by the Southern California Indians A.M. Jern, Ph. 1878. Phanecia L., belonging to the Sectio Sabina in southern Europe and the Orient, has red, glossy berries of 8-14 mm diameter. The herb Sabine of French pharmacies often comes from this plant. Colin, J. Sabina L. has black, blue-fruited berries of 6-8 mm diameter. J. Virginiana L. has dark purple berries. Only the berries of Juniperus sabina have been actually observed as an addition to juniper berries church. The red berries of Phanecia are easily recognizable. Application. Since ancient times, juniper has been considered by the people as a sovereign universal remedy against water retention, like lingonberry. How highly he was regarded is shown by the following old verse. Before holly trees and cranesbill go back into my home, and snow me until half noon. Even when transferring plant diseases, Herr Wachtholder or Frau Kranewit, Mr. Juniper or Mrs. Cranesbill, played a role in the past IP 1088. To ward off witches, small children are still held over fires where juniper berries are burned. Juniper fumigation was also considered an effective remedy against the plague. In alley streets and squares, 100 or so fewer from Cranesville wood smoke, so that the air may be purified. Schmeltzel 1548 now. The medical use of the berries is minimal. They are used in tea blends and fumigations, baths and herb pillows, gin as mentioned above, in veterinary medicine for throat powders, and as a diuretic gainer. Extracted juniper, berry powder, presumably derived from oil distillation, has been observed as an adulterant of pepper spayeth. It was offered for sale in lots of 300 hectoliters weighed. The Serbian spirit vodnijica is obtained by fermenting juniper berries with mustard and horseradish, IS 1018, lit. Gemeiner, Farm, Zeit, 1906, Spayeth Forschungsbeer. I 1893, Waje, Verunrein, von Drogen, Beredi Farmdes, 1893. History. Juniper was used in ancient times for incense as it still is today, but it likely referred more to Juniperus oxycedrus and Phoenicia, which also occur in the southern Mediterranean region. These are probably also meant in the Bible Job 35:4, Kings 19:4. Seeds and berries of Juniperus Phoenicia, hieroglyph PRT men, Persho. In numerous recipes of the Eberus papyrus, berries of Juniperus fennec are listed. Juniperus was called Syrian wood in Egypt, as it was imported from Syria. The recipe for the famous incense Kaifi Warai, S473, included the fruits of this plant, referred to as Phenia agrion aeophyllon by Theophrast I, S5137. Dioscurides mentions two types of Juniperus, Arcuthos megale, possibly junip, Phoenicea or macrocarpa, and Arcuthos micra, which is junip. Communists, according to Daubeny or S559, and called Arcethus by Cangezer, meaning cursed bush due to its prickly leaves. In later Greek texts, the terms katsaria, katsuron, and katsaria are found for June, komun. For J. Phoenic, the terms are kentros and kendros. Synonyms for juniperus include Emnacythion, Acatalis, Zuar insipid, used by Africans Carthaginians, Libium by Egyptians, Juniperus by Romans, e.g., Plinius and Jupacellicin by Gallians. Communists alongside Cedrus junip, Oxycedrus. Scribonius and Marcellus, in their respective works, also refer to Juniperus, as does Medigon Midfa, the Alfida, circa instance, Nizaldus's Medicus Hortus Pauperum, and Cordus, all in various sections. Actuarius differentiates between Bacchae minoris juniperi, J. Com, and B. majoris juniperi, J. Fennec. The juniper was introduced to medicine by medieval Arabs. Distilled juniper berry oil is mentioned in Saladin's Compendium Aromatariorum, 1488, Ryff Ein, S875, Cordus or Ernst, S801, Schnellenberg's Arsnebuch, Königsberg, 1556, I. S. Unger, Streifzüge, etc. Gildemeister Hoffmann, Essential Oils, Fructus Sambuci, Sin, Bacchi Sambuci, Elderberry, Hollerberry, Holderberry, Alehornberry, Shiptonberry, Lilac berries Hutchelm, Grana activa in the Middle Ages, Vlader in the Gothair Arzneibuch, Hildre in Middle English Medical Books 1, SS 817, by Van Helmont Ortus Medicinae, 1648, and others. In the Braunschweig Register of 1521 Varn, S. 814 OL, the Granis juniperi is listed alongside OL juniperi. Otho Cremonensis, Bouchon, Preliminary History of Botany. 1895. Schweinfurth, The Last Botanical Discoveries. 683. Bays de Sureau French, Black Elderfruit English, Sambuco Italian, Lievrucht Dutch, Celia Punmarja Finnish, Bodzabogyo Russian, Ancient Greek, in Dioscurides, Hippocrates, Theophrast Galen. Among the Gauls, Scobian, the Dacians, Seba. The derivation from Persian sambuca, a triangular stringed instrument, seems doubtful coincidental homophony. Also Riscus, among the Arab physicians of the Middle Ages raises, Ibn Bathar, Aktha Chaman, Sabukat in Japan, Set Kotsmoka, Etim. Sambucus perhaps from ale, or red dye, or plant used for dyeing red, after the juice of the berries. Elderberry better as Holunder, possibly from Hull, due to its hollow pith and tar. Tertre purger. Holder thus breaking wood, due to the fragility of the wood. Ahad day. Hollentar, Holenter, MHD. Hollar, Ellower, Holunder, Holder, MG Holdern. Lilac is the German name for Sambucus nigra. It likely comes from flater to flutter, Stampfpflanze. Sambucus nigra L. Line spec. Plant. Ed. I. 269. Caprifoliaceae. Sambucae. Secte. Usambucus. According to Grassman, Eller and Holunder have the same root al, Dothic allen to grow, to rise. Further folk names by Pritzel Jessen. The strange name Ahornbeeren is corrupted from Alehornbeeren, derived from Alhorn see above. How it came about that the name lilac was also transferred to syringa is unknown. Black elder is a shrub or tree reaching up to 6 m in height, with barked trunk, decussate branches that are round, green, and covered with lenticels in the juvenile stage. Older branches contain a large bark that can be easily separated from the wood, forming the much-used mulberry bark in the preparation of microscopic cuts. In gardens, many varieties differ by leaf division, entire or partial variegation, or chlorosis laciniata, argentea, aurea, virescens, monstrosa, or possess white fruits leucocarpa. The plant is almost widespread throughout Europe to Toria and Caucasia, also cultivated in many places and ascends far into the Alps, but usually remains near huts. It often leans against a house wall or seeks its nearness. Sambucus nigra is a component of peasant gardens in Germany, Austria, France, and Switzerland, all countries that were once united under Charles the Great's rule. Lit. Fig. Bird. Pabst Kohler's Medicinal Plants and Hain, Drug 4T16. Description in Luers. The flesh is purplish red. The solitary stone kernels are brown, wrinkled and convex on the outside. Drying causes them to lose of their weight and shrink significantly. Pathology. 1112. Description of the drug. The half-submersed ovary of the elderflower, see above, is usually 3, rarely 2-lobed. It contains 3 2-hanging, anatropic epitopic ovaries. The fruit is round oval, up to 6 mm long purple-black, with a nipple at the top. Parasitic fungi as fruit destructors of Sambucus nigra are not known to us. Fisher. The epicarp consists of large, isodiametric, or slightly elongated cells containing a violet-brown content, which appears striped due to the rough folding of the cuticle fig. 19. The folds run at very regular intervals. Slit openings are only found sporadically. The mesocarp comprises more or less thick-walled cells, often with a mucilaginous intercellular substance. This seems to be a particular case of pectin metamorphosis. The tissue is dotted with delicate bundles. The endocarp, the stone coat of the stone kernels, is very hard, showing ridged elevations, making the stone kernels appear coarsely granular. Externally lies a series of short, bent, radially stretched, unequally tall sclerenchyma cells with branched, split lumina fig. The strongly thickened sclerenchyma cells have an irregular outline and are interlocked. Then follows a layer of 1 to 2 rows of fibers aligned in the longitudinal direction of the seed, followed by another 1 or 2 rows of cellulose cells arranged at right angles to the previous layer. The arrangement of mechanical elements in crossing layers and the interlock of the cells is common in fruit and seed coats and significantly increases strength. Also, the fibers in the inner layers are interconnected among themselves and with the sclerenchyma. The seed coat of seeds derived from hanging, anatrop epitropic ovules with only 1 integument Bachmann consists only of an obliterated nutrition layer fig. 20. 1.5 beta. The embryo and endosperm contain allorawan grains abundant in oil plasma, where both crystal and globule forms are found. Fig. 24. Illustration. Fig. 19. Sambucus nigra. Numbers correspond to 1-3. Bast cell from layer 3 isolated. Church, pectin and protopectin. Bear, Farm, Jess, 1907. Rosenberg on the metamorphosis of pectin. Dis. Top. Cross-section through the edge portion of the fruit. Mesocarp in pectin slime metamorphosis. Bottom. Plan view of the epidermis of the fruit. Nach Church Esterly. Atlas, transverse section through the endocarp and margin of the seed. 2. Transverse sections through the endocarp, ... Byrne, 1908. Balkman, Construction and Development of Official Samplings in Fruits. Dissert, Byrne, 1901. Arthur Meyer, Drug Study. Chemistry Scheele found apple acid, but no lemon acid. Enzi, 1859. Fermentable sugar, essential oil, bitter substance. The pigment is iron green absorbing. It turns blue with lead sugar, blue with alkalis, red with acids. It occurs in the dried berries, which only yield a yellow pigment in alcohol, along with a little spectrally barely detectable chlorophyll. In water, it slightly stains violet red. Kunz and Adam found 1901 lemon acid, but no apple acid. Regarding the wisteria pigment, it should be noted that different species of Sambucus appear to behave differently in spectral analysis. Certain species give a clear stripe with alum, similar to the mauve pigment, while others display a deviating behavior Vogel. The red extract obtained from the drug by water gives, after precipitation of the mucilaginous substances with alcohol in the spectrum, a dark band at D, approximately from 0.56 to 0.6. Adding ammonia to the solution results in two bands appearing, a darker one between 0.61 and 0.66, and a lighter one between 0.57 and 0.59. Chirk. The unknown, sweat-inducing component of the flowers is also present in the fruits. Sack and Tollins found tyrosin in the berries. The pentose content is 1.2. In the bark, the fluid extract of which is called le moine sambucine, and the leaves, in addition to tannin, laxative resin, and an odoriferous substance. The oil from the seeds has a repugnant juniper scent and taste. Newer investigations on the carbohydrates of the berries are lacking. The berries of Sambucus ebulus have a similar composition, and the bark, leaves, and roots were more commonly used in the 16th century than the berries and flowers see above. Litt, Scheele, Schriften 2, 3-78. Vogel, Spectral Analyse. Malmayak, Joren, Farm, Chim, 1901. Über die Blätter von Sambucus nigra Vegel. Mitlache aus dem Arzneischatze des Volkes. Farm, Post, 1908. Dort die Literatur. Historisch interessant. Martin Blochwich, Anatomia de Chemia Sambuci, or the Anatomy of the Elder. 1670. Anwendung. Die Fliederbeeren geben gepresst einen Saft, aus welchem man das Holunder oder Fliedermus, die Fliederkreide, Holundersalze, Rop, Rub oder Rapsambuci bereitet. This flywell is found already among Arab doctors. Dried elderberries then in the pharmacies of the 16th century and later. Gova Erz Blätter Rhein Trav, Sock, Ph. Dunvers, 1880. Sack und Tollens, Bear D. D. Schem, Guess 1904. Sack Dissert, Göttingen, 1904. Kunz U. Adam, 1901, 244. Van den Driesened, Tescherot 1. Alfred Blanc, Liebel Monography, Montpellier, 1905. The Dutch pharmacopoeia includes recent fruits, mixed fruits. The pressed juice from the leaves of S. nigra was used by Hippocrates as a dietary laxative. In Stone Age settlements, e.g., Musidorf near Bern, as well as in Bronze Age, Terramares Parma, seeds of Sambucus nigra have been found here. Acte is found in Hippocrates, Theophrastus, and Galen. In Scribonius Largus I, p. 578, Sabucum and Sambucum are mentioned. Even the Stone Age man seems to have used elderberries for dyeing and making mousse. The use of Sambucus acinos for dyeing hair is also mentioned by Plinius. According to ancient Germans, they not only colored their faces but also the images of gods with elderberry sap Lowenstein. Among the ancient Prussians, elder was sacred and not to be harmed grim. Also see the verse regarding Juniperus p. 52. Sambucus is found as a component of sacred herb wreaths. Also, in the transfer of diseases to plants, Lord Elder, Lady Honeysuckle, and Lady Hornbeam play a role in folk tradition, see I. p. 1088. In Alphita, the Synonoma, circa Instans, and the Tabulae Magistri Salerni, it is written, Sambucus actus Helarn, ebulus, camiactus Sambucus. Thus, Sambucus ebulus and nigra were often combined even in ancient times. The name acte then became adage, i.e., Sambucus ebulus, Adich is derived from acta. In Hildegarda first, p. 671, only the honeysuckle tree is mentioned. In Harpistrangleri, p. 684, it is Sambuca, and in the Gothic Pharmacopoeia I, p. 679, it is Elhorn, Alhorn, and Elder. In Cordis, Sambucus flos et simacum is alongside Samsucius, which is interpreted as Majorana. See also Kuhn, the elderberry in Old Medicinal Botany. Medical Clinic 1907, No. 33. Parallel drugs. In North America, the so-called American elderberry, Sambucus canadensis, L., is used in the same way Jackson Moosbrugger. The more reddish fruits are sweeter. In Brazil, Sambucus australis. In Siberia, Sambucus racemosa, L. Others in Dragendorf, medicinal plants. The berries of Sambucus ebulus L., the dwarf elderberry chamaicact of the Greeks, ebulum of the Romans, nabsacat of the Arabs, mentioned by Hildegard, purgative ingredient in Kneipp's tea. They are smaller, four-seeded, with a clearly protruding calyx remnant. Sambucus ebulus is more or less poisonous in all parts. The berries of the dwarf elderberry are used in Romania to color wine analysis and spectrum of the dye by Raduilescu. Literature Jackson, Farm, J. 1906. Yarber, 1899. Home. Sambucus canadensis, Merck Rep Desitate, 258, 259, and 1909. Fruit of prunus. Sin, plums, sloes, plum trees Hildegard, black plums, prunes French, prunes English, pruum Dutch, lumu Finnish, Greek, according to Ibn Baithar, Idshas. Prunus derived from Greek, likely originating from Asia Minor, where it was used for Prunus domestica, according to Schmidt, the AAD. Fruma still used in the 11th Chronicle Plumo. MHD, Fluma, originated directly from Greek and not Latin prunus, prunum through Thracian or Illyrian mediation. In Greek also, a wild fruit tree, or early, as its fruits ripen in midsummer. According to Klug, Pflauma was already borrowed from Latin prunum, pruna before the AHD, period. The R of Latin is absent. Wortis ist ein L geworden, wie bei Morus in Molberbaum. Und prium hat noch das R ebenso frets, prune tal, prugna, span. Fruna, nicht mehr Angles, Plume, Ingel, Plumda. Zwetsche hat wohl ursprünglich Quetsche geheißen Quetschen. Quetsch noch heute in Thüringen, im Rhein, in Hessen wegen des daraus bereiteten Muses, auch in Paris, Lest, oder von Slav. Sweska, viel mehr deutsche Volksnamen besitzt Prunus incetitia, die heimische Pflaume, die im Mittelalter auch Sinus, Sinum, Prinus, Pruna, Spinellum genannt wurde. Kriech, Creature, Kriegen von Krie, Evrazee, Krek-Session, Ahdacht, Rosaceae, Prunoidae, subgenus Prunophora. Some Linnaeus de Candolle consider all plums to be varieties of Prunus domestica. Others, Dierbach, derive the round plums from Prunus sativa fuchs. Yet others, Koch, hold Prunus incetitia, L. Val. Friesan Kritzen, Spilling Spinellum Durnlein, Braume, Haber, Kickerling, Marunken, Pelskirche, Prumum, Schlucken, Spelje, Zibarten, Zipperli, Uvi, Avagel, Pritzeljessen, Stamppflanze, Prunus domestica L. Linnae, Speckplant, ed. Linnae, Speckplant, ed. Or. I. 4075, with numerous varieties. Don knows 270, particularly well P. divar Juliana D.C. to be the type species for the round ones, and Prunus domestica for the elongated ones. Among the round plums with a short, thick stone kernel are Mirabelle and Rheincloud. Among the elongated varieties with a long, flat stone kernel are Damask and Brignole. Only these blue, elongated plums are used medicinally. In Japan, Prunus triflora Roxb. is cultivated. Ascherson and Grebner with Folke, Boissier, rather consider P. domestica, L. P. domestina, Dierb, P. domestica. According to Engler, modern plum species are derived from various parent species. The plum, in a narrower sense, P. oeconomica Bork, belongs to P. domestica L., widely distributed in the Caucasus, Talysh, and Elbrus. Cultivation and trade. Prunus incetitia L. creamer plum is native to the Caucasus and Asia Minor, but its range extends to North Africa and southern and central Europe, which is indigenous to Turkestan and generally throughout Western Asia, cultivated in Persia. The most extensive plum cultures are found in Bosnia and Serbia, as well as generally in the Austrian-Turkish border regions. There in the gold mine of Slivovitz, one finds entire cherry forests, and from there dried plums are exported to all countries. Recently, North America has cultivated many plum trees. Germany imported 392,469 Z dried cherries in 1907, predominantly from Serbia, 135,115 in North America, then from France and Austria. Pathology. Alongside Sclerotinia cinerea, see under Prunus cerasus, which also occurs here. Exoascus pruni fuck is the most important disease-causing agent of the cherry tree. Its micelle develops in the fruits, causing them to exhibit an entirely abnormal development. They become curved, flattened, or greatly elongated, white or reddish-colored and inedible, with no differentiation between stone and fleshly endocarp. These deformed fruits are called fools, pockets, or starving cherries. The asci of the fungus develop on their surface. Ed Fisher, Animal Pests Ender cerasus description. The fresh blue egg-shaped with a lateral groove plum has a variable size. It shrinks significantly upon drying and becomes almost black on the outside, with the flesh turning brown-red. It is a drupe containing a flattened stone kernel that encloses the seed. The epidermal cells of the fruit peel often still show the divisions of the mother cells. The epidermis has a waxy coating, but no hairs. Sugar efflorescence often occurs on the surface of the drug. The flesh consists of parenchymal cells. The vascular bundles contain spiral and net-like vessels. The endocarp is made up of sclerenchyma. The seed coat cells illustrated in Winton are quite small, roughly the size of those in the apricot. The endosperm is narrow. The cotyledons form the main mass of the seed. Chemistry. Fresh plums, on average, according to Koenig, contain 78.6 water, 14.71. Invert sugars, in the dry substance of the fruit 68.74, 0.74. Dried plums contain 23.28, 59.2. Invert sugar, average 43.15 in the dry substance. Average 2.44 free acid calculated on apple acid, and saccharose 0.512.81. The ash of the whole fruit is 3.117, of the seeds 2.5, and of the flesh 4.2 calculated on dry substance. Ash analyses by Koenig B.I., p. 862. Seeds contain a cyanogenic glycoside and a hydrolytic ferment. From the pressed and crushed fruits of plums, a plum brandy Slivovitz, Slivovica is produced in Alsace-Lorraine and elsewhere, containing approximately 43.5552 alcohol and 0.23. For its composition, see Windisch, Works of the Imperial Health Office, 1898. Just as the sugar content of plums varies greatly, so does the alcohol content in plum brandies. By cooking down the mashed fruit pulp strained through a sieve into a thick paste, plum pures vechenmus, pulpa de pruno, pulpa prunorum, rob pruni is obtained, which has been used as a mild laxative for centuries. It contains approximately 24.5 invert sugar, 8.8 saccharose, and 1.7 pectindol. A syrup of plums appears in the Hareb calendar from the year 9161 I, p612. Pest of the drug. Dried plums often harbor mites, such as Glyciphagus prunorum, Israel. History. The royal garden of Nebuchadnezzar contained, according to the alphabet of Ben Sira, also plums. Prunus incititia. The creeping plum from Germanic Crick, Schrader, is the European plum, which has already been proven for the prehistoric flora of Central Europe, namely in stake buildings from the Neolithic, Bronze, and Iron periods. Bouchon. Under from stone fruit. Perhaps, however, contains an Oriental word. The slow plum was called lawn. Dioscurides understood both this domestic plum, which is still called caramelia in Greece today, as well as those from Syria, particularly those from Sarnan, as well as those from Syria, particularly those from Damascus, i.e., the Damascene plum Prunus domestica, whose cultivation initially developed in the Orient Ingler. The Romans confused both. Even at Hildegard I, p. 6070, the name Prunebaum seems to encompass both, as indeed our word plum does all kinds, round and long. The word prunus in Albertus Magnus I, p. 675, appears to have been used for both Prunus domestica and P. armeniaca. Excavations at Salzburg showed that plums, apricots, and cherries were already being cultivated there by the first Christian centuries by the Romans. Eastern Germany may have received the Damascus plum from the Austro-Turkish border regions via Hungary, Transylvania, and Moravia, where it was certainly much cultivated 400 years ago, Relling and Bonhorst. How old the culture in Serbia and Bosnia is unknown. Perhaps it existed even before Slavic immigration. Making a drink from berries, where the northeast is abundant, is an old Slavic or Eastern European custom already hinted at by Herodot in his description of the lands beyond the Skytes. A prune tree is mentioned both in the Capitularies of Charles and in the St. Gallen monastic plan, find T622. However, this was not the Damascene plum. In the Alpheto Arai, P656, there is mention of white and black prunes, while the tabulae refer to immature and Damascene plums, and Serapion uses the term anas. The plum plays a significant role in folk medicine, though it does feature in folk erotica, as evidenced by many of its folk names: prickly plums, goat plums, titter plums, sperner plums. For more information, see Agremont, Folk Erotica, Lit. Engler, in Hain, Cultural Plants, 7th ed., 1902. Bouchan, Prehistorical Botany. Winton Moeller, Microscopic Examination of Vegetable Foods, 1906, which includes further literature. Dort die Chem, Literatur, Illustration, Hain, Arsnageva, 4th t. Greek, Avicenna, Hunan, and Zufa Izef. Already in Serapion, Uips, Indian Jube, Ber, Beri Hindi, Badara, Kola Sanskrit, Sidar, Anabe Hindi Arabic, Sida Wanap Ibn Bethar, Gunnar Persian, Daunhon in Anam. 43, and Nies von Essenbeck, P.L. Med. T319, Fructus Jujubee Sin, Bakai Jujubee So, Zizifi, Rot Brustbeeren, Zieserleisbaumbeeren, Judendornbeeren, Judendornbeeren, the lotus of the ancients. See history. Greek, from which the genus name of the plant. In later Greek, Hanab N, the fruits of cedar in Ibn Bethar, Tal, common jujube, Pitni Ber Hindi, Anna Arabic, Ibn Bethar, An-NB, Vision Didagilani Persian. Ziziphus and Ramnus fruits are called in Chinese Stammpflanzen und Paralleldrogen, die in Deutschland und Frankreich benutzten spanischen oder französischen Brustbeeren, common jujube, große J, welche Hahnbutten, Jujubie kommen. Ramenus Ziziphus L, kultiviert in Spanien und Südfrankreich. Die weniger süßen kleinen italienischen und nordafrikanischen von Ziziphus lotuslam, Z. nomularia, W.et.a., Rhamnus nomularia Burm, kultiviert in Ägypten, Italien und Südspanien. Die ostindischen Jujuben Indian Jujube, Chinese Date von Ziziphus Jujuba lam, Z. Mauritiana Ham Z. D. Sororia Schott. Rhamnus Jujuba L. Heimisch im indomalaiischen Gebiet bis nach China, kultiviert in Vorderindien, Persien, China und nach Balkans, Indien Z. Spina Christi Wild, Egypt, Palestine, further in Dragendorf's medicinal plants. Systematic position and description. Rhamnaceae ziziphie, Ziziphus vulgaris is a shrub or tree originally native to China, now cultivated throughout southern Europe and North Africa. It grows to 5-7 m with spiny side leaves. The glossy, zinnober to brown-red oval fruit, ripening in July-August, is the size and shape of a large olive 2-3 cm, and is a drupe. It shrinks significantly upon drying, and contains an oblong stone seed, often with reduced or twisted embryo. Lotus, for example, which is widely spread in Tunis, are smaller, often only half the size of the regular ones. Most large jujubes now come from Provence and the Isles d'Hire, while the small ones originate from Italy. Jujubes, especially when dried, are very susceptible to insect damage. Anobium panaceum, chemistry taught Latour discovered crystalline zivus acid and ziziphin in the wood of Z. lotus. Application. Jujubes are not as effective for coughing, etc., as domestic sweet mucilaginous substances. Gren 1799. Within the tough, leathery epicarp lies an exceptionally soft, fleshy, well-aerated mesocarp sarcocarp, whose cells contain crystal druses here and there. The endocarp is woody and hard, consisting mainly of a broad layer of sclerenchyma and a narrow inner fiber layer. Of the two varieties, usually only one is cultivated. The fruits of the Z. Jujubes contain such high levels of sugar, including both hexases and saccharose Church and Erickson, that they often have a tough syrup inside, and a cut through the flesh under oil is dotted with sugar crystals. Furthermore, they contain mucin, malic acid, and tartrate. Geoffroy already conducted a pyrochemical analysis. Vonig therefore only considers the Cyrenian lotus as Ziziphus lotus. Theophrast knows of two distinct species of the Cyrenian lotus. The Indian lotus is Nelumbium speciosum, the Egyptian lotus, Nymphaea lotus, Theophrast's great lotus of Cyrene D. Plinius, Celtis australis, the lotus pear, Diospyros lotus. The sour, sweet, fresh, almost apple-like tasting fruits of Ziziphus jujuba are eaten in India, those of Z. vulgaris in southern Europe. On Z. jujuba, the lac scale forms a stalk lacquer, see below. History. Lotus was an ancient collective term. They often found older chest syrups and lozenges in company with dates, raisins, and sebestes, see below in Pharmaceutical Gallic. A Rob Jujobi pulpa de jujubis was listed, and jujubes are an ingredient in the Quatre fruits pectoraux, some older chest pectoraux, some older chest teas, and others small fruits, chest pastes. The latter has been accurately described by Polybius Athenaeus XIV, 65, and from his description, it is clear that this species cannot refer to any other plant but Ziziphus lotus. Paris, 1788, Data. This Ziziphus is generally considered to be the lotus tree mentioned in Homer's poems of Theophrast. It is also known as Melalotus, according to Strabon-Vestiseptine III, whose fruits were used to make Libyan wine, a favorite drink among the poorer citizens of Alexandria, according to Herodotus. We do not know after which lotus the lotophages were named. In the papyrus of Evers, according to Luring and Joachim, p. 475, besides the fruit for plaster resins, wood, shavings, bread, and powder from Ziziphus lotus are mentioned. The second African lotus is Celtis australis. The sycamore of Galen, was perhaps also a Ziziphus. Uncertain remains whether the Paliurus of Strabon is a Ziziphus spina Christi, from which the crown of thorns of Christ was made, p. 491, or not. The Egyptian plum tree of Plinius might be Diospyros lotus, a fruit found in an Egyptian tomb, previously thought to be Diospyros lotus, was identified as Mimosaups cumul hoxt. At that time, the consul Sextus Papirius brought it from its original home in the east to Italy. The jujube tree must already have been well known in Italy during the time of Pliny, as Pliny compares the leaves of the tree with those of the cypress and the ziziphus, which are both familiar. Jujubes are also mentioned by Columella, Gargilius Martialis I, p. 573, and others. The Arabs made extensive use of the fruits, see Ibn Bathar, and the botanical lexicon Kitab Ar, c. 980, as did the West. In Alfita, jujube is found Funin, Zufaisif. Bartholomew Warren, p. 650, refers to it as Pomas Sancti Johannes, and in the Frankfurt List 1450, it appears as jujube and jujibe in Cordus I. Now they have largely fallen into oblivion. Jujubes are among the drugs of first-class princely importance in the oldest Chinese pentis ale, the Shin-known Penda. They have been highly valued there for thousands of years, down to the present day. Lit. Jussio, General Plant 1, 3798. Embark Encyclop, and Dict, Voljo, 185, F1. Floor, Brit, Ind. I-632, Watt, Diction, Econ, Prod, V. 4. Pharmacographia Indica. Illustration by Weber-Bauer and Ingler-Prantl plant families. Pomet I. P. 941 gives a fantastic illustration of the plant. A slightly better one in Valentini's Museum I and in Harel Traité de Pharmaco. Pig. 66. Bacche myrtillorum, Heidelbeeren, Blauberen, Beige d'Arel Myrtille France. Bilberries, blueberries Indel, Bacca di Mirtillo Ital. Blau Boschbessen Hol, Mostica Fin, en Grieche. Illustrations of Z. vulgaris, Hain 10T43, and Dusseldorfer Atlas 16T22. Illustrations of Zijujuba, Reda 4041, and Rumphius 2T36. Geoffroy, Materia Medica, p. 36. Wunig, Die Pflanzen im Alten Ägypten. Second ed. 1886. Latour, Jurin, Farm, 1858, 420, Sebestin. The formerly widely used often, see Geoffroy in conjunction with jujubes, the black breastberries or Sebestin in Theophrast, in Paul. Aeginida, in Actuarius. Sebestin originated from Cordia mixa L. They are already found in the Papyrus Ebers Y, p. 463. Fructus mortilli, Sin. Boschbisi, Braunber, Udelbeeren, Krekelbezin, Heverbesen, Etem. Schwarze Bessinge, Bessinge. Bickbier, Gandelbeer, Hasselbeer, Hadienbeeren, Kranbeer Padel, oder Rossbeer, Puckelbeer, Setbier, Wolpere in Siebenbergen, Kürtegen Kutsitzen, bei de Hildegard, Waltbeer und Heidelbeer, bei Bock, Staudelbeeren, bei Cordus, Heidel, im Athdi, Heidbeere, Heidperi, im MHD, Blueberry Bilberry. Blueberries because of their color. The dark, almost black color is also indicated by the names Bickbeer Hall, Pick Pitch Black, Blue A's, Moretz Dark Berries, Brambels, Brimbels, Blayberry, Mustika UA. Also, the Russian name Cherinka means blackberry. The ordinary derivatives of vaccinium through corruption from or from vaca cow are rejected by Kangieser, and, as it seems to me, with justice derive the word from baca, Bacinium berry bush, since umlauts from B to VR are frequent Botanica inni. Botanica, Valeriana in Baldrian, Barbascum in Verbascum. Myrtillus is a diminutive of myrtus, because the little shrub resembles a small myrtle. Basi basing by from ban bas shining, Stampflanze, Vaccinium myrtillus L. Linnaeusbeck, plant 349, Systemat, position and description of the Stampflanze, Ericaceae, Vaccinioe, Vaccinioide, Vaccinia, Vaccinium myrtillus. Fruit apex, K. Kelch, fused with the FW ovary wall, Testatarium. Attachment of the corolla. D. disc, GR stamen attachment. S. seed, church. The bilberry is circumpolar in Central and Northern Europe, Asia excluding Inner Asia, Canada, and Middle North America down to Colorado south. The bilberry is a bare shrub, growing up to 30-50 cm tall, with elliptical round leaves and solitary axillary flowers. The flowers have an inferior ovary that is completely fused to the fleshier calyx on the sides, and only free at the tip illustrated in Engler Prantl, Plant Fam. IV 1, p. 24. Here, there is a small disc to which the corolla and stamen filaments are attached. The fruit is not a true berry, although it has the characteristics of a berry because the fusion of the calyx and corolla is complete stoneberry muller, as the calyx also participates in the formation of the fruit peel. The albino form with white fruits, Vaccinium myrtillus L. Lycocarpum hausum, is not relevant for us. In Russia, the governments of Vladimir and Moscow, as well as Poland, supply mortills. Description. The berries ripen in July and August, are brushed off with wooden combs or rakes and dried in the sun. 6 parts fresh produce, 1 part dried. Commercial varieties. Blueberries come from various regions of Germany, such as the Fichtelgebirge, Bavaria, Bohemia, Silesia, and also from Russia. Dried, the berries shrink significantly. Soaked in water, they immediately release pigment and swell. Each lobe contains numerous. The blueberries are 4 or 5-lobed, spherical, about pea-sized or smaller, blue-black and ripe. They taste sour-sweet, slightly bitter, and contain a dark violet juice. At the tip is a wave-like disc, edged with a fringed margin formed by the irregular calyx border, in whose center one can discern the attachment place of the stalk fig. 21. The epidermis of the fruiting calyx, i.e., the cup attached to it, see above, consists of polygonal cells containing blue cell, ... Slit openings with 4 adjacent cells, 2 large and 2 small, parallel to the split, are found only on the calyx margin at the tip of the fruit. In the parenchyma of the fruit peel, sclerenchyma is often combined to form nests, and even the inner epidermis of the fruit peel and the septa walls are partially sclerified. The parenchyma cells contain the pigment dissolved in cell sap, and here and there, oxalate crystals. The small bundles are collateral. The fusing of calyx and fruit peel is so complete that no boundary between them can be seen in the mature fruit. The epidermis of the berry shell consists of thick and speckled cells on the inside, and at the lower parts of the sides without slime membrane deposits distinguished from bilberry. The rest of the berry shell consists of the obliterated nutritive layer, whose side walls are slanted. The embryo is embedded in a laromon-leading endosperm. Pathology. Fisher reports. In the fruits of Vaccinium myrtillus, Sclerotinia baccharum, it represents a hollow spherical structure that forms in place of the tissue of the pericarps, and looks like a dirty white blueberry externally. For more details, see Warrenin on the sclerotial disease of Vaccinium berries. Mem. Acad. Taisai. St. Petersburg, Sever 7, T36, 1888. Also see Senft Farm, post-1903. The number of microlepidopterans living on blueberries is also very high. Chemistry. On animal pests, Israel reports a very large number of polyphagous silk moths, spinners, and especially owlets from the genera Acronicta, Adina, Mamestra, Agrotis, Anarta, etc., live on Vaccinium myrtillus. Among spinners, a number of Sidaria and Acidalia species that feed on the leaves of Vaccinium species are particularly notable. Blueberries contain, according to Fresenius, martinine, margold, coolish, and omaze. Fruits, 1192. Free acid calculated on apple acid, and likely present as such in dried berries. Kaiser gives 7.02 calculated on wine acid. Shield found apple acid and lemon acid in almost equal amounts, and C 0.5 pectin. The pentason content is 0.76 to 1.28. Ash amounts to an average of 0.71. Omaze and Hornberger found. In addition to iron, C2 manganese oxide. Kernels and shells amount to C11.5 to 13. Agirdiard gives 4.5 water and 2.888 ash of the dried substance at 105 as values. The sugar content of the berries increases during ripening from 0.42 to 1.9, and finally to 5.42 to 1.9, and finally to 5.13. The ratio of acid to sugar is approximately 1:3. Myrtillus. The coloring matter of blueberries is dissolved in cell sap, soluble in water and alcohol, insoluble in ether, benzene, chloroform, and sulfur carbon. It belongs to the anthocyanins, specifically the wine-red group Weigerts. Schlegel found 3.92557 invert sugar, 0.15 alcohol, 6.92929 extract, 0.29 extract, 0.22 ash. Total acid calculated as wine acid, 1.11. Botanical as acetic acid, 0.3 dollar. Acid calculated as acetic acid, 0.3. And inus benzoic acid, which Nestler found in Vaccinium oxycoccus, is not present in V. It turns dark brown with iron salts, green with alkalis, red with acids, and reduces feeling solution upon boiling, supposedly having the composition Cho-Nakin. He is gray-green when treated with lime milk. He is not identical to the wine pigment spectrically, as André stated, but different Vogel, a difference that becomes particularly evident after adding ammonia and alum. The pigment changes upon drying the berries, compare Vogel. The extract from fresh blueberries, which allows blue and red to pass through, shows a band at B that shifts to D after adding ammonia, and a broad band between D and B is observed after adding alum and ammonia. According to Hayes, the pigment consists of two substances. One, reddish-brown, soluble in acidic water. The other, reddish-violet, forming the main portion, is not. The latter splits into glucose and the aforementioned pigment during hydrolysis with diluted acids. The pigment almost completely passes through the gastrointestinal tract without being absorbed. Therefore, it colors the feces and also appears in the urine. The active substance remains unknown. Winternitz holds the dye, while Miller and Blau hold the tanning agent, possibly chinagerb acid, with Blau stating it constitutes 7.28 of the dry substance. According to Nakin, the tanning agent is a glycoside. Its aqueous solution turns green upon addition of iron chloride. Whether the glycosidic bitter substance, Ericolin Cho, found in leaves of various Ericaceae species, especially ledum, and 29 types of genera, including Erica, Rhododendron, Pyrola, Vaccinium, including Myrtillus, Azalea, Gaultheria, Clethra, Erudiction, Ledum, and Epigea, also occurs in the fruits, as I have indicated, remains questionable. See also Senft on the decomposition of arbutin in mortilliform. Post-1903, counterfeits are rarely encountered. The blueberries have found diverse medical applications. They can be found, for example, in Schroeder's Pharmacopoeia Warren, p. 890, in Murray's Apparatus Medicamentum First, p. 952. Berries of Vaccinium uliginosum L. raspberry are larger, outwardly lighter, less sour. They are likely to have the same effect. The berries of Vaccinium vitis idea L. are red, not very juicy, astringent, sour due to citric acid and apple acid. In them, the content of citric acid increases during ripening. It reaches 2.5. Application. As an antidiarrheal and in the treatment of eczema externally and from mouth rinses, they were recently recommended by Winternitz in the Leaves for Clinical Hydrotherapy, 1891 and 1895. The so-called martillin, i.e. Extractum martillorum by Winternitz and blueberry wine, are used frequently. The leaves have also been recommended recently, 1892, for diabetes. Blueberries are also a popular natural dye for wine. Germany supplies a large amount of this to France, presumably primarily for this purpose. Then, blueberries were also introduced to France for alcohol distillation. History. Blueberry seeds and fragments of the fruits have been rarely found in Stone Age settlements, Robenhausen here. The Celts certainly did not use the fruits much. Plinius the 1631 seems to have referred to V. myrtillus. He contrasts it with a Gallic species Vitis idea, used for dyeing the clothes of slaves. In Alfida S. 653, Myrtus and Myrta are mentioned, whose seeds, myrtillus. Lanicerus also has myrtillus. Cordus Arern, S. 800 mentions mortillarum, succus et bacca. The Frankfurt List 1450 has myrti, and the Nördlingen Register of First, S. 813 has myrtith. 1902. p. 461. Includes anatomical illustrations and medical literature. Lampeao Garcine, Rech Histogen, D. Pericaps Charnus, Margold Jarisber, F. Agric, Chem, 186,1062, Pulish, Zeitcher, Angu, Chem, 1894. Omeis, Chem, Central Bull, 1889. Schlegel, Jaresby, D. Farm, 1908. Nacken, Zerchem, Tarekt, Die Heidelbeerssaft des Forschungsver, 1888. On Spektralanalyse, 1889. Dort die Spektren. Speth, Zeitcher, Unters. Gautier Bull, Soak, Chim, 25 Arch, D. Farm, 9, S4086. Münzberger Zeitcher, D. Oester, Etcher, Elpa. Bear, 1893, 318. Omaze, Studien über die Entwicklung der Frucht die Analytik. Erlangen 2, Heft Farm, Center, 1889. Roechlader und Schwarz, Sitzungs B. D. 11. Thal Farm, Zeitcher, F. Russell, 1883. Neveny, Bilberries and Blueberries, Zeitcher, F. Haig, U. Infektionster, 1908-95. Analysis of bilberries by Koenig, IP 862. Used only in their fresh state and not as drugs. Cherries, plums, raspberries, blackberries, crowberries. These can also be classified as acid drugs as they contain aliphatic acids. See chemical composition, but they are more appropriately listed here. Fructus rubiidae, Sin. Raspberry in Braunschweig, Gorst in Jesner, blackberry blatternut, Entabier, Hentabier, Humpbier, Empe Malin. In older languages, one finds Hintperi, Hintberi. In medieval texts, Hintdi are also hyper. Hierotberg, Herutbeg, Himberige, with angelic roots, meaning strawberry and raspberry. Himberry English, Himpen fruit, Himper in Norwegian, Himpen fruit. Cordus. Framboise French, raspberry English, raspberries whole. Lampone Ital. Vatu fin, erde mal nahun, grk. Fupuante sechi etim. Dioscorides says, Idea was called so because it produces many in Ida. Raspberry is seen, for example, in Bach, allegedly dewberry, i.e., hind or deer cowberry, meaning forestberry. perhaps from hunk honey or from Heim, ampe of Ampornola, Malin from Slavic Malina. Raspberry from rasp to grate to scratch, due to the thorny branches bramble eater. Bia and var, anomala ararch, also, var. Denudatus spenner, spinulusus mul, and trifoliatus bel solter. Systematic position, rosaceae, rosoideae, potentire, brubinae, sectio ideobatus. Also, the Spanish name Zarza idea recalls its prickliness. Frambosia, 1537 by Ruelius, from which framboise French and frambouse Dutch derived from German Brombeer blackberry. For rubus, see under rubus fruticosus. Staminal plant rubus, Ideus L. Linnae, spec plant, ed. I. 492, with two varieties var, viridis a. viridis, occurring in light forests, hedges, and rocky mountain slopes throughout Europe, with the exception of the southernmost regions. The plant reaches up to the 70th parallel in Norway, North Siberia in Asia, and even ascends to 1,200 meters on mountains in Scandinavia. It can also be found in Greenland and on Sakhalin. It is also cultivated in many gardens, recently also American hybrids with Rubus occidentalis L., but never propagated by seeds. The cultivated raspberry in America, according to Bailey, is a sprig of the native, their Rubus strigosus Mich X, which is related to the European raspberry R. Ideus L. Winton, pathology, Bot. About the enemies of the raspberry and blackberry species that cannot be separated without force. Israel reports, 1. Beetles. By Turris fumatus F.B., raspberry weevil. The larvae of this little beetle live in ripening raspberries. Haltica ruby fabra. Is said to live on Rubus ideus, Antinomous ruby herps. This flower beetle lives particularly on Rubus and Prunus species. 2. Moths. Argynnis daphne W.V. A. Paphia L. The larvae feed on Rubus and Viola species. Zirichthus malvaea L. The larvae feed on Fragaria and Rubus species. Thecla ruby L. The larvae feed on Rubus species, Sarathamnus, and Genista species. Thembetia heliformis lasp, raspberry glassewing. The larva of this Thesia lives in the roots and lower stem parts of raspberry bushes, eating them. One often finds the larvae in the spring in the previous year's stems, which can be easily pulled out. Calomorpha dominula L. C. Hera L. Caterpillars feeding on Rubus species, nettles and willows, etc. Arctia caja L. Caterpillar quite polyphagous, also on Rubus species. Gonophora dirasa L. Thyatira baptiste L. Caterpillars feeding on Rubus species. Acronicta leporina L. A. rumicis L. Caterpillars feeding on Rubus species, forest meadows, and many lower plants. Otherwise, there are occasionally many polyphagous, or almost polyphagous caterpillars from spiders, owls, geometer moths, and microlepidopters that feed on Rubus species, which cannot all be listed here. In general, the leaves of Rubus species are a very popular food source, which is accepted and gladly eaten by many caterpillars. Spring-collected, overwintered caterpillars, of which the food plant is often unknown, but which are usually not very picky about their diet, often take Rubus species as food, and can be reared to the imago stage with it. 3. Moth. This small fly lays its eggs in the still herb-like shoots of raspberry bushes. The raspberry is not a berry, but an aggregate fruit that arises from a group of fruitlets united in one flower. Each single fruitlet is a drupe with juicy mesocarp and sclerenchymatous. Through feeding by the young larvae, elongated swelling stem galls occur, which are very commonly observed on raspberry canes. In spring, the mature insects emerge from the now wood-like galls. 4. Snout moths. On Rubus species, especially the leaves, and rarely on the herb-like stems. Description. The 20-50 individual fruitlets lie so close together on the fruit base that they rub against each other. They are hairy and still bear the approximately 4 mm long, inserted style slightly below the apex of the fruit. The beautiful red, rarely yellow aggregate fruit detaches from the fruit base, remaining on the stem as a hollow, half-ellipsoid, resembling an upturned pot, which bears the remnants of the calyx and stamens at its base. The detached raspberry looks like an upturned bowl, hence the Chinese name fupotize, meaning upturned bowl. The raspberry ripens in July or August. Only the red ones are used, White and yellow varieties are albino forms. The more aromatic, fragrant forest raspberries are preferred. Illustration, Fig. 22. Rubus strigosus. 2. Cross-section through a fruit. Epidermis. Salmon shell. Raphe. Endosperm. Embryo. The third. Natural-sized stone seed, ivy thorn. Same magnified 8 times after A. L. Winton. Illustration, Fig. 23. Rubus strigosus. After A. L. Winton. Lit. Bailey. The Evolution of Our Native Fruits. London, 1898. Beneath the epidermis lies a layer of collenchuma cells. Flückiger. Pharmacognosy. Arichu on the descent and relationship of Rubus idaeus. Jurin, of Bott. 1873 Bott. Jarisber, 1874. Illustration in Bergschmidt. Atlas der offiziellen Pflanzen. Plate 64. There is a floristic literature listed. Pabst Kohler, Medicinal Plants, Plate 43. Ain, Medicinal Plants, the third. 8, and others. On the difficult genus Rubus, also see Focke and Engler Prantl. Plant Family's Anatomy. The pericarp is covered by an epidermis, consisting of polygonal cells, which bears split openings and, on the free surfaces of the fruit, numerous long single hairs that are so densely entangled as to give the surface a velvety appearance. The mesocarp fleshy part consists mainly of crystalline, radial, thin-walled parenchyma cells, while the sclerenchyma endocarps comprise 2 layers, an outer one with uneven widths that gives rise to the bumpier texture of the released stone seeds, and a narrower inner layer composed predominantly of longitudinally oriented cells. The directions of the cells in both layers intersect. The delicate seed coat has collapsed significantly, especially in the nutrient layer. The endosperm, on the other hand, is several cell layers thick. Schierke. Contributions to the Comparative Anatomy and Developmental History of Some Dryadine Fruits. Journal of Natural Science, 1886. The small radicula is located at the tip of the seed. The large oblong plano-convex, fleshy cotyledons make up the main mass of the seed. The retained long style widens at the base and is there hairy. The epidermis is small-celled, with oxalate druses in the tissue. Lit. Winton. Contributions to the Anatomy of Berry Fruits. Zeitschrift für Unterer Ernährung und Genussmittel, 1902. Also with numerous illustrations in Report of the Connection Agricultural Experiment Station, 1902. Muller-Winton. Nutritive and Delicacies, 2nd ed., with illustrations. Fresh raspberries contain on average 430-84.7. Invert sugar. The ratio of levulose to dextrose. Villiers et Colin, Alteration and Falsification of Food, Substances, 1900. Markmann, Contributions to the Microscopic Examination of Fruit Marmalades, Zeitschrift für Angewandte Mikroskopie, 1896. Fresh fruits yield about 70-67-78 juice that clarifies through fermentation. Also present are trace amounts of amino acid and very small quantities of salicylic acid, likely as methyl ether, traphogen. 145 pectin substances, 2.08 pentasons, 0.32 ash, which contains a lot of potassium and phosphoric acid, Gozman. On average, the dry substance contains 35.82 sugar. Scheele found lemon acid and apple acid in roughly equal amounts, while Blay reported a ratio of 8:13. The aroma of the odorant appears to be a fatty acid ester. Forest raspberries are lower in sugar than cultivated ones, containing only C2.83.5 Gallenkamp, Zervas, Seifert. Lately, lemon acid 0.6. Pabst stated that apple acid and lemon acid are dominant. From distilled aqua ruby idae, flaked separate that can be obtained completely extracted in small sheets that dissolve in alcohol, ether, and also in water and potassium hydroxide Blay. The almost regular occurrence of sedimentation in raspberry juice is due to the microcrystalline deposition of ellagic acid Kunstkrause and Schweisinger. Helferman found in freshly pressed juices from Saxony and Werder raspberries an average of 0.437 ash, with alkalinity of the ash at 5.64 ccm normal water. The ratio of ash to alkalinity does not drop below 1:10 Bathian in waters. The total free acid was 156 when calculated on apple acid. Alcohol content was 2.99. It is dissolved in the plant's cell sap, belonging to the group of anthocyanins markworts, and specifically to the wine red group. It is related to wine red Pabst. The raspberry pigment produces two non-sharp bands in the spectrum, one at E and a second between B and F, which soon merge into a broad band between DE and FV lapel. Pabst found 46 G levulose and 25 G dextrose per liter juice. The free acid content in fermented raspberry juice is on average 1.836, calculated as citric acid. The volatile acid, calculated as acetic acid, is on average 0.359 spec, and the ash content is 0.515. The pigment is not further investigated. Pressed raspberry juice decolorizes only after 2-3 days when mixed with an equal amount of nitric acid, specific weight, 1.2. Ether, acetic ether, amyl alcohol, and chloroform do not absorb the pigment. Lead acetate gives a strong green precipitate with pressed raspberry juice, and the filtrate is weakly yellowish. Water-diluted raspberry syrup, subjected to capillary analysis, shows a lower, weak, dirty violet band about 2.8 centimeters wide and an upper nearly colorless. Comparisons of the reactions of the pigments from raspberries, cherries, and blueberries were made by Van den Driesen Mareu, Spaeth, et al. See Jaresper, D. Farm, 1900, p. 588. For the detection of foreign pigments in raspberry juice, see Regal Farm, Zeit, 1897, p. 247. After adding a small amount of fuchsin solution, a 3 centimeter wide dirty violet zone is obtained, followed by 0.15 centimeter of vibrant fuchsin red with a violet tint, 1.1 centimeter of light fuchsin red, and finally a 5.5 centimeter reddish appearance Joppelsroder. The raspberry kernels contain 14.6 of a fatty, highly drying oil, which comprises linoleic acid, oleic acid, and isolinoleic acid creon. Literature Koenig, Nahr, U. Genus, Blade, Mayer, Arch, Farm, 2, 13, Lacetit. Farm, 312, 1879, Dotted. Bayfian and Waters, Zeitcher. F. Unters, D. Narda, U. Genusum, 1905. B. Lapel, Die Pabst Bull. Soki Chim, 1885, and Van den Driesen, Ned, Teicher, 1900. Analyses by Gallenkamp, 1854, and Zervas, 1855, in Jaresper. Dichem, 1857, p. 636. Gossman, Amir, Chem, Jern, 1, Buignet, N. Chim, et Farm, 361, 1861. Traffigan and Burke, Jern, 1861. Heffelmann, Zeitcher, F. Uffenthal, Chem, 1905. Kunz, Krause, and Schweisinger, Apoth. Zeit, 1907, p. 825. For raspberry juice, see the numerous works in journals for the investigation of food and consumer goods. From the pile dwellings of both the Neolithic and Bronze Ages, we know stone cores of raspberries bushes. The raspberries and blackberries of the pile dwellers certainly came from wild-growing plants hoops. In Greek, batos referred to raspberry and blackberry. Batos Idaia, possibly raspberry, according to Dioscorides, was named after Mount Ida, either Teleridi on Candia, where raspberries no longer grow, or Kasdai in northwestern Asia Minor, Flukiger. Batos Acantodois of Theophrastus may have also been Rubus Idaeus. It is absent from Arabic writers, and also from Hildegard I, p. 667, and Albertus Magnus I, p. 672. The Rubus of Alfeda likely refers to blackberries, see above. It is not entirely certain whether the Greeks and Romans used our raspberries. The Middle Ages paid them no attention. Cordis dispensatorium Orin, p. 800. Used the fruits Mora rubiidae along with mulberries and strawberries to make Rob diameron. Rubiidae seems to have been first described by Gesner Epistolar, Medicin, Lieber III, ci. p. 847, who was captivated by its magnificent color, its highly pleasant taste, and scent, see Flukiger, 3rd ed., p. 862. The plant was described by Bach, Fuchs, and Cordis. Bach provided an illustration. In Bauhin's Pinax, it is called Rubus Idaeus spinosus. Fructus rubifruticosi. Shin, blackberry bay de Ronser, blackberry eng, Brambes Dutch. Hegimal Nahum. Bramel, Bramel, Bramble, Bromising, Hyper, Swartjebeer. Angels. Brombelepel, Bramaberian, Blaisberian, Arab. Ulaik, and Ibn Bathar, rosaceae, rosoidae, potentile, rubinae. This name, however, just as much as Bathus, Elwashki, also includes the blackberry. Brahma Hildegard, Scratching, Blackberry Cordus, Truman, Brambernstruch Megenberg, Chinese, Huan Tiaozi, Rubus fruticosus L, with many variants, or resolved into different kinds. The name blackberry comes from Old High German. Brain Dorn dutet auf die dornige Beschaffenheit hin, ebenso wie das englische Bramble und das niederländische Brambez, MHD. Bramber, Ahad. Bramberi, eigentlich die Beere einer Dornart, AHD. Etymology. Rubus in Latin is a collective term for various thorny shrubs, perhaps from to pierce, less likely from red or red, because only the unripe fruit of the blackberry is red, but also the French ronce is probably related to rouge red. Mewers is perhaps derived from black, due to the black color of the ripe fruit, just as the English blakeberrien, blackberry cangisser. Im Mittelalter finden sich auch Namen wie Morus rubi, Citromora, Batus in der Alphita rubus ferens mora, Bedegar morabati, Mora sylvatica, Dumus, Genesta, Morabati, Vepres, Rubus fruticosus, die europäische wilde Brombeere, die über Europa und Asien verbreitet ist, kommt in Nordamerika, weder wild noch kultiviert vor. Dort wird sie durch Rubus villosus eit, crescende Brombeere, Taubere, Rubus canadensis Eldornenlose, Brombeere und Rubus nigrobacus Beil, große oder Buschbrombeere, gemeine amerikanische Buschbrombeere vertreten. Rubus nigrobacus var. Sativus Beil ist der Stammvater der meisten Gartenvarietäten. Beschreibung: the stone kernels are usually but vary between varieties slightly shorter and thicker than in the raspberry, which was already used to distinguish post-medieval constructions. Winton, on the other hand, states that they are larger. The aggregate fruits of Rubus caesius L usually consist of only a few fruits. Die Brombeere ist die Himbeere Este. Similarly structured, but the fruits are balled and attached to the soil. Thus the blackberry aggregate fruit does not detach from this so easily as the raspberry. The epidermal cells of the fruit wall are elongated. The tendrils are shorter, C2 mumida, long and bold. They do not widen at the base. In the dry substance, on average 40.117 of sugar is found. The blackberry colorant has been studied in its reactions by Kremer. See the origin and nature of color in plants. They are bluish-black and lightly berried. The odorless, sour aggregate fruits of Rubus saxatilis consist of 3-7 rather large, scarlet fruits. Fresh blackberries on average contain 530 invert sugar, little 0.48, or no raw sugar, 0.77 free acid calculated on apple acid, 1.44 pectins. Blackberries also contain very small amounts of salicylic acid, probably as a methyl ester traphogen and Burke. History. Some assume that the burning bush senna of Moses was a blackberry bush Rosenmüller. As the bush is common in Greece, it was known to Homer, Theophrast, and Dioscorides as bramble also included the blackberry. Is still how they are called in modern Greece. Plinius mentions the blackberry. 657 were likely Rubus fruticosus, as was Battus from the Synonoma. In Serapian's tabula, Rubus is listed alongside Rubus canis. Albertus Magnus refers to the blackberry as rhamnus. The Succus mororum rubi of Cordus is blackberry juice. Palladius provides dere rustica totorzi, a recipe for blackberry jelly. From the pile dwellings of the Neolithic period, we know blackberry stones. Scribonius Largus the Friend, p. 578, and Celsus Barern, p. 588 mention Rubus, Morus fructus, Mora rubi, blakeberries, Rubus ferens mora in the Alfita wine, p. The highly prized drink moratum, also mentioned in Carl's Capitulare, was made from blackberries, honey, and wine, with added spices, Fischer benzoin. Histological study of seed coats. Winton, Contributions to the Anatomy of Berries, Journal of Nutritional and Food Sciences, Food Additives 1902, and Agricultural Experimental Station AES Report 1902, Lampe et al., Traphogen and Burke, Pharmazeutische Zeitung, 1903, p. 23, Muller-Winton et al., Koenig et al., Older Chemical Literature in John Tables, Fruit of Cerasus acidus, Sin, Sour Cherry, Black Cherry, Morel Cherry, Cerise French, cherry English, Silesia Italian, Zure Keres Dutch, Kersica Finnish, New Greek. Etymology Kirsche. Old High German curse, Alemannic Krisi is changed to skash. Ahad de Kirsa does not certainly come from Latin theresum but, like the related Roman words, from a Theresia, Emlet Cerisi. The borrowing of HD likely occurred before the 7th century Cluj, in the Gotha Pharmacopoeia Ferend. Subganus cerasus, a hybrid of sweet and sour cherry. Two varieties are distinguished from the sour cherry, considered as distinct species by Ehrhart in 1792, and also differentiated by Gärtner as Cerasus acida and Cerasus austera by Late. Acida R. 680 still reads Cursibare. Weasel is, according to Hoops, the ancient pre-Roman German name for the native bird cherry, which also stuck to the wild cherry after the introduction of the Roman cultivated cherry. Native plant and systematic position. Prunus cerasus, L. Linnae, spec plant. Edit. I. 4074. Rosaceae, prunoideae. Glace cherry with clear sap subspecies and varieties in Ascherson-Grebner synopsis and Austera air. Black. Sour cherry. The sour cherry Prunus cerasus is certainly wild in Transcaucasia, but it is also indicated in Macedonia, on the Bithynian Olympus, and on the Caucasus. Its cultivation extends over Europe and the United States. The wild sweet cherry Prunus avium was already native in Europe in prehistoric times. Engler. Description. The cherry is a relatively small tree with rounded crown. Fisher reports on plant pests. On Prunus cerasus cherry, Sclerotinia cinerea Bonn. Schroeder causes the death of the leaf shoots and flower stalks. The sclerotic endocarp surrounds the seed and forms with it the spherical hardstone kernel of the fruits. The seed consists of two convex cotyledons and a short rootlet. The long shoots of the sour cherry are infertile. The fruited shoots arise from the tips of compressed short shoots standing in the leaf axils. The flower possesses only one ovary. From it develops a depressed spherical stone fruit, usually brown-black in color, and purple mesocarp. In doing so, a side fruit form of the fungus develops in the form of gray mold pillows, Monilia cinerea Bonn. See Warrenin on Sclerotinia cinerea and Sclerotinia fructigena, Mem. Akkad, St. Petersburg, Sir 8, T10, 1900. Pneumonia, erythrostoma pers. Ours W. Primarily affects the sweet cherry, rarely the sour cherry. On the animal pests of Prunus species, Prunus armeniaca L., Spinosa L., Ceracifera ert, Domestica L., Insatitia L., Avium L. Israel reports. The number of insects living on Prunus species is very high. It develops on leaves and fruits, slowing their development and leading to their demise, overwintering in the dry leaves that remain on the tree, where its ascospores mature in spring, and reinfesting leaves and fruits. This disease was particularly severe in the 1880s in the old land near Hamburg B.L. Frank. The present disease of sweet cherries in the old land. Agricultural Yearbooks des Instinct, 1887. Fusicladium cerasi Robin causes discolored spots on still green cherries and can result in stunted growth and drooping. Rot and decay on cherries are also caused by gloosporium. The most important insects are as follows. 1. Beetles. Phytoacia cylindrica, L. larvae in dry branches of fruit trees, also in old balloon baskets. Saperda scalaris L. larvae in fresh shoots of cherry trees and other deciduous trees. Liopsis nebulosus L. The larva of this long-horned beetle lives in the bark of cherry trees, also in other fruit trees. Antonymus druparum L. The larvae of this weevil live in the flowers and fruits of Prunus cerasus and P.R. padus, and other Magdalena species live as larvae under the bark of distant hawthorns, cherries, quinces, plums, apples, and other fruit trees, often also in dry branches. Pelobius pyri L. P. argentatus L. P. oblongus L. P. oblongus L. and other Pelobius species often seriously damage cherry and plum trees as mature rhinoceros beetles by nibbling and consuming the buds. Rheinschites cupreus L. R. bacchus L. R. alarii L. and other Rheinschite species live as larvae in unripe fruits of cherries, plums, apples, dog roses, apricots, medlars, hawthorns, etc., etc. Rhinosimus planirostris, Fabra, larvae in dry branches of cherries, plums, apricots, blackthorn and whitethorn. Ecoptogaster, pruniratsp, B. Larvae of these splinter beetles often found in apple, plum, quince, peach, and other fruit trees, also cherry trees. Valgus hemipterus L. Larvae in prunus species and willows. Also found on raspberry canes. 2. Moth. The number of lepidopteran caterpillars living on prunus species is also enormous. Only the most prominent ones are mentioned here. Polygraphus pubescens Faber, larvae in splits of cherry trees, also often found in various conifers. Bostricus chalcographus L. B. dispar. Fabricius and other bark beetles do not only live in conifers, but also in decaying broadleaf trees in forests and gardens. Aporia cratoaegi L. Caterpillar, particularly common on all prunus species in Crataegus, as well as apples, quinces, etc. Formerly very common almost everywhere, the moth has now become rare in many regions of Germany. The caterpillars live in nests when young. They are usually abundant where they occur. Vicla betulae L. T. pruni L. T. Spini W.V. Caterpillars primarily on prunus species, also on almond trees and rhamnus species. Agolopo infosta L. Eno pruni W. All prunus species also occasionally host a whole number of polyphagous bear caterpillars, Artidae. Among the many spinner caterpillars, the most important ones are mentioned here. These include the most harmful of all Lepidoptera, Cossus lignoperta. F. Cossus L. The caterpillar is often also found on prunus species. Zosera perina L. No. The caterpillar occurs not only in forest trees but also in gardens, almost all fruit trees, and even in syringas and Staphylea. Dasichira pudibunda L. The caterpillar feeds on various broad-leaved trees, mainly oaks, but often also in gardens on fruit trees. Prothesia chrysaroa L. P. In gardens and along avenues, it seems to prefer stone fruits cherries. It is polyphagous. Bombyx cratatigi. B. populi L. B. nustria L. B. Similis. The webbing caterpillar lives in nests in forest trees. In gardens, it is often very harmful, especially on fruit trees. It is also common on hawthorns. This very dangerous caterpillar often attacks broadleaf trees, but particularly conifers, often destroying vast areas of conifer forests. Landstress L. Caterpillars on almost all fruit and forest trees, particularly the caterpillar of the ring spinner, is often extremely harmful in gardens and along avenues. Valera butafal LL. The very harmful caterpillar, often found in large numbers on lindens, maples, roses, poplars, willows, birches, elms, oaks, hazelnut trees, cherries, apricots, plums, sloes, apple and pear trees. It occasionally also attacks exotic broadleaf trees in parks. Lasiocampa pruni, L. Caterpillar of the rare butterfly on prunus species, L. cursifolia. Caterpillars of the copper gum in nurseries are often very harmful. They prefer prunus species. Saturnia pavonia L. Caterpillar, also on prunus species and others, such as Agliatau L. Caterpillar, found on oak, beech, linden, and other trees, including prunus. The number of owl and webby caterpillars living on prunus species and other fruit trees is also extremely high, but these are not actual pests that can only rarely cause defoliation, etc., on fruit trees. This is the case with Chimatobia brumata, L. and Hibernia defoliaria L., and a few others to a significant degree. The number of microlepidopteran caterpillars living on prunus species is also very high. Among them are pests like Sciaphila nubilana, HB, which can cause defoliation in entire areas. They cannot all be listed here as they appear less important compared to the harmful spiders. 3. Fly, Tripedus signata magi. The larvae of this fly live primarily in sweet cultivated cherries, often in such numbers that one can barely open a cherry without finding one of these larvae. Various Cicedomia species live on the leaves of plum species. Snail-like aphids. Aphis pruni, F.B. Droda, lives in very large numbers on the underside of the leaves of plum species, deforming them. The leaves curl up and take on a diseased, white powdery appearance. Harvesting is often hindered for years as a result. Aphis sericina wake lives particularly on cherries and also on hawthorns, deforming the leaves and preventing harvest. Chemistry. Sour cherries contain 630-10.2 invert sugars in dry substance 4462, 1.22 free acid calculated as apple acid. Sweet cherries usually contain 10.7, 13.1, 1 up to 16.5 invert sugar in the dry substance 4258 up to 72. Unripe cherries contain a lot of apple acid, citric acid, and tartaric acid, as well as a little inositol germ. The pentose content of the cherry is 0.6, 11.07 Whitman. The tannin in the dry substance amounts to 235 in the whole fruit and 2.25 in the pulp king. The seeds contain 37.61 of the dry substance fat. The release of cyanide was already known to Ittner, 1809. By distilling fermented and crushed fruits, Kirsch, a spirit with approximately 4358 alcohol by volume and roughly 1448 mg of cyanide per liter, according to Windisch, Works of the Royal Health Office, Forest, and elsewhere. Schmid found glycerin in dried cherries. Cherries usually contain 0.1, 0.2 mg desmouliere to 0.4 mg traphogen salicylic acid, probably as a methyl ester, as well as small amounts of buric acid Norton. The seeds contain a cyanide-releasing glycoside together with a glycoside-splitting enzyme. The colorant of cherry juice exhibits the same absorption bands as those of raspberry juice. Spectral reactions differ when reagents are applied as mentioned by Lepel. Over time, the colorant changes. History. Whether the cherries listed in the Royal Garden of Nebuchadnezzar by Ben Sira, translated by J. Lowe, were actually cherries is uncertain. It's no longer possible to determine if the word, used by the Greeks alongside theophrast, referred to the sweet bird cherry, sour cherry, or both. It is not Greek indigenous but comes from Pontus, from which the word Kira derives, thus having no connection to Charis. The city of Cerasus is named after the cherry, not as Isidore believes vice versa Bouchon. The cultivation of sweet cherries Prunus avium seems to have originated early in Pontus, and Lucullus probably brought the sweet royal cherry to Italy from their cut. Cherry stones from the Stone and Bronze Age are all sweet cherry stone fragments here, Bouchon. De Candolle assumes that the sour cherry prunus emerged from Prunus avium in prehistoric times. The sour cherry is corroborated by finds from the Paleolithic period in southern France. 120 years after the introduction of cherries to Italy, they were already being cultivated by Romans conquerors on the Rhine, in Belgium and Britain. Plinius. On Pompeian wall paintings, IS 575, the cherry Prunus cerasus, which is likely not long after the sweet plum cherry came to Italy. Different varieties of sour cherries are mentioned in the Capitular I, p. 620, the Breviarium Orne, p. 621, but not in the St. Gallen Monastery Plan, p. 622. Albertus Magnus calls the sour cherry Amarella, Amarina. Cerasorum nuclei are listed in the Compendium of Magister Salerni-Worth, p. 639. Glauber already produced cherry grape sugar in 1660 p. 883. Lit. Il. In Bergschmidt, Atlas. Table 61 also includes floral literature. N. Cultivated plants, etc. Bouchon, Prehistorical Botany, 1895. Keim. Studies on the chemical processes during the development and ripening of the cherry fruit. Wiesbaden, 1891. Von Lepel, on the behavior of fruits of different ages to reagents. Analytical Chemistry Journal, 1880. Schmidt Journal. Desmouliere, on the normal presence of salicylic acid in various food substances. Original Vegetable Thesis. Paris, 1902. And Journal of Pharmaceutical Chemistry, 1904. Norton, Amer, Chem. Suck, 1909. Koenig AAO, Muller Winton AAOA. Historical Development of Fruit and Seed in Prunus ceracifera in Copper. Contribution to the History of Official Seeds and Fruits. Dissertation, Bern, 1909. Fructus mori. Synonyms: mulberries, more Italian, more BZ Dutch, or Ancient Greek. In Megenberg's writings, Mulper mulberry, in Middle High German. Also, Mulbaum, Mulebeere, as well as Dubeere, Dusbeere, Swadsbeere. Etymology. The derivation of, from part composite aggregate fruit, or from unpalatable bland seems unlikely to me. More convincing is the derivation from dark-colored Celtic more black, an expression that also applies to the blackberry, which was often confused with the black mulberry. The Greek moron and Latin mora mulberry gradually transitions into more morani, then bromeri. The stem more reverts to id, morperi, murperi, mhd. Morber, mulberry derived from Latin, staminal plant and systematic position. Morus nigra L, moracea, moroide, moree. Description. The tree is said to grow wild in northern Anatolia, Armenia, the southern Caucasus, and Persia. The black mulberry tree is undoubtedly wild in South Transcaucasia, and possibly also in some Persian provinces. It reached Europe around the time of the Attic tragedians. In Italy, it was used for silkworm cultivation until the introduction of the white mulberry tree c. 1434. Now wild there, and cultivated north of the Alps, the fruits still ripen in Gotland, Sweden, and England. The ancients often equated it with the sycamore. The mulberry is a false fruit. She arises from the spur-shaped female inflorescence through the growth and fattening of the four-petaled floral envelopes perigonose, which enclose the fruit's nuts as juicy fruit covers and form sham fruits. These sham fruits come together to form an egg-shaped, approximately 2 centimeter long, almost black sham fruit filled with purple, sour sweet juice. The individual fruits, where one can still clearly see at the tip the 4-ray split and the 4 paragon leaves, measure 2-3 mm. The fruits, which externally resemble raspberries, only taste good when fully ripe, but then only last for a short time. Illustration, Fig. 24. Morus alba, A inflorescence, B fruit cluster, after Bayonne, pathology. About the pests Israel reports. Silkworm. The mulberry trees, still found in the vicinity of many German cities in gardens, parks. The leaves of these trees are the main food source for the silkworm, the larva of the spinner Bombyx mori. In captivity, they can also be raised on the leaves of Scorzonera hispanica. Occasionally, the larvae of Acronicta, Acerus L., and Smeranthus tiliae L. live on Morus. The breeding of the latter often produced a brown variety. Cossus ligniperta F. Cossus L. This large wood moth was found by Hanau, Maine, in the wood of roots and stems of felled mulberry trees. In the dry substance, 60.1 of sugar is found. Mulberries are therefore one of the most sugary fruits. They also contain a very small amount of salicyl acid methyl ester desmouliere. Otherwise, this highly damaging larva mainly lives in the stems of willows, poplars, oaks, pear, apple, cherry, and other hardwoods. Chemistry. Fresh mulberries contain 84.71 water, 9.119 invert sugar, 1.86 free acid, calculated as apple acid. Like blackberries, elderberries see above, juniper berries see above, and carrot roots, mulberries have been used to make a rube, rum under the name Rob mororum bacarum. Sir, mori is mainly a flavor corrector. In Greece, an intoxicating drink is made from mulberries. History. In Theophrast, the mulberry tree and sycomora share the same name. Black mulberries are mentioned by Hippocrates de Victus Ratione Libdi. The Seton mulberry is called by Aeschylus. Diodor distinguishes between the mulberry and fig-bearing. The mulberry tree is mentioned by ancient writers and was known, for example, to the ancient Jews. Mulberries are also listed by Ben Sira among the plants of Nebuchadnezzar's royal garden, J. Lo. 180 is Morus nigra, and alba was the sycomora. In the Middle Ages, the mulberry tree was distinguished from the blackberry bush as Morus celsa, or Sycomorus, Celsa mulberry bush, or simply Celsa celsus, with its fruits known as Morus telsi. It is also found in Carl's Capitulera wine, P620, and the St. Galler Klosterplan wine Pio. 622 is Murarius, and in Harib's calendar from 961 I, P612. Sir, in the Alfida it reads, Celsus, Sicaminum, and Serapion, Mora celsi tut I, P644, 1907 Circ, 83. B drugs containing sorbitol, dota. The succus mororum from the tree is mulberry juice. Lit. Flukiger Hanbury, Pharmacographia, Vogel, Food and Nutrition. Fresenius Ann, Chem, Farm, 101. Koenig AAO, Muller Winton AAO. Illustration in Bentley and Tryman. About Morus alba tartarica, Russian mulberry, CUS dept, AGR forest, divis. The reduction product of D-glucose is D-sorbitol, OHO-CCC show, HOH, found in the berries of Sorbus aucuparia, along with its related compound. HOH-D sorbose, Troco-CCC. Sheer-kissed mana of the Pomaceae cotoneaster nummularia is likely also sorbit. C drugs containing glucuronate acid, O-sorbitol, has so far only been found in Pomoidae, Prunoidae, and Spirioidae, e.g., Tyrus common, P. malus, Nespelus germanic, Prunus cerasus germanic, P. persica, P. torsica, P. persica, P. arminiaca, P. lorocerasus. Only plants of these families possess the ability to form starch from sorbate tribu. The Cherkestit S to glucose, the associated acid, glucuronate acid, attaches, whose relationship to glucose is evident by comparing the following formulas. D-glucose, acid, co-CCC, C-cuo broad, HOH, to which then attaches the D-sugar acid formed when treating D-glucose with nitric acid, OHO-CC. Free glucuronate acid, which is often formed by animal bodies, has not been found in drugs or medicinal plants to date. Bound forms were also unknown in plants until recently, because the euzanthin acid found in Indian yellow, puree, Indian yellow, a widely used dye in India, is not a purely vegetable product. It is obtained from the urine of cows fed with mango leaves and consists of glucuronate ether, euzanthin, or calcium-magnesium salts thereof. The euzanthin comes from the plant, while the glucuronate acid comes from the animal organism, which has the ability to esterify introduced phenols by pairing with glucuronate acid and excrete them via urine. Glucuronate acid was first discovered in the plant kingdom in licorice, 1907 Church with Sederberg and Gouchman, but it also seems to occur in algae, e.g., laminaria, Tollens. Noerdings, 1910, showed Goldschmidt that stutilarin, which Molish found in Stutilaria and other Labiaden, is also a glucuronate ester. A good reaction with glucuronic acid is the one by Tollens with naphthoresorcin Bear D. Shem, 1908, 1788. It produces a water-soluble red-violet pigment whose spectrum shows a band at D. This reaction distinguishes glucuronic acid from pentases, with which it shares some reactions, e.g., with orson and phoroglucinic acid salts. The glucuronic acid is liquid and tastes sour, but its crystalline anhydride lactone, OOO-CHO, C-O, tastes sweet. Glucuronic acid and its compounds give a smaragdine green coloration with naphthol and concentrated sulfuric acid, which gradually changes to blue and violet upon addition of water. Guido Goldschmidt, a new reaction with glucuronic acid. Phys. Chem. 65, 1910, 389. Glucuronic acid yields furfural upon distillation with HT-out. Rad. Liquiricia. Sin. Rad. Glycyrase. Licorice root. Sweet root. Bois. Uracin de reglista Franz. Licorice root ingo. Plegno dolce. Liquoritia. Regolitia et al. Zoet haut hol. Acrezi jurifin. Edijakev N.Gr. at Theophrast. Russian licorice at Dioscores. D also mentions the following names: glyceraton, symphyton, leontica, glycophyton, scythian, adipsin, silithra, labisathin, amalmoin, pentaumonin, at Plinius. Galen's GL was perhaps GL. Glandulifera, from Scribonius Largus Referend, S. 5077. Glycyrrhiza was perhaps G. glabra, in the Liber Medicinales of St. Gallen 9th century, Liquiritia. The late Latin form liquoria first appears in the 4th century with Theodorus Priscianus in De Diaeta, K.P. 9, then also with Vegetius Renatus I, S. 591. It is found, for example, in Otho Cremonensis. In Isidore's Etymologicon I, S. 592, Ligusicium, Liguricium. In Hildegard I, S. 668, Liquoricium honey-scented fern. In the Gotha Pharmacopoeia, S. 679, Lacriste, Lacarician, Estrician, Lacarice, 678. Liquorici, in Harpestrang Vern, S. 684, Licoricia, Lacrisa, Lacrice, Lacrice. In Middle English medical texts of the 14th century, Licoris. In the Ferrara tax of 1424, IS 811, Requilezia appears, and in Saladin's compendium. In the Inventory of Lefort 1439, US S 805, it is mentioned as Regalis. Various folk etymological transformations such as Lacarici, Lacaritza, Lacaritza, Lecarici, Lequaris, 652, circa instance, and the tabulae, as well as in works by Simon Januensis I, SS 64, Liquoricia, Glacoria, Glacoria, the Serapion, Nahim ad-Din Mahmud, and Ibn Bathar, SS 611, also mention SSS. In the Synonym of Arai, S 639, Glycoricia, Glycida here combined with Paeoniophect, Glycicida, by Scribonius. The synonymy of the Paters in Schroeder or Roy, S 891, where the name Galician Haut is also found. Ind, Molhadi, Jetimat, Sanskar, Aduka Licorice, Yashti, Matuka, Licorice, Shirin Bagan, Urakdar Haram, also Glikiriza Leclerc. Shin, Kautsau Kautsau, Komso, Kaulaim, Pflanzenharz, Saukraut. Etim, das Stammwort für alle Namen ist von Süß und Wurzel. Aus diesem Worte ist das latino-barbarische Liquiritia in all seinen zahlreichen Umformungen vglt. Auch I, S 1060 Lacrise, Reglis, etc. entstanden. Das sanskritische Madhu bedeutet ebenfalls Süßigkeit süß. Es kehrt beim Honig S8 und mit I, SA 1016 und den Bastiablüten S23 wieder. Leguminosae, Papilionata, Caligae, Astragalinae sect, Euglissuriza. The stemmed grapes are shorter than the leaves. They appear later and hang loosely. The calyx is tube-like, divided almost a half into frilled lobes. The banner is lineal oblong, only slightly curved upward. Beschreibung der Stammpflanze. Die Pflanze bildet einfache Stängel, eine oft gewaltige Wurzel und zahlreiche Ausläufer. The leaves are unevenly feathered, many-paired, with egg-shaped, blunt, often slightly rounded tips, short spiky, upper side bald, lower side weakly droopy, and otherwise bald or hairy short-stemmed leaflets. Of the 10 straight staminodes, 9 are nearly halfway fused into a slit tube at the top, but even the 10th hangs from the base with this connection. The fruit knot contains 6-8 campilotrope ovules. Glycyrrhiza glabra is distributed across southern Europe to Central Asia. It varies greatly depending on location and forms numerous varieties and growth forms. Now, according to Boussier, the following varieties are distinguished by her, some of which were previously considered species. Typica, reg, et herd, G. glabraat. Quite naked, calyx teeth linear-pronged, as long as the tube, flag purple, pod naked, 3 to 6 seeded. In southern Europe, Mediterranean countries, small Asia, Crimea, the Caucasus-Caspian region, Syria, northern Persia, Turkestan, Afghanistan. Violetia bois, quite naked, leaflets smaller, elliptical, calyx teeth broader, pronged, slightly shorter than the tube, flag purple, pod naked, somewhat narrower, 4 to 7 seeded. In the Euphrates and Tigris region, Babylon, Assyria. Glandulifera reg, et herd, G. glandulifera, WK, G. hirsuta pol, G. Brachycarpa bois, lower. Stem hairy or slightly rough. Flag purple, pods scattered or densely stinging, glandular, soon more or less seeded. In southeast Europe, Hungary, Galicia, West Asia Central and southern Russian governments, to Turkestan and Afghanistan, southern Siberia, Chugari, China up to the Great Wall. Pallida bois, stems pressed and rough with short curly hair. Calyx teeth narrow, pointed up to twice as long as the tube, flag red-white. In Assyria, also the species known as G. asperamalin, F. sapelli. 330, which is indicated as in Arenosum et colibus inter Volgum Aegaicum, in Deserto Tatarico ad FL, Karaman, in Monte Uralens, et ad lacum in Derianzam de Candolia, Prodrome, Tet. 248, is likely, like G. uralensis fish, in lit, from the Uralensis, hung, i.e., 20t, 21. It occurs in Sibirica uralensi, in Siberia altaica, in Dahuria, in Mongolia chinensi, in Desertis Songoro Kirgizisis, Riegel and Herder do not share this view, but they still want to at least combine Asperma and Uralensis. They describe the following varieties of GL: glabra, typica, asperula, hispidula, glandulifera GL, glandulifera gaudilla, glandulifera waltz et tit, G. glandulifera, boas et busce, echinata, tuberculata, of G. asperma, Uralensis, desertorum, Sutenermis intermedia, glabra, typica. In any case, G. uralensis is very close to glabra, especially the variety glandulifera, as Lederberg calls it in his Flora Russica. G. glandulifera, grandiflora, and even G. glandulifera car et kier is synonymous with it, as glabra glandulifera is indicated in Hungary, in the Caucasus provinces and Transcaucasic deserts, and in the Sorgoro-Kyrgyzic regions by Ascherson and Grabner in their synopsis. They consider G. glandulifera as a variety of G. glabra. In contrast, Glycyrrhiza echinata Linn. Spec. She is likely the Glycyrrhiza of Dioscurides, who describes the root as somewhat herbaceous, and the aerial parts more like glandulifera and glabra. Confusion begins here. 1046, illustrated in Berg-Schmidt's Atlas, 1st ed., native to Apulia and Tartary, is undoubtedly a distinct species. It does not form runners, and its root is neither yellow nor sweet, thus it cannot produce licorice. Nevertheless, in 1887, Becker in the Bulletin of the Imperial Society of Natural Sciences in Moscow demonstrated that it does indeed produce no licorice. Russian licorice, in more recent works, e.g., Engler-Prantle's Plant Families, Ascherson-Grabner's Synopsis. Glycyrrhiza glabra is a shrub about a meter tall 1-2 m, with a massive, covering many square meters system of roots and runners. See the illustration in IP 324, which can also form an undifferentiated thicket above ground if left to grow freely. How difficult it is to dig up an entire plant, with its often 8-meter-long runners from the soil, is shown by the practice reported by Weigand that the Gardeners' Guild of Bamberg once required as a masterpiece from their apprentices to dig out a licorice plant with all its roots and runners intact Flückiger. On the fine lateral roots are found root knolls church, as with many Papilionaceae. G. glabra still grows on sandy soils, but requires ample irrigation, so it thrives best at riverbanks, in dry riverbeds or in floodplains. If left to itself, it quickly takes over vast areas. It occurs on Crete, in Asia Minor, and north of the Caucasus. B. a troublesome weed. Also in Sicily, where licorice grows wild in Semitotal near Catania, and in Calabria, where it is found in the plain of Sabari in the valley of the Crati River, north of Corigliano and Rossano Ravazzini. And thus we find both wild and cultivated licorice almost exclusively in river valleys, the Guadalquivir, Ebro, Meander, Ural, Volga, Amudarya, and the Euphrates Tigris. We can now assume that the Spanish and Italian licorice, as indeed all European, is Glycyrrhiza glabra, Ella, typica reg, et herd, while the Russian is Glycyrrhiza glabra L. glandulifera, reg et herd. The Mesopotamian and Chinese varieties of Glycyrrhiza glabra Elvar, Violatea, Boava, Violatea, Boas, G. uralensis fish, respectively. Whether the latter also provides Ural's sweet wood is highly doubtful, see below. I do not believe it. Even Holmans, 1910, considers the ancestral plant to be the same as Russians. Illustration in Berg-Schmidt. Atlas, Plate 55, also includes botanical literature. Pabst Kohler, Medizinalpfel. Plate 135. Bentley Trimmon, Medicinal Plants, and numerous other illustration works. Boissier, Flora Orientalis II, 202. Regel and Herder, Enumer, Plant, in Regionibus, Cis, 2 527. Sestini, Gazzetta Chimic, Italian, 1878. Whitman, Zeitcher, D. Oster, Apoth, Ver, 1886. Bunja, Enumerat, Plant, Quay in China Boreali Colleague, Petrop, 1831. Bretscheider, Bull, Roy, Kew Gardens, 1896. Aitchison, Some Plants of Afghanistan. Church. Article Glycyrrhiza in Realenseglab. D. Farm, V. 76, Pathology. Magnus, über das Auftreten eines Uromeißes auf Glycyrrhiza in der alten und in der neuen Welt. Berichte der deutschen Botan. Gesellschaft 1890. im Süßholz des Handels, Glycyrrhiza glabra. Typica wird vornehmlich in Spanien und in Italien kultiviert. Professor Ed Fischer berichtet über die Schädlinge. Glycyrrhiza glabra wird von einer Uredine uromuche, Glycyrrhiza eraba, Magnus befallen, deren Meisel ganze Sprossen durchzieht und an der Unterseite der Blätter Uredolage produziert. Aus dieser Form des Auftretens ist zu schließen, dass das Myzel im Rhizom perenniert sp. Spain exports licorice, and Italy processes most of it into sucas. The Spanish cultures are particularly located in the Ebro and Guadalquivir valleys at Alicante, Tortosa, Barcelona, Córdoba, Elche. See also trade varieties. In Spain, licorice is also widely found wild. Italian cultures are particularly found in Calabria, then in Atri near Teramo, in Abruzzo Ulteriore Primo, and on Sicily, especially in the South Caltanissetta. Licorice grown wild on Succus. Southern France also grows a little licorice. Then England. Surrey Mitcham, Yorkshire Pontefract, Nottingley, near London. Hugh, Isleworth, but not enough for its own needs. In Austria, cultures exist at Auspitz in Moravia, and in some Hungarian districts. The culture at Bamberg is insignificant, a place where it has been grown since ancient times. CIPI. 32. The cultivation of sweet wood, which once enjoyed a distinguished reputation, is now confined to a few small plots near Schweinfurt-Schwebheim. Pharmacist Kraft from Bamberg informed me about this in 1910. The cultivation of sweet wood in the Bamberger district has been reduced to a handful of small parcels. The yield is tied into small bundles and sold at the vegetable market uncut. Commercial significance has been attached to the cultivation in recent times, which I would like to extend over almost 25 years, as this is how long I have observed it myself. In the 16th century, Bamberg supplied all of Germany's needs. Small amounts are cultivated near Smyrna and Sofia in Asia Minor. However, most sweetwood is gathered from wild-growing plants, since the plant occurs in vast quantities within Asia Minor, for example, in the Meander and Hermus valleys. Often, one can see extensive areas of land east of Smyrna, completely dug up Tannenberg. In Syria, cultivation only takes place in the vicinity of Antioch since 1865. Yesterday, as in Anatolia, it seems to be G. glabra, as the drug resembles that of Spain. Collection in Anatolia begins from October. In the evening, farmers deliver the collected licorice root to depots. There, the root remains until May or June and loses about 50 of its weight. It is then either unsorted and sent in hydraulically pressed bales of 220 pounds, especially to North America, or sorted by debris and bagged, and exported in sacks of 330 pounds. California also cultivates a small amount. In cultures, glabra rarely blooms, and when it does, it produces few or no seeds. Man does not propagate licorice through seeds, but through buds, and runners, which are set in England, for example, at the beginning of April. For information on cultures in Russia, see under commercial varieties. In North America, successful cultivation trials with G. glabra have been made recently P72, largely upon the recommendation of Rittenhouse Amer, Jern, Piaccior, 1895 and 1897, who began cultivating it in New Jersey, Pennsylvania, Louisiana, and Florida in 1895. Between the rows of plants, trenches are dug there, which make it possible to easily lift out the entire runner system. In the first years, potatoes and cabbage are intercropped between the licorice plants in England. In mixed cultures with wheat, peas, corn, licorice is also sometimes found in Calabria. The best roots and runners are obtained after 3-4 years. In England, the harvest takes place in September, in Spain from September to March, and in Syria, the harvest begins in November. Licorice does not suffer from parasites and tolerates frost well. The harvest is done using a plow. The roots are initially stacked in piles in the production countries after digging and before drying, and seem to undergo a fermentation process that gives them a beautiful color. The harvested runners and roots are washed, cleaned, and often freed from lateral roots by shallow peeling. It is not easy, because after 5-6 years, the roots can reach a thickness of 2 dm, and the runners a length of 8 m. The plant easily multiplies through the runners, which remain partly in the soil. She is very grateful and demanding. In England, the runners are inserted vertically into the soil. 1884, 268, Cannonberg, Kleinassians Naturschätze and Nicum A.M. J. Farm, 1895, 306, Syria. Jern, Farm, 95 and 1896, 636, and Pro C.A. Aim, PHS. Peeling C. Russian sweet root takes place at the production site, and in trade centers e.g., Hamburg, Lit. Culture in Italy, Sestini, Gaz, Chim, Ital, 1878, England, Pharmacographia, Jahresber, D. Farm, 1894, 156, and Whitman-Zacher, Öster, Apoth, there, 1886, 277. Asia Minor, Jahresb D. Pht, Purn, Ph, 1897. New Zealand, Arch, Farm, 1883, 854. Commercial varieties. 1. Russian Est. Until 1870, production was sufficient from Spain, then southern Russia, particularly the countries north of the Caucasus emerged, whose licorice had been known in Germany since the beginning of the 19th century, followed by Asia Minor, especially Pakistan, Anatolia, Rome. Since 1908, Ural licorice from the Ural and neighboring steppes has dominated German trade, which had already been distinguished from Caucasian licorice and positioned against it in 1889. The taste of Ural licorice is intense and pure sweet, while Caucasian licorice is weak and unpleasantly sweet. The harvest ranged between 10,000–15,000 pounds, 1907. Interestingly, licorice has been collected for a long time on the banks of the Ural, where glycyrrhiza grows in large quantities. 25 years ago, so much so that the government had to restrict or entirely ban digging. The Russian Ural licorice is currently the best and twice as expensive as Alicante. It comes in well-munched simply and doubly peeled, beautiful yellow batches in bales of 70, 90, 110, and 120 kilos for sale, traded at the large fair in Nizhny Novgorod and reaching Hamburg via Moscow and St. Petersburg. Even the offcuts that fall off during peeling and repeeling, very cheap chips, are commodities bales of 140 kilos and are often processed into succus. Wholesale differentiates simply and doubly peened. As illustration, Fig, 25, Brad, Licorice Ross, Peel, Wright Layman, and Omni Fought. See also Greenish textbook, allegedly Ural sweetwood from Glycyrrhiza uralensis fish. Glycyrrhiza esperma, Elphora uralensis reg, is supposed to come from the native name chuncture. Sweet wood collected from this plant, according to Cowley, pharmacognostically differs from Spanish and Russian, and is in between regarding glycyrrhizin content. The one harvested in autumn is richer in glycyrrhizin than that harvested in summer. However, I doubt if the Ural sweetwood comes from this plant, and is rather from the closely related Glycyrrhiza glabra glandulifera reg, adhered, which until recently was considered as the sole type of Russian sweetwood. The latter was cultivated to a considerable extent on the islands of the Volga Delta and at Sarepta, and the drug was transported from Astrakhan to Moscow. Then, in the 80s of the 19th century, cultivation was also begun at Batum on the Black Sea, and Lyaka Elizabetpol district became the main storage place for Caucasian sweetwood. But the plant is also found growing wild both in Ciscaucasia, in the Kuma and Tarik areas, and in the Dagestan region, as well as in Transcaucasia, particularly in the Elizabetpol governorate, formerly the Tartaric Khanate of Ganja, between Tiflis and Batum. The harvest in the Caucasus often amounts to 11,000 tons or more. Rosenberg reported to me in 1907 that in Transcaucasia, the collection of roots from wild-growing plants is exclusively carried out by Tartars, who are still partly nomadic, and that the trade in licorice root there is monopolized by the English through fixed contracts with the elders of the Ols. They export large quantities of licorice for the production of port and ale via Black Sea ports Batum, Poti, Novorossiysk to England, and have also established a succus factory in Elizabetpol. The root is pressed into large rectangular bales using hydraulic presses, which are then surrounded by 810 iron hoops. Fig. 26. Wright Layman and Omni photo. See also Greenish textbook. Even in the Caucasus, licorice grows wildly in large quantities, particularly in the floodplain of the Terek and Sulak rivers. The extracted root is used as fuel, and the ash is processed into potash. The first Russian sucus factory in the Caucasus was established at the beginning of the 90s by a German Peters. The brand he introduced, Sanitas, is still available on the market today. Illustration, Fig. 26. One can see entire mountains of licorice in the fields, which, if the trading situation is unfavorable, are simply used for burning. This land, consisting of alternating layers of vegetation and flooding, has been cultivated by German colonists, mostly Mennonite communities, for several years, as reported by Rosenberg. Here, the plant forms true labyrinths with its stems, and it is extremely difficult to completely remove it in order to cultivate the soil. The great demand for licorice, especially by sucus factories in the Caucasus region recently, is now primarily met by Bukharia, where the licorice plant grows in large quantities on both sides of the Amudarya River. The center of extraction is the city of Chardshu. Die Wurzel wird hier, nachdem sie nach dem Graben vorgetrocknet wurde, in großen Trockenanstalten fertig getrocknet und mittels hydraulischer Pressen zu Ballen von 9-10 Pud gepresst. Ein großer Teil der Wurzeln wird über Krasnowatch und Batum nach England und Amerika ausgeführt. Die Ausfuhr betrug im Jahre 1909 über 600 Pud. Russland verbraucht übrigens viel Süßholz zum Einmachen der Früchte. Das russische Süßholz, das man in Bastmattenballen im Handel findet, ist meist geschält, Fig. 25. Doch kommt auch ungeschältes vor, Fig. 26. Das spanische Süßholz ist stets ungeschält und besteht nur aus den Ausläufern. Die beste Sorte ist Tortosa Catalonian in Päcklein van Ballen, a 24 Bunde, a 5 Kilogramm, 2 bouts 2,930 cm. Es ist zurzeit einmal teurer als die zweite Sorte. Alicante, die in 60 Kilogramm im Handel ist, bisweilen, aber ZB 1909 fehlte. Traders make a distinction between yellow, red, and brown sweet wood. The best Spanish sweetwood Tortosa comes from Aragon and Catalonia near the Ebro. Second best from Cordoba, Andalusia, in the Guadalquivir Valley, as well as from Navarre and Old Castile. Lower quality varieties from Alicante, Valencia. Main export centers are Seville, Alicante, Barcelona, Bilbao, and Malaga. Spanish sweetwood is represented by, and also includes G. glabra typica, from which other European varieties originate. Italy processes sweet wood into sucus and exports little of the Spanish type. Sicilian sweet wood was peeled, dried in the sun and oven in 1909, available in English trade. Greek sweetwood was found in German trade in 1906, packaged in lots of 60 and 150 kg. English sweetwood is exported sparingly. It is mainly processed into sucus pontefract cakes. The same applies to the Austrian Gołolowski 1906 and the southern French sweetwood. The other varieties are of no importance for German trade. 3. Anatolian sweetwood is shipped from Smyrna, particularly to North America, which imported more than half its requirement, namely 53 million pounds, from the Asian Turkey in 1909. Anatolian root is somewhere between Spanish and Russian in terms of sweetness. It is shipped from Smyrna and resembles the Spanish variety. 4. Syrian sweetwood. The ports for Syrian sweetwood are there. The root is brought on camels. It resembles the Spanish variety. 5. Mesopotamian and Persian sweetwood. In the land between two rivers, a lot of sweet wood Violacea and Pallida grows, which is mostly processed on site to sucus, but is also exported via ports in the Persian Gulf. Persia exports a lot, particularly to India, Turkey, but also to Europe. 6. Australian sweet wood. In New Zealand, there has been a culture and production of licorice since the beginning of the 19th century. In Australia, New South Wales, Glycyrrhiza thrives and the harvested licorice is good, but not yet commercially available. California licorice, in small quantities since 1896 in American trade, allegedly containing 14 glycyrrhizin in extract. 8. Chinese licorice. China consumes large amounts of licorice. I encountered it finely cut in all Chinese pharmacies. It is there, next to ginseng, the most commonly used medicine Simmons. It is considered a means of retaining youth and beauty. European trade only receives unpeeled Chinese licorice that resembles Spanish licorice. This Chinese licorice, this more ripe than Uralic licorice, is from G. uralensis fish. See above pipa. According to Brett Schneider, 1896, Shantung, Shenxi, Kansu, and Sichuan produce licorice root. On Manchurian licorice root, also see farm. Jern, derived from the fact that the plant occurs in South Siberia, Ural, Turkestan, and Mongolia, as well as Tibet, i.e. in Chinese or neighboring countries, but also the northeastern provinces of China, e.g. Manchuria, supply large quantities of licorice root. Stacking places are Shefu, Hankow, Shanghai, Tientsin. 1904, April. Glycyrrhiza uralensis is also called the original plant of licorice by Przewalski, which the Mongols sell to the Chinese, who bring the drug downstream to Chinese markets on the Huanghe. The licorice root of G. uralensis chunchir contains more glycyrrhizin than Spanish, and less than Russian according to Kowaleyu. The fall plant contained more than the summer plant. Lit. Kowaleyu, Farm, Jern, Russ, 1908, on 63 Farm. Zeit, 1909, No. 8. Of this, in 1907 and 1908 from Arabia. 442, 446, Minor Asia. 16588, Syria, 235-0, Persia, 1346-0. Other imports by sea were 5117, by rail and Upper Elbe, 668-19. Germany primarily consumes Russian licorice. Italy exported only small quantities of Radicia di Liquirizia in 1907, 1014, 1908, 822, 1909, 1061 quintals. France imported 28,840 quintals of licorice in 1908, especially from Turkey and Spain. Small amounts 1366 from Russia, only 443 QTM from Italy, and some also from Algiers. America sometimes buys up the entire harvest from small Asia and Syria. Illustration. Fig. 27. Glycyrrhiza glabra, microscopic image of a runner. Japan imported licorice in 1908. 558,336, 1909. The imports were 1906, 10,215.1969, 1907, 6,611.588, 63, 1908, 10,935.572, 1908, 9,070. Founds mainly from Russia and the Asian Turkey too. Niles all. From Churcho Esterly, Atlas. Description of the drug. Spanish licorice consists solely of the bundles of bundled, mostly straight and simple unpeeled runners of considerable length that usually sink slightly in water. The runners are often of equal thickness over long distances and almost exactly round in cross-section. They can be up to 2 cm thick, heavy, dense, tough, with a coarse and fibrous break. The surface is longitudinally wrinkled and cross-cracked, with a somewhat variable color, ranging from grayish-brown to reddish-brown. Here and there you find ridges on the bark and scattered buds or their attachment points. The inside is yellow. Under the microscope, a roughly textured structure made of wood and bark becomes visible. The bark is clearly flamed. Within the wood, vessel openings can be seen, with the cambium appearing as a gray line. The shoots always have a mark, and larger roots occasionally fig. Transverse section of a shoot at the cambium. After Church, anatomy. Russian licorice is usually peeled to some extent, making it also outwardly light lemon yellow. It contains both thin shoots and roots that narrow downwards, sometimes reaching enormous dimensions and bearing a massive round or multi-part root head. The shoots are equally thick over long distances here. The break is often fibrous compared to the Spanish variety, which tends to be much harder, almost horn-like. Cracks in the wood body also frequently occur here. It is usually lighter and looser than Spanish, and one often finds pieces that do not sink in water. The cork layer is often 10-25 cell layers thick, and sheds due to separating layers between the cork plates. The secondary bark is perforated by 3/8 cell-wide rays that expand outward, carrying starch and oil droplets. On the outside, numerous vesicles can be found, groups of bast fibers exposed by peeling, which are part of the bark's anatomy. The shoots are covered in secondary cork formed within the vascular cambium, the primary bark. Carrying the root hairs is shed early on. Church. Applied anatomy Fig. 316. Between them lies the secondary sieve part, consisting of sieve tubes, cambium, bast fibers, and phloem parenchyma. The sieve tubes are only preserved intact near the cambium. A little further outwards, they are obliterated together with the cambial tissue and no longer form conducting, broad, stretched, slit-like keratomous bands. Fig. 28. The phloem parenchyma is not obliterated. It transports starch, oil, and here and there monosymmetric oxalate crystals, single crystals, and twins, the latter particularly in the immediate surroundings of numerous bundles of bast fibers in so-called crystal chamber fibers. The cells that contain the crystals are provided with an irregular to almost crystal-reaching thickening layer which turns blue-violet under iodine sulfate acid and forms earlier than the crystal. This gives the crystal the appearance of being stuck in a pocket. The bast fibers are very long and strong, often almost up to the disappearance of the lumen, thickened. Their primary membrane is heavily lignified, the secondary one little, and the tertiary one not or almost not at all. The cambium is poorly defined. The woody body consists of vessels, tracheids, wood parenchyma, and bast fibers libriform. Particularly in the periphery, there are very numerous and very wide vessels. In general, the width of the vessels varies greatly. The narrowest have a light width of 25 microns, the widest up to 170 microns, most between 100 and 130 microns. The narrowest ones possess short tips with slit-like outlets. The middle ones have ribbon-shaped and network-like thickenings. The perforation sites of the original lateral walls are clearly visible, making the vessel wall distinctly segmented. Fig. 29. The vessels are accompanied by tip or net fiber tracheids. The wood parenchyma contains the same content as the phloem parenchyma and the vascular rays. The fiber groups, which do not differ from those of the bark in any way, are accompanied by crystal chamber fibers that enclose similar crystals, of the type marked. Both single crystals and twins are found. In the center, a larger or smaller parenchymatous mark is usually present. In all parenchymatous cells, in addition to often numerous, small, round, spindle-shaped, egg-shaped, or rod-shaped starch grains, glycyrrhizin is also found. If concentrated sulfuric acid is added, the entire tissue turns straw yellow, and the dye is stored in the membranes of the vessels and the primary membrane of the fiber's church esterlet, atlas, transverse section through the vascular part of a shoot tip. From churcho-esterly, atlas, the roots only differ slightly from the shoots. The secondary structure is almost completely the same. Even mark is often formed so that it becomes difficult to distinguish small pieces of runners from roots. The primary, usually tri- or two-trart bundle, quickly transitions into the collateral construction, and the primary bark is shed early, only remaining in the form of fragments on 8-10 mulleted thick roots. Church, Angu, Anatomy, Fig. 315. Occasionally, in sweet wood, individual parts of the bark, wood body, or mark are surrounded by pith cork formation and thus disconnected from the septflow. On the outer side of these cork bands, there are numerous oxalate crystal cells vogel, often forming entire nests. The usually powder-like substance obtained from peeling the root in poorly cooked products. Some cork cells may be present, turns dark red to orange-yellow with concentrated sulfuric acid. It reveals the strength kernels, calcite oxalate crystals and their fragments, the spots and network-like vessels, as well as the bast fibers and their groups. G. W. Weedle, De Glycyrrhiza, 1717. Here the first, however very primitive microscopic examination. Wigand, Flora 1877, and Lehrbuch 1879. Church, Applied Anatomy and Article Liquoritia in Real Encyclopedia of Pharmacy VIII, 234. Church Esterly, Anatomical Atlas. Vogel in Wiesner, Raw Materials. 2nd ed., A. Meyer, Drug Science. Developmental History of Fruit and Seed from Glycyrrhiza in S.T.S. Sherbatchev. Contributions to Development of Certain Plants. Sam, U.F.R. Arch, Farm. 1907, 48, Chamey. The most important component of licorice root is glycyrrhizin. Primary structure by Hulford. Archives of Pharmacy, 1889. The powder described in detail in Koch, Microscopic Analysis of Drug Powders II, Table 17, and also in Kramer, American Journal of Pharmacy, 1897. Proceedings of the American Pharmaceutical Association, 1898, 310. Aycliffe, Drug Circular, 19 others. Lade, Cho Gorupesanes, Cho Haberman, No Orchno. Glycyrrhizin glycyrrhizic acid. Licorice sugar, root sugar, was discovered by Piaf and named glycion, while Robiquet gave it the name glycyrrhizin in 1809. It was subsequently studied by Dober-Ehner, Berzelius, Buchner, Martin, Hirsch, Rump, Flückiger, Muller, Sestini, and others. It was refuted by Church and Cederberg, 1907. Organic ammonium salts have never been found in plants, incidentally. Glycyrrhizic acid is bound to potassium and calcium in the plant, according to Sestini, only to K, which is unlikely. Haberman obtained a resinous substance upon hydrolysis, which he called glycyrretine, along with parasugar acid. Gorupesanes identified a fermentable sugar. The initially unlikely view, first expressed by Flückiger, 1867, that glycyrrhizin in the plant exists as an ammonium salt, was repeated by Rouse in 1875 and entered all textbooks. Cho, 23145, 032, H2UO, HC Cho, Cho. Church and Cederberg also first obtained glycyrrhizic acid in pure form from the tertiary potassium salt, and showed that it decomposes into glycyrretinic acid and glucuronic acid upon hydrolysis. They therefore formulated OHC Cho, Fu, O, D31 of 4503, Ku Cho. However, both the colorless crystalline tribasic, optically inactive glycyrrhizic acid, Chu-Ku F205, and their water-soluble potassium and ammonium salts taste intensely and purely sweet, not biting, even in solutions of 1/20,000. They neither reduce failing solution nor ammoniacal silver solution. Glycyrrhizic acid is soluble in hot water. The solution congeals upon cooling. This was already observed with crude glycyrrhizin. Glycyrrhizin, which represents a special type of sweetener, contains about 530 to 7 by weight in the dry substance. Church, Cederberg, and Erickson. Previous authors Flückiger, Sestini, J.H. Bach, Cho, Ku, O, glycyrretinic acid, glucuronic acid. Glucuronic acid was then further identified and likely synthesized by Church and Gauchman, 1908, who determined that glycyrrhetic acid contains only a double bond and the core O. Neither glycyrretinic acid F2O10, which crystallizes in needles, nor glucuronic acid as mentioned on page 77 is Muller et al. Report values of 627, 7.5, 8, and even higher 9 Gawalowski. However, they only had impure G in hand. Russian licorice is richer in glycyrrhizin than Spanish licorice. This was already found by Nice, 1863. Raw glycyrrhizin separates as a paste when the root percolates or treated with sulfuric acid. From the alcoholic solution of the latter 1,3, upon further addition of alcohol, a nitrogen-containing gum-like mass forms. Drying the filtrate by distillation in alcohol and adding ether results in a particularly bitter and scraping-tasting mass. Arnst and Hart give the sugar content for Spanish licorice as 957, for Russian licorice as 1039 in the dry substance, 8.16. According to Razanak, saccharose is also present in significant amounts in licorice. The glycyrrhizin thus purified yields some glycyrrhetic acid to ether, see above, which accompanies the glycyrrhizin in the plant. In the filtrate from the sulfuric acid precipitations, see above, D-glucose and mannitol are found Chirk and Relander. However, it is questionable whether mannitol primarily occurs in the drug. King states that for Spanish 213 and for Russian 1038, licorice is therefore a true arsenal of sweeteners. It contains no less than 4 of them. The method I propose for determining the 3 sweeteners, glucose, raw sugar, glycyrrhizin sequentially in the same solution, has been tested by Ella Erickson at my institute. It is based on the fact that glucose reduces feeling solution in cold saccharose only after short heating, and glycyrrhizin requires prolonged cooking to be determined according to Alleyne. In the extracts freed from alcohol by means of Schleimstoff, glucose is first oxidized and determined after standing for 12 hours with fueling solution in cold conditions. Saccharose is determined from the filtrate of copper oxide by boiling it for 3 minutes with fueling solution, while glycyrrhizin is precipitated from the filtrate with sulfuric acid, dissolved, boiled for 15 hours with fueling solution, and then also determined according to Alleyne. We found in air-dried sweet wood powder, glucose 139, 145, saccharose 2.4 to 2.57, and glycyrrhizin 6.2, 7.1 b. Using the gravimetric method of Cederberg, we obtained slightly less. Robiquet mentions in his analysis a crystalline substance similar to Vauquelin's. Moulin identifies asparagine by adding sulfuric acid and some resorcin, heating it, and adding diluted ammonia, resulting in a fluorescent solution. Furthermore, sweet wood contains L-asparagine NHEO.CHHANHAQ at 2,4-cysteine, which Caventou discovered and named H. Doyle. Also Pfaff had it in his possession. Henry and Plisson identified it in 1828 as asparagine, discovered in asparagus by Vauquelin and Robiquet, 1809. Furthermore, licorice contains up to 3.5 fat. We found only 0.2, 0.8. A little resin, glycyrrhizin resin. Yellow pigment in the vessel walls. Deep yellow with potassium. Small amounts of tannin. A lot of starch, 31.33 in Spanish licorice, 20.73 in Russian, according to Arnst and Hart, 1.54 gum, according to Madsen, and an essential oiled 0.3 in Spanish, 0.035 in Russian drug. Hensel. Licorice also contains small amounts of salicyl methylate desmouliere. The occasionally mentioned apple acid is likely glucuronic acid. The extract content is usually 35-38 in Russian licorice root, and 20-25 in Spanish la wall. Received 55 in 1896. Leaving licorice in ammonia gas is said to make it slightly sweeter Landerer's rad, liquirate, ammoniata, but this procedure is unacceptable and its effectiveness questionable. Ash content is 3.6, rarely more than 5. Holke, after Dieterich, 3.20 to 6.15. In powder form slightly higher, Dieterich, Russian 4.8, 11.7, Spanish 5.1, 9.9. According to Farm, Helvet 4th, not exceeding 6. The water content is 650-10, average 8.75. Arnst and Hart. Hirsch, Yaris B. D. Shem, 1860, 551. 1871, 308. Lukiger, Pharmacognosy. I. Olfel. A. Vogel, Juren, F. Pract. Chem. 28-1. Lideon Chem. Farm. 5924. Gorup Bezanis. D. Glycee. Dessert. Erlangen, 1877. Yaris B. D. Farm, 1878, 426. Waselski Uat. Literature glycyrrhizin. Older literature in Schwarze, Tables, 1819. Pfaff, System der Materia Medica, I, 187. Zeeks, 113. Dobereiner, Elements of Pharmaceutical Chemistry, 149. 143. Tromsday Journal, 19. Bersalade Pogand, and 1827. Martin Yaresp, D. Shem, 1860. Rumpf and Rupert, D. Farm, 4, 153. Benedict, Bear D. Shem, Jess, 1876, 1158. Ramsan Juren, Farm, Chim, 1875. Arch D. Farm, 1876, 150-70. Orn, 1876. 171 died, 1,801. Bird Farm 808, Arch D. Farm, D. Shem, 197, 1879, 105. Church U. Rolander, Spochen, Wochens, F. 1898, S. 243. Church U. Sederberg, Arch Farm, 1907, 97, 97. Church U. Gauschmann, Arch Farm, 1908, 545, U558. Brasenack, Arbeit D. K. Gesundheitsamt, 1908. Ainselsberichten 8, 899 Arns. Koenig, Nahar. Eugenussen, to 65. Carmel, Farm, Post, 22, 194. Moulin Journe, Farm, 1896, 543. Lawolem, M. Journe, Farm, 1896. Nisi, Yarisp, D. Page, 1863. Asche. Glycyrrhizin in other plants. Glycyrrhizin has been conclusively proven and analyzed only in the root of Periandra dulcis Mart, P. mediterranea Vel. The Brazilian sweet holly root Alcaçuz, as suspected by Peckold, confirmed by Church and Gouchman, as well as in the Monesia and of Prodosia lactescens Vel, Radel K. Chrysophyllum glycifloium Casar, a Brazilian sapitaceae from which Payen first obtained the sweetener in an impure form, also by Church and Gouchman. According to Hooper, the root of a Bruce precatorius contains approximately 1.5 raw glycyrrhizin, while its leaves have 9-10. The numbers may be too high. The Jacurity root has been recommended as a substitute for licorice Indian licorice. However, extracts are slightly bitterer Rudolph. Glycyrrhizin is also found in Glycyrrhiza lepidota macculla, Sarcocola, Trifolium alpinum LN. The underground parts are known as the Reglis de Montagne, Astragalus glyciphilos, the rhizome of Polypodium vulgare sweetgrass, and Pinnatifidum var. Schroeder, Guilielma speciosa Mart, Ononis spinosa. Reportedly 850, Tabermirca nomularia, Alicicarpus longifolius, and Micrua arenaria. The root of the latter plant is found in Indian Bazaar's Simmons. However, the proof that glycyrrhizin actually exists in none of these plants has not yet been provided. The sweetening agent, which was examined by Razenac and recognized as a glycoside from Eupatorium ribodianum, on which Burtney Farm, Zeit 1902, 108 drew attention, is not glycyrrhizin, as shown by Church and Gouchman, 1908. Gignet, Yaris B. 1885-16. Schroeder, therein Arch, Farm, 1885-621. The taste of licorice is peculiarly strong and sweet, slightly scratching, a little mucilaginous, and very weakly bitter. Peckel, Zeitcher, D. Oster, Apoth, Ver, 1867. Farm, Runch, 1888. Payen Exum, Chim, et Ned, Dumonesia. Paris, 1841. Dignet Rep. D. Farm, 1372. Simmons, Bull. Of Farm, 1894-205. Rudolph, therein, 1897. Flukiger, Pharmacon, und Pharmacographia. Adulteration. In powder form, olive kernel flour and cornstarch were found as adulterants Evans, also potato starch, 1988. Wigand, 1887, states that the powder is adulterated with flour, arrowroot, turmeric, refined sugar, guaiac, ochre, sema, guaiac, ochre, sema. Trigonella. I observed nothing similar in 1909. Also, Mittlacker found licorice to be barely adulterated. Bastin describes the differences of the stolons and roots. Hansen draws attention to the adulteration of the powder with extended powder. Literature, Evans, Farm, Journ, 1905. Wigand Pharmacognosy, Mittlacher, Results of Pharmacy Visits, etc. Journal of the Austrian Pharmaceutical Association, 1904. Bastin, Detection of Stem Admixtures in Root Drugs. Farm, Journ, 1902. 652. Hansen, Amar, Drug, 1886. A pest of sweet wood is Pyrolis farinalis, the flower moth Jackson. Then particularly Nyptus halalicus falderman, a very harmful peat in it, which was introduced into Germany through Russian sweetwood in the last decades, and has spread greatly Israel. It is found in the magical papyrus, I, p. 465, and is one of the components of Theriac Warren, p. 551. Among the Indians, sweetwood maduka was used in love spells jorit. A decoction of sweetwood root and sweet tea, Gymnostemma tisoides, is also used for bathing Buddhas on his birthday, on the 8th day of the 8th month. In the morning of this festival, the statue of the god is placed in a basin and doused 3 times with this tea by the worshippers. The dripping liquid is collected and forms a highly valued remedy junker von Langegg. Liquoricia is also among the first-class drugs princes of the Shen Nung Pen Sao King, the oldest Chinese herbal book 1, p. 515. It has been used since ancient times. Theophrasta 9:13 states. Sweet also is the Scythian, and some call it directly sweet. It is used around May, and is beneficial for asthma and coughs, and generally for pains around the chest. It can also stop thirst if one has it in the mouth, etc. and it makes the paste for roughness of the arteries. The sap acts against roughness of the air passages, as Dioscorides III, 5 already mentions. We find it mentioned by Theophrast I, p. 548, and Dioscorides I, p. 561. Further by Galen I, p. 5081, or Abasius I, p. 588, Marcellus Empiricus I, p. 590, Paulus Aegineta I, p. 590, Paulus Aegineta. Similarly, it is found in Susrutus I, p. 505. The Indians likely adopted it from the Persians and Arabs. It was highly valued by them, but does not appear in India, which still imports the drug today from the Persian Gulf, Karachi, and Afghanistan, until the 10th century. The cultivation of sweet wood is also ancient, particularly in Spain. However, it does not date back to the 10th century. The calendar of Harib does not mention sweet wood. The cultivation of sweet wood in the field near Bamberg is attributed by some Rius Walafridi Strabi Hortulus, 1033, while others likely more correctly attribute it to the Benedictines of Michaelsburg Abbey, who brought sweet wood from Italy and Spain to Germany in the 15th century. In the Vocabulary of Afrix, Archbishop of Canterbury, 10th century, in Carl's Capitulare, and in St. Lo, the monastery plan in the garden, and near Macer Floridus lacks sweet wood. It was therefore hardly cultivated in Germany before the 13th century, probably only from the 15th century onwards. Platerius Lures, p. 635, and Crescenzi, p. 6078 mention cultivation in Italy, and describe the preparation of succus. 848 mentions Succus liquoritiae from Crete. Liquoritia radix, or succus, is also mentioned in English documents from the 14th century execution of the Bishop of Exeter's Testament 1310, and liquoritia appears in various regulations of the Florentine Recitario of 1498. Of 1498. In the Frankfurt list of 1450 I, pt. 812, liquoritia and succus liquoricic are listed, while the Frankfurt Catalogus of 1582, I, p. 8017, includes Rad, Dulcos, Scythica Russian, and Hispanica, as well as Cretan Candiacus. The Esslingen tax list of 1571 I, p. 816, as liquoritiae liquor condensed. A figure of the plant, the trade form of the drug, in a succus tablet with the imperial eagle, was already given by Bachfig, 30. According to Tabernamontanus, a great deal of licorice was grown in Germany at the beginning of the 16th century, and Silcus in contrast to the Venetian vulgaris. The Bavarian licorice is mentioned by Cordus, Bach, and Gesner Horti German. Schroeder in his Pharmac, and Chim mentions only the Bavarian one. In the Frankfurt Reformation of 1656, it is explicitly stated, Liquoritiae succus impesatus Bambergensis. The English licorice appears in the Burlew list, 1724, I, p. 949. The cultivation of licorice in Italy does not seem to date back much further than the 13th century. It is first mentioned by Crescenzi, and later it cannot have been significant, as Anguillara, Mattioli, and Portaville, Libri XII, do not mention it. Succus liquoritiae is a healing remedy no younger than the root. Already Andromachus I, p. 551, lists Cyanea glycerizae, following Cordus. In Megenberg's Book of Nature, mid-14th century, I, p. Sweet wood has been used throughout the Middle Ages just as much as in later times, for it is absent from no medical work. Italian and Spanish sweetwood arrived in England in 1264 and paid customs there in 1305 p. In Sicily, succus was still prepared in 1770, as during the time of Platerius Ridicel, traveled through Sicily, 1774, 692. There is a mention of Lakritzenza Herzaf, das man Zwischolz heißt, a preparation using licorice root. This is the first mention of succus in Germany. Palladinus includes it in his series Medicaminum in the Compendium Aromatariorum in 1488. Theodoric Dorsten described it in the Botanicon, Frank F. Dodd, 1540. The representation in Italy, and Walter Reef gave in his Konfektbüchlein, Frankfurt 1544, an improved prescription Flückiger. Already in the 15th century we find it in tax lists. In the Rates of Merchant Goods I, p. 921, the succus is mentioned. In the Berlou list of first, P951, one finds Succus liquorice Angel and Hispan. In the tax lists from Frankfurt 1718 and Goslar 1731, Sucis liquor, Hispanic, is mentioned. In Geoffroy's Materia Medica 1742, Spanish, French, and Dutch succus, then Pretensian, Italian, and German, are specifically mentioned, with the Catalan, one around Dertusum and Eilerdam, prepared being referred to as the best. Gren also mentions in 1799, mostly the latter alongside Sicilian. In the Antidotario Romano, from the year 1675, it is said that the succus is made from roots collected in the area around Ascoli in the autumn. In the 18th century, the Essucci de Roiglis de Bayon is mentioned. Parallel drugs. The indigenous North American Glycyrrhiza lepidota nud. Contains glycyrrhizin culone, up to 639 according to Hooper. However, it does not seem to be used extensively. Also see Indian licorice P91 and Brazilian licorice P91. Lit. Cullen, Amor, Jurin, Farm, 1890. Hooper, Farm, Jurin, 1894. Illustration, Fig 3030. From Hieronymi Tragibach, Historia Stirpium, 1552. Left shows the commercial form of licorice, right succus tablet with stamp. Photo reduced, succus liquoricia. Licorice in many languages, see I, P 1060, also Finn. Lakritzi, licorice sap, bear dung, bear sugar, sucé or jus de réglizefar, extract or juice of licorice eng, sugo or succo di liquirizia or di regolizia. At Actuarius, IP 792. Succos dulcis radix, hind, Yatimat caras, Arab, Robusus, Atum, est susholz, duenom. In all countries where sweet root is grown and collected, succus is also produced, most notably now in Russia, which supplies England and America with it. The variety used in Germany mainly comes from Italy or Asia Minor. The Spanish, French, and English is mostly consumed in their respective countries. Only these rods become hard and weather-resistant and can be broken. The reason is unknown. Illustration, Table I. In Italy, where our succus of primary interest originates, succus is manufactured both in Calabria, where it is known as Réglisse de Calabre in France and Sicily, usually in small enterprises on the land, which are largely dependent on largely businesses and hold on to traditional practices quite conservatively, having changed little in 100 years. Illustration. Figs 31. Washing and cutting of sweet root at the Barone Campagna licorice factory in Corigliano. The washed roots are pushed by 2 workers with sticks into the visible cutting machine at the front. Ravazzini fought. Succus can only be presented in the form of solid rods made from fresh root. 432. One liqueurist factory of Baron Senator Campagna in Corigliano Prove, di Cosenza. In 1, the roots are cleaned, washed, cut, and cooked, and the juice evaporated. In 2, the succus is rolled out. In 3, dried. In 4. Illustration. Table 2. Interior of a single mill liqueurist factory of Baron Campagna. Flukiger reports on the presentation in Catania. Early April 1889, I visited, in Catania, 2 factories which process the root of a plant that grows wild in the area from October to April. The washed, cut, and crushed root is cooked twice in iron pans caldaia that hold 2 hectoliters, then pressed twice, taking 1 day each for the pressing operation. Director Luigi Caruso. Crushing the licorice root with the roller mills. Ravazzini. Illustration, Table for 3rd. All processing liqueurist factory of Baron Campagna. Director, Luigo Caruso. In the middle, unrolling the stems. Left, spreading out to dry and evaluate. Ravazzini. For pressing, the cooked root is either filled into a basket-like mesh, frantoggio, made from chestnut wood shavings, Porta di Pezzuola, or layered with 18 perforated iron plates, lastra di ferro, held together by a wooden frame gabbia and subjected to tow. The pressed one. A pan yields approximately 400 kg of pasta, which is immediately divided by workers on an oiled table made of oak, as mentioned above. After clarification, achieved by allowing the juice to stand still, the last portions that flow out are poured onto new batches of roots. The juice is cooked in the cauldron over a coal fire and finally brought to the desired consistency using charcoal. Yay. Either blocks blotchy or pani of 5 kg are formed, wrapped in blue paper, 20 per box cassa, or rods billy of the same size are made from the pasta using marble or brass channels, which are quickly washed after stamping to remove any oil absorbed during rolling. Martius, on the preparation of the crude succus liquoritia Bookning, Rep. 89. Finally, the drying takes place on hurdles tables in the storehouse, which requires the summer months, as at least in those factories in Catania no drying room with heating was provided. Copper is excluded here, as one can see, during manufacture. A similar description of the preparation, which we find in T. 289, 1845, and the statements by Hamburys, who made them in 1872 based on his own observations in Calabria, in Pharmacographia, is shared by Hartwich according to information he received in 1896, as follows about the preparation commentary to the drug. Book for the German Empire 2, p. 622. The manufacture consists of 3 operations: boiling down the roots, clarifying the juice, and evaporating it. In Italy, during the campaign from November to June, the lateral roots, the extract is already in English, so no translation is necessary. Rubbing is done in all larger factories by machines. The paste-like mass is now cooked with water for approximately 15 hours. After boiling, it is filtered through bags, often also pressed and brought into a clarifier basin. Here it is for reference. Obtained by digging up plants at least 4 years old, while the main root and side roots lying deeper than M are spared to produce offspring. After washing, they are cut and rubbed into a fine paste. In Italian operations, peeling does not seem to take place. In Tiflis, only peeled roots are processed. Before packaging, they are washed again, rubbed with gum solution, and stacked between laurel leaves to prevent sticking together. According to information received after 1910 from Ravicini, succus is usually extracted in quite primitive ways, but more carefully lately, only from mid-December to early May. The extract from the clarifiers is pumped into shallow condensation pans, called caldaia in Italy, where the thin succus solution is evaporated under stirring, first over lignite, then over wood coal, to avoid strong heating towards the end. A caldaia produces about 400 kg of succus. Drying takes place on wooden boards in the air and requires a long time in warm weather. 31. Carefully washed with water and crushed in a mill consisting of 2 lava rollers, table 2. At times, the root is first macerated in water overnight, or directly boiled in water for several hours over a weak fire, and then pressed sharply. They use plants that are 4 or 5 years old, as both younger and older ones produce less succus. The shoots and roots are typically dug up in the fall, immediately after the first rainfalls, when the soil is already looser. They are cleaned, then cut into fragments of 3/6 inches fig. The pressed root is then usually boiled again twice over a stronger fire, and the juice, after being filtered through a sieve, is reduced. Some factories use vacuum in a copper kettle to a concentration that still allows filtering, then filtered again, and finally evaporated, while stirring continuously with wooden spatulas over a gentle, slowly dying fire until the mass hardens upon cooling. Now, loaves pani, blotchy weighing around 5 kg, are formed from this mass and packed in boxes of 20 loaves, 100 kg, or they are shaped by hand, dusted with starch, oil, or ash, or molded using oiled wooden or brass forms into the known sticks bastoni, or bigly, table, which are shaped in various sizes depending on the factory brands. 6, 8, 15, 25, 35, 45, 55, 35, named after the manufacturers, are De Rosa Atri, Teramo, Martucci, Baracco, G. Grasso, Conte d'Alife, Zagaresse e Company, Inibaldo Odo, Duca di Atri, or Datri, in the province of Abruzzo Ulteriore, Musi no longer in trade, Grimaldi, Pignatelli Principial, Bongiorno and others. Illustration, Fig 32, various forms of Secustingen, Ravicini, 2. See map on P98, 3. With fanciful names. Theseus, by G.E.R. Fritz, then manufactured by Baron Campagna, Schiavonea, Dodonia, Cesarello Veneta, Fratelli, by Count de Life. In Torre Cerchiara, Duca di Corigliano, an old good brand, Baron Campagna Corigliano, table 2 and the 3rd, Solazzi near Corigliano, B. Fischera, Baron Amarelli, Salvago, Savarini, FSD, no longer in trade, P.S. Prince de Salerno, Bergarella S.S. Franco, Isurdo, La Rosa, Caflish Catania, G. Named after places, Corigliano and Atri. These two brands are also listed among those named after their manufacturers, as the respective gentlemen bore the titles Duke of Corigliano and Duke of Atri, renowned, also known as Papagallo, due to the parrot on the label, Geras, Messina, Rossano, Policoro, Sicilia, Catanzaro, Torcella, Puglia, etc. Regarding the additionally mentioned brands, Polisi, Lavoro, De Rosas, probably an imitation of De Rosa, Convitato, Veraggiuolo, Esraft, Lagusso, Cagliano, Pastora. I was unable to learn anything. Sometimes, in addition to the factory stamp, one can find impressions from pens that are incorporated into the shapes, particularly with the Veraggiuolo brand, or a star Castano, or a coat of arms Pignatelli, or the designation Sud per Caflish, Italy Duca di Corigliano, Barone Campagna, and so on. The sticks, after being freed from dust and made shiny lavoro di lustratura, are covered with laurel leaves in Russia with oak leaves and packed in boxes of 50. Even with loaves, laurel leaves, mentioned by Geoffroy in 1742, are used as packing material. As stated above, copper kettles are not always avoided. Even Jansen Florence mentions such in brass molds for the succus in mass production. Despite this, the trend now is to exclude copper as much as possible, for example, in many Italian, then English factories, and finally in those of Tiflis, where iron kettles, etc., are preferred. The fear of copper is, incidentally, unfounded. See Church. Copper, from the standpoint of hygiene, etc., from 5 parts of fresh root, 1 part of finished product is obtained according to Woodcock 16, according to Ravicini from winter root 1822, from summer root 1214. 100 kg worth 1,749,600 lire 1909, 13,744 quint. Most Italian sucus went to England, 3,102 quint. After that come Belgium, Austria. To the map drawn by Ravicini of the Italian sucus manufacture Fig. 33, pl. The rods are packed between laurel leaves in boxes of 60, 110, 120 kg. The weight of the laurel leaves may not exceed 3 of the total weight. In addition to rods, sucus in massa blocks, loaves is also manufactured. The above. Italy's total export of sucus in 1908, according to the Italian Ministry of Trade, 11,664 quintals, 1 q. 98, he adds the following explanations. The factory of the Baron Campagna is located in Corigliano. It produces the prime brands Duca di Corigliano, 4, 3, 2, and 1, once bars in Cassano with a star, as well as some secondary type C map, with an annual production of 1,500-2,000 D. Not far from there, in Isola Caporizzuto, is the factory of Baron Alberto Baracco, which produces the famous brand Baracco. In Rossano are located the factories of Marchese G. Martucci and Baron Amarelli, from whom emerged the good brands Martucci, Barone Amarelli, and G. Amarelli. Both are said to work with vacuum apparatuses. Near Rossano are the licorice factories of the Grafen dalla Veiff and Zagarese Company. The first factory produces the brands Conte d'Alif, Solazzi, and Favela, while the second makes the brand Zagarese, as well as the factory of Francesco Pignatelli in Cerchiara di Calabria, where the V. Pignatelli brand is made. Further south, in Policoro, is the factory of B. Berlinghieri, producing Geras after the coastal town and P.S. brands. A remnant of the old licorice industry in Ascoli is the Arte Rosa factory in Atri, near Teramo in Abruzzo, making brands De Rosa and Regina. The Musi brand, also from Abruzzo, has ceased to exist. In Sicily, Catania is the main hub for production. The largest factory is that of the Fratelli Caflish, producing their superior Caflish brand with the Super designation. Intermediate quality comes from G. Bongiorno, while lower quality licorice is produced under the Vittoria name in small sticks of 6-8G and 15-17. The company Bernardo Fichera manufactures the brand Fichera, the company L.A. Rosa Pastor, the brand La Rosa. The company G. Grasso is said to want to give up manufacturing. Illustration, Fig. 33. The main production sites of Succulus liquoriceae in Italy. Next to each location is the manufacturer, and next to them the types produced by them. Ravicini. In Messina, the factories of the companies Santo Franco brand S. Franco and Salvago Nunzio A. Company brand Salvago were destroyed by the earthquake on December 28, 1908. The nephews of the deceased Santo Franco established a new factory under the company Fratelli Ami's brand S. Franco.net. English factories, which mostly work with vacuum equipment, are located in England, Yorkshire, Lacryzen, Pontefract Capes, CP84, and the Caucasus. Syria also produces Succus 1901, as does Mesopotamia. The factories of Sinibaldo Oddo in Termini Amares brand Sinip. Otto and Vito Bergarella in Trapani brand Bergarella have closed down as the licorice in the Imarato has been eradicated. The factory of Vincenzo Giuffrida in Caltagirone only produces 5 kilo rolls in 100 kg boxes. A Russian factory, founded by a German and now operated by the Pharmaceutical Trading Company, is located in Tiflis. America produces Succus in Philadelphia and New York from imported Russian, Greek, and Anatolian licorice, as does Germany. Southern Russian brands such as Sanitas and Tiflis are renowned for their excellent quality due to modern facilities, vacuum, etc., used in production. In Germany, popular brands include Baracco, J.G. Stern, J.D. Riedel, while in Austria, Martucci and Theseus Fritz are favored. French factories are in Nîmes de Bayonne. Variety seems to be no longer extant. Spain in Girona and Vitonia. The factories in Seville and Saragossa belong to French consortia. In Greece, Succus was produced in Patras no longer since 1910. Emmanuel and Morea Gastuni used to also figure among the varieties not since 1910. Some non-Italian companies have their brands manufactured in Italy. For example, G.E.R. Fritz Pezzolt, Isus, J.D. Riedel, and J.G. Stern. Baracco is the most expensive and often counterfeited, with its stamp for trademark protection sometimes altered to Baracco. The most prevalent brand in Italy is now De Rosa. Spanish brands include Alicante, Carreño, Zaragozzana, Spagnola, and Imit. Baracco, Spanish Succus, is generally referred to as d'Alicante in Italy, but it is considered of poor quality. Among the best-regarded brands in Italy are Corigliano, Cassano, Baracco, and Martucci. Of the imports in 1908, 402 came from Asia Minor, 1232 from Italy, 1313 from the Rhine province, 227 from France, 127 from France, 196 others by sea. According to a 1900 issue of the Austrian Pharmaceutical Association Journal, Hafner described Cassano as inferior, while Salvago as the highest quality. The importation of licorice to Hamburg by sea in 1906 was 3,032, 1907, 3,632, 1908, 24 tons. The sucus is processed in a similar manner almost everywhere. Only in New Zealand, or at least since 1883, is the extract obtained by boiling water, condensing with sulfuric acid, then precipitating with alcohol and neutralizing with potash added to starch, pea flour, and gum. In Italy, nearly all licorice harvests are processed into succus. Germany imported 5,817 tons of succus by rail and river in 1909, with 2,902 tons from Italy and 1,548 from Asia Minor. France imported 908,700 kg of Succus regalis juice in 1905 kg of Succus regalis juice. North America imported licorice paste in 1908. 644,457 pounds, and in 1909, 551,084 pounds. The extracted residues are used as fuel material. Formerly, they were used in paper manufacturing Marat Helens. This is due to the fact that the bast fibers are very long and numerous, making them suitable for this purpose. Flukiger Hanbury, Pharmacographia, Flukiger, Pharmacognosy III, Alpha 8, und Arch, Farm, 1889. The sticks have a varying diameter and length depending on the type 1120 cm, long and 2.5 cm thick. They are black, smooth on the outside, flexible in heat, and brittle in cold, with a shaggy break. The mark is brown. They lose up to 20 water upon drying at 100, float on chloroform, and sink in sulfur carbon. Sestini, Gaz, Chim, Ital, 1878, Yares B, DPH, 1878. Woodcock, Juran, D. Farm, Chim, 13, 1886, 275 Chem. Drug, Meralens Diction, 13, 1886. Au Fontenelle et Poisson, Man, Campo du Argent Papet. Paris, 1828. Paris, 1828. Preparation in Sicily. Apoth. Zeit. 86. Description of the drug. After drying at 100, the specific weight is approximately 142.7 Flückiger. Chemistry.L. Cold water extracts about 60-75, sometimes even up to 90 of the soluble components, including moisture from the sucket. Pontefract cakes, Dunhills, for example, release 71 to cold water. The sticks retain their shape when packed between wood wool. The residue still containing traces of glycyrrhizin is partly made up of starch globules, pectinus, and gum-like substances. Raw glycyrrhizin is precipitated from it using sulfuric acid liquor. Liquorous solutions should therefore not contain mineral acids or alkaloids. In the solution, glycyrrhizin, glucose, saccharose, mannate, and their transformation products, which also dissolve in alcohol, as well as the aforementioned accompanying substances, are present. The aqueous extract forms a precipitate with wine spirit. The washed precipitate dissolved in ammonia and evaporated gives the commercially known glycyrrhizinum ammoniacal merc. Pejurier as a black lamellar preparation, which is also obtained from sweet wood known as glycine in France. On average, the succus contains 720, usually 1014 water, in cold water insoluble substance 1040, usually 1733, including C15 gum-like substance and starch paste, 130-35.5. Starch pills. The extract content varies between 33 and 79, mostly it amounts to 55-72. We cannot yet pass a completely sure judgment on the glycyrrhizin content, as an exact determination of this has not yet been found. Therefore, it very much depends on the method. Up to now, only raw glycyrrhizin has been determined. See qualitative determination. 1900, 216. 6.6 to 14.7. Salvago usually 1013. The percentages given are for ammonium glycyrrhizate. 5.8 11.9 20.8 creme, 40213.34 powder, 1.330 18.14 pill, 330, usually 1018 Proleus, 15.8 Renard, 1.88.6 Schroeder, 6.427.8 Kinsey, in on a Tausian wine Taufleiser brand Senatus 30 Utestra. In the table by E. Schmidt-Pot, Zeit. 90 in my laboratory, 1910 in Cassano. 15.9 16.8. Glycyrrhizin determined Sitterberg 12.8 to 15.6. 5.86.3. Reducing substance in cold feelings. And 11.11.8. Reducing substance in short cooking feelings. The succus is difficult to ashes. The ash content varies greatly. Counterfeit licorice often has less than 2 ash, so a lower limit should also be demanded. In the ash of genuine licorice, 34-43 potassium is found in counterfeit. 1830. Dyer, 1888. Parry gave 1910 the following figures. Soluble inversion. Calabrian 10.95595, 17.959, 14.511.95. Juice stem 13.6735, 25, 20, 25, 25, 12, 12, 12, 18.85, 10.888, 12.9. Juice block, 20.57.22, 8.523, 12, 13.9. Spanish juice 8.5, 13.5.22, 4.955, 12.7.514, 14.515.25. Ella Erickson found using my method see above. P. Good varieties, e.g., Baracco, do not exceed 5 of the air-dried substance alkaline ash. The ash of the insoluble residue in water is slightly over 3 Flückiger, see above, but total ash often rises to 6, 8, 10, according to Madsen even to 14. Good succus does not exceed 8. The lack of a uniform procedure explains the extraordinary diversity of commercial products. and the entirely justified suggestion made 60 years ago to produce the sucus itself, perhaps according to a pharmacopoeia guideline. It can be admitted that a certain percentage of insoluble substance, probably mainly starch and pectin bodies, is necessary for the firmness of the sticks. The changes that the components of the root undergo during the presentation of the sucus are not yet studied. I have reasons to believe that a part of the glycyrrhizin is split. Impurities. The sucus is occasionally, but rarely, supplemented with gum, dextrin, starch sugar, and gelatin. See below. Starch was already mentioned by Gabor. Woodcock, as well as rice and wheat flour, and Johannisbread powder, Vogel's flour, and dextrin. The influence on the composition of the sucus is whether it is obtained by cold extraction of the root, or cold pressing of the juice, or by boiling the root, and whether the boiling is continued for a long or short time over a moderate or strong, fire. Finally, whether the juice is clarified, whether parts of the juice are separated by precipitation or coagulation and filtered out, and whether the vacuum was used during evaporation, or if it was evaporated under a strong or moderate fire. However, one must be cautious with the accusation of impurity, as in Italy, workers responsible for rolling sometimes rub their hands with starch. See above to prevent the sucus. Occasionally, recently, rarely, the sucus contains copper form. Zeit, 1894. A recent and increasingly popular addition by manufacturers to achieve greater strength of the sticks, at 0.3 gelatin, is unlikely to be objectionable. Previously, as adulterants were indicated. Extracts of nettle, dandelion, and chicory, iron sulfate, clay wallweber, 1862. Pest. The weight of the residue dried at 100 C should not exceed 25 Cg. Often, old sucus is infested and destroyed by Cytodrepa panicea warned, S379, Nicobium castaneum var, Hirtum oert, S381, and another white caterpillar, larvae ibid, testing. Generally, a good sucus is now required to contain no more than 25 insoluble substances in water medicine. Found 2645, from only 142025.26. Evaluation can be carried out as follows. 1 g of air-dried, broken into smallest pieces sweet wood sap, is poured over with 150 g warm water and 10 drops of ammonia. The mixture is shaken frequently, and after 24 hours filtered through a tarred filter with a diameter of 10 centimeters. The residue is washed onto the filter and rinsed with enough water until the filtrate weighs 200 g. The method mentioned above, P90, needs further testing on larger samples. It provided good results for Ella Eriksson in Cassano. When 40 g of the filtrate is distilled on a steam bath, the residue should weigh at least 12 Cg. 160 g of filtrate, reduced to 10 g, mixed with 30 g of wine spirit, gives a brown precipitate, which, after complete washing out with wine spirit and then drying at 100, may not weigh more than 24 Cg dextrin gum farm, Helvet IV. The ash content should not exceed 6.8, and the water content 17. For the determination of glycyrrhizin, we do not have a completely reliable method. So far, the gravimetric method of Hafner has proven to be the most reliable for practical purposes. I have slightly modified it. See Sederberg's dissertation, Bern, 1907. As the dry licorice root contains approximately 5.57 glycyrrhizin and yields about 25-30 extract in factories using different methods, 16 to 20 of the fresh root, there should be roughly 1621 glycyrrhizin in good sucus, remains intact during processing, which is not the case. Tables of analyses of Sucus liquoricia can be found in the commentary to the German Pharmacopoeia by Hager Fischer Hartwich, 1896, 2, p. 624, Wittstein's Handbook of Pharmacognosy, p. 821, and in E. Schmidt's Apothekerzeitschrift, 1900, 216. The data provided by Perry is as noted above, p. 100. Lit. Studies on succus were conducted by Matzen, Investigationes of Succus Liquor. Chim, 1897, 280. Pilz, 1876. See Wittstein's Handbook, p. 821. Prolius in Fischer-Hartwich, Handbook of Practical Pharmacy. Hager Fischer-Hartwich, Comment on the Drug Book, 1896. Kreml, Notes on the Examination of Medicinals and Comment on Eastern Pharmacy Education 7th, Archives of Pharmacy, 1889. Deal, Farm, Runch, New York, 1883. Kinsey, American Journal of Pharmacy, 1898. Journal de Pharmacie, 1898, Valjo 7, p. 304. Hafner, Zeitschrift der Öster. Apotheker Vereinigung, 1899 and 1900. Pharmazeutisches Zentralblatt, 1899. From Pharmazeutisches Zentralblatt, 1901, p. 324. Trubeck, Journal of the American Chemical Society, 1900. Farm, Zeit, 1900. Zetsche, Farm, Central, 1901, p. 277. E. J. Perry, The Licorice Juice of Commerce, Chem and Drug, 1910, Baldwin 21, H. J. History, C. Rad, Licoricia. D. Drugs containing mannate, mannose, see above, p. 6, is also a hexose. Muller, Hager, Utescher, Fresenius, Glucksmann, Morpurgo, Leden-Hilsebosch, Stein, Moore, Church, Sederberg, Erickson et al. Application. America uses a lot for chewing tobacco, France for a drink, the cocoa, England for porter and ale. Most goes to pharmacy for licorice tablets. China and Japan need success in the production of ink and dye. However, its reduction product, D-mannate, plays a role in pharmacology, whose relationship to mannose is shown by the comparison of formulas. HHOO mannose, CHO C, CC choch OOH, HOO D-mannate, CHO CCC CHO OOH mannate fraxinin. Etymology. Not the manna of Hebrew man, Arabic man, a gift from heaven, or Hebrew man who. What is this? After the exclamation of the Jews when they saw the first manna rain, see Exodus 16, Numbers 11, as already interpreted by Jeffrey. It is not very sweet and forms needles or rhombic prisms, melting point 166, which dissolve in 6.5 parts water and 1,500 parts absolute alcohol. It reduces Fehling's solution even in heat not, but after oxidation with permanganate. 1. Eshiana. Manna in many languages. Heavenly bread, manna from heaven, manna, Spanish. Manna in Dioscorides, Pliny. Galen always means a less significant variety of the related substance. For example, manna furis, also in Paulus Aegineta, i.e. fine-grained incense. Fraxinus ornis, L. fraxinus paniculata mill, F. florifera stop, F. argentea los, vulgature, segi, ornis europea purs, manna ash, ash with manna. Etymology. Fraxinus does not derive correctly from Isidore's quod magis, inter aspera loca montanaque fraga, nascitur, which perhaps more accurately translates to born among rugged places and mountains, likely due to the tree's use in constructing fences, or break, fracture because of the wood's fragility. Esche ash tree, possibly Proto-Indo-Germanic, has cognates in Dutch esch, Icelandic asker, Swedish ast, Old High German ast, Middle High German eish, Old Norse askar, English aish, Old English aest, also spear and eggs, aest. The most original form appears to be ls as hoops. It's possible that spear was the original meaning, then the root would contain as to throw, hurl grassman. Also, Latin ornis from osinos means both mountain ash and spear hoops, perhaps from growing on mountains. System, position. Olice, Oleoidea fraxinia, Thecta ornis. The manna ash is a moderately tall tree 5-7 m, rarely over 10 m, with gray, smooth bark, and odd pinnate, 3 to 4 part leaves. The leaflets are edge-shaped, pointed, and toothed. The rich flowered hanging raceme of flowers is not longer than the leaf. It resembles a delicate feather bush, due to the fact that the flowers have 410 mm, long free, narrow lanceolate, pale yellowish-white corolla lobes, and 2 stamens with very long filaments. The tree is native to southern Europe, forming forests in karstic areas, Croatia. It can withstand the winter north of the Alps, and is a popular ornamental tree. But it also tolerates the African climate, and is cultivated, for example, in North Africa. It blooms on Sicily at the end of March. Fraxinus rotundifolia lam is certainly not to be distinguished from F. ornis elfarm. It can also be found in Ticino, South Tyrol, Carinthia, Lower Styria, Hungary. It grows particularly well along the northern, western, and eastern coasts of the Mediterranean, from Valencia through southern France to Italy, from Istria through Dalmatia and the Danube countries to Macedonia, Thessaly, Greece, Lebanon. Americana pers is likewise, like several other species described by Persoon, identical with it, in that those forms are mistakenly indicated as being from America Schumann, whether the variety Fraxinus ornisvar. Ravicini. Illustration. Fig. 35. Manna plantations Frassinetti near Cefalù in Sicily. Workers are about to make cuts 1910. Ravicini. Cultivation. Rotundifolia can be maintained as the principal supplier of manna seems to me very doubtful, since, as Hanbury established in 1872, none of the manna is cultivated on Sicily deserves this name. In the plantations around Palermo, Flukiger found rounded leaflets rarer than sharply lanceolate ones. The leaf shape varies considerably. On Sicily, Uphar ornis is also distinguished from Uphar fractionaster. It is believed in Sicily that Uphar rotundifolia, the so-called amaleo, produces good manna. Ornis wild waxen ash, ornage, of Orne provides inferior Castelbuono or Frassino manna. Lit. Linné, Spect, Plant, i.e. 1057, Fig. Berg-Schmidt, Atlas de Sudum, Alpha Alpha. 40 also includes further systematic lit. Tabst Cooler, Meginal Flanson TFF, 115. Pathology, among the various fungi, known to grow on branches and trunks of Fraxinus ornis. Fisher. Illustration. Fig. 34. Locations of manna collection in northwest Sicily. The cultures that produce manna orniello, Frassino della Manna, are located on the north coast of Sicily, specifically in the upper part of the C-zone, or lower part of the middle zone. In the C-zone, one finds sumac, olives, oranges, oak, fig tree. In the middle zone, pistachio, walnut, almond, chestnut, John's bread tree. The manna oak is particularly associated with olive and chestnut. It requires no good soil or fertilization, but does need sunlight. The cultures are now primarily found in the western parts of northern Sicily, near Palermo, S. Maria di Gesù, opposite Valdese, then in the districts of Torretta, Capaci, Sinisi, Terracini, Favarota, west of Palermo, Mezzagno, and particularly at Cefalù. However, recent attempts have been made with potash fertilization. Potash affects sugar production favorably. The seedlings are planted at distances of 1-2 m, or even further 3-4 m. Mariani. Manna oak plantations, Frassinetti form light groves of earth. The lower branches are pruned up to a height of 2 m. Here they go far up into the mountains, up to 1100 m to Castelbuono, San Mauro, and Geraci. Here and in Cefalù, the best manna is harvested. In Castelbuono, also from wild trees, the smaller varieties Flukiger. In the district of Cefalù, Castelverde, Polina, and Lascari should also be mentioned. In the west, manna is harvested in the district of Trapani Castellammare del Golfo, near Alcano, Monte Giuliano Ravicini. However, alone in the area around Palermo, 2,070 ha are still dedicated to manna cultivation and collection, with an average yield of 980 z per year, not including children. 800-900 people participate. Here and there, attempts seem to have been made with grafting. The cultures of the manna trees, which currently cover 4,000 ha and form the main source of income for the residents in the aforementioned areas, are now often replaced by more profitable crops, such as oranges. See history for more on those that have then disappeared. A minimal amount is still harvested south of Naples, in Cetera near Salerno, in San Martino Valle Cardino near Avellino, and in Acciura near Potenza Ravicini. Lit. Fickle, Pharmacognosy. Arcuri. The cultivation of the manifer. Southern Agriculture, 1879. Illustration. Fig. 36. Manna exuding trees, Sicily. New shoots develop from the stump, which can be cut after 4 or 5 years. The cutting is done as follows, with a curved, sharp, large knife, Fig. From the journal Plant Nutrition, Extraction. When the little trees are 7-12 years old and at least 2 tall, with their trunks just spanning your thumb and middle finger, extraction begins. Even 4 cm thick trunks yield ample manna and remain productive for 12-20 years. Then the tree is felled. 150, which is done with one or both hands, is carried out in July, August, and September during the early morning hours, first making a cross-section through the entire thickness of the bark at the base of the stem, on younger trees cutting off about, and on older trees of the circumference, and continuing to climb upwards by making a new horizontal cut each morning. Fig. 35. The cuts are approximately finger width apart, or slightly wider 1/4 centimeter. They are either made precisely horizontally or somewhat diagonally. If one side is marked with cuts up to the point where the branches originate, the same is done on the adjacent side in the same manner. The number of cuts per tree often reaches 90. 36. But most of it runs down the stem and hardens on the surface into rill-shaped pieces, hence cannellata, M in cannoli, which show on one side the impression of the tree's surface, and on the other warty protrusions, manna cannellata, or lat. Cannulata. A worker can wound 4,000 trees in a single morning. From the cuts flows a brown-blue fluorescent liquid, which becomes almost white and crystalline in a few hours and loses its initial bitter taste in some hours. Here, natural stalactite-like formations, spikes, cannels, perhaps from cannellata, appear on tilted branches. Fig. I do not know if the former custom, to insert a straw canna into the wound and let the manna harden on it, as portrayed by Pommet in 1694, is still practiced. I have never seen stalks or hollows that could be attributed to extracted stalks in trade manna. Ravasini tells me that the custom is no longer practiced, and Mariani also did not mention it during his visit to the Manahane in 1909. The manna that drips from the tribe or branches is caught by spread-out bricks, or the stems pali of the fig cactus Opuntia, vulgaris manna insorta. Younger trees of Amalaleo produce the best manna, while older ones of Frasino yield lower quality, partly greasy varieties. Manna Frasino, M. sminuzo, from sminuzare to crush, M. in frasca branch, M. in grosso, etc. 37 takes place on clear days with intervals of several days or weekly, or every 10 days from mid-June to mid-September. When bending the small branches, the manna pieces naturally come off cannellata. The remaining sticky material is scraped off with a spatula rotami, and the smaller pieces are called M. in lagrime. The workers usually carry 2 tubes or other containers made from tree bark on a strap over their shoulders. In one they place the carefully stripped white pieces from the trees, in the other the usually colored runoff masses. These form the 2 trade varieties. If rain threatens, which would dissolve and wash away the manna, all available workers are immediately called upon to save what can be saved. Therefore, even at night, a guard is posted in the oak woods who rings a bell. As soon as the bell sounds, everyone rushes to help. Trade reports often speak of harvests disturbed by rain. The price then rises quickly, as production can sometimes drop to a quarter, e.g., in 1901. A moderate harvest requires at least 4 or 5 undisturbed collections. Prolonged dryness also has an unfavorable effect on production. The manna obtained from the lowest cuts of the trunk and from older trees is less pure, dries poorly, remains therefore more or less moist and sticky. The sap exuded from the upper wounds, especially of younger trees, produces the best, purest, quickest drying, completely crystalline manna. Particularly collected in August and September, manna is then dried in the sun. 1 hectare contains approximately 5,000 little trees or fewer, which yield 8,100 kg of manna. For every 4.5 kg of manna in canisters, there are 85.5 kg in bulk. The production of manna is declining due to its unprofitability, but export still amounts to approximately 1 million lire Mariani. Castelbuono alone produces around 2,000 dozen. It is said that manna on Fraxinus ornis can also be induced by the sting of Cicada orni. I believe that any injury in oleacean plants increases the production of manna. Manna is carelessly collected in Castelbuono. A man scrapes off the exudations from the bark in their entirety, and then sorts them into better and worse pieces. M. Castelbuono selected, i.e. choicest, and M. Frasino, near Venice, is called M. Frasino. The hardened mass on the tree forms manna cannoli, and the ones that flow down in wet weather are manna rotami fragments, broken manna. Sporca dirty manna. Illustration, Fig. 37, the shedding of manna in Sicily, from the journal Plant Nutrition. A newer report by Ward states, the mana flows from cuts made across the bark of 10-year-old trees, extending about 1/3 of the circumference, daily during the season that ends in September, approximately 45 per day. In the following year, fresh cuts are made alongside those of the previous year, and in the third year, the process is repeated on the remaining uncut parts of the bark, after which the trunk near the roots is felled. Each root then produces several, usually 4, new trunks. As a byproduct, when harvesting the manna, one obtains a honey-like non-hardening secretion with a sweet taste, called myalaco. This is collected in hollow stems of Opuntia ficus, indica known as pali, and has the advantage of not containing any foreign impurities. It is usually mixed with emerotomy. 1738, Annual Report of Pharmacy, 1872, 137. Cleghorn, Transactions of the Botanical Society of Edinburgh, 186,869. Annual Report of Pharmacy, 1870, 144. Tettner, Archives of Pharmacy, 1870, 148. Flukier, Archives of Pharmacy, 1889, 1028, and Pharmacognosy. Science Papers, p. 362. In Sicily, Ward, Pharmaceutical Journal, 1893, 381, Pharmaceutical Times. The Italian trade distinguishes Capaci Canolo, C. Rotami, Gerassi Canolo, G. Rotami, G. Lagrim, Castelbuono Scelta, Dottor. The German trade now distinguishes Mana Canolata electa in Lacrimis, Tiermana, and in Fragmentis in Granis. Geras, correctly Gerassi, is also misleadingly called Calabrina, or even Calabra Geras. Canolata is often twice as expensive as Gerassi. The cheapest is Castelbuono. Previously, distinctions were made between Canolata, Geras, Calabrina, Communis, and Capus. Traders also differentiate the commercial varieties according to the places where they were produced. Canolata is produced in Italy by dissolving M. Calabrina in 10 times hot water, filtering the solution, digesting it with animal charcoal, clarifying with egg whites, concentrated evaporation, and molding into sticks, continuing to pour over the mass until the desired thickness is achieved. New Teicher. Farm, 1885. Manna is traded in boxes of 30, 50, and 90 kg. Just from Cefalu, 3,000 Z Canolata and 2,000 ZZ. Frasino have been exported in the last 10 years. Germany imported 1909, 372 ZZ of manna from Italy. France imported 1908, 41,137 kg. An artificial M. Recently, an Italian manna pura has also come onto the market, made by dissolving, filtering, evaporating, and shaping into 1 kilo loaves. It is 15 more expensive than manna canolata. Unpleasant-tasting manna can be purified by treating the aqueous solution with animal charcoal. Hirschschneider, comment 1891. Good manna forms flat, or rill-shaped, or stalactite, dry, easily crumbled pieces of yellowish-white color, with a honey-like smell and sweet, slightly bitter taste. Smaller varieties produce more or less yellow-brown, granular masses that are sometimes quite soft or even slick. Often, bright grains are stuck together by a brown mass. The pharmaceutical books usually only request M. canolata. If you crush a manna grain in a drop of oil and observe it under a microscope, numerous well-formed crystals and their fragments can be seen. If you examine a manna grain in water, you often find several tissue fragments, primarily from the wood body of the manna tree in mushroom spores farm. Helv afur, sometimes also calcium oxalate crystals and starch grains. Manna is preserved over lime pH. Helv vive fear, now available in tin cans. Dried manna Caesar and Loretz. Illustration. Figure 38. Manufacturing of mannet cones at F. Giglio E. Company in Cefalu, Sicily. Chemistry. The main component of Eschen manna is D-mannet. This was discovered by Proust in 1806 and is identical to fraxine, granitin, promulin, thrimulin, syringin, and grassroot sugar. The amounts found in manna vary greatly. Pure white manna of the highest quality is said to contain up to 90 Flückiger, while lower quality manna has a content of 30 or less. All these figures require revision, as Tanrit discovered 2 new crystalline sugars in it in 1903. Mannitotros mannantetrasaccharide CHO, F. 167, water-free D. 150, and maninotriose manan trisaccharide CHO, D167. Manna in tears consists of approximately the manna in kernels of these sugars. Backhausen considers it to be grape sugar, Bignet invert sugar. After tannerite ordinary manna contains 40, manna in tears 55, mannic 3 or 2.2, glucose 3.4 or 2.5, lebulose 16 or 12, manotetrose 16 or 6. Previously 1890 manna contained 11.8, 11.31 reducing sugars. Butler. Generally the content varies between 2 good manna and 20 bad manna. Then, in smaller quantities, raw sugar, a lot of levulose, dextrin bignate 1868. Flückiger found no dextrin, mucilage, which provides salpeter's acid mucilage, acid Flückiger, traces of citric acid, and the fluorescent solution-producing glycoside and the fluorescent solution-producing glycoside. Fraxin, which is split into fraxitin, a methyl dioxycoumarin, and grape sugar during hydrolysis. Flückiger. Thenard found a repugnant body up to 1 in poor manna. Already Rebling discovered that the better the manna, the more mannite and less sugar it contains. He found 82 mannite and 2 sugar in manna cannellata, 57 and 8 in M. Geras, 50 and 18 in M. common, and 37.5 and 30 in M. Capus. 4 Italian factories, 2 in Milan, 1 in Genoa, 1 in Cefalù process manna into mannite, which is sold as coniapani and avaletti. The Coney 200-400 G are depicted in figs. The tavoletti are tablets of 25, 50, and 100 G. The ash content of manna varies between 0.07 and 5 deuteric. Only in the inferior varieties does it exceed 3 Hawke. The moisture content is at most 10, as specified by pH, Helv, Firth, Lit, Tanrit, Compt, Rend, 134, 1586, Bull, 1587. Butler and Flückiger, Pharmacognosy the 3rd, 27. Bignate Journ, Farm, 7, 401 and 8, 5. Earlier analyses by Fourcroy and Vauquelin, Buchholz, Leptweiss. Microscopic characteristics also described by Kramer, Procéan PHS, 98, 334. Illustration Fig 39. Drying of mannet cones at F. Giglio, Company in Cefalù, Sicily. Flückiger, Arch, Farm, 200 1872 159. Ash Hauke, Zeitcher, D. Oster, Beppoth, Ver, 1902, and Dieterich, Helfenbe, Anne, 1905 U, 1905 U, 1905 U3. Bouillon Grange, Jur, 57, 117, 10. First mention of crystallized mannet pure manna. Manna produces D-mannitol in higher quantities only after injuries, thus being a pathological product. However, it appears to be present normally in organs, especially bark, of oleacean species Olea, Filaria, Fraxinus, Thuringia. Fraxinin is impure mannitol. Mannitol seems to be widely distributed Japec. It is also found in eponymous species, Platanus orientalis, in Fir cambial Ace Pacar, Court Dot, Graminis vulgar, celery and carrot, as well as in Laminaria and Fucus species Stenhouse. The bacterium causing the mannet disease in wine converts fructose into mannitol. Canelle Meyer and Reiche, bark of Juniper brasiliensis Quasnick, and Basanacanthus spinosa Grützner. In fruits of Coffea arabica, 2.2, Busengo, Prunus lauroseraceus Vincent, and Delicanal. Hippophae rhamnoides, Erdmann. In Aconitum tubers Flückiger. Licorice Church, Ries Dahl. Investigations on the occurrence of mannitol during various vegetative periods are due to De Luca's work. Through precise study of the respiratory quotient, Gerber demonstrated that mannitol transfers to fat in olives. Lit. Zapek, Biochemie. W. Meyer and von Reiche Lieb, Ann 47, 1843, 234. Vulker, on the occurrence of mannitol in the roots of Triticum repens, and on D. Shem. 59, 1846, P380, Stenhouse, Lieb, Ain, 51, 1844, 1854, 254, 254, Tackler Monet. Jean-Gerard Bottot, Yari S.D., 1893-2, 461. Quasnick, Shem, Zeit, 1892, 192, 109. Grützner, Arch, Farm, 1895. Luca, Compt, Rend, 55, 470, and 506. Peckold, Mannet containing plants of Brazil, Zeitcher, Oester, 1896. The determination of the insoluble part in alcohol raw mannite can be carried out according to dietetic Helfenbein. On, 1893. Good mannite should contain at least 70-75 raw mannite. When 2 g of mannite are cooked with 2 g of water and 40 g of wine spirit for an hour in a reflux cooler, passed through cleaned cotton wool, the residue and filter are washed with 10 g of hot wine spirit. After evaporation of the liquid, the weight of the dried residue at 100 c should be at least 1.5 g, corresponding to a minimum content of 75 raw mannite pf. The ancients believed that manna fell from heaven. Jupiter Melplut said Galenus lib. 3 de alimentis. On the manna of the Bible, see below. What the MNN, which Ebers reads on the walls of the laboratory in the temple of Edfu, was, we do not know. It is said to resemble anticorner from the Nehabaum, but we do not know what this was in sense. Also, the reading ante according to Spiegelberg is considered incorrect and the word NTW vocalized approximately. Je should be. Incense is usually written centiar and T. Brugsch and Lauret hold MN for earth pitch, not for manna. Helve the fourth. Mannite must not contain starch, flour, or honey. The Florentine Rigittario of 1498, p. 794, mentions finely ground licorice as an adulterant of mannite, Meunier 1842, cornstarch, Frickinger recently wheat dough, and Jandis grape sugar. Application. Manna is a mild laxative often combined with senna. History. It was probably a resin. The oldest certain mention of sweet manna is perhaps in Susruta Ophai, S505, where sweet exudates from Anathem soa, Cordia latifolia, and Apholius are mentioned. Such manna from the leaves de fronda is still found in attacks from Rome 1558, Ein PL 188. But both this manna and that, mentioned by the Arabs of the Middle Ages, Ibn Bathar Referned, p. 608, Umran I, p. 598 and Serapion, as well as the often mentioned Manna Alfida, Frankfurt List, Braunschweig Inventory, in Cordis, Schroeder especially Manna Granata, Granulata, or Masticina, are certainly not birch manna but Persian or Syrian products. Mainly Al-Haji manna see later, then cedar manna. They were highly regarded as mild laxatives, and were still widely used even after the introduction of Calabrian and Sicilian birch manna. As late as 1578, Acosta stated that the best manna from the Orient came through Venice, but neither he nor Garcia da Horta, nor earlier Avicenna, made a clear distinction between the different mannas. In the Frankfurt Catalogue of 1582, the Calabrina is described as the worst, the Brianzona as average, Granulata, Granata so Masticina, as the best. Conversely, Wecker in his Antidotarium affirms, Schroeder in his Pharmacop, Medic, Fies d'Ordo, still lists Terraniaban, Manna Granata, and Masticina alongside the Calabrian in 1649. In the first Brandenburgian tax of 1574, it states, Manna Syriaca id, et Masticina, optima, Levant, Manna. In the Reform of Worms in 1609, it mentions M. Granata sive, Granulata, M. Wenrich states that the manna of Mainz, along with sugar cane, was brought to Sicily by the Arabs, although the plant is native to Sicily. The earliest but questionable mention of Sicilian manna dates from the 9th century, where it is listed among items collected by the Venetians in Sicily Marin. Masticina. The best M, comparable to mastic grains, M. Calabrina, the very worst and least desirable mem. The Florentine Ricettario of 1567 I, p. 794 mentions Manna di Soria, along with that from Cosenza di Caloria. Thus, Escian manna was first obtained in Calabria Hanbury. Sicilian manna is not mentioned by Pegolotti c. 1340, Antonio Dausano c. 1442, or others. Even Saladin Compendium Aromatariorum, 1488, and Pontano only mention Calabrian ash manna, and in their works, like Mattioli's comment, Venet, 1565, lib. It seems to refer only to that which naturally drops from leaves, branches, and the trunk. The same is found di fronde and di corpo, in a Roman tax list from 1558. In Saladin's Compendium Aromatariorum, The month of May is referred to as the collection month for manna. Gather also in this month manna, both in the east and in Calabria, for then that precious dew from heaven falls. A contemporary of Saladin, Giovanni Gioviano Pontano, glorified the collection of manna by the Calabrian farmers in the poem De Prina, Errore e Manna. The practice of wounding tree bark with cuts to produce so-called manna forzata emerged in the mid-16th century. In 1691, the amount collected at Campana and Bocciglioro in Calabria reached 30,000 pounds Hanbury. During the 18th century, all the yield had to be surrendered to the Crown Flückiger. Hanbury concludes, Manna was first collected in the first half of the 15th century, specifically in Calabria Manna Nostra, Aitet Cuepit in Calabria, Provenire, stated Raffaele Maffei, Volaterrenes in 1470. The use of carving to increase yields was not known there until after the middle of the 16th century. In Sicily, manna was produced much later. It is first mentioned as manna forzata around 1697 by Boccone, who lists Giacchia, Gerassi, Castelbuono, Esmaro, Mistretta, Carini, and Capacci as production sites. Annibale Brigante demonstrated that the spontaneously exuding manna is identical to that produced by cutting. Pommet mentions manna from Calabria Gallipoli on Mount St. Ange and Sicily in 1694, describing its extraction with a cane hist. General Z. D. Drog, p. 236. Geoffroy also writes about Sicilian manna, forzata like icicles, through cuts with a three-bladed knife or in the form of M. forsatella, or di foglio, naturally exuding from the leaves of wild trees. By the end of the 17th century, this type of manna was already dominant. Pommet still mentions man de la tolfe mistakenly man de Briançon, manna liquide, terreniabin, see below. Boccone mentioned in 1697 from Calabria, manna di corpo, the best, naturally exuding from small wounds, M. In the 18th century, a lot of manna was collected in Calabria Sitra, south of Taranto Gulf, especially in the territory of Rossano, then at Corgliano. Cariati and Cosenza. Boccone also mentions Luciro, Tarsia, Taverna, Castrovillari, Viesti, between Bari and Monte S. Angelo. The manna industry in Calabria, which was still thriving at the beginning of the 19th century as Hanbury confirmed on site in 1872, was already nearly extinct then. Only very small amounts were collected from the Ornelli for personal use in the Rossano area, and the government had even banned the making of cuts. Boccone mentions the following producers of manna in 1697, San Felicita, Tolfa, Castro, Palombara, Vicovaro, Monteflavio, Cori, Albano, Montesel, Montorio. Even the production of manna in the Marem of Tuscany has ceased. Similarly, the thriving collection of manna in the Papal States San Lorenzo and Civitavecchia, Tolfa manna, during the 16th and 17th centuries. In the 18th century, three types of manna were distinguished, Calabrian, Tolfa, and Puglia. Boccone describes the collection of Tolfa manna, which is consistent with Calabrian manna forzata, through two daily incisions on the eastern side of the trunk. It was already claimed by Angelus Palea and Bartholomeus Aberbeder, two Franciscans who wrote a commentary on Massieu in 1543, and Donatus Antonius ab Altomari, a Neapolitan physician and philosopher, that manna is not falling from heaven, but is the concrete sucus of the oak. 1558 through an experiment, by covering the trees with cloths, and yet found manna to be correct. The observations of Altomari confirmed Goropius, Lobelius, Pena, Costeus, et al. Nevertheless, a century later in the Antidotario Romano, manna was still referred to as dew falling from heaven. The first to clearly mention the purgative effect of manna is Actuarius 13th century, p. 792, but the reference does not pertain to ash manna, nor do the similar remarks by Arabs. The purgative effects of ash manna were first extensively treated by Rolfink, 1667, De Purgant, Vegetable, De Spagiarists, 869. Geoffroy, in his Materia Medica, provides a thorough discussion of manna and shares a pyrochemical analysis of it. Among the chemists of the 16th century, the term manna referred to a particular form of Pedamontanus calls p. 879 benzoyl acid manner of manna, lit. Ebers, through Gossan to Sinai. Note on Italian manna started to be collected in this century. St. F. Jeffroy, Materia Medica Ars, p. 4098 there. The Observations of Altamari, 2, Australian manna. Late seeing 1871. Brugge, Hieroglyphic Dictionary, Lauret Rec of Travel, related to philology and Egyptian archaeology, p. 158. Hanbury Farm, Journ, 1869. Arch, Farm, 1869. 80. Flukiger, Pharmacognosy, 80. Flukiger, Pharmacognosy, 80. Silvivi Balconis, Curious Notes on Various Natural Things, 1697. This manna outerman called is found on a polygalaceae, Myoporum platycarpum Robert Brown, known as the sandalwood tree of Australia, and flowing down at the foot of the trees on the ground. It is collected near Fowler Bay in South Australia. Fresh it is white, but in trade it is reddish-brown. In this manna, Berthelot found mannite in 1856, and Chim, 5th. The pieces are hand-sized and form up to 1 foot long, straight cylinders. Under the microscope, numerous mannite crystals can be seen. This Australian manna contains 89.65 mannite, 2.87 reducing sugars, 0.51 invertible sugars raw sugar, and 237 mucilage maiden. Lit. Bennett, Wanderings in New South Wales, London 1834. Maiden, Farm, Journ, 1893, 608 Flukiger, Apoth, Zeit, 1893. 39, Flukiger, Arch, Farm, 1894, 394, 311. 3, Platanus manna, a mannite with 90. 117, 1892, 498. 4, Manna from the Cape Verde Islands. 1901, 209. It is believed to be produced due to a bacterial infection. Mannite-free mannas are described under disaccharides and trisaccharides. Drugs containing dulcet is stereoisomeric to mannite as indicated by the comparison of their formulas. OHO dulcet, HHOO mannite, CHO, CC CHO. The indigenous people of Bebans call a substance exuded from the trunks of diseased olive trees olive and honig olive honey, which contains 52 mannite, 7.8 reducing sugar, and 930 substances precipitable by alcohol, according to Trabant and Battendeer, Journ, Farm, 1901-13-1077, Zeitcher, Nachrumsum, Unters, 1901, 1991, and Apoth. Zeit, O. It is also related to D-galactose, CP6, whose reduction product it is. Dulcet forms crystalline, asparagus-like structures, optically inactive, non-fermentable, and non-reducing. Gilmer, Borodin and Scrofulariaceae Eifler, Monteverde, v. Gilmer, Borodin. The presence or absence of mannite and dulcet can be used as a genus and group characteristic for Scrofulariaceae Monteverde. This manna of unknown origin, forming crystalline light bulbs, consists almost entirely of pure dulcet. Dulcet is found in a manna from Madagascar, in the vegetation of Melampyrum nemorosum, Hunefeld, Eifler, Erlenmeyer, and in the cambial sap of Evonymus europaeus, stinging nettle, also in the honeydew of Evonymus japonicus marken, in Celestris and Schafferia, as well as in Celestraceae Kubel, v. Chapek, Biochimo Firth, 212. Drugs containing disaccharides of hexaces. The disaccharides or hexobiosa are to be regarded as ether-like anhydrides of hexaces, formed by the condensation of two molecules of a monosaccharide, namely a hexose, under exclusion of water. To obtain dulcet, it is sufficient to recrystallize it from alcohol or hot water. Gilmer showed that the melamparite of Hunefeld and Eifler, as well as the evanomite of Cobel, are identical to dulcet. Lit. Laurent Comte Rend Comte. 4041, 339 and 31, 694. Liebigzan. 76, 358, 80, 345. Jacqueline, Ibid, Jomer, Liebigzan, 123, 323, 375. Herein belongs the saccharose raw sugar, cane sugar, which is an ether of D-glucose and D-fructose, the lactose milk sugar, which is an ether of D-galactose and D-glucose, be considered as an ether of D-glucose and D-glucose. The group of disaccharides also includes trehalose or mycose-cho, 2-ho, which is built similarly to raw sugar and occurs in trehallosa, mold, and other fungi Tambuchi, Agaricus muscarius. The following formulas show the relationships between the three most important disaccharides of hexaces. They are split into their components by acids or enzymes. Invertase splits raw sugar into glucose and fructose. Lactase splits milk sugar into glucose and galactose. Lavoisier already performed an elemental analysis on a disaccharid, raw sugar. 1. Sugar group. Saccharose seems to be absent in animals, but is much more widespread in plants than previously thought. This has been pointed out by recent studies. Schulze, Anderson, Harley, and Borcolo, the latter of whom obtained good and clear results using his invertase method, which does not require pure sugar for analysis. CHO, CHHLOOC, HTLOHTA, OOHC, HTAOO, HC, HCAOHTAOHO, CHOOAGU, D-fructose, residue, D-glucose, sugar, saccharose lactose, lactose anhydrous sugar, aldehydic sugar CHO, HHAOHTOH, OOHHCAO, CHAAOHTAO, CHO D-glucose, residue D-glucose, residue maltose. It is known to occur in sugar cane, beetroot, sugar maple, sweet corn, many palm juices, digger roots, coffee beans, barley, oats, walnuts, hazelnuts, almonds, johnny cake, nectarines of many flowers, see Beilstein. Handbook. We found a great deal of raw sugar in Arad. Rhymonocorum, Harley 1905, also found it in umbellifera roots. Bignett 1861 attributed its presence to many fruits. However, all older reports should be taken with caution. From a physiological standpoint, raw sugar, where it occurs in such large quantities that its extraction is profitable, can be regarded as a reserve substance. In the stems of palms and sugar cane, where it is present throughout the ground tissue, it replaces starch and is primarily intended for nourishing the budding flower spike, or was originally formed for this purpose. In beetroot, it also replaces other reserve substances that otherwise occur in underground storage containers. Through culture and selection, the amount of sugar can also be increased here, and culture has already achieved a significant increase. For example, in beet sugar, from 3 to 26. Raw sugar is found particularly in plant parts that do not contain chlorophyll jodin. On the distribution of saccharose in the plant kingdom, see Japek, Biochemie and Lippmann, Chemie der Zuckerarten. The identity of palm sugar, sorghum sugar, maple sugar, and sugar from Johannisbread with raw sugar was already established by Berthelot Jadisber, D. Shem, 1858, 486. Literature cited there. That raw sugar is an excellent food. The ancient Indian, Persian, and Arab physicians Lippmann knew, and that it must be so follows from its high calorific value. The same is according to Rubner Cal, per 1G, 40,001, Cal, per, due to its exceptional ability to replace blood sugar and glycogen during intense muscle exertion. It is superior to fats in terms of protein conservation. According to the monk Albertus Akensis, crusaders chewed sugarcane in times of food scarcity. For information on fermented beverages made from sugar, see I, p. 1016. Only sugars with 3, 6, or 9 carbon atoms are fermentable. For details on sugar fermentation without enzyme, Praxis 1908, 266 shade. Camille Hofmeister describes the following microhistochemical method for detecting raw sugar and glucose. Slices from the tissue to be examined, approximately 3/4 cell layers thick, are directly placed in dishes with concentrated boiling hot copper. Sulfate sodium hydroxide solution, allowing the oxidizing agent to act as quickly and in large excess. After 1-2 minutes, the glucose is quantitatively oxidized. The slices are removed, quickly washed by swinging them in a porcelain bowl with a strongly diluted wine acid solution, and then placed on an object carrier in a drop of concentrated magnesium chloride. The magnesium chloride, especially after short heating, smoothly dissolves the copper oxide precipitation in 1-2 minutes. The magnesium chloride is now washed away with wine acid containing water, and the slice is placed in a drop of concentrated invert sugar solution on the object carrier. If the drop is nearly dried, it is rehydrated. The sufficient time for the inversion of raw sugar was always reached as soon as drying had occurred 2-3 times. Now, the slice is covered with a drop of copper sulfate sodium carbonate solution. The cover slip is placed over it, and it is gently heated until just below boiling point. If raw sugar is present, red-yellow copper oxide separates. In microchemical sugar detection using the Sachs method CP7 above, cells containing raw sugar are dyed light blue. The regular shape of raw sugar crystals was first mentioned by Cézalpini Olivier de Serres, knew about beet sugar around 1600, described its crystal shape, a widespread but entirely unfounded misconception in French works. Lippmann. Triboluminescence was already known to Bacon of Verulam as something well known. The rotational property was recognized by Seebeck 1816, and Biot founded optical saccharimetry on this basis 1819. The inversion of raw sugar was discovered by Dubrunfaut in 1847. Alkaline copper oxalate solution for detecting invert sugar and grape sugar was recommended in 1841 by Trummer, who worked in Mitscherlich's laboratory, and in 1848, Feeling published the recipe for his alkaline copper tartrate solution and described the recipe for his alkaline copper tartrate solution and described the method for quantitative sugar determination. Leite, von Lippmann Chem, der Zuckerarten, c. Hofmeister, über die Mikrochem, Nachweis von Rohrzucker in pflanzlichen Gewebe. Jarb F. Wyss, Bot 31, 1898. A. Schulze, Nachweis die Rohrzuckers in Pflanzensamen. Zeitcher, F. Pfizertem, 52, 1907, 419-7, 404. 61, p. 233. E. Schulz und Frankfurt, über die Verbreit der Rohrs in den Pflanzen. Zeitcher Feast Chem, 20, 1895 and 27, 1899. Anwar Gier, Omer Socrates Forekomst och Quantität, Droger, Farm, Noticeable, Helsing. From the Ardennes, 1901, where the plants containing raw sugar lists are located, and Journe, Farm, 1903. Harley, the saccharose in underground plant organs. Thesis Paris, 1905, where the literature is also mentioned, and Journe, Farm, Chem, 1905. Lefebvre, Application of Biochemical Processes to the Research and Dosage of Sugars and Glucosides in Plants, etc. 1905, 1815. Cultivation of Raw Sugar Plants. Bruno Line, Hydrolysis of B3 and Polysaccharides. Dissertation, Basel 1905. Fonses Diacon Polysaccharides. Colonial Museum, Haarlem. Raw sugar drogen, I-drogen consisting of raw sugar, saccharum. Dioscurides was likely Bambumana, C. Tabashir, Periplus, Saccharum Plinius, the staple plant and systematic position. Saccharum officinarum, L.D. Synonyms, sugar, raw sugar, saccharose, saccharobiose, sucre French, sugar English, zucchero Italian, açúcar Spanish, sucre Dutch, soccer Swedish, sockery Finnish, sugar eng, sakkar Rus. The designations for sugar all derived from the Indian word sarkara Sanskrit, sand or sakara Prakrit. Linné, Spec, PLI, 54, Kasab el-Sukr by Ibn Baythar. According to some it is a cultivated form of Espontaneum, which is now a very noxious weed in South Asia, e.g., on Java alang-alang. Gramine, Andropogone, Eusaccharum. Description: the home of the sugar cane, a plant of the humid warm tropical climate, is India. The wild progenitor is no longer known with certainty. It was initially introduced to the rest of South Asia, then to the Middle East and Europe, see below, and is now cultivated in most warm countries, see below, including Central Africa, Congo, and Nyanza, Equatoria. Cold and dryness are the greatest enemies of sugar cane. In appearance, sugar cane resembles corn but grows much taller, up to 6 meters and over 5 centimeters thick. It is almost exclusively propagated by cuttings and rarely blooms in cultivation table 4, and almost never forms fruit. The juice of ripe sugar cane contains on average 12-15, sometimes 15-17, and occasionally 18-20 raw sugar, along with only 0.6 uncrystallizable sugar. Pathology. Professor Ed. Fisher reports on plant pests. Sugarcane is affected by numerous diseases. See Lindau's treatment in Sarauer's Handbook of Plant Diseases, 3rd edition. Waker and Wendt. The Diseases of Sugarcane on Java Refers, 1898. Cobb Fungal Diseases of Sugarcane, Honolulu, 1906. An overview of the sugarcane diseases observed in Java was provided by Zentner Oversicht der Krankheiten des Metadil, Proefstaat, Java. Refer to the catalog of the Colonial Museum as well. Haarlem 1900, also refer to I.P. 376. We will only highlight the most important diseases. In recent times, several bacterial diseases have been identified, one of which is the top rot spitzenfoil. Leaf spot diseases are caused by Leptosphaeria saccari Breda de Haan, Cholerae saccari sac, Breda de Haan, and several Cercospora species. A dangerous stem disease, red rot, red smut, which also reduces the sugar content while glucose levels increase, is caused by Coletotrichum falcatum Wendt. The pineapple disease also occurs on the stems, caused by Theloviopsis aephyseticus, which is not a mandatory parasite but requires wounds to penetrate. Also, the burn fungus Usulagos saccari raben appears on sugarcane stems. Finally, hymenomycetes and gastromycetes are considered, whose mycel causes diseases in seedlings or root diseases. Marasmius saccari waker, a hymenomycete that is the cause of the so-called Donkellenkrankheit, and the two phalloids phallus, Salebicus and pH coralloids. The most dangerous disease is called Serae, about which there is an entire literature. Waker doubts its parasitic nature. Extraction. Fresh sugarcane contains 1218 raw sugar and up to 0.7 reducing sugars Vandesmet. The sugar is not evenly distributed. Under various organic non-sugar substances, aconitic acid has been found in sugarcane. A. Bear. Illustration. Fig. 40. Harvesting of sugarcane. The extraction of raw sugar from sugarcane is carried out as follows. As soon as the stem reaches a certain height, it is cut slightly above the ground. Fig. 40. This happened earlier in the production countries in a very primitive way, and colonial sugar had to be refined in Europe. For example, at the top, only 1.91 fort is contained. The content increases in the upper part of the stem to 7.79, in the middle to 14, and in the lower part to 14.7. Conversely, the glucose content decreases in these same sections from 236.7 to 0.945, 0.175. However, these ratios are highly variable. Then the leaves are removed figs, 72 and 73, and the knotted, thick stems are transported on barges fig, 219, carts figs, 74 and 215, or field rails, to the mill fig, 144, after which the raw juice is clarified, concentrated, and crystallized. Unrefined sugar, or 17.5 shakar jaggery, i.e. dry unrefined sugar, or 19.5 REE syrup, refining. Now, using the experience gained in the beet sugar industry, see above, numerous modernly equipped raw sugar factories have been established in the production countries, which now also produce pure raw sugar, and even consumer sugar in the tropics. For example, the Javanese sugar factories are equipped with all conceivable modern mechanical facilities. Table V. Illustration. Table V. Sugar factory in Java sugar, from sugarcane, from great crops. The average yield of 100 cane stalks is 18 gouda, i.e. the art of refining sugar from raw cane sugar, which was brought to Europe under the names Muscovade, Muscuat, and Cassonade, and the process of raffination, raffinatio, were already widely practiced in European countries during the 16th and 17th centuries, e.g., see Angelus Sala, Saccharologia, 1650, the Frankfurt Catalogus of 1582, I.P. However, the first detailed description was provided by Duhamel du Monceau in his work L'art de raffiner, le sucre, the art of refining sugar, published in 1764 with 10 plates CI, p. 975, Amsterdam, followed by Hamburg and Berlin, became the main centers for Nordic sugar refining in the 18th century. C. Lippmann. The first sugar refinery in Amsterdam emerged around 1600. The first German sugar refinery was established in Augsburg in 1573 by Roth, followed by a second one in Dresden in 1597, then Hamburg, Orleans, and Rouen. The 30 Years' War also devastated this industry in Germany. Trade varieties see also beet sugar, 817 Saccharum canarians, Candum, not from Candia, the word comes from Persian Quande sugar, see Crystallinum, Maderense. Arab and Persian Panid writers of the Middle Ages, then in all German taxations, perhaps so-called Gerstenzucker, Tabarzith Persian, Tabarzat Aktut, also for rock salt. In many taxations from the 16th to 18th centuries, Thomasinum from 17th to 18th centuries. Thomas in the Gulf of Guinea, where sugar cane has been cultivated since 1485, see Rubrum and Miscellaneum. In the Braunschweiger list of 1521 bar 5, P814 appears. Outsucker, Melzucker, Zuckerpanid, and Zuckerkand also see under History. Properties. Raw sugar formula compared to P. 114 crystallizes in large monoclinic crystals. Sugar canned consists of such. It exhibits treboluminescence, conducts streaming electricity very poorly, heat very badly. It melts at 160 and solidifies amorph raw sugar, but the mass gradually becomes crystalline and cloudy aging. Upon stronger heating it caramelizes. Its specific gravity is 1.58 at 1750. In absolute alcohol, raw sugar dissolves poorly 180, more easily in diluted solutions. It dissolves easily in invert sugar solutions, and in of its weight in water. Concentrated sulfuric acid chart at difference from D-glucose. Its specific rotation is D66.5, or generally for any concentration, D6638.6. It reduces feeling solution only after, for example, inversion that occurs during cooking. The usual beer and wine yeasts ferment raw sugar only after inversion by yeast enzymes invertase, etc. Regarding rum, see IP 1019. The farm. Helvetica IV includes sugarcane alongside beet sugar in its production. Produce sugar from raw sugar now. The United States, Louisiana, Puerto Rico, Hawaii, Cuba, British West Indies, Trinidad, Jamaica, Antigua, and St. Kitts, Barbados, French West Indies, Martinique, Guadeloupe, Danish West Indies, Croix, Haiti, and Santo Domingo, the Small Antilles, Mexico, Central America, Guatemala, El Salvador, Nicaragua, Costa Rica, British Guiana Demerara, Dutch Guiana, Suriname, Peru, Argentina, Brazil, British India, Siam, Java, the Philippines, Australia, Queensland, New South Wales, Fiji Islands, Mauritius, Reunion, Egypt, Spain. Mauritius was formerly known as the Sugar Island. In Java, the production of raw sugar plays a significant role. The yield in 1907 for Java per acre was cane 38 tons 15 CWT, sugar 4 tons 3.2 tunny yield. Total cane yield 1,210,200 tons. In 1908, 115,458 hectares were under sugarcane cultivation. Cuba's production is significant, producing 961,1958 tons in 190,708 and 1,513,582 tons of raw sugar in 190,809. In 1908, 26,982 metric tons of raw sugar were imported into Hamburg, including 19,516 tons from East Africa. Java exported in 1908. Main sugar 10,759,355,160 kg. Saccharin sugar 8,095,028,200 kg. Molasses sugar 9,027,800. 820,820,820. Brazil exported sugar 8,494.8346 kg in 1906 and 12,857,857,899 kg in 1907. Over 100,000 tons are produced by the Antilles and Central America, Brazil, Queensland, Mauritius, Peru, the Philippines, Argentina, Demerara, with the rest going to Fiji Islands, Egypt, Reunion, New South Wales, and Spain. See also under sugar beet. Distribution across the earth. Sugarcane is native to India and has spread across the globe from there. France imported 119,561,084 Cato in powder form from its colonies of Reunion, Martinique, Guadeloupe, and Mayotte in 1908, as well as 669,357 kg from English Africa. Global raw sugar production reached 5,161,1900 tons in 190,708, with Java accounting for 1,156,400 tons, a region known for sugar production since the 17th century. The United States, Louisiana, Texas, producing 950,000 tons, increasing to 1,350,000 tons in 190,809, and Hawaii yielding 450,000 tons. As early as 327 AD, sugarcane was found beyond the Ganges Narcos, in 250 AD in China, around the time of Christ's birth in Java, by 400 AD in Tibet and Kashmir, around 600 in Ceylon, around 700 in Cambodia and Socotra. It also spread early to Southwest Asia. As early as 643 it was found in Egypt, 680 in Syria, around 700 on Cyprus, and around 818 in Crete. The sugarcane culture reached Spain in 14. The Arab calendar of Harib from the year 961 bars estimates the planting of sugarcane. It went to Sicily in 827, not just in the 12th century as IS 33 states, and to Provence in 750. In the 12th century, the sugarcane industry flourished in Sicily, but already in the 11th century, Sicilian sugar was found on the market in Venice. The raw sugarcane culture survived in Egypt and Spain, Elche, otherwise it faded away in the west. In Morocco we find them 709, in Tripoli around 900, in Madeira 1420, on the Canary Islands and St. Thomas around 1480. Lipman Istakri, Burst, P16, reports T920 about sugarcane cultures in Tripoli, Khuzestan, Mazarkan, Asker Makram, where sugarcane cultures in Tripoli. Factories also existed. During the Crusades, Syria was Europe's largest sugar supplier. In 1448, the sugarcane culture claimed the best and most extensive coastal strips of Sicily. Lipman. Already at the end of the 13th century, Cyprus supplied a lot of sugar to the European market, and in the 14th, 15th, and 16th centuries, sugarcane came to America through Columbus wine, pp. 745 at 1493. When it was brought to Hispaniola on his second voyage, it rapidly acclimatized. Oviedo Worm p. 75t, followed in 1514. It reached Mexico around 1520, Brazil in 1532, Peru in 1533, Paraguay in 1580, Argentina in 1620, Guadeloupe and Martinique in 1630, Barbados in 1641, Louisiana in 630. By 1869, Lower California had extensive sugarcane fields. Ross Brown. The good development of the sugarcane culture in America is particularly due to the introduction of slavery. Sugar production began in Mexico soon after the conquest. As early as 1553, we hear of sugar exports from Mexico. Illustration, Fig. 41. Sugarcane processing in Sicily, around 1570. After the collection of images Nova Ruperta, by Joanne Stradamus. History. The sugarcane was used long before learning to make sugar from it, probably chewed mostly. The first representation of solid sugar took place in India, but not before the 3rd or even 7th century by Lipman. Therefore, it is possible that the saccharum varieties mentioned in Susruta Oy, S505 were sugar. Paulus of Aegina and Avicenna, thus named sugar sal indus. The Arabs also called it tabarzif. In Alfida, with Bartholomew, and in Circa Instans, IS 6061, it is written, Zukara Zakara, Zukarum Zakarum. The Persians and Arabs then took up sugar production and brought cane and sugar preparation to the West. During the wedding celebrations of the Caliph Mescadi ben Ritale, 807 AD in Baghdad, enormous amounts of sugar were consumed. The sugar cone is considered a Persian invention, as is the art of refining. Initially, sugar was used in Europe as a medicine. Then it became a long luxury item. Even at the end of the 17th century, sugar was very expensive in Germany. In the pharmacies of the Middle Ages, one finds Saccharomyces, not from Malta, but perhaps due to its yellowish color, like molasses, Lippmann, S. Matarense and Canariense, as well as S. Thomasinum from St. Thomas's Island, CP 120. The large crystalline sugar was already known at the time as S. Candum candies. Pegolotti de Firth, P702 lists, hot sugar, Moquera, Cafetino, Bambionia, Musciato, Don Maschino. 2. Candied sugar. 3. Crystal sugar polvere di zucchero, farine from Cyprus, Rhodes, Syria, Cranco di Monreale, and Alexandria. The hats were wrapped in palm leaves, 2 at a time, and then wrapped in linen una copia di zucchero. In the Droits et Picortage established in Paris in the 15th century ED. By Dorveau sugar is mentioned in bales and loose form, as well as croissants in pieces, Cyprus and Alexandria powders, in the Nördlingen Register of 1480. I, P813, one finds flour of sugar, sugar candy, sugar tabaret, and sugar penidarium. The Braunschweig Register of 1521 I, P814 lists hout sugar, melt sugar, sugar peanut, and sugar can. Penidium sugar was likely barley sugar, obtained by melting with wine yeast leading to a partial inversion, resulting in an amorphous state flüssiger. Tabarzd, as mentioned above, P. 121 was pure crystalline granulated sugar, as Cordis describes it as sac. Tabarzeth album, on P802, similar to salt indum see above, a name still found in the Braunschweig City Council Pharmacy, inventories of 1604 Flückiger. The production of raw cane sugar is already mentioned by Piso Warren, P. 893, in 1658, and by Pommet I, P. 942, 1694, A.B. Then there is also an even older illustration in the collection of images from J. Stradanus's Nova Ruperta C, 1570, printed before Lippmann's History of Sugar. See Fig. 41, Lippmann Geschichte des Zuckers und Chemie der Zuckerarten. Ill. Bentley Tryman, Medicinal Plants, T298, Pabst Kohler, Metzanopfel, T169, Nies von Essenbeck, PL Med, T3335, Tussock, Flordy, Antilles T25 and Engler Prantl 23, Share, das Zuckerrohr, seine Heimat, Kultur und Geschichte. Also an illustration of sugar cane there too. One such in the images of the Colonial Museum Haarlem. Pache, Zuckerindustrie und Zuckerhandel, D. Welt 1891. W. Kruger, Das Zuckerrohr und seine Kultur, Wien 1899. Timon, Zuckerrohr, Kultur, Fabrication Usability, 1899. Van Gorkum, Eastern Indian Cultures, Semler, Tropical Agriculture. Yearbook for Sugar Manufacturers on Java. Maps in Langdans, Smaller Trade Atlas 1895, and Scobel, Trade Atlas 1902. Deet sugar, main crop plant, Beta vulgaris L. var, Rapat du Mort, B. vol, var, Rapat du Mort, B. vol, Altissima and other varieties and cultivars. Second ed. 1903 describes the culture there. Literature on Javanese sugar production in Catalogus der Buckfordsammlung. Colonial Museum Haarlem. Further, Proof Station, Midden Java, Report, Proof Station, Midden Java, Report, Proofstat, West Java Kagok, Pekalondon, Report, Proofs, East Java, Report, Archive for the Java Sugar Industry, Archive. Particularly popular are Imperial, Electoral, Mangold, White Silesian, Quedlinburger beets, as well as the so-called Klein-Wanzelbeiner beet, Schindlerbot, Zentrobile. 46 traces, all cultural varieties from the still wild Beta vulgaris L. that occurs along the coasts of Europe today are Maritima Cook, Abe, Beta vulgaris L. Swiss chard, sorrel, turnip, chard, manichel, rabbit root, red beet, Roman kale, lunger beets or runkel beets, food, Zwieback, names that are sometimes used for both Beta vulgaris var, Hekla and BV, substrapa. In the Middle Ages, Ahad, names such as Basekol, Bieza, Bioza, Stur, Sturbede, Manigold appear. In Ortus sanitatis Roman kale, in Brunswick, Mangold, in Jesner, Bavarian turnip. Etymology. Likely the Teutonic of Theophrast is now generally divided into two varieties, Sikla el Garden chard and Rapadum. The latter is further subdivided into two subspecies, B. bulb, subspupacia, rubra, red beet, and BV. Rapacia altissima sugar beet. Systematic position, Canopodiactae, Cyclolobae, Bitae. Synonyms. Beta already used by Plinius, perhaps from Celtic. Bet rot due to the color of the red beet, or more likely from meta, indicating any spindle-shaped figure, in this case the beet cabbage eater. Beety is still the term for beet in northern Germany. In the Gothair Arzneibuch refers, p679, Bether T6s, and Betywort. Betas are mentioned in the Capitulary Charles I, p620, and the St. Galler Klosterplan 1, p622. Runkelrübe thick beet. Runkel from Old Norse fruga, to compact, due to the thick roots. Illustration in Vulcans in Ingler Prantel, Plant Fam. Thrané 57. The root is a more or less hypertrophic beet, often reaching a very considerable weight, and mainly consisting of starch-containing storage parenchyma. See above. Cultivation. Beta vulgaris is a herbaceous plant with a large basal leaf rosette and a usually unsuccessful or suppressed spike-like inflorescence. The unremarkable five-petaled flowers have a nearly triangular ovary. The stamens are united at the base into a fleshy, ring-shaped pad discus. The embryo of the sperm is ring-shaped curved. The sugar beet, swede, or mangold is native to the Mediterranean, Caspian Sea, Canary Islands, Mesopotamia, and East India, and has been cultivated since the 4th to 6th centuries BC. Lippmann. Pansau Kangmubar, p519, knows Beta vulgaris. Plinius describes its cultivation, as do the Roman agronomists. p571. Dioscurides recommends it as a medicinal plant, as do Arab physicians in Rhazes. It is listed in Karl's Capitulara 1, p619, and by Megenberg refers, p693, as Kaisenkraut. The beet culture came to Germany from the Netherlands soon after 1700. The present sugar beet, according to Russig, is a Burgundy beet from the Burgundian Netherlands, first reached the Palatinate and spread from here throughout Germany, particularly Franconia, Saxony, and Silesia. The problem of cultivating beets rich in sugar was solved by Accard through his cultivation experiments begun in 1786. The first upsurge in the beet sugar industry dates back to the Continental Blockade. After France, the sugar beet was introduced, among others, by the older Vilmorin. It is now cultivated in Germany, Austria, France, Russia, Belgium, and North America. The sugar beet is also a coffee substitute. See Sicorium, Pathology. On plant pests, Fischer reports, the sugar beet is plagued by several bacterial diseases. One notable one is the so-called Reuben-Schwanzfäule. It consists in the death of the beet, beginning at the tail end, with inversion of the cane sugar. Peronospora schachtii is regarded as the cause of so-called waving disease of beet heart leaves, which can sometimes cause significant damage. In what is known as root or heart rot of beets, Trabut observed a disease of beet roots characterized by the development of fleshy, grape-like protrusions, in which a fungus occurs which Trabut considered Ustiliginae, but which Magnus determined to be the chytrid genus Uroflictus, specifically UU, leprode. June, Carmoral Munben. Frank on the form of Mycus phorella tabifica, a pycnidiopyronomacy, following Prillo and Delacroix. However, the causal relationship of this fungus to the disease is not entirely clarified. In sugar beets, or their juice, especially through V, the same fungus in association with Pythium debarianum and Aphanomyces levis is also believed to be involved in the most dangerous sugar beet disease, root rot. The mycelium of Sclerotinia libertiana and a mycelium of unknown affiliation, Rhizoctonia, infect the beetroots, with the former specifically targeting chitted beets. The so-called scab disease of beets is also not fully understood as to its cause. Reports on diseases of sugar beets are continuously published in the annual report on research in progress in the entire field of sugar manufacturing, edited by Joe Bach, Braunschweig, Vuegg. Extraction. The thin juice thus obtained, which contains 10-12 sugar, is concentrated in vacuum appliances and then brought into crystallization in various ways. The juice coming from the diffusers, containing about 12-15 raw sugar, is treated with calcium hydroxide and heat, nearly saturated with carbon dioxide, heated to boiling, passed through a filter press. Sulfuric acid, and finally passed through the filter press again. The task of beet sugar production is to separate raw sugar from non-sugar and bring it to recrystallization. This now usually happens in the following way. Individually, deviations are observed. That well-washed beets are cut into slices and subjected to diffusion in diffusers combined into batteries. Lippmann very numerous substances detected. Besides raw sugar, which makes up approximately 1518, little raffinose and invert sugars, then citric acid, oxalic acid, allylic acid, allyl acid, aconitic acid, adipic acid, benzoyl acid, glutaric acid, benzoyl acid, glutaric acid, glycolic acid, glyoxylic acid, malonic acid, oxycitric acid, tricarbolylic acid, further glutamine, asparagine, leucine, tyrosine, then lecithin, choline, betaine, citric acid, and a beet sugar acid, arabinic acid, metapectic acid, meta-arabin, para-arabin, galactin, finally xanthine, guanine, hypoxanthine, adenine, carnine, arginine, allantoin, vernin, and vicine, by the enzymes tyrosinase and a DA, allantoin, vernin. By centrifuging the cooled mass, one obtains raw sugar. What is thrown out of this is the syrup, which supplies one or two byproducts upon further boiling, and the last, no longer crystallizable mother liquor is the molasses. The production of the well-known sugar cones, sugar sticks, is done by filling the conical forms, pointed downwards, with the crystal mash, allowing the mother liquor to drain off and then pouring a saturated pure sugar solution covering on top. She is now often still chemically decolorized with strontium or fermented into alcohol, and the molasses syrup into potassium carbonate. Raw sugar is usually refined in its own refineries, consumer sugar, and then marketed as highly pure white crystal sugar, and raffinate most often in characteristic cones or cubes. In Germany, 361 beet sugar factories were in operation in 1909. Most sugar is produced in Prussia. This displaces the mother liquor and is finally drained off, after which the cones are dried in drying cabinets. Production. The European beet sugar production for 190,708 was 6,527,800 t, of which 2,135,000 t fell to Germany, approximately 1,400,000 t each to Austria-Hungary and Russia, the rest to France. There is currently 1910 a resurgence in the production of raw sugar, such as beet sugar, similar to that in 190,708 when more beet sugar was produced. Both compete constantly. The area cultivated with beets in 190,809 was alone in Germany, 432,400 h, in Russia, which now competes with Germany, even 561,300 ha, and throughout Europe 1,680,500 h. Germany exported 3,303,364 double centner of beet sugar in 1909. Crystal sugar, 3,303,364. Plate, rod and cube sugar, 400 foot-by. Flour, 69,335. Candy, 30,827. Raw sugar, both solid and liquid, 4,037,927 data. The production of beet sugar is a complex problem that is closely connected to rational beet cultivation, achieving high percentage beets, soil prices and labor wages, tax regulations, as well as the mechanical equipment in factories, chemical control of operations, and the utilization of waste and byproducts. A good picture of global sugar production is given by the trade flows in North America. It deals with taxable sugar, trade varieties. The trade distinguishes raffinate subcategories, cube sugar, pilé, cubes, granulated sand sugar, castor sugar, crystal sugar, mealie, Thorenzucker, bastard sugar. A saccharum usable for medical purposes must be white. 1 cc of the solution, 23 with 1 cc cobalt nitrate, and 2 cc sodium hydroxide must take on a stable purple coloration. See also under production. For pharmaceutical preparations, only the finest raffinate or crystal sugar may be used. Helva-Force, for example. Absence of metals in grape sugar allows only traces of lime and sulfates, and specifies that 0.5 g shall be burned without a weighable residue. Test. Adding 2 parts sugar with 1 part water produces a colorless, odorless, neutral syrup of 133 specific weight that should not settle out when standing, and must mix clearly with alcohol. 10 cc of the syrup may, after adding 1 cc sodium hydroxide and 1 cc copper sulfate within 5 minutes at ordinary temperature, show only a greenish turbidity, but no precipitation of red copper oxide grape sugar. The diluted solution must be indifferent to sulfur hydrogen and ammonium oxalate, and give at most opalescent turbidity from baryt nitrate and silver nitrate. Medicinal sugar must be ultramarine-free. The blue ultramarine is added to mask the yellow color of impure sugar. Indeed, our eye is very sensitive to yellow, and can easily detect even a slight yellow tint, while it is less sensitive to blue. Marggraf is the scientific founder, and Descartes the technical founder of the beet sugar industry for P. 964. The first beet sugar produced on a larger scale by Descartes was refined in 1798 by the Berlin Sugar Refining Company into candy, flour, and syrup v. Lippmann, Nildischen, Hermstedt, and Gutling. The first true beet sugar factory was established by Descartes in 1802. Let v. Lippmann, History of Sugar contains further literature. Large crops, Rosig, a botanical description of the rutabaga or beetroot, Leipzig, 1800. Documents, Scheibler, Documents on Beet Sugar Production in Germany, Berlin, 1875. Rumpler, Comprehensive Handbook of Sugar Manufacturing, 1909, completed special reprint of the article Sugar in Musprat's Chemistry. Rumpler, Non-Sugar Substances from Beets, Wiley, Experiments with Sugar Beets, U.S. Department of Agriculture, 1894, and Progress of the Beet Sugar Industry in the United States. House of Representatives, Document 699, 1900. Annual Report on Investigations and Progress in the Overall Field of Sugar Manufacturing, founded by Stammer, published by Bach. The 48th year 1908 was issued in 1909. Plant Illustrations by Pabst Kohler. Medical Plants Aldo 55, and in Les Grandes Cultures. On another Chenopodiaceae, Salsola foetida, Aitchison observed in 1887 in Afghanistan, a sweet-tasting manna for third, maple sugar. Parent plants and systematic position Acer saccharum, sugar maple and its variety A. saccharum nigrum, black maple, primarily, then also Acer rubrum, red maple, ACI. Saccharinum silver maple AC macrophyllum, Oregon maple AC nagundo box elder, Acer saccharinum wangena, is illustrated by Pax and Inglerprantel, Plant Fam, P271, Acerate, extraction. The sap of the sugar maple contains 240-270 g of raw sugar per liter. The sap of our maple also contains about 3 sugar in spring. Pure, fresh maple sap contains no trace of reducing sugar. Wiley. Yields vary with location. Maple trees on mountain ridges and southern slopes produce the richest sap. The fresher the climate, the finer the taste of the sap. More. Native Americans in northern North America have been using maple sugar for countless generations. They cut into the tree horizontally with an axe and directed the sap into containers using a piece of bark, where it was then concentrated in winter by freezing. They knew solid sugar. The wound was no longer made with an axe, but an inch hole drilled, into which a metal tube, usually coppered iron pipe, was inserted, and a bucket attached table side. The first settlers imitated and gradually improved the methods of the Indians. Boiling and crystallization took place in the forest itself. Fig. 42. A genuine maple sugar industry developed around mid-19th century, leading to improvements in the method of tapping and especially concentration work. Thickening now took place in long, flat, slant-topped pans. Cook's evaporator over the fragmented, steam-heated, or directly heated bottom, of which the sap from the tanks flowed slowly in a zigzag course from one end to the other. Fig. 43. In remote areas, the old methods are still practiced. Illustration, Table Vot. Maple sap collection in America. Buckets attached to the tree during the season. After Fox and Hubbard. Illustration, Fig. 42. Evaporation of maple sap in the forest in North America. After Fox and Hubbard. Illustration, Fig. 43. Modern evaporation plant for maple sap in North America. After Fox and Hubbard. Each tree yields 5,150 liters of sap annually. from which 1235 kg of sugar can be obtained. The maple sugar I have here is slightly colored. The maple sugar industry has particularly spread in the northern states of the Union. Of the nearly 12 million pounds of maple sugar produced by the United States in 1900, almost 5 million pounds came from New England states Maine, New Hampshire, Vermont, Massachusetts, Connecticut. About as much was supplied by the Middle Atlantic. States New York, New Jersey, Pennsylvania, Maryland, Virginia, West Virginia, about 1 million pounds from the central states, and only a small amount from North Carolina. Most maple sugar comes from the states of Vermont, New York, and Pennsylvania. Maple syrup production is significant, with approximately 2 million gallons harvested in 1900, over half of which came from the central. In 1909, maple sugar production was estimated at 22.5 million pounds. Some 15 million iron pipes required replating. In 1901, maple sugar and syrup production in Canada totaled 17,804,825 pounds, worth £1,725, $182. Of this, Quebec produced 13.56 million ounces. Production has since increased further. Additionally, special maple trees have been planted in recent times. Hermann Stedt discovered raw sugar in the following Acer species in 1809. Acer saccharinum, A. pseudoplatanus, A. campestre, A. platanoides, A. dasycarpum, A. tataricum, A. negundo, and A. monspeciulanum. Profitable sugar production is also possible with Japanese maple species Acer argutum and A. japonicum. Considerable quantities of palm sugar are produced in the Malay archipelago, for example in Java, from the sap of the sugar palm. Arenga saccarifera labile, lit. Fox and Hubbard, The Maple Sugar Industry, U.S. Dep of Agricult, Burr, of Forestry, 1905. Will F. Hubbard, Maple Sugar and Syrup, U.S. Dep of Agriculture, Farmer's Bull, 52, 1906. Palm sugar. Palm sugar. The production of palm sugar jaggery is described in B.I. Piece 1017. There are also listed the palms that supply palm sugar. It contains a considerable amount of starch in its trunk, which has earned it the name sagopalm from Malacca, and is, for example, produced on Celebes, also known as Gamutus saccarifera, Sierras Rumei, Roxby, which is called Gumuti in Malacca, Aren or Anau in Java, and Akol in Menado, other names by Clerk. A rather rough image in church, Ind, Heil, Unutsville. Gamuti or Aren palm that grows inland on the Malay Islands, far from the coast. As soon as the female inflorescences have developed, and the first male appears, the stem is knocked until abundant effect exudes through the cuts. Now a piece of bamboo pipe, consisting of several internodes and closed at the bottom, but transformed into a tube often 2 meters long by penetrating the separating transverse walls, is attached to the cut surface, so that the sap flowing out from the cut surface flows into the sterilized tube through smoking. This tube hangs down from the tree along its length, and is fastened to the trunk with rattan or iju, i.e. orange strings. The same procedure is followed when a sentin flowering cluster appears. I often saw 3-4 such bamboo tubes hanging from one tree. About 2-4 liters of sugar sap flow daily for about 2-3 months. The same is distilled. After the tube is lowered and emptied over open fire every few days, until a drop, when brought to a stone, hardens. From the brown sugar mass obtained as a result of careless preparation, round slices or rectangular blocks are then formed, which are beaten into the leaves of Aren or Zalaca edulis. The extraction of the sugar sap takes quite a long time, so that a tree is able to provide a lot of sugar. An acre of Aren palm trees could yield 8,000 pounds, but the Aren palm is nowhere cultivated in plantations. I only saw individual specimens. The sugar of Arenga saccarifera consists of 87.97 raw sugar, and only contains 1.53 dextrose. During Junghun's time, mid-19th century, there were still 159 cooking places for Arenzucker, with 334 iron pans in the neighborhood of Bandung. Now, raw sugar is gradually replacing Arenzucker. Nevertheless, I still encountered it in 1889 in many Warong's stir-fry kitchens, and at the Pasar market. 1018 provides large amounts of palm honey in Chile. For example, a plantation near Valparaiso, with 150,000 trees yields 200,000 liters, similar. The palm sugar from the date palm, known as the wild Indian date palm Phoenix sylvestris, which is exported, is primarily produced in Bengal. Its preparation, involving tapping the trunks, inserting a bamboo pipe, and thickening the sap, is described by Semler Tropical Agriculture, 2nd ed., 1897, 686. Also see Watt, Dictionary of Economic Products of India. The production of sugar in rural areas of India is still quite primitive, employing ancient methods. Even Joseph from Kalachutbor, S743 describes the process of making palm sugar. Profitable was also the extraction of sugar from the date palm and the coconut palm. In Malabar, they add some lime to the squeezed coconut juice, CIP 1017, to prevent it from fermenting. The thickened palm sap is spread on palm leaves and hardens there. This coconut palm sugar is a well-known trade product in Malabar Schroeder. Incidentally, sugar is also produced in Malacca from the Arnica palm, which is also called kabum and is cultivated there. The flower spikes are called mayams there. For information on palm wine production, see IP 1017, Odorico di Porto Maggiore, Perpen, p. 726 already reported on trees that bear wine. In Ceylon Maratua and North India Talagunj, Konnagar, a great deal of coconut sap and date syrup is processed into araktadi, which is called tembo in German East Africa. Lit. Church, IND, Heilenmutzpel, Bentley Tryman, Medicinal Plants, Simmons, Tropical Agriculture. Watt, Dictionary, Economic Production, Schroeder, The Palms IP 1020, Clerk, New Plant Science, Lexicon of Dutch India 1909. V. Sorghum sugar, Saccharratus, Holcus saccharratus L. And some varieties of sorghum vulgaripers, Andropogon sorghum var, vulgaris, Graminea, Andropogone, Andropogon. Subgenus sorghum, origin and extraction. The sugar cane, or the Chinese sugar cane, sorgo, and the African sugar cane imphi, which is sometimes distinguished from it as Sorghum caffrarium, are originally native to the eastern coast of Africa, but now distributed throughout the world. Sugar cane was first introduced to China. From there it spread to Europe and then to America. The stalks contain raw sugar in the cells of the parenchyma tissue. The total sugar content is often up to 16 quail. As it consists mainly of invert sugar, the yield of crystalline sugar is only small, usually only a few percentages, while sugar beets already yield up to 18, and sugarcane e.g. in Cuba already 13 of cana e.g. in Cuba already 13 above. Its weight as crystalline sugar. The fact that the juice of sugar cane contains not only raw sugar and uncrystallizable sugar glucose, but also a lot of protein and ash components, and reacts acidic, makes the production of crystalline sorghum sugar difficult and unprofitable. On the other hand, sorghum syrup can be produced successfully. This is done in America, where a rather large sorghum sugar industry has developed, often in small operations, using the evaporator mentioned above P127. The great hopes placed in North America for sorghum sugar production have not been fulfilled, or not to the extent expected during the sorghum fever era. Nevertheless, it is said that in 1885 temporarily 600,000 pounds, but rather impure, sorghum sugar was produced there. Also, several unsuccessful attempts have been made in France, India, and Australia to prepare sorghum sugar. The refined sorghum sugar contains 92 saccharose and 4.5 glucose. Incidentally, the Mexicans also prepare a syrup from the stems of Z. Mael Taylor, but it is believed, especially from the variety called sweet corn, that raw sugar has been produced since ancient times. Even in the pre-Columbian era, reports by Cortez, in Europe, maize sugar was obtained as early as the 18th century. In 1836, Pallas demonstrated that the stem of maize contains raw sugar. A stimulating drink is prepared from maize este Mexico and from sugarcane sap in China. In Mexico, this is called pulque de maíz, lit. Semler, Tropical Agriculture 3rd, 301, H.W. Wiley, Recce of Experim, Conduct. Bachtel, Central B. F. Agric, Chem, 1880, Z's. Other materials supplying raw sugar. It has also been proposed to process the pineapple into raw sugar, as its fruit cluster contains 11.5 crystalline sugar. However, it is accompanied by 2 non-crystalline sugar. By the Commissioner of Agriculture and the Manufacture of Sugar from sorghum at Rio Grande, New Jersey, Kenner, Louisiana, Conway Springs, Douglas and Sterling, Kansas, 1888. Soe Record of Experiments with Sorghum, 1891,1893, USD. Of Agriculture, Div. of Chem, Bulletin 20, 29, 34 U40, Rep. of the Secretary of Agriculture, 1892. The juice is therefore not suitable for raw sugar production, aside from the fact that the starting material is too expensive. The same applies to the apricots, which contain 6 crystalline sugar and 2.75 non-crystalline. Even the sugar beet Siam cicerum, cultivated in southern Europe and North Africa, is not exploited for sugar, although Marggraf found raw sugar in it. From the sap of the agave, CI, p. 1018, the ancient Mexicans and Peruvians made sugar. This is no longer done today. The sap of agave americana contains 6 saccharose and 2.6 fructose. Sugar from coconut milk contains 74.95 saccharose. Sugar from the sap of Borassus flabelliformis at 79.12. Further information in Lippmann, History of Sugar. Types of manna containing raw sugar. Birch sap was processed into sugar in Scotland and Ireland, and is still done occasionally in North America. For more details, see W. Lenz, über Birkensaft in Arbe die Farm, Instit, Berlin 7, 1910, p. 28. Previously, Heracleum spondylum and Sibiricum in North Asia were also used to make sugar. The stems were dried and the sugar exited was tapped off. Avicenna knew about sugar derived from Asclepias theriaca, the sweet-tasting fruits of Glyceria, Fluten's mannagrass, mannahorse. She believed that they fell from the sky like dew, and apparently were never used for sugar production. All free from manna, Alhagi manna, or Terrenschaben, die im Mittelalter über Aleppo in den Handel gebrachte Sog. Syrische Manna war diese, die wohl auch Megenberg sah, die Stammpflanze Alhagi maurorum, Turnef, DC, Pedisarum alhagi, alhagi, maniferum, des, Khorasani, alhagi manna, Persian manna, Terrenschaben, Terrangiabin, Persian fruit honey, Engjabin honey, Aitchison translates. Raises and Avicenna. Terrangiabin in Ibn Bathar, Taranshubin, Arabic Elbach, in Simon Januensis. Alhagi camelorum Fischer, eine Papillonatze, wird überall in Persien, besonders in Khorasan, als Kamelfutter benutzt, daher Kamelsdorn, das Manna schwitzt, wie es scheint, nur unter besonderen Bedingungen nach größerer Hitze, auf besonderen Standorten, als ein süßes Exudat in Tröpfchen aus. 606 Terrenia Bean, bei Garcia da Horta, Tirimia Bean, Trungibim, bei Alpini und Cordus, Estate, S800. Terrenia Bean oder Manna Orientalis est Drosomeli. Die Manna Granata, Sibi in der Frankfurter Liste der Rend, S812, und bei Cordus, war vielleicht auch Alhagi Manna flüchtiger. Ibn Bathar quotes, after Ishaq ben Amran. Taranshubin is a dew that falls from heaven, similar to hard granulated honey and called manna. It grows in Syria and Khorasan, and has green leaves and red flowers that do not bear fruit. Indeed, despite the wide distribution of the plant, which is also found in Afghanistan, Baluchistan, and Hindustan, this manna only comes from North Persia Tabriz, and from the Persian Gulf Bender Bushir, usually mixed with fruits and stems in Commerce Schlimmer. The area around Yorhaut in Persia is famous for this manna Aitchison. Some are translucent, granular, brittle, crystalline, while others are tough, soft, amorphous Ebert. They sometimes have a faint senna-like odor. This manna was the primary sweet laxative used by ancient Persian physicians and may have been mentioned in Sushruta as Hedisarum and by Theophrastus His, plant, or Capi 4. The best manna is the white one from Khorasan. L. Rowolf Bavern, p. 771, describes the manna he saw in 1573 at the market in Aleppo, along with the tree that produces it. Mir Muhammad Hussein states that it is collected in Khorasan, Mararunahi, Kyrgyzstan, and Hamadan. It forms brown, dry clumps of irregular shape, mixed with plant residues. It is still used as a laxative in Persia, and is traded there in green-yellow loaves. Dimmock found it in Indian markets in 1891. Ludwig found approximately 35.5, Ebert 42, raw sugar, and around 20 mucilage. Some chlorophyll was also present. The insoluble residue was about 32, and consisted of plant residues, thorns, leaves, flowers, sand, and added foreign starch Ebert. The crystalline pieces are almost pure raw sugar, 2 Ho therein, which Alichin described its preparation from. Ebert did not find the body. Lit, the plant first, in the Botanical Lexicon Kitab as RC 980. Ebert Beiter Z. Kenton, Einig, Selt, Manasorten, Dis, Zeit, 1909. Polak, Persian, 1865. Schlimmer, Terminal, Medico-Pharmac, Frank Pers. Tehran, 1874. Ludwig Bistout, Einig, Manasort, D. Orient, Arch D. Farm, 1870. Villiers Bull, Sokchim, 27, 398. Plukiger, Pharmacognosy. There's 31, further lit. A. Levanta Handel, Hausknecht Arch, D. Farm, 1870. Alichin, Zeitcher, D. Russ, Chem, Gist 21, P. 420, after Colin Jurin, Farm, Chim. 1890 in Persia. 2 purgative and 5 pectoral men were distinguished. An overview of Persian and Indian men also in Hooper, Farm, Jurin, 1890. Bocone mentions in his curious remarks, 1697, Terengibin al-Hagi, Churchist Shirquest, Jirsis, see also, Vire, sur la man des Hébreux et les man divers de l'Orient, Journe, P. 1818, 120 their older lit, Maiden, Vegetable Exudationes, Scient, Res, Tabashir, Tabaxir, from Tivakashira Sanskrit Rindenmilch corrupted, in Surutas. The ash content is 0.96. Only 0.7 of a feeling solution-reducing substance could be detected. This tabashir is probably also, according to Lippmann, the D of diasturates, which he calls honey of sugarcane, and describes as being formed by excretion and similar to tabashir I is found on the surface of the stems of certain Indian bamboo species, particularly Bambusa stricta, Roxbeat da. Dendrocalamus strictus knees, native to Central and South India, in the form of stalactite-like flattened white or light brown pieces that dissolve easily and completely in water of the same weight and consist almost entirely of raw sugar hooper, containing only a small amount of reducing sugars. 808 also mentions this tabashir. 2. Another type of tabashir desut is found inside the stems of bamboos. Ibn Bathar already distinguished it from the one described above. It consists almost entirely or mostly of silica and silicates. It was a trade item on the west coast of India, especially from Thana, where it was encountered by Idrisi 1135. Similarly, it is known to Ibn Sina, the customs list of Aden the Ferns, S6699, and Garcia da Orta Thurs, S736. It is still used today in traditional Eastern medicine, but has become rare. The Pharmac. Persica from 1681, I.P. The relationship between the 2 types of tabashir can be understood as follows. Originally, a mixture of silicates and sugar was secreted inside the stems, which initially existed in an aqueous. Fourcroy and Vauquelin found 70, Ince 86.39, 91.69, Rost van Tonningen 86.38, Thomson 90.5, Gubor 97.3, Isilica, as well as lime, potassium, sodium. It also contains 4.25 raw sugar and 2.6 mucus Ebert. These then formed tabashir II upon drying. This would explain why tabashir I is rarer. Kobus, who investigated the matter on Lippmann's request several years ago, did not find the above theory confirmed in Java. Even tabashir is still used medicinally today. I often found a significant amount of watery liquid inside the stems of bamboos in Java when cutting them. Then it dialyzed particularly the crystalline sugar through the stem wall into the outside, where it only retained and crystallized during the dry season, but was washed away during the rainy season and remained in the cavity of the internodes as a sugar-poor solution that contained amorphous, colloidal substances mucilage and silicates Ebert. In the literature, with the exception of analytical works, it is rarely clear which of the 2 is being referred to. Thus, Salmasius and Humboldt would be right, who, contrary to Pereira's opinion, thought that the of the Greeks was the sap of the bamboo stem, also see Pereira's Fourcroy and Vauquelin, Annals of the Museum 6, 1806, American Tabashir, Dubort, History of Simple Drugs, Thomson, Records of General Science, 1836, Watt, Dictionary of the Economic Products of India, Hooper, Pharmaceutical Journal, 1891, and 1900, 1640, Ince Ibid, 1896 analyses, Pollock Bambusa Arundinacea, Pharmaceutical Center, 1886, and Austrian Apothecaries Journal, 1887. Huth, the Tabashir in its significance for botany, mineralogy, and physics. Berlin, 1887. Kurtz, Indian Forester Urn, Brandis, Ebert, Contributions Towards the Knowledge of Rare Manasorts. Dissertation, Zurich, 1908. Flukiger, On the History of Tabashir, Austrian Apothecaries Journal, 1887, and Swiss Pharmaceutical Journal, 1887, and Swiss Pharmaceutical Journal, 1859. Observed on another grass. Phragmites communis is a sweet exudate, likely produced by Aphids Watson, known as California Manipater Piccolo, and Ross Brown at Lloyd. It is still collected by Indians today, Lloyd Californian Manna, Amer, German, Farm. 1897, German, in Bear D Farm, G.A.'s. 1897. Also from a grass, specifically Andropogon annulatus Forsk. Originating in New South Wales, comes Bluegrass Manna Baker and Smith Farm, Jern, 1897. Weiden Manna Bide Kesht, Bid Chisht, is exuded from the leaves of Salix fragilis LL. In Persia during late summer, collected in villages at the foot of Mount Elbrus Polak, or in the district of Cheriar Schlimmer. A similar manna seems to occur on apple trees, Pyrus glabra, and Salsala futida. The pieces presented to Ebert in 1908 contained rose leaves and a Ferolacean fruit. Hausknecht states that it is mixed with flour. In the purest pieces it contains 50 raw sugar. Additionally, it includes 17.5 dextrose, 13.26 other water-soluble components. The insoluble residue gypsum, wheat flour, plant remains was 19.2. A similar manna is provided by Salix tetrasperma in India. Hooper, Farm, Jern, 1890, F. Oak manna or Gezelefi. The oak mannas, Vallonan mannas, Manna corsina or Corsia, Gezelefigetsa, among the Turks Kudret halwa celestial sweetness. This contained Teva reducing sugar farm. Zeit, 1893, 548. From a Beidengabine, a sugar similar to Saccharose Beidengabinose was isolated, along with 12 glucose. For other types of willow manna see below. Lit. Ebert A. O. Flukiger, Pharmacognosy. Ludwig, Arch, Farm, 1870 for older literature. It occurs in Persia on the leaves and fruit cups of Quercus, Vallonea kochi, and Quercus persica jaub. Itzbach ibn Baithar calls Q-Cutzifera jedar, allegedly by the leafhopper Coccus maniparus. In August, oak forests are infested by these leafhoppers, which cover the leaves with a fine powdery mildew that coalesces into very sweet water-clear drops, often covering the entire ground around house. This manna falling to the earth does not seem to be collected. Instead, the inhabitants of mountain districts gather the leaves infected by the manna, weigh them finely and form gray-green, firm, durable clumps from the sticky mass. It seems that the leaves are also dried, and the powdered manna that has been dried off is scraped off Berthelot, Schlimmer. On the other hand, they also dip the sticky leaves in hot water, reduce them to syrup, and use it directly or thicken it further. Mix the extract with flour, spread it on linen strips, and dry it in the sun. This product is called Pekme's house slave. Few animal remains are present. Ludwig and Flukiger report 48 and 90 grape sugar respectively, with no raw sugar, but Flukiger only states that he found right-rotating sugar that he was unable to crystallize. Dextrin, as Berthelot indicates, could not be found. Ludwig only determined the rotation of the drawer. The clumps mixed with leaf mass, which appears to be the only variety of this manna sold commercially, contains, according to Ebert, 52.2 raw sugar. Berthelot found 61 in the mass, freed from leaf matter, 19 grape sugar, 1030 mucilage, 745 moisture, and 10 residue. Schurat. Berthelot Annalen der Chemie und Physik 3 Series, T67, G. Schier, Kith, in Avicenna, Lit. Tolak, Persia, the country and its inhabitants, 1865. Schlimmer A.A.O., Ebert A.A.O. Flokiger, Pharmacognosy, U. Archief für Pharmacognosy, 1872. Ludwig Bestand, Einiger Mannesorten des Orient. Archive für Pharmacy, 1870. There, the older literature. Hausknecht, Mannesorten die Orient, Ibid, 1870. Hausknecht. The manna studied by Ebert in 1908, which was definitely shown to come from Cotoneaster, formed gray-white brittle pieces with the size of a pea, and the plant remains pieces of stems, bark, calyces, and leaflets were covered by a mealy coating. This manna contained 12.9 raw sugar, 37.5 glucose, 24.2 mucilage, and 15.9 moist. The manna from Cotoneaster nummularia, widely used in India fish. The designation shirkisht. Hardened milk is a Persian-Indian collective term for manna in General Dictionary of Economic Products of India, but is also used for a special kind, namely the manna mentioned by Ibn Bathar under the name shirshashak, as a cough and purgative remedy, which is collected in Herat, Elbrus, and Khorasan Schlimmer, and originates from the Amalanchier Cotoneaster nummularia Fischer at Meyer, and from the Polygonum atrafaxis spinosa, L. at Meyer, a shrub up to 14 feet high of the Paropamisus range in Khorasan, is collected in June by shaking the branches and exported in large quantities to Persia and India. Aitchison. Hooper found 830 glucose, 4.1 raw sugar, about 50 Cherkis related to mannite and sorbit, probably sorbit, rabi. Since Echarkist is a collective name, see above. In Ibn Bathar, it is called man. It is understandable that other manna types occasionally came into trade under this name as well. Thus, the Echarkist by Rabi, in which he found a new sugar, allegedly similar to sorbit, the Cherkestit, and also Bidinggebin Bidengibin. Manna, in which the same contained Bidingibinosis, is certainly different from the above, and likely to be classified among the pasture mannas, CP 133, and also the manna of Ludwig, in which he found 17.8 levorotary sugar and 22.5 starch, must have been a different product, a Trafaxist manna. The manna masticina of Prosper Alpin was perhaps Tamariscan manna, lit. Polak AAO. A list of Indian manna types in Watt's dictionary. A compilation of plants that produce manna, also in Chem. Drug, 1890, 863. An older monograph on manna was written by Claudius Almasius Plinian. Exercitation, Ultraject, 1689. H. Tamarisk manna. Tamarisk manna Arab, Gazanjabin, Purs. Schlimmer AAOO Hausknecht AAOO. Ebert, Dissert. Zurich, 1908. Rabbi, Cherkes, and Bidinggebin. Piash, Journ, Transact, 1889. P900, 1889. P903. Ludwig A.A.O. Hooper, Farm, Journ, 1890, 421. Further types of manna see under the Trichoreeds, under mannite and dulcet. 598. Persian gaz, Gazangabin or Jesenjebin, thus tamarisk honey. Tamariscus is in Alphida arbor Geneste Esmericae. I. P. Gazangabin, Jesangabin, Gezenjebin, in the Pharmacup. Persica 1681 CIP 808. Gezengebin likely included several types of manna. In Alpini, Turingibel is from Tamarix gallica var. Manifera Ehrenberg. Arabic ASL. Tarfa also in Serapion. Athol in Imran, IPA. 660 collected and allegedly produced by the scale insect Cacus maniparus erimb. This up to 7 m tall tamarisk is found almost throughout Persia, especially common in the south, then in Afghanistan, Arabia, the Sinai Desert, Upper Egypt, and Nubia. Burckhardt found the tree in the Sheikh Valley, and it occurs in greater quantities in this valley of Arabia through which the Jews traveled at that time. Manna is collected before sunrise when it has hardened. In the sun, it melts. The Arabs cook it and strain it through a piece of cloth. It is dirty yellow, tastes sweet and slightly spicy, and never hardens. In Persia, Tamarix manna does not seem to be collected, at least not now. Tamarix manna contains 55 raw sugar, 25 levulose, and 20 dextrin, as stated by Berthelot. The glossy white honey-thick drops of this peculiarly pleasantly smelling, good-tasting tamarisk manna dripped down from the highest branches in the sun warmth of June and July, gathered around St. Manna collected in leather bags at the Sinai monastery, and for centuries as reported even by St. Anthony the Martyr, around 570 A.D., it has been partly enjoyed and partly sold to pilgrims at a high price, as the entire harvest in the best year amounts to only 700 pounds, according to Welsted and Flückiger, following the common assumption based on the works of Ritter, Tischendorf, and Ebers. This is considered the biblical manna. Even Flückiger accepts this. I leave the question open, IP 490, and consider it possible that it could have been a lichen, perhaps Sphaerothalia esculenta. I base this on Hausknecht's observations, who notes, regarding the biblical manna, i.e., Chlorangium Jusufi, Link Lecanora, Esculenta Eversman, Lecanora desertorum, Krempel Huber, the seemingly miraculous description in the Bible. Some exaggeration must be allowed for the Orientals, as they still claim today that this manna fell from heaven. It is clear that the Jews collected their manna only in the morning, when the mist had disappeared, as then the lichens, swollen by moisture, were easily visible, but after longer exposure to sunlight, too. Moses 16:21. She melted, which is likely a false translation. It should have been, disappeared she, as the drying lichen curls up and mechanically encloses itself with earth, or respectively, is no longer visible between the stones. Church. From 4. That the lichen, undried, formed heaps in large masses and immediately heated up and spoiled, is self-evident. Moses 2:9, one can see that the manna must have been a dry, solid substance, as it was ground in mills. The fact that the manna was only found in deserts that had never been cultivated, where lichens could form in large quantities, is evident from Joshua 5:12, because it stopped upon approaching cultivated areas. Even the taste description in the Bible only fits here like bread with honey, although it would have been more accurate to translate this passage as like sweet flour, or like sweet bread, because they did not know bread like we do today. Since Ehrenberg observed manna exudations on tamarisks in the ravines of Sinai, it has generally and with considerable certainty been assumed that these were also the manna of the Jews. However, the properties of this manna completely contradict the biblical accounts. It is also not conceivable that such a relatively small exudation could have served as food for an entire army. If we relate these statements to the lichen, we cannot help but see in it the true manna of the Jews. Henry Castry, La Nature, 1898. Shares this view that it is a lichen. He calls it manna of the Jews, Sphaerothalia esculenta, and ABS, and reports that even today the Arabs, who crossed the sand deserts of Arabia, use this lichen, which is very common there, and forms large heaps on the sand after each rain, for their own nutrition as well as for camel feed. The aforementioned chlorangium is ground by Persians, and used to make bread, known as shirsad, on the bazaars in Isfahan. The pea-sized mealy grains, with a rather pleasant, slightly sweet taste, contain 14 nitrogen substance, 32 carbohydrates, 4 fat, and thus seem capable of serving as food for some time. Information about a recent manna rain in Diyarbakir, where the lichen could be baked into good quality bread, was obtained through La Nature in 1891. Ascendens voice. Et Haust. It covers the branches like a mold and can be scraped off. This manna is processed into unique, highly popular baked goods, along with almonds, pistachios, spices, and flour a Hausknecht. The belief that manna falls from heaven is also found in Masu, a mistakenly identified variety of the Tamarix mellifera, bearing the same name, a manna, known as Jez Engibin, i.e., Tamarix mellifera, that is collected and widely used in Persia, particularly in western Isfahan, from Astragalus florulentus bois. It contains 30.95 dextrin, 17.93 invert sugar, with surplus fruit sugar, 10.71, a mixture of dextrin and invert sugar. Almvardveid, lit desud, Moses 16 and Ive, Moses 16 and Ive, Moses 11. Tamarix mellifera in Bhutan, Lexicon Kitab Ar. Antonius Martyr, Delosis Sanctis Cap, 39. Ritter Erdkunde von Asienkultur 1846, 1846. Tischendorf, aus dem Heiligen Lande 1862, Eberes, durch Gossen, zum Sinai 1872, p. 223, 223, 243. Berthelot, Archives de Pharmacology 115, 1861, an Annual Report of Chemistry 1861, p. 751. Schweig, Journal 29. Dierbach, Magazine der Pharmazie, 1826. Hausknecht, Mannessorten des Orient. Archiv of Pharmacy, 1870. Ludwig über den Bestand bestimmter Mannessorten des Orients Ibid. Stolze and Andreas, Ergensuch, 77, 1885. For other Persian manna species, see Hausknecht, Locke. Polak, Persian, 1865. Vambery, Rize, in Middle Asian, 1865. Osland, 1800, 1867. Annual Report of Pharmacy, 1869. Pharmacographia, p. 415. Chemical Study of the Manamos by Castribull. Gen. de Therap, 132. Wamside. By Castribull. Plantetude antique. Donathardy, Van Hunten, Reichhardt. Über die Manneflechte Sphaerotalia, Esculenta ne. Proceedings of the Zoological and Botanical Society, 1864. Dreher, Tor, Tort. Johannesbrot, Sodbrot, Sudschot, Bockschherndl. Siliqua dulcis, John's bean or bread. Algaroba of Spain English. Caroba, Fruto del Carubio Italian. Johannesbrut Dutch. Johanneksen Lipe Finnish. Sentjanoscanier Hungarian, Greek. Carnuk Nukti Indian. The first two words mean originally after lauret, a curved object with pointed ends like the moonhorn, particularly a pod. The third word designated the sweet pulp of the fruit, which has the same root as the Semitic words, Kuruga and Garta, Bushel and Dadi. The name carobe is also used for other things, e.g., the galls produced by Pemphigus cornicularius on Pistacia terebinthus. Caraben leaves are the leaves of a number of bignoniation species, Jacaranda, Bignonia, Sparatosperma, Cordelistris. The hieroglyphic inscriptions name the fruit of Ceratonia daruga, Ua, and Giari. John's bread tree, because according to the legend, John the Baptist fed on the fruits in the desert. In Palestine, they even show the tree. The expression John's bread appears first in the inventory of the city pharmacy of Braunschweig in 1522. Ceratonia, so in Galen from Ion. Also sometimes Ceratea, the fruit in the Bible. Also Dioscorides writes, perhaps from horn, due to the shape of the fruit. New Greek, Persian, Charnub, Arabic, Charub in Ibn Bathar, Chernub, from which Italian carobo, caruba, Spanish Italian carabo, caruba, garobo, algarobo, Portuguese alfaroba, French carube, carouge. 1591. In Cordis, Fructus Ceratonii, Zeloceratia, Zelocaracta, also in the Nerdling and Register Chilocaracta siliquadosis. In Albanian, Totshobanus goat horn. In Plinius III, 8. Siliqua, which Jones calls Chironia. In Columella, Siliqua greca. In Scribonius Largus, S. Syriaca. Siliqua perhaps derived from artichoke fruit and transferred cook. Siliquadosis first mentioned by Prosper Alpindinde. Plant, Egypt, Dada. A blooming branch. B. Male bloom. C. Hermaphroditic bloom. D. Longitudinal, cut through the same with the cup-shaped discus. E. Pod. F. Longitudinal, cut through the base of the same. G. Longitudinal and H. cross. After Tauber in Ingler Prantal. Plant families. Main plant. Ceratonia siliqua, L. Linnae, cyst, veget, ed. The flowers are arranged in short lateral racemes. Plinius states that the Ceratonia bears its fruits on the trunk. 4 teeth. 1167, 1. John's bread tree, John's broad tree, and Judas tree, Middle High German. Carubiae. Systematic position. Leguminosae. Chisalpinioidae. Cassiae. Description. The Johannesbrot tree has paired, feathery leaves with leather-like slightly lobed leaflets, and very small stipules. It is polygamous, dioecious. They lack a corolla, but only have 5 short, inconspicuous calyx-like lobes. Male flowers have 5 large epipetalous stamens and a rudimentary pistil. Hermaphroditic flowers have 5 small stamens, staminodea, and a large, stretched, short-stalked, inserted in the middle of a cap-shaped glandular disc, hairy pistil with a short style, rounded stigma, and numerous ovules. Fig. 44. The fruit is a pod, a legume, Therefore, the name Siliqua, i.e. pod dulcis, is incorrect and misleading. By the way, one still wrongly speaks of vanilla pods beans, husks, fruits, and our pod pisum is well known to be a husk as well. Illustration. Fig. 45. Serotonia siliqua with fruits, after Hamilton. The fruits hang in large clusters on the branches, an old tree fig. 45 can provide thousands of kilograms of carob. The tree is native to Syria and Palestine, not Egypt and Greece, nor Arabia Schweinfurth, but it came early to Ionia, Knidos, southwestern Asia Minor, and Rhodes Theophrast Plinius. Its northern limit now roughly coincides with that of citrons and oranges Hine. It is more sensitive than the olive. The southernmost occurrence is Yemen. Hamilton, Botanical Studies of the Bible, 1871. A plate of a carob tree, also in Ellen Assure, 1902, 316. Pathology. Several fungal species from the groups of Paranomycetes and imperfects occur on the leaves of Serotonia siliqua. It is also not excluded that these could also affect young fruits, but no information on this has become known. Ed. Fisher. Culture. Now it is widely naturalized in Cyrenaica, Algeria, Sicily, etc. Lit. Bonzone, Delamotte, and Riviere, on the carob tree, and its fruit. Paris, 1878. Tolbert, 1878. Tratte, Plate, G. Bianca, Il Carubo, Monographic Study of Historical and Agricultural Botany. Italian Agriculture, 7th, 1881. The carob tree, which belongs to the Mediterranean drug region, is a fairly tall, widely spread, densely shade-giving, evergreen tree fig. 45 that loves proximity to the sea. It often becomes several hundred years old, grows slowly, and bears fruit, usually only at 20 years of age. For abundant fruit formation, it must be pruned like the olive tree and vine, and preferably also artificially fertilized. Usually, wind ensures fertilization, and it is known that winds from certain areas, apparently those where male trees grow abundantly, increase fruit yield. The Arabs spread its culture to Spain, southern Italy, Apulia, Sicily, Sardinia, Greece, and the islands. The culture has produced numerous varieties that differ in their sweetness, fruit size, aroma, and durability. Only recently have male trees been obtained, which farmers in Sicily used to destroy or only use for grafting. Its cultivation does not go back very far. It was first described by Palladius I, p. 574, as cultivated and propagated in Italy, a later edition, and through grafting, a large, fleshy, very sweet variety Flukiger was achieved on Cyprus, Chios, and Candia, production and trade varieties. Cyprus has been the main supplier of carob beans for at least 6 centuries, shipping many millions of kg annually, partly from Cap Carubii near Larnaca on the south coast, partly from Limassol in the west and Cerignola in the north, also from Mazzotta and Lefcara. The best ones are considered to be the Italian varieties, particularly those from Sicily, Avola, Bari Puglia, Mola, and the so-called honey carobs, which are also shipped in large quantities. Levantine, Asian Minor, Candia, and Spain also supply significant amounts. The richest in sugar content come from the coastal mountains of Algarve. In Bari, poor varieties are called Caballo. The total production was estimated at around 10 million cato annually in 1895, and it was higher in 1910. The main trading place for carob is likely Trieste. Trade. Germany imported 37,393 ZD of John's bread in 1909, mainly from Cyprus, Malta, Gibraltar, and a little from Italy. Hamburg imported 24,689 Z in 1908, with 18,878 from Cyprus. From Cyprus, 2,130 from Italy, 1,690 from Greece and the Jonic Islands, and 921 from European Turkey. Italy exported 121,230, 907 whole shiploads of carob from Bari, a major trading center for carob, are sent to Russia. France imported 232,147 quintals of carob carouge in 1908, mainly from Turkey, but also from Algiers and Tunis. Illustration, Fig. 46. Cotyledons, R. radicula. Church illustration, Fig. 47. Serotonia siliqua. Longitudinal cut parallel to the surface of the fruit through the gaps in the edge ridges of the fruit. Church. Description of the drug. Fruits that are deep purple at maturity are somewhat horny curved in the early stages, as suggested by the horns, see above, also in goat horns, and the Albanian word as mentioned above. They do not always ripen. They sit on a short stem and can sometimes reach a length of 25 cm and a width of 4 cm, varying greatly in size depending on the cultivar varieties. The tip, appearing like a small appendage, is slightly pressed laterally towards the abdominal seam. The middle is deeply indented on both sides and shows delicate, fan-shaped rays that converge towards the edge fates, 44 and 47 ascending from the stem. The edge is bilaterally thickened in waltzed ribs, and each rib is divided by a median groove, giving the cross-section a handle-like appearance. Fig. 46. One groove corresponds to the abdominal seam, and the other to the dorsal seam. These marginal ribs contain 4 rows of depressions. If one cuts the ribs parallel to the broad side of the fruit, one sees in each rib a row of oval, superimposed hollows with quite smooth walls. Fig. 47. Where the seeds lie, the middle surface is slightly but usually not strongly raised. This is more pronounced in young, undeveloped fruits. The seeds are numerous, up to 15. They lie in oval, smooth hollows lined with endocarp quite closely together. The bridges between them are only narrow, not always are all well developed. They are smooth, reddish-brown, glossy, and inserted at the belly suture with a relatively long funiculus. Fig. The fruit breaks smoothly, although it is very fibrous. The epicarp is a single-layered epidermis, whose cells are heavily thickened and cuticularized externally. From the surface, they appear as straight-walled polyhedrons, 12-30 micrometers wide. They contain a brown content body. The cross-break appears glossy due to the high sugar content. Pest. In the fruits, occasionally, is found the larva of Mylos cerotonii. Illustration. Fig. 48. Cerotonia siliqua, cross-section through the marginal layer of the fruit wall. Drawn by K.H. Hellstrom, Anatomy. Figs. 48 and 49. Some stomata are irregularly distributed over the epidermis, as are a few hairs, or, since these are often broken off, their foot parts vogal. The hairiness varies greatly. Sometimes I found none at all, then again many and long ones. Then follows the mesocarp. Under the epidermis lie about 6-8 rows of parenchymatous cells completely filled with brown, phlobofen-like content. Fig. 48-2. The same consists mainly of highly organized bast cell groups, to which brachylamellar fibers are attached here and there. Then follows a loose circle of small, along the longitudinal axis bent bundles with not very wide spiral, net-like, or pored vessels, transverse section through the innermost part of the fruit peel, where a seed lies. K.H. The bast cells are quite long, according to Muller, almost 1, according to Vogel, even occasionally over 150 mm, and C18 10 to 30 mic. Wide, strongly thickened, with mostly blunt or knotted ends, and only slightly slantingly arranged slit pores. The bast cell groups are accompanied by crystal chamber fibers. The crystals are embedded in a sac. 48. 5 contain either distinct crystals or irregular rectangular masses, possibly sugar, when viewed under alcohol. These components thus usually dissolve in water, leaving a granular plasma behind. Hellstrom drawn as far as these bundles extend. The ground parenchyma is closely celled. Within the bundle of vessels it becomes remarkably clear, and the large cells stretch out distinctly radially in this formation. The tissue extends to the endocarp. The cells in this middle layer fructose. Fig. Upon drying, the solid tannin body detaches from the cell wall as a wrinkled sac. This therefore leads to a very peculiar microscopic image. Scattered within this sugar-containing tissue are numerous tan cells, either alone or in multipartite groups, resembling the shape and size of sugar parenchyma. They contain primarily tannin, along with other substances, and can therefore be considered tannin tubes. In fresh fruit, the mass fills the entire cell. The inclusions easily fall out of the cells, and are isotropic and not hollow, but solid ticomero, but not uniform in mass. From the edge, lighter. These contents bodies, inclusions, are yellow, copper-stained or violet-colored, often streaked. They are insoluble in water, alcohol, glycerin, ether, diluted acids, fats, and ether. Oils. Ammonia does not dye them. Strong lye causes blue drops to bubble up flüssiger. The composition of the mass is unknown. It seems to contain fluoroglucotannin. They turn gray-blue to violet blue when cooled. Turning deep blue immediately upon heating. Dyeing with potassium is dependent on concentration. Live 25 and above dyes pure blue, weak up to 5 reddish-violet. Intermediate colors result in Hellstrom. Through iron chloride violet blue to deep blue, almost black, through iodine and iodosulfuric acid yellow, through vanillin hydrochloride red winkle, through eau de la baraka, yellowish red ticomiro, Orsine ruby red, through ammonium molybdate and sulfuric acid deep blue, with osmium acid blue-black Hartwich and winkle. The inclusions are arranged very early. Even fruits that are 1 centimètre long contain some fully developed, and many in development, even at the earliest stages. Cells pigment with iron chloride, osmium acid, and vanillin salt acid. The development of the contents seems to proceed centripetally. In young inclusion cells, a fine potassium-resistant framework is found. However, this does not produce the potassium and iron reaction, nor does it color with iodine and Millen's reagent, although methylene blue Hellstrom does. In the outer layers, the lignin sacs are small, while in the inner layers they are larger, similar to the parenchyma. Similar inclusions are found in dates. See below in khaki fruits, and other Diospyros species, Annona reticulata, Ziziphus vulg, Elaeagnus angustifolia, Rhamni cathartic, blue grapes, and the fruit peel of Glycyrrhiza glabra, St. Sherbatchev. The empty marginal flanges, see above, seem to be caused by tissue shrinkage. Young fruits lack them. The endocarp consists mainly of heavily walled, blunt bast cells that are stretched tangentially and have longitudinal or very steeply angled slits. They were found in Flückiger at Serotonia, Pharmacognosy, 1st ed., and are so characteristic here that they can easily be recognized as containing carob or carob coffee, especially after the addition of vanillin acid salt. The innermost zone of the mesocarp is often collapse fig. 49, 7 tauta. These bast cells run parallel to the contours of the cavities in which the seeds lie, not always straight but often curved and joined into feather-like bundles, thus anastomosing. They are accompanied by slime cells, crystal-producing cells, crystal chamber fibers, and a few sclerenchymatous cells vague. 49, 8 dot. Within this skin layer lies another zone of multicellular parenchyma fig. 49, 9. This layer becomes mucilaginous. At places where no seeds are present, the edges of the fruit wall usually touch, and peculiar hairs Hellstrom lie on the sides. The seed coat consists of a C. The T-bearer zone is narrow, while the nutrient layer is broad and formed from numerous layers of collapsed cells. Illustration. Fig 50. The inclusions in the fruit of Serotonia, cross-sections, the rest in perspective or longitudinal sections. 150 m high palisade layer, whose 4 m wide light line runs 55 m below the coarse cuticula. The outer wall of the palisade cells is extraordinarily thickened over a distance of 45 m, and the lumen of the palisades themselves can barely be seen as a fine gap beyond the light line. Church. The broad slime endosperm contains cells with strongly thickened walls, either elongated or star-shaped lumens. The intercellular substance middle lamella, primary membrane of the cells, is only barely visible, even after adding reagents. It seems to be incorporated into the slime metamorphosis. The secondary membrane thickening layers are slime membranes, and the tertiary membrane consists of cellulose. The slime, here serving as a reserve substance, owes its formation to the secondary membrane thickening layers, and it belongs to the true slimes that do not turn blue with iodine or iodine sulfuric acid, and to the class of celluloses. The content of the slime endosperm cells includes protein and fatty oil. The cotyledons contain very water-resistant aileron grains. The parenchyma-bearing sides lie on top of each other. The strands of procambium traverse the middle part of the cotyledonary leaves. Lit. Flückiger. Pharmacognosy. Hopefully. Here mentions the tannin sacs for the first time. Vogel, Nahrungs Eugenus Mittel, 1899. Muller, Microscopy. Fisher-Hartwich, Handbook of Pharmaceutical Practice. Hartwich and Winkle, Archive für die Pharmazie 1904, 471 and Winkle, on the alleged occurrence of fluoroglucin in plants. Dissertations, Byrne 1904. Ticomiro, the cell-to-cell inclusions similar to Johnny cake in the parenchyma of some sweet fruits, etc. Bulletin de la Société Impériale des Sciences et Naturelles de Moscou 1905. Same all 5. 1905. Same author, Botanical Annual, 1884. K. H. Hellstrom, on the developmental history of the fruit wall of Serotonia siliqua L. and Tamarindus indica L. The sugar content varies according to the varieties in the analyses of Furstenberg, Anderson, Volker. The sugar is indicated at 51.70.70.7. Reports of the Pharmaceutical Society 1910. S. Sherbatchev. Archive for Pharmacy 1907. Chemistry. The fruits contain up to 32 saccharose and C18, glucose Heckel and Schlagdenhaufen. The raw sugar, which is sometimes found crystallized in the seed compartments and marginal cavities, was recognized by Berthelot, 1859. Ballin found 2174 saccharose and 2136 glucose in Candia carobin, 28.57 sucrose, and 14.53 glucose in Cyprus carobin, 8.2 sucrose and 4.9 glucose in Mersina carobin, and 1576 sucrose and 21 glucose in Portugal carobin. Furthermore, it has been shown to contain wax 1.82, tannin 0.72, pectin 720, and raw fiber 34. Reinsch states that the fruit shells alone contain by percentage 12 water, 6.2 fiber, 41.2 sugar, 20.8 protein and plant gum, 10.4 rubber, 7.2 pectin, and 2 tannin. The seeds alone contain 44.8 mucilage, 33.7 protein, rubber, fiber 8 starch, tannin, and gum, 2.1 sugar, and 1.5 oil. Recent studies have confirmed the sugar content of the seeds Burklow, Schulze, and Frankfurt. They found 0.11 reduced sugar and 1.58 raw sugar. The water content is estimated at 14.96 to 23.8, fat at 0.55 1.28, and ash at 232.53. The pentose content is around 4.45 Whitman. The very characteristic odor is caused by about 1.5 fatty acids, particularly butyric acid, and also antacid acid. Grunzweig showed that the acid found by Rettenbacher in carob beans, which Marsan isolated from it, is isobutyric acid, Cheech2. Its content varies depending on age and storage. Moist fenugreek contains more of this compound. Young fruits do not have a butyric acid odor. Therefore, it is produced only during the ripening, especially in the post-ripening process, likely through the fermentation of sugar by butyric acid under the influence of a specific ferment or an enzyme belonging to the protoplasm. The butter acid is accompanied by caproic acid, acetic acid, and benzoic acid green branch. During the fermentation of carob beans, Weissenherz obtained resinic acid 1818. In unripe Johnny cake, which tastes very bitter, Rosenthaler found a crystalline phenol and a substance with alkaloid reactions. In carob coffee, see back. 44.2 sugar, 2.4 ash, soluble in water, 1.9 was found. In the seeds, Affront found 1140 water, 18.92 nitrogenous substances, 62 carbohydrates, 2.3 fat. The extract amount varies. 46.9 Vogel, 63.71 Koenig. Koenig reports in percentages. Water 6.72, nitrogenous substance 8.72, ether extract 3.1, nitrogen-free extractives 70.81, crude fiber 768, fish 2.9, water extract in the dry substance 58.13. The pericarp makes up 8890, the seeds 1012 of the fruit. Carubin is converted by the hydrolytic enzyme, carubinase, also present in the seeds, into carubinose, a sugar identical to mannose. Carubinafrons is a galactomannan that, upon hydrolysis, along with small amounts of galactose, yields primarily D-mannose Burklow and heresy. Of the seed consists of this galactomannan, predominantly in the form of hemicellulose, and part of the mannan is also known as mannan cellulose. The grain of rye Janus bread is suitable for obtaining pure crystalline mannose Eckenstein. It also contains some dextrose, cellulose borculo. During germination, a diastase-like enzyme forms in all parts of the embryo, which transforms hemicellulose into mannose and galactose. Pectin also appears. A glue used in preparations is obtained by extracting water from 7182C from seeds from which the sprouts have been removed. The extraction of this elastic gum from rye grains is accomplished through DRP-protected Annual Report of Pharmacy, 1907, 32, but already in 1834, Rumard took out a patent for the production of a gum similar to Tragant from carob seeds. Moffat found 50-55 tannin in the bark of Ceratonia siliqua, used as tanning material. Occasionally, the stem and leaves in Sicily are said to exude sugar klaproth. Litt, Koenig, Food and Pleasure Goods. There the analyses by Furstenberg, Anderson, and Völker. Newer analyses in Balland. Analyses of carob beans from different origins. Journal of Pharmaceutical Chemistry, 619, 1904, 569. Proust, Jellens N. Journal 2, First Analysis. Range, J.P. Piach, 1842. 401 in Chem, Central, 1857-85. Elker and Kensington, Ibid, and Journal of Agriculture, 1856. Berthelot and D. Heckel and Schlagdenhaufen Rep. De Farm, 1892. Sup. Agric, Portici, Naples, 1881. Rettenbacher, Liebig's-Annal, 57, 1077. Brunswick, Liebig's-Annal, 158, 158, 117 and 170. Marsen, Arch, Farm, 48-2. Die Nahrungs- und Genussmittel, 1887. 450 Fruchtanalyse. Moffat, Farm, Juren, 1892. Klaproth, über den Zucker des Karubis. Mem, Arcade Roy, Berlin, 1804. Rosenthaler, über einen Bestandteil des unreifen Johannisbrotes. Arch Farm, 1903, 616. L.S. Cellule, 13th, 7, 1897 Farm. Zeit, 1898, 396. Front, Count, 125, 38, 116, and 309, 1897. Jern, Farm, Shim, 1897. 1899, 153, and 249. Keimung des Karubiensamens, Manus de Produktion durch einen löslichen Ferment. In 1899, 438, forgery. In 1888, a false Ceratonia was observed in London. It was the fruit of Calliandra piscolobium, Samansi Phil, trans. Application. The ripe fruits serve as food for animals, pigs, horses, donkeys, and people from poorer classes, pig herders, donkey drivers in southern Europe, and the Orient, especially when roasted or baked beforehand. The prodigal son desired to be nourished with the horns, Luke 15. The Crusaders under Richard I. Carobs now serve only as an expectorant, added to chess teas. The seeds serve as weights in pheasant for wheat kernels. They weigh approximately 0.18 g. The word carat unit for weighing gold and gemstones is usually derived from caration. However, there appears to be a confusion with the Abrus seeds Jacurity, whose name could also lie at the basis of the word carat, and which are closer to the carat C 0.205 as a weight for golden gemstones. First resorted to carob's flaxseed in 1191 during a famine. Unripe fruits were considered harmful by the ancients, as well as the unpleasantly smelling flowers. The fruits were an old trade item throughout the Orient. Dioscorides considered fresh fruits purgative and dry fruits diuretic. Indeed, it seems that the term carat was first used in India as a unit for weighing diamonds, then later in Africa as a unit for weighing gold. Others attribute the origin of carat to the seeds of Erythrina abyssinica quara, or Acacia nilotica. The matter deserves a historical critical study. Arabs made rube from Ceratonia fruits, as also described by Alexander Trallianus I, p. 591. Even now they prepare a lemonade and a syrup from them. The sweetest varieties of carob are pressed in the Orient, and the resulting honey is used for pickling. As a child's treat, the fruits are found everywhere. Roasted fruits, often mixed with fig coffee, serve as a coffee substitute, see above. Analysis of carob coffee at King. According to Rossi, after 3 days of fermentation, one obtains 25 of the fruit weight in alcohol. Here and there they are also used to sauce tobacco. Since Völker recommended them as livestock feed, They have often been used, including in our region, as fattening feed as an additive to livestock fattening powders. Lit. Rossi, Estrazione dell'alcol dalle carube. Ann St. Sup. Die Greek, Portici Napoli, 1881. History. The carob tree is the Saronia of Theophrast, and the Saronian fig tree of Plinius. Theophrast mentions carob plantations on Rhodes. In ancient Greece, its fruits were called Egyptian figs at market. Already Plinius explains this as a mistaken designation, for he is not born in Egypt, but in Syria, Ionia, and around Anedum, and on Rhodes, implying the plant's origin. However, in ancient Egypt, there are few traces of it woning. Now it is entirely absent from their Asherson. It is dedicated to St. George Hain. Bianca considers Serotonia one of the lotus plants of the ancient Theophrast, Hist, plant, IFB 3. See also P1070 and above, P61. In Ben Sira's alphabet, 11th century. The fruit, however, arrived early to Egypt from Syria, and appears to be depicted in a grave at Beni Hassan Vonig. Serotonia was called Woan in Egyptian, yet its interpretation is disputed. Joachim does not list C, contrary to Liebling in the papyrus Ebers. In Asia Minor and Syria, the tree still enjoys religious worship today. The plant list itself, being older, lists the henbane tree Krub, Emmanuel Lowe, among the plants of the royal garden of Nebuchadnezzar Strabon Ornt, S532. Serotonia is mentioned by Strabo. Among the ancient Jews, as indeed in regions where the tree is common Syria, and the fruits fall in masses from the trees in April, they have been used as livestock feed since ancient times. Luther apparently did not know that not only these, but the entire fruit in the Orient is pig feed, and he could not have suspected this, as fruits in the north were a delicacy. Marty suggests that Luther might have chosen the expression, Traber might have chosen the expression, sour in thought of the relative clause, the pigs ate it. Fruit. In the parable of the prodigal son, Luke 15:16, Luther translates in the Vulgate Siliqua, Ulfilas Hauern, and the Syrian translation curata, with tres. This false translation likely arose from his association of the term with the hard, fruit-pressing residual parts of the fruit seeds, endocarp, fibers as described by Dioscorides, or perhaps from learned friends, a term that also refers to grape and olive pressings, and sem. Siliquastri are found in the 1657 tax list of Nordhausen, further evidence above under Etymlit, Flukiger, Pharmacognosy III. Hain cultivated plants, etc. Wonig, plants of Egypt, Decandol, the origin of cultivated plants. Emmanuel Lowe, Aramaic plant names. 2. Trihala Segroup, Trihala Mana. Trihala or Trichala Arab. Skaker al-Ashar, Purs. Skaker Thigal or Tigal animal sugar. Nest sugar consists of the peculiar cocoons that envelop the larva of a snout beetle, Larinus maculatus falderman, named after Frauenfeld, Purs. GL. Larinus nidificans, after Gibor, belonging to the Curculionidae family, is produced in the stems and flower heads of various Echinops species, particularly Echinops persicus fish. These cocoons, which primarily sit on the stalks of the flower clusters, are round oval, 18 to 20 mm long, yellowish-white, rough outside, smooth inside. They have a bland, sweet taste and originate from the uncultivated steppes of Tehran and Qum, as well as western Persia houseknet. Trehalose has been known for a long time, and is described, for example, in the Persian Pharmacopoeia of 1681 I, p. 888, Trehalose Cho. According to Ebert 1908, they contain 17.5 trehalose, 23.84, according to Apping, 28.8, according to Gibor, 27.8, according to Gibor, mucus 18.8, according to Apping, and 31.7, 524.9, according to Apping of iodized, red-violet being amylodextrin starch, so-called RERD9 amylodex, starch derived from the plant. The ash content is 2.6 to 2.8. Lit Gibor, notice sur le Trehala, Hausknecht, Arch, Farm, 1870. Tuho is identical to Mycos, the mushroom sugar first discovered by Wiggers and Mitscherlich, then also by Minson mushrooms, which contain up to 10 of this substance in their dry matter, and likely also with Tihalin. It tastes sweet, rotates to the right. D199 water-free and forms rhombic crystals. It does not reduce feeling solution. 1859. Science Papers pp. 158 and 159 Laranus Illustrated. Apping-Unters, über die Trihalamana. Dis, Dorpat 1885 there. The literature is cited. Burning Unters, die Inversionsprodukte der Austrihalamana. 1888. A. Redlin Unters, über die Stärkemehl and plant mucilage of Trihalamana. Dis, Dorp, 1890-09. Milk sugar synonym saccharum lactis, sucre de lait, the sel de lait French. Sugar of milk, milk sugar English. Dragendorf, on Trihalamana. Sitz, Bear D. Dorp, Nat. Seasuck 1890. Winterstein, on the knowledge of trehalose. Tico Miro, the glycogen of ascomycete fungi, in relation to trehalose. Arch, Farm, 1908. Milk sugar group. The content varies depending on breed and individual differences, duration of lactation period, sexual state, type, quantity, and composition of feed, working capacity of the cow, care, and other circumstances. 73. That milk sugar also occurs in the plant kingdom, specifically in Acris sapota, has not been confirmed. Daily fluctuations and variations according to time of day are also observed. Lippmann. Sugar in milk, and it is always the same, can also be found in the milk of other mammals, such as dogs 1.4, rabbits 2, reindeer 2.53, goats 3.26.6, sheep 3.46.6, mares 4.7.7. Human milk also contains sugar in milk 4.7.5, rarely up to 8, making it the richest source of milk sugar. Certain plants, e.g., Galaga officinalis, increase milk and milk sugar production. Little is known for certain about where milk sugar is formed in the body. According to Burt, milk sugar is produced in the liver and transported through the blood to the mammary glands. Kremer suggests that mammary glands produce milk sugar from D-glucose and D-galactose, with the latter derived from mucus and gum components of plants. The statement by Bouchardats, the milk sugar was until recently, especially in some Swiss cantons that produce a lot of milk burn, Lucerne, particularly Emmenthal, Bernese Oberland, Simmental, obtained from the whey of cow's milk, which is a byproduct of cheese production after separating the casein using lactic fermentation. The clarified whey was evaporated to a syrup consistency or further reduced and cooled, resulting in initially finely granular, slightly colored raw sugar sand, Schotten sand, that was then refined in some factories by clarifying and decoloring the solution, possibly also by precipitation with alcohol. In front of cheese factories and tanneries, one often saw bags of Schotten sand standing, whose grainy contents did not have a pleasant scent. Sugar sand is a yellowish powder. Blüchiger estimated the production in Switzerland in 1888 at 30,000 kg. Since 1910, this production branch has ceased in Switzerland, after Ludi Bergdorf purchased 8,000 kg of Schotta sand in 1909 and continued to sell it abroad. Due to high wood prices previously, the Sennen received wood for free. Manufacturing has become too expensive, and the Sennen preferred to use the Schotta weave for pig feeding Ludi. Currently, lactose is produced in relatively significant amounts in Mecklenburg-Güstrow, Gilo, Lauenburg, Berlin-Meyer-Evoll, as well as particularly in Holland and a little in Italy Lombardy, near Lodi. Always only in regions with intensive effect, livestock farming. North America manufactures and exports lactose on a large scale. German milk sugar exports via Hamburg in 1907. 84,900 kg, 1908. 142,600 kg. Most of the milk sugar produced in Germany is consumed domestically, particularly for medical purposes. Properties. Milk sugar crystallizes heavily and forms hard crusts on suspended rods, as is executed in practice. Milk sugar is known to exist as a monohydrate, several water-free crystals, and presumably in amorphous water-free form. The milk sugar sold in commerce is the monohydrate Ho, which crystallizes in large monoclinic crystals, has a weak, sweet taste, exhibits triboluminescence, is pyroelectric, and does not release its crystal water even after 24 hours of heating in a water bath. In an aqueous solution, it shows right rotation. D52.53. Freshly prepared solutions exhibit multi-rotation. Milk sugar dissolves in 5.87 parts of water at 10 C and in 2.5 parts at 100, It is completely insoluble in strong alcohol and ether, and it does not dissolve to any notable degree in diluted wine spirit difference between raw sugar and dextrin. Milk sugar prevents the coagulation of many colloids. The heat of combustion, important for evaluating milk sugar as a food, is 3,951.5 calories per 1 g and 1351.4. It contains an aldehyde group, which has been retained in the glucose residue, CP114. True yeast from pure cultures, Zyme, Mycoderma, Aspergillus oryzae, Saccharomyces apiculatus, and others do not ferment milk sugar. It is easily and completely fermented by so-called milk sugar yeasts, all Taurolacine, then mixed kefir and kumis ferments, and others. Not all microorganisms that convert grape and raw sugar to lactic acid fermentation also do so with milk sugar. Diluted sulfuric acid splits according to the formula. Cho-ho-cho-cho, sugar, lactose D-glucose D-galactose trade. Recently, multiple instances of glucose adulteration up to 28 patch have been observed. Proc. MPHS, 1906, as well as raw sugar oligar Kasperi. Testing. The slightly sweet solution 11 is neutral and foams when heated or shaken. When warmed with sodium hydroxide, it takes on a red-brown color and immediately forms copper oxidule upon subsequent addition of copper sulfate. 1 cc of cold prepared milk sugar solution, 120, mixed with 1 cc of sodium hydroxide, and 10 drops of cobalt nitrate produces a pure blue liquid. Germany imported in 1908. 137, 1909. 135 deep tea milk sugar from the Netherlands and Switzerland, and exported 1908, 1432, 1909. 1652, especially to Great Britain and Japan. 1650 deep tea, especially to Great Britain and Japan. France imported in 1908, 129,419 kg milk sugar, especially from Italy and the Netherlands, little 8,402 kg, also from Germany. Adulteration. If 1.2 g of milk sugar is shaken frequently for half an hour with 12 cc of diluted wine spirit, then 10 cc of the filtrate should leave no more than 4 mg of residue upon evaporation in a steam bath. After combustion, milk sugar should leave no more than 0.2 ash farm. Helvethorf, Dieterich, found only around 0.08. Raw sugar can be detected in milk sugar by allowing a solution with pure yeast to stand. Since only raw sugar, not milk sugar, is inverted by the yeast's invertus. Milk sugar was first produced by Fabrizio Bartoletti in Bologna and Mantua, 1581 to 1630. 971 investigated it further. Lactose was first depicted by Michael Ettmüller in Leipzig, 1684. In the canton of Bern, lactose was already being produced in larger quantities in 1766. Kunkel noted at the end of the 17th century that alcohol could be obtained from milk and J.G. 883. Under the name manna or nitrum seri lactis in the Encyclopedia Hermetico-Dogmaticus 1615 described. He obtained it by evaporating milk, and 1700 by the Venetian Luigi Testi, as well as 1715 by Valesnerian de Praestantia lactis. Recommended it as a medicine Flückiger, von Lippmann, Liechtenstein, and Hermstetter first, p. 1906, on 22 best. Der Lactose in der Milch. M. L. Willamos, De Sale Lactis Essentiali, 1756. Gemelin discussed Kumis, 1732. The use of sour mare's milk by the Mongols of East Asia certainly dates back to the 13th century, probably much earlier. Flückiger, Lit. Flückiger, Pharmak, Chem. Von Lippmann Chemie der Zuckerarten, Nielsen, Proc. Ammer, Farm, S. 1906, Tekken, Meth, Z. Milk Zuckerbereit, Petain, Bull, Sock, Chim. Hierher gehört die raffinose Melitriose, Melitose, Gossipose, die als Äther der Melibiose eines Disaccharids aus Galaktose und Glucose und Fructose zu betrachten ist. It decomposes upon hydrolysis according to the equation. 1832-16, 2H2, UT612, O6T8, well 6T8. Milchzucker, 1772, Cruikshank, Scherer's Old, Juren, Diechem, 3rd, 293, Hydrogen, welche Trisaccariden enthalten. Die Trisaccaride oder Hexotriosen sind als durch Kondensation eines Disaccharides mit einem Monosaccharid entstanden zu denken, enthalten also 3 Zuckerreste. The latter property is used for separation from raw sugar. She turns right D104.5 and does not reduce the feelings solution. Raffinose is found in eucalyptus manas, beet, and beet sugar syrup. Here also seems to belong the malazitose, which is just as sweet as glucose, with the formula CHO. Raffinose, fructose, glucose, galactose raffinose can be written as CHO, HTO, HTOO, O, OH, OCH, HCHCAOO, HCAHCAAHA, CHO galactose, residue glucose, and quite soluble in absolute methyl alcohol. 2-Ho, rotation water-free, D88.51, does not reduce feelings solution, decomposes upon cooking with diluted acids into glucose and tyrannose CHO. It is found in larch manna, hence melazitose, from meles larik, decidua, and alhagi, manacide. To the trisaccharides belongs also the manino trisaccharide, not reducing feelings solution, isolated by tannerite from Eschen manacid, which upon hydrolysis splits into 2 mol galactose and 1 mol glucose. Hans Mittelmeier, Über die Melitriose, Dis. Bern, 1890. There the literature. Scheibler and Mittelmeier, Ber die Chem. Machen in the sap of linden bull. Sock, Chem, 3-9, 1893-723. Borcolo and Erisy, on the hydrolysis of melazitose by soluble enzymes. Eucalyptus mana is an exudate from several Australian eucalyptus species. It is reportedly induced by cicada morans, particularly on Eucalyptus viminalis labile, Eucalyptus manifera moody, Eucalyptus resinifera Smith, GS22, U26. Melazitose, 1859, by Berthelot, in D. Mana, from Briançon. Found new research on bodies analogous to cane sugar and Chim, Phys, 355, 1859, 269, 269. 269. Villiers found it in the sap of Alhaji Marorum research on melazitose, bosoxatose, Chim. 27, 1877, 98. Alakine in Persian manabul. Soak, Chim, 246, 824. Manifera products discovered by Johnston and Thompson in 1832, first mentioned by Viry, involved a crystalline sugar termed melitose, molasses and cottonseed extract, isolated by Ritthausen. The rotation power of Melibiosi is D103.47. Another exudate from Eucalyptus guinea, Hook, var. Darden. Rubia was studied by Passmore and Ebert, with the latter finding 68.49 melitose Passmore 60, 20.86, UN crystallizable glucose, 2.14, invert sugar, 3.22 mucilaginous substance, 0.1, wax. Another type of eucalyptus manna, from Eucalyptus pulverulenta, seems the text provided is already in English, so no translation is necessary. Here it is for reference. Derived and pale white, brittle, sweet-tasting pieces that emit a scent of eucalyptus oil, containing, according to Ebert, 2135 melitose, 16.15 fructose. The residue was 1. Litt, Johnston, Manna from Eucal, Manifera, Chem Gaz, 1843, Annual Report of Pharmacy, 1849. Rischbieth and Tollens, Melitos from Eucalyptus Manna, Report of the German Chemical Society, 18, p. 2016. Scheibler and Mittelmeier, Report of the German Chemical Society, 22, p. 1678. Passmore, Manna from UC. American Journal of Pharmacy, 1896. Ebert, Contribution to the Knowledge of Rare Manna Types. Dissertation, Zurich, 1908. Further literature as above. B. Larch Manna, the Larch Manna, Manna from Briançon, Manna brigantiaca, Manna brigantiaca, Manna brigantiaca, Manna brigantiaca, Manna brigantia. In the Paris Customs Tariff of 1542, Man de Dauphiné et de Provence, p. 815. Also in the Edicts, p. 947, who called it Man de Malaise, it was in use. Now, it seems to be of no significance in France. It forms dry white grains that owe their crystalline structure to melazitostost, alakine. A similar manna is found on Cedrus libanotica, 706, where Pommet also calls it Manna laricia. It appears on the shoots of all trees of Larix europaea L during summer, and is probably only collected to a limited extent in Dauphiné, near Briançon department of Hautes-Alpes. It served as a mild laxative in France formerly. At the time of Geoffroy P.L., Pommet describes it as very rare and highly prized under the name Manna masticine du Levant ou de Syrie. In the Brandenburg Tax of 1574 p. 8/17, it is called Manna syriaca, i.e. Masticina optima, Manna de Levant. It resembles Calabrian manna and forms grains similar to mastics. It is likely the same that Geoffrey Cedrine calls, and which he believes was known to Hippocrates and Galen. Also, Pinus excelsa Wallach and P. longifolia provides in India, particularly at Simla, in the Himalaya Flückiger, a manna. 1877, 893 Pinus lambertiana provides charred pinnet, a manna. Similar sugar exudations have been observed on Libocedrus decurrens and another Californian conifer, Ref. Pommet is. Geoffroy, Tract on Mathematical Medicine, 1757, RV, p. 142. Watt notes that this occurs in greater quantities only every 20 years, encrusting branches and needles and also dripping onto the ground. He considers it identical to the Lebanon cedar's manna see above. In North America, the sugar fir Pinus lambertiana produces a sugar-rich mannaloid. Also see Thurber, California manna, PHJ. Of these tetrasaccharides, only stachioz, isolated from the roots of Stachys species by von Planta and E. Schulte in 1890, is known. Alichin Jern. Of the Russian Chemical Society 21, S420, Lloyd Californicia manna, Bear, D. Farm, Jess, 1897. None of the above-mentioned types of manna pp. 131, 136, 147, and 151, 152 contain mannate, i.e., polysaccharide drugs containing tetrasaccharides. It reduces to CHO4-HO, and upon slight hydrolysis, breaks down into manninotrisaccharide manninotriose, CP109 and fructose. Complete hydrolysis yields 1 mole of glucose, 1 mole of fructose, and 2 moles of galactose. Literature. Lucien Piault, on Stachiosa thesis, Paris 1910, E. Polysaccharide drugs. The polysaccharides include starch, dextrin, inulin, and a large class of membranines, to which we must include cellulose and its modifications, such as hemicelluloses, lignin, membrane gums, pectin gum, and related formations, and also cork, cutin, polanin, fungal cellulose, and chitin. Their constitution is still unknown. Our understanding is based on the fact that all these substances, upon appropriate treatment, especially hydrolysis, form bodies of sugar groups. A completely different, highly questionable view is held by Genti's bull, Akkad, Cracovie, 1907, who considers all the aforementioned substances to be colloidal tannoglycosides. Starch meal, starch, flour, amidon, fécule French, in French code, amidon de blé and fécule de pomme de terre, starch English, zetmeal Dutch, amido Italian, starch Eng, amido Italian. Starch stoid Hercules fin, Hercules fin, caminito hung, Giorca. In a similar way, carbohydrates do not seem to exist in the form of starch, although we often encounter small starch grains in the conducting vessels or their vicinity transitory starch, but rather in the form of other members of the sugar group. If we cannot assume that starch is the first product of plant assimilation, it being perhaps one of the other bodies belonging to the sugar group, it is certain that it is the first visible, appearing in the form of very small grains within the chlorophyll granules assimilative starch. Not only in vegetative organs, in underground storage reservoirs, tubers, rhizomes, overwintering roots, but also in the stem and evergreen leaves, and in the aerial reproductive organs, seeds and fruits. Reserve starch 60 to 80, up to 93 in individual parts of the corn kernel. The precipitation of soluble starch in plants is, according to Wolff and Fernbach, affected by a ferment, amylocoagulasa. Certainly, the strength that takes the form most frequently assumed by the carbohydrates, formed during the assimilation process when it comes to storing the material, in the form of reserve substances, reserve starch, is certain. These organs are precisely those that allow for the technical utilization of starch, and are therefore employed for this purpose, while assimilatory and transitory starch occurs in too small quantities to make extraction worthwhile. Starch is obtained from tuberous potato starch and from rhizome starch. Vincent Arrowroot, from the sago palm, represents various cereal starches from the endosperm of seeds and legume starch from cotyledons. The French distinguish seed starch as amidon and underground organ starch as fécule, but recently El Planchon, 1910. Both words are also used synonymously. The starch content in underground reservoirs varies depending on the vegetative period. For production, it is important to determine when the organ contains the most starch. Starch is a very common cellular component in drugs, but it cannot be said that the effect of many of them is due to starch. It is absent in Rhizs, Gramineas, Gentianae, Rad, Saponariae, Rad, Senegae, and replaced by other reserve substances here. In underground organs of composites, Campanulaceas, Goodenias, and Stylidias, it is replaced by inulin. During the expulsion of vegetative organs and the germination of seeds, starch is gradually dissolved. The grains show signs of corrosion and melting fig. 51. Therefore, anatomically, one can determine if, for example, germinated cereals are present. The conversion of starch to sugar during germination takes place through secreted diastase, in what is known as the transitory transport of starch, where dissolution also occurs by a special translocational diastase. Starch from germinated wheat. The end products are dextrin, maltose, and dextrose. The enzyme amylase, correctly known as amylomaltase, initially converts starch granules, not raw potato starch, into a high molecular weight dextrin and maltose wheat and barley. Based on Churcho-Easterly Atlas, that starch is a polysaccharide is based on its behavior towards enzymes and during hydrolysis. If diastase is left to act upon a starch slurry, the blue coloration due to iodine gradually disappears. Iodine initially colors purple, then brown-red, and finally not at all. Under certain conditions, both are further broken down by amyloglycase into dextrose, CHO, CHO, starch high molecular weight, maltose dextrin, CHO, broken down dextrin maltose, CPA, 115 CHO, 2CHO. Maltose dextrose CP6 drying and heating starch to 150-180 C also converts it into dextrin. It was Machen who successfully completely converted starch into sugars, proving that it consists solely of maltosins. Machen demonstrated, contrary to A. Meyer, that the main component of the cores is amylose, Machen, which he extracted in large amounts through retrogradation as artificial. Meyer assumes that the grain cores contain very little amylodextrin, and slightly more 0.6 to 2.5 non-iodine blue, amylose, negali, brown, eru, and predominantly amylose negali, along with other components. Some Siniewski believe they are uniform, while Forward considers them a colloid. According to him, the starch consists of 80-85 amylose Machen and 15-20 various condensates of amylopectin. Wolf and Fernbach, 1906, proposed that the starch is made up of amyloses that can be polymerized and glucosylated, amyloses that can only be glucosylated, and Machen and Ruth amylopectin. However, all these data are still very uncertain. Pfeiffer and Tollens give the strength of formula CHO, but it only has a provisional character, as does the formula Siniewski's CHO, 3-Ho, which views it as a high molecular anhydride of amylogen. The amylogen CHO, water-soluble and non-reduced, is conceived by Siniewski as built up from 3 maltose residues and 1 dextrin residue containing 18 carbon atoms, itself composed of 3 glucose residues, of which 2 are contained as isomaltose. The artificial starch kernels obtained by heating starch with iodine at 330, by Rodewald and Katyn, at a molecular weight of 32,700. Pure iodine colors pure dry starch yellow. Starch is only colored blue by iodine when water or iodine hydrogen or a compound of the same, or a substance forming iodide J from iodine, is present. The iodine starch has, according to F. Mylius, the formula CHOJ, HJ. Kuster and A. Meyer, however, they consider it a solution for the iodine water stuff in the starch substance. The ratio between the iodine taken up by the starch and that remaining in the aqueous solution follows the Nernst law of distribution. Even 150,000th of iodine causes violet coloring in starch paste. The iodine reaction of the starch grains can be fixed by treating the blue-colored grains with silver nitrate, exposing the preparation to the sun, and then developing it with hydroquinone, after which the grains remain permanently brown lagerheim. Iodine only colors certain naturally occurring substances, such as saponiferous bargers. Blue Report of the Chemical Society, 1902. Violet, like phenolic acid and glucosamine, see also under cellulose. First, Dufour, found in the epidermal cells of leaves of Saponaria, officinalis, and Bryonia dioica, a water-soluble substance that turns blue with iodine. However, some membrane proteins, e.g., lichinin and breakdown products of membranes, also turn blue with iodine preparations. If one lays down various starch samples on a glass plate, with a test tube filled with some crystals of iodine next to it, after 24 hours the different starch types will be colored differently. Cornstarch black-violet, grain starch taupe gray, potato starch yellow-gray, sago milk coffee color, dubasque. Some starches, since they contain oxidases, turn blue with guaiac tint corsini, but this never occurs on the starch kernels themselves. The starch kernels themselves, the white color of flour comes from the air between the kernels. Starch absorbs a lot of water, so-called green starch, contains C55. Air-dried starch contains 1319 water. The gelation temperature varies among different starch types, ranging from 50 to 70-75 degrees. The determination of the gelatinization temperature is used for differential diagnosis, as well as the behavior to solutions of different concentrations of kalium bellier. Lenz uses the different swellability of starch by sodium salicylate solution to distinguish individual types of starch. Starch appears to be always formed or also located in starch-forming cells, amyloplasts. Remains of the same can sometimes still be found. Iridis, crown tube of verbascum, anatom, Atlas Table 22. The boundary values of length diameters are determined, and the most frequently occurring values are also given. Even the form is characteristic of each strength flower. At least there is always a type that can serve as a leader church. It is always present in the form of grains, whose size in the storage containers ranges from 4 rice to 170 micrometers canna, and whose cubic content varies between 20 and 320,000 cubic micrometers. When their size reaches 150 micrometers, they can be seen with the naked eye. The size varies for each starch meal within certain limits. Very often, the layering and position of the core are diagnostically important, such as determining whether simple, complex, solitary, adelphic, monotone, or polytonal grains, A. Meyer, are present. A. Meyer considers the always double refracting strength as an organoid, specifically a spherocrystal built from countless short amylosterichites. Delbruck, Chem. Zeit. 1901, 195 described a method to test the strength for health. Soluble starch can be represented by heating with a 2-sodium borate solution, or according to the Lintner method, heat with 7.5 hydrochloric acid for 3 days at 40. Wash out the acid and dry. Small amounts of starch are best detected using iodine chloral hydrate. The factory representation of strength is essentially based on the comminution of the starch-bearing tissues, washing out degrading the starch grains, and separating them from the cell residues and water. For tubers, e.g., potatoes, either the organs are rubbed in a roller to transform them into a paste, which is then washed, scrubbed through a sieve with water. The pulp remains on the sieve, or the sliced tubers are first fermented in piles vats. Intact starch resists fermentation and decay. For seeds, e.g. wheat, either the seeds, soaked for 10-15 days, are crushed between rollers, allowing starch to escape from the paste in treadmills. With water martin or centrifuging, firm seeds have also been previously opened up with alkali soda, lime, ammonia. The initially settling seed meal is very water-rich green starch. It is usually dried in dry chambers and then bleached in the sun or artificially. Only a relatively small number of varieties are manufactured industrially, as despite the wide distribution of starch, only rarely are all conditions for a profitable technical yield. Richness of the material in starch, easy crushing, absence of material in starch, easy crushing, absence of disturbing impurities, cheap acquisition, uniform quality of the material, present. 910 of all seeds are starch-free. In large scale, potato, wheat, corn, and rice starches are manufactured industrially. Since starch attracts a lot of water and odors from the air, it must be stored in a dry and odorless place. History. Dioscorides says of amylum that it bears this name because it is made without a mill privativum and mill. He describes its preparation from spring wheat. The same is steeped in water for 5 days, then crushed with the feet and trodden under water. The upper husks that float to the surface are removed. The slurry is filtered and quickly dried on stones in the sun. A kind not suitable for medicinal use can be prepared from spelt. He considers Egyptian and Cretan amylum to be the best. Similarly, Plinius speaks of the preparation of amylum appellatum, quod sine molla fiat, holding the inhabitants of Chios to be the inventors of the process. He further knows oats flour, and the use of amylacea in diarrhea, which Rhazes also mentions. Plinius refers to Cato. Indeed, one finds in this CI, p. 572, the first brief mention of the representation of amylum. It says in Cato de Re Rustica, in the LXXI7 chapter, amylum thus made. After cleaning the silage thoroughly, place it in a vat and add water up to the 10th day. When the water has evaporated on the 10th day, mix well with clean vat, making it as if it were to become a cake. Put this into a new linen bag, squeezing out the cream onto a new plate, or into a mortar. Make it all like this, then rub it again. Place the plate in the sun, and it will dry. Where it dries, place it in a new hull, and make it with milk. The term satsmel, absatz, and keystone can also be found among the ancient ones. Rice flour was a popular remedy among the old Indians p. 504, and was also used in love potions. Gerstemeal, lentil flour, and ervermeal were used by Hippocrates p. 541, as skin remedies. These were likely flours. In Scribonius Largus's composition as IP 576, amylum is mentioned. Ibn Bathar refers, S68 lists it under the name nashapers, nashhastach, which El-Gafaki describes as a derived from an aromatic seed, seasoned from Dioscorides. In Serapian's table I, S. 605, it is listed as amylum, while in Alphita Orn, S. 641, and Circa Instans, Mateus Silvaticus or Simon Januensis, S. 63, mentions amylum, vel apoioi. 797 used amylum and amylum asatum. The first Brandenburg tax list from 1574-1, S. 8 Thona 17, includes amylum vulgo, amidum common wheat flour. The term craft mill. The coarse flours or facula of earlier centuries included facula ari, brioniae colchici autumnalis, elaterii orchidis, sudacori peoniae. They attributed specific effects to them. As Flukiger documents, see Tariff's reports, in the 17th century, 4 faculas were kept by pharmacies from the roots or tubers of Arum maculatum L, Brionia alba L, Iris florentina L and I, Pseudocorus. There was the flour of rad. Nowadays, usually only 5 starch flours are kept in pharmacies and partially listed in pharmacopoeias. Rice, wheat, potato, corn, and maranta starch. Only the Japanese and Portuguese pharmacopoeias have other starch flours, see below. The Germanic peoples prefer wheat starch. The various types are now widely represented. Serpentarii polygonum bistorta L. and Amylum mecoacanae, jalapi. With Gren's System of Pharmacy, 1799, only wheat starch is mentioned. Also, Pommet and Lemery only mention the amidon of cereal fruits, not arrowroot or potato starch. Dierbach, 1841, mentions wheat and potato starch. In America, cornstarch plays the same important role in industry and pharmacy as rice starch does in England. Wheat starch and potatoes used. This is also reflected in the pharmacopoeias. Already Leeuwenhoek considered cereal and bean starch under the microscope Philos, Transact, as he himself polished stronger lenses than Malpighi, and Grew had at their disposal. He could extend his observations to smaller objects as well. Under amylum as a whole, the pharmacopeias of Roman countries and Germany mean wheat starch. The North American pharmacopoeia means cornstarch. Great Britain means wheat, corn, and rice. Portugal means mandioca or manihot, and Japanica refers to the theme. Aforementioned types. In the Portuguese pharmacopoeia, amylum aurei is still listed. The first starch to be produced industrially, initially in a domestic setting, was potato starch, whose production Friedrich the Great 1765 encouraged. N.C. Bloch founded 1811 the potato starch factory in Alsace. Even wheat starch was first produced by household industry. Luke Howard recognized in 1800 the changes in starch grains due to water absorption during heating. Even before Schleiden, Payen showed in 1838, and Pereira in 1842, P340, that different types of starch flour could be distinguished under the microscope. C. von Nageli, Die Stärkekörner, 1858. Wiesner Hubel, Microscope, Investigation. A. Meyer, Unters. Lutz, Lamedon, Bull, St. Farm, 1906. However, the most comprehensive morphological anatomical investigations on starch grains are found in C. Nageli's work, Die Stärkekörner, Zurich, 1858, which is richly illustrated with plates. In it, the theory of starch grain growth through intussusception was also argued, which can now be considered overcome. AFWF. Schimper, Arthur Meyer. Kirchhoff discovered the saccharification of starch paste by malt extract diastase in 1811. Collin and Gaultier de Clobris observed the blue coloration by iodine, which had been discovered a few months earlier, in 1814. The oldest paper 8th century AD was glued with wheat starch paste. Wisner, Lit. 30, 2415. Vogel, Nachroms und Genussen, 1899. Etienne Smoller, Microscopie Dinar, Eugenusmittel. 2. Aufle, Villiers et Collin, Traité des Alterations et Falsifications des Soups, of L. Church, Starkemel-Analysen. Arch, Farm, 1884 and 1885 in Applied Anatomy. Journal of the Eastern Pharmaceutical Association, 1906. D. Croc, Contributions to the Study of Flowers from Indochina. Annals of the Museum of Marseille, 1908 and 1909. Louis Planchon and Armand Juillet, Study of some Colonial Starches. Annals of the Colonial Museum of Mars, 1910. Church Esterla, Anatomical Atlas. Frank and Church, Plant Physiology Wall Charts. T.F. Hanausek, Food and Nutritional Materials, 1884. Schimper, Guide, 2nd edition, 1900. 1900. Rosen, Anatomical Wall Charts of Vegetative Foods and Nutritional Materials. Huge, Hess, Studies on the Composition of Tropical Starch. Von Weinzierl, Qualitative and Quantitative Microscopic Analysis, a New Method for Studying Flour Products. Kramer, American Journal of Pharmacy, 1899. Proceedings of the American Pharmaceutical Association, 1899. Journal of the American Chemical Society, 1899. Science, 1900. Others. Sachs, Chemistry and Physiology of Pigments, Carbohydrates, and Proteins. Leipzig, 1877. On the Ash Content of Starches. Lowell, American Journal of Pharmacy, 1897. Duhamel de Monceau, The Art of Making Starch. Paris. V. Wagner, Starke Factory Production. Braunschweig, 1876. Data. Seal, Extraction and Presentation of the Most Important Foods and Delicacies. Stuttgart, 1902. On the Determination of Starch in Cereal. Seeds according to Lindet. On the Investigation of Raw Materials and Starch. Eckenbrecher and Lunge. Chemical Technical Analysis Methods the 3rd, 494. See also my article on amylum in the Real Encyclopedia of General Pharmacy Wine. P. 583, Euler, Plant Chemistry and Japek, Biochemistry. There's a botanical literature list. Payen, Memoirs on Starch considered from anatomical, chemical, and physiological standpoints. Ann S.C., Nat. 1838-90. 2-27 First attempt at microscopic diagnosis. A fairly complete list of plants that produce starch can be found in Wisner, Raw Materials I, p. 564. A determinative key was provided by molar microscopy. The Duffer table for determining starch types is printed in Pharm. Praxis 1904, p. 54. Von Heinel, Starch, and the Products of Milling. General Encyclopedia, Kassel 1882. Haars, Agricultural Seed Science. Berlin, 1885. Berg, Anatomical Atlas. Look at your church. Fundamentals. Muller, Microscopy of Cereals. Farm. Central, 1884, and Pharmacognosy, Atlas 1892, Tables 127. W. Lenz, A New Microchemical Distinction Between Rye and Wheat Starch. Apothekenzeitung, 1909, and work from the Pharmaceutical Institute of the University of Berlin 7th, 1910. Blomendal, Contributions to the Knowledge of Starch. Farm, Wheatbill, 1906, Bauer and Polenstedt. Work of the Imperial Health Office, 1906. Foar, on the colloidal properties of starch and on the unity of its constitution. Bulletin of the Chemical Society, 1908. Lintner Journal for Chemistry 34, 1886. Annual Report of the Silesian Society for Native Culture, 1909. Dubast, Chem, Zeit, 1904, 1149. Lagerheim, Zeitscher, F. Stärke aus unterirdischen Organen. Amylum solani. Sin, Kartoffelstärke, Fécule de pomme de terre fer, potato starch eng, ardapelzet meal, ende, amido di patate ita, potati terkei, Solanum tuberosum L. linnae, spec plant tort, Mecrost, 14. Machen, Bull, Soak, Chim, 1906. Wolf U. Fernbach, Comte, Brand, 137 Hugo 38. Corsini, La Guaiaco Reazione nella, 1907. 224. Utilization of coeo, also in Reverend Intern. Des falsifiques, et d'analyse des mat, aliment, 1907. 183. Erdapfel, Erdbeeren, Grundbeeren, Patake mit zahlreichen K9 100 Varietäten, Sorten und Kulturrassen. Solanaceae, Solanaceae, Pachistemonum, etim. The Italians called the potato tartufo, due to its similarity to truffles, which led between 1650 and 1760 through dissimilation to the German word, Tartufel. The transformation from Erdapfel Old High German, Erdapfel Truffel, or Erdapfel Erdtuffel, Artoffel to pomme de terre is also notable. The name Grumbeeren ground pear, earth pear, suggests the underground nature of the tuber. The English word potato allegedly originates from Haiti Pataken, Old Frankish, Nightshade's black harm. Solanum comes from solari, meaning to comfort, strengthen, or cause sunburn caneater. The strychnos of the ancients was likely a solanum. Nolan tuber is better described as dianola the knob. Solanum tuberosum is a perennial, compressed, hairy, branched herb of 51-20 cm height, with interrupted pinnate leaves, terminal lobes larger than the oblique lateral lobes, white or violet-red flowers, doll-like clusters. Fruits yellow-green, about cherry-sized berries. The plant is propagated solely through its tubers, not seeds. Underground runners, stolons, sprout from the axils of lower leaves of the plant, even the shriveling cotyledons in ZJ. 52, and are covered with scale leaves AC and develop lateral roots however, when they emerge into light, they can also become shoot buds. The ends of these underground runners swell to form tuberous storage shoots TB. These form the potatoes. They contain greatly increased starch-storing parenchyma in their flesh hypertrophy of the flesh. One circumferential vessel bundle, forming a marginal circle, is only small. Extern, the tuber is surrounded by a multi-layered cork that protects the water-rich tuber tissue from drying out fig. 53. Here and there, on the tuber, small scale-like leaves can be found, in whose axils lie buds called eyes beer. 52, which can sprout during the multiplication of potatoes and produce a new plant. The parenchymal cells of the marginal layers are smaller than those of the inner parts. In red varieties, all cells contain, besides starch, a red cell sap. In red-skinned tubers, it is only present in the marginal layers. Potatoes contain 15-20 starch, many analyses by Koenig. However, in some varieties, the starch content can reach 22 or even 24. In Germany alone, 3 million hectares are under potato cultivation. Illustration, Fig. 52. Formation of tubers, storage sprouts from underground wandering sprouts. Below is a longitudinal cut through the top of a young tuber. From Sachs' textbook, Pathology, Professor E. Fisher reports on plant pests. This parasite leads to the death of the shoot, which can naturally also result in a delay in tuber development. But the fungus itself also spreads to the tubers, causing browning and death of their tissue. Secondary bacteria and molds then complete the decomposition process. However, certain mold fungi, notably Fusarium solani Mart. Sakei, seem to be able to cause disease dry rot independently, at least in wounded tubers. A chytrid Chrysophyctis endobiotica Schilberski is considered the cause of a scab disease of potatoes. Finally, in recent times, a series of primary bacterial diseases of potato tubers have also been described. Lit. Apple and Kreitz, the current state of our knowledge about potato diseases and their control. Anstalt F. Land, on Forstwirtschaft 1907. Heft 5. On the control of potato diseases with Bordeaux mixture. See also Church, Copper from the Viewpoint of Hygiene, etc. Stuttgart 1893. On animal pests, Israel reports. 1. Beetlesteg May. Agriates, Lineatus L. Larvae bore holes in potato tubers, otherwise feed on cereal and grass roots. Melolantha vulgaris L. The May beetle. The larva lives on the roots of all kinds of plants and trees, often in large numbers on potato tubers. 2. Moths. Acherontia atropos L. The skull. The caterpillars occurring in central and northern Germany come from moths that flew in from southern countries Hungary in May. They mostly live on potato plants, but also, although they occur more frequently, on Datura, Lycium, Hyoscyamus, Daucus, Syringa, Philadelphus, and others. The caterpillar is never harmful as it usually occurs individually. Calocampa exhalata L. The polyphagus, very beautiful caterpillar, also lives on potato plants, among other things. 3. Flies. Sciaria vitripennis, smart. The larva of this fly prefers rotting potatoes in cellars. Potato starch sometimes contains the mite Alarobius farinae. Illustration, Fig. 53. Cross-section through the outer layer of a potato tuber. Church representation of potato starch. Potato starch has been manufactured on a large scale since 1846. The drum-washed potatoes are ground in shredding machines, and, together with the potato juice fruit water, passed through sieving apparatus. Fig. 54. The remaining pulp is either fed to animals or ground on millstones and passed through the sieving apparatus.